Hello, welcome to developing 2D and 3D games with Unity for Windows. I'm here with my good friend, Dave Oyles, and we have an exciting day planned for you today. We have tons of Unity learning content, how to develop 2D games, 3D games in Unity, bring them on over to Windows. We have such an exciting day. I'm very happy to be here.
Likewise. Thank you for having us.
I'm Adam Tuliper, a technical evangelist with Microsoft. I focus on a whole bunch of different technologies, gaming, cloud technologies, web technologies. I pretty much love everything tech related. So this is going to be exceptional day right here. Been a software architect for many years. And David, why don't you tell us about yourself?
Yes, I'm relatively new to Microsoft. I'm also a technical evangelist based out of Philadelphia. Previously, I was at Comcast working on their Xbox applications before joining Microsoft. And now kind of specialize in web development, video games, and the cloud. And pleasure to be here with Adam this morning, kind of going over all this Unity content with you guys.
Very cool. So today we've got developing intro and Unity overview, 2D game development, 2D and 3D asset creation, which I'm especially excited for that one because I'm an awful artist.
And we have a special guest coming in for that.
Special guest for that. 3D game development, building for the Windows platform, optimizing your games, ALM, Application Lifecycle Management in Unity. Great session on marketing and monetization, one area where developers need a lot of help.
Yep.
And using Prime 31 to connect your Unity games to Azure. And finally, adding the finishing touches to your game.
Yeah, so we'll have several evangelists coming in and out throughout many of these sessions, as well as some special guests from Unity and some other places too. So you'll kind of have a mixed group of faces throughout the next 2 days.
That's right. You are going to see 7 of us off and on the camera through the next 2 days. So it's a really good crowd, really good group of folks that we have here. So again, I can't say enough. Very excited, but I hope you are too. So let's set expectations. Who is this event for? Well, hopefully everybody, but primarily targeted towards beginner and intermediate Unity developers, C# programmers. I would also say aspiring artists because of the art sessions we're going to have on there as well.
And fortunately, Unity makes it very easy for artists to get started as well.
Suggested prereqs and supporting material, C# fundamentals for absolute beginners. If you don't have any programming experience, that is on Microsoft Virtual Academy. And one of my favorite sites, digitaltutors.com, who has awesome Unity learning content out there. I mean, there's a bunch of great free content out there that's pretty targeted paid content as well.
Yeah, absolutely. They have step-by-step tutorials on how to write an entire project from beginning to end. So highly suggest you go check that out.
And please join the MVA community. We love doing these things for you. Everybody that's here loves doing it for you. There's a ton of great content out there. There are over 2 million registered users now for Microsoft Virtual Academy. And you can get points for each event that you complete. Go to aka.ms MVA voucher, and there's a special code on there that does expire October 10th, so get on there and check it out.
And all this content will be recorded right now, so if you do happen to miss some of this throughout the day, you can always catch up to it in the next couple of days, as it'll be stored on our site later on.
Now, Dave, the fact that we love gaming,
yes,
and we work for Microsoft, I think this next slide shows something that's very cool. Every time these announcements come out, I actually get pretty excited about this.
I don't know about you, but that's why I came on board. Was largely to work with independent gamers at Microsoft.
That's right. So let's go down the list of some investments that Microsoft has made here. Prime 31 is a leading plugin writer for Unity. There's a year free for Prime 31 plugins for Microsoft. If you go to their website, go to the Microsoft section, you'll find, rather than prices, and a lot of them are typically like $75 or so, you can download them for free there for a year. Secondly, and this one was extra cool, Microsoft acquired Syntax Tree. If you've ever heard of Unity VS, that enables you to use Visual Studio to develop and debug your Unity code. Previously, you could only use it as a code editor. This plugin allows you to also debug with it. And that was about a $100 product. Microsoft bought the company, turned around, added some additions to it, and those folks came on board here, and now they turn around, release it for free.
Yeah, absolutely. So typically, developers will often start writing code with MonoDevelop, which is packaged for free with Unity. But Visual Studio does tend to cost a bit of money. So why don't you tell them a bit about BizSpark and then how we can get many of the developers we work with free versions of Visual Studio?
BizSpark, great program for startups. If you are forming your own little game company, to me, you are a startup. The criteria are typically that your company, not you, are less than 5 years old, less than $1 million in annual revenue, that you are a privately held company and working on a software product as a core part of your business, not just consulting, for example. go to bizspark.com or contact your local evangelist, and we can help you out with that locally as a resource as well. That gives you free Visual Studios, Windows, $150 a month credit to Azure for virtual machines, websites, and up to, I think, 7 users on an account get that as well.
Yes.
And we partner with Unity to provide various offers. So right now, on Unity's site, pages/windows/offer, there's a really cool offer going on that gives you you can get a free device, you can get free Windows licenses. The current offer right now gives you, I think, a $100 voucher to Unity's asset store. So check out that site. There's always new stuff coming up on there. Check often. So this session, we're going to be doing intro and architecture of Unity. In this module, it's going to be a basic intro and the interface. We're going to talk about game objects and components, essential parts inside of Unity, prefabs and packages, and
the architecture of Unity, the application itself, and quite a bit about how to architect your games as well, best practices, I suppose.
Architecture is, coming from a software development world,
yes.
Architecture is a very important subject. I think it's real important to understand how Unity works, its various components, how it kind of fits together. And that's what we'll be talking there, the coding model on there.
Absolutely.
It is kind of unique. Coming from an enterprise software background
yes.
and going to game development, at first I had absolutely no idea where to start.
Right, you have to understand the draw loop, the update loop, how that all ties together, Unity's component system.
I'd heard of a game loop.
Yep.
But when it came down to it, I didn't know how to write one for Unity. And so we're going to show you some of that today. And hopefully this will all kind of make sense and add up. What do you think about the code model in there?
Say it again, I'm sorry.
What do you think about the code model in Unity?
I actually enjoy it quite a bit. I like the fact that they give developers the opportunity to go with either C# or JavaScript, their own type-safe JavaScript.
Don't forget Boo. Nobody uses Boo, but you can't mention Boo.
Boo does absolutely exist. I don't know how people are using it at this point.
I've never met a person yet. I'm literally talking to thousands of Unity developers.
And I've used this for about 3 or 4 years now. I have not run into anyone that either. How about you? Do you prefer one language over the other?
C# by the way. And interesting enough, coming from a web development background, yes. And I love JavaScript.
Same with me.
But also I like C# is more strongly typed on the Unity side, yes. So you can get away with less, which is good from an architectural standpoint as well.
Absolutely.
All right, so let's start talking about the intro and interface to Unity. Unity is, let's talk about what it is and what Unity is not.
Sure.
Unity is a game engine, but more importantly to me, it's also an ecosystem. I mean, there's tons of game engines out there, some very good game engines out there. Some work in the web browser, some work across a console. What matters to me is the ecosystem. We're going to talk about the Unity Asset Store in a little bit and how that kind of fits into this. Unity supports more platforms than any other publicly available tool that I could find. And we deal, being with Microsoft, many cross-platform products.
Yeah, middleware is our friend.
Yep. Xamarin, I mean, even if you go to Azure Mobile Services, they will generate the code for you on our own website to run things on iOS, Android, websites, etc. So that being said, there's really great multi-platform support built into Unity.
Absolutely.
It's used by hobbyists, students, professional developers, major studios.
Yeah.
So this is for everybody. I've had folks mention to me, I'm writing my first game. Is Unity the right tool for me? Yes, it is absolutely.
It really does hit like that broad spectrum of things. One of the few tools, like you say, that really can hit just about everything.
Absolutely. Now let's talk about what Unity is not.
Okay.
And I hesitate to say what it's not because Unity is always kind of adding new things on there. They're acquiring other companies and adding their capabilities into the core product, making it better and better. So Unity is not, though, as it stands today, a 2D image or vector graphic creation tool. In other words, think of like Photoshop, GIMP, Paint.net. You're not going to go into Unity and start drawing out a sprite.
Right.
Matt is going to show you later on today how you can do that. Unity is also not, and I put a big asterisk after this, it is not a 3D modeling environment. There are some very powerful 3D tools out there. There are free tools like Blender, paid tools like Autodesk Maya, 3D Studio Max, there's Sheeta 3D, there's a whole bunch of them out there. But Unity does not have built-in a modeling environment. It does have a terrain system built in.
Yes.
So that is modeling in a sense. You can build out your terrains. I did that about a year ago here for a Virtual Academy session. But it does support many third-party plugins because of that ecosystem.
Huge selling point for that system or this platform because very, very few can even offer that at this point.
Yeah, huge. If this was small, this is huge.
Yeah. And I mean, extensibility is another large key feature for this, because if there's something you don't enjoy about the engine, often you can write that yourself, extend it, and if it's of high enough quality, you can even sell it and make quite a living off that in an asset store.
There are some folks that I believe have made over $1 million off of these asset stores. So keep that in mind. You can sell your own assets on there, 3D assets. Well, we'll look at the asset store shortly. I don't want to get too far ahead of myself, but the asset store is amazing. But in the asset store, speaking of 3D modeling, you can get Pro Builder. There's other plugins as well. Pro Builder is one that I know because Matt uses that. And that allows you to do some rudimentary 3D modeling inside of Unity. So that's why the big asterisk follows that.
Right.
All right, so features and capabilities of Unity. What can it provide you? What can it provide me? And all of you attending today? AAA game quality. It is a good engine for your game. Unity provides an editor, which is what you work in, and that gives you the ability to do level assembly, where you can kind of drag and drop, assemble everything there.
Right.
But more importantly to me, it gives you an in-editor gameplay experience. So you can develop, click play, run your game. Develop, click play, run your game. You don't have to do these separate builds and export, which really makes your workflow fast.
Or even the ability to drag and drop assets into a scene live is a huge selling point.
Yes. Physics. We'll talk about the physics engines in a little bit. Programming with C#, JavaScript, Boo.
Yep,
One day I won't mention Boo anymore, but I still feel like I need to for some reason. 2D and 3D support. So Unity was always a 3D tool to start, and they didn't have built-in 2D support until a couple versions ago. They had various plugins in the asset store to allow you to do that. And now they have added some pretty cool 2D support built in.
Yeah, so, as of November of 2013, that's when they finally added those 2D tools, along with many assets and pre-built scenes that developers can actually use and engage with.
Free stuff you can download and check out and kickstart your 2D game. Audio. 2D audio, 3D audio. You hear a gunshot in the distance over there. You can hear from your right-hand side, gunshot over there, left-hand side. Backing tracks. It supports a bunch of different audio formats. Very powerful audio there. And particle effects, one of my favorite things.
Absolutely. Shuriken's a beautiful thing to work with.
If you want, you being you, because you're on the East Coast, if you want snow, for me, I live in California, so smoke, fires, earthquakes, right?
Right.
You can generate all of that through particle effects. You can generate little ghosts coming out of the ground. You can do snow, rain, all sorts of amazing things. We'll look at particle effects very briefly in this as well. And the animation system, 2 animation systems, the legacy animation system and Mechanim, which allows you to do so many cool things. Previously, maybe if you had a character shooting a gun, you had a character running. If you wanted to merge the two, well, you needed a separate animation of a shooting, running character.
Right.
And now with Unity, it will actually blend those on the fly. You can say, hey, from the waist down, I want you to do these animations, which is running, and then from the waist up, I want you to do whatever other animations I apply to it. So an amazing system called Mechanim there. Now the asset store, nearly everything that you need for your game. Complete projects, 3D models. We'll explore the interface real quick in the asset store shortly. It is absolutely amazing what you can find there.
Makes you wonder how we got by before.
I know. Well, I didn't develop games before.
Oh, well, there you go.
I didn't get by it. All right, so let's go right into talking about the environment in Unity. It's all about the scene. And we're going to explore the scene in the interface shortly. Let's just talk about a scene first. Think of a scene as a level in your game.
Okay.
If you have multiple levels, you'll have multiple scenes. And your game is going to be a collection of one to many scenes.
Okay.
Make sense so far?
Absolutely, I'm with you.
Scenes are what's included in your build. In other words, when you provide a game to someone, it's because you have various scenes that have been compiled and packaged up into that build.
Now, do I have to include every scene that I'm building or working on for my game?
Great question. You do not. So one of the games we're working on right now, I think we have 38 scenes or something in there.
Holy cow.
And there's, I think, 3 gameplay scenes. The rest are all different test scenes and controller test scenes, weapon test scenes, everything like that.
Okay, so it makes it kind of pretty easy to test and debug as I'm moving along.
Absolutely.
And I take the best of each project.
Absolutely. You can have many test scenes, not in the final.
Oh, well, there we go.
Good question. So, I can't say this enough. Remember this icon.
Okay.
This icon is the all-important icon because to folks that are new with Unity, if you close Unity and you go back and you open it, you might not see what you were just working on there. That's because a lot of times you have to go find your scene and open it. You didn't lose your work. You just have to go find the scene, provided that you saved your work. Find the scene. All right, let's open up Unity and talk about the interface here. The first time you're going to open Unity, you will see this lovely dialog box here.
Now it looks like you're creating a new test project.
Call that new Unity project. All of this right here, you might want to do this to start. I know I wanted to do that because I didn't know what any of these meant the first time I opened up Unity.
Right.
These are all various packages, pre-packaged components that Unity and other folks provide that you can bring into Unity. If I want a guy to run around in my world, I can bring in a character controller package. If I want a sky on my level, I could bring in a skybox package.
Beautiful.
If I want, in fact, let me just do that skybox package real quick. So many different packages. Unity works through these Unity packages, and we're going to get to Unity packages a little bit later. Yeah. This here, my friend, is what you were talking about was added in their 2D support.
Absolutely.
So this little drop down here used to not exist because Unity was always a 3D tool. So they've added these, and you can still mix 3D and a 2D game. Actually, a 2D game really is still a 3D game. You just happen to have your camera fixed.
Right.
And Carl's going to be covering 2D in our very next session. So let's go ahead and create this project. And every time you open a project or do a new project, Unity will close, come back in again. And that decompressing, if you saw right here, that's happening. That's because I checked off the skybox package, and it's just bringing in a bunch of sky images right now. We're going to close this little dialog here. And I'm going to go to my default layout, which everybody will see the first time you load Unity. You can always reset your layout. So in Visual Studio, every now and then, because I'm always clicking around pretty fast, moving windows around, it's inevitable. I do this, and I mess up my windows. Everybody does that at some point. You're like, okay, how do I get back to my interface?
Yeah.
You can just change them up here. Go to any layout you want and change them around.
Everyone has their preference. Do you prefer one visual style over another?
I typically use default, and then depending on the monitor I'm on, I will go switch over to 2x3. 2x3 is good because you can see this game tab, which we'll talk about shortly at the same time.
Yes.
So I'm going to start out in default here because that's what everybody, the first time they open it, will see. And in our interface here, this is where we are doing our scene design. This is a scene. And in a scene in Unity, you cannot see anything without a camera. Thankfully, in any new scene, if I do File, New Scene,
looks like one's included for us.
One's always included there. And thank you, Unity, you also give me an audio listener. So you cannot see anything in a scene without a camera, which is there by default.
Yes.
And you can't hear anything without an ear, which happens to be an audio listener component.
This essentially serves as our starting point, our eyes and ears within the world.
Yep. So it's there. You don't have to worry about that. So this is our scene view here. Now, everything that's in our scene is over in this window here. This is our hierarchy window. And this happens to be pretty empty right now because we have just a single camera in our scene. So if I highlight that item, then we get the properties of it over here in the inspector window. And the inspector window shows some basic properties. We're going to talk about these game object properties coming up next.
Okay.
But all these other components get added.
Yeah, it looks like you have a bunch of different things there.
If I want to create a cube, for example, click away from it, click on it, I can see all of my cube's properties. Now, navigating in here, I highly, 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 highly recommend a 3-button mouse. And you're like, well, what is a 3-button mouse?
Oh, you find it's kind of difficult to do this on a laptop touch.
You can do the key commands like Control Alt or Shift Alt right mouse click and then zoom in on your trackpad, or you can pinch zoom. There are different commands that you can use on there.
Sounds like it would be a bit of a keyboard ninja.
Yes, yes. If you are very comfortable on the keyboard, you can do it. Sometimes when I don't have a mouse with me, I do it, but I highly recommend it's a 2-button mouse with a clickable scroll wheel is what a 3-button mouse is. All right, navigating around here, my scroll wheel zooms me in, zooms me out, and you'll find that most of the time that you spend in Unity, in the interface, doing your scene design here, is dragging and dropping objects in, moving things around, rotating around to see how they look, because 3D space is very confusing at first. It might look like this cube is sitting down on the earth, and yet when I go ahead and I rotate, if I move up here like this and rotate, I can see that that cube is actually pretty far above my ground there.
Yeah.
So it's going to take you a little bit. The first time you open Unity, you're going to be a little confused trying to navigate around and moving things around. Right-click to zoom around like that. Click your center mouse wheel to pan. Now this equates also to the icons on the toolbar here.
Yes.
Pan is the same thing as clicking your scroll wheel. And these we're going to talk about shortly when we get to talking about game objects. Let's look at the next window down here, our project window. This is everything that is included in our project. So this roughly maps to what's on the file system here. If I right-click on this and show and explore, it will show me my Unity project here. Now, you might notice that the only folder that you see here happens to be the assets folder. That's because Unity's tracking these for other internal purposes, and I'll talk about those a little bit later on today. Don't mess with these folders. It's typically a bad idea unless you have a specific reason that you know what you're doing.
Right.
Virtually everything you can do in the Unity's interface here. If you need to drag in an image, you can just literally take it from Explorer. Let's assume this was an image, and I can just drag it into my project. So that works. Don't mess with the file system.
And also, it'll update things for you as well on the fly. So if you start adding new scripts, it'll quickly rebuild the project with the scripts in real time.
Absolutely. Because I brought in that skybox, what I'm going to do is I'm going to show you something really cool. Just like that, because I brought in that package. Now, if you recall, that was the skybox little package that I checked off here. Now, any of these packages, you don't have to bring them in now. So don't feel like you have to check those all off. You can always bring them in later through Assets Import Package.
Perfect. Sometimes less is more.
Sometimes less is more because more is more in this case.
Overcomplicate your project, especially when starting off.
Yes, and if you're like me, I'm always running out of space on my system.
Yes.
So these will make your project size grow, and because it's media and files, your project can get pretty big pretty fast.
Yes.
Now, the coolest thing about Unity here is play mode. I click play. I'm going to go from my scene view, and it's going to switch over to my game view here. So I'm playing my game. I can't do anything with here. I can't interact with it in any kind of way because there's no code to do that.
Right.
There's nothing telling Unity to interact with the scene. It's just a camera that's looking out at my scene. And I can do this in real time. So I'm playing my game right now, literally. You see these buttons highlighted up? I'm playing my game. I can pause it and advance frame by frame.
Yes.
So if I need some real fine level physics testing, maybe I need to see frame by frame when objects collide, I can literally just advance frames like that.
You know, something that caught me a few times at first was I would press play, but forget that I had it playing in the background. Is there any way to let me know in a not so subtle way that I'm actually playing?
Absolutely. So every single Unity developer I have ever talked with, and I always call this the most important setting in Unity, has lost work in Unity because of this. So what David's talking about here is I'm playing, and I forget that I'm playing. I come back here, I'm like, all right, let's start designing my level some more. I think that is the best cube of all time. I want to duplicate it out a bunch.
That was a nice cube.
Very nice cube. In fact, it might be perfect. So I've added a bunch of these perfect cubes to my scene.
Okay.
Maybe I like sugar cubes in my sunny sky.
Kind of time consuming to start to add more and more things over here.
Now, when I get out of play mode here, watch what happens. All gone.
Where'd they go?
When that first happened to me, I thought, what is this buggy software? And then I realized, user error.
Yep.
All my fault. So what's happening here, play mode is a playground for you to test your game. So that's exactly what this is. You're playing it, you can test things out, duplicate it, whatever you want to do, tweak settings, see how it looks. When you're done, it goes back to the way it was. There is a plugin you can get from the Unity Asset Store that will actually apply those changes at runtime.
Ah, I need to look into this.
But let's do my favorite setting here. Edit Preferences, Colors, Play Mode Tints.
You notice how it's kind of in its own little setting by itself.
Yes. They should have a big box around this, and when you open this dialog, have like a neon sign pointing over here.
Yeah.
So open that up and choose, I used to do red, now sometimes I'll change the color a little bit.
As long as it's not blinding to the eyes.
And that might be blinding. We'll do orangish because we're coming up on Halloween and not that.
That's right.
Oh goodness, it's
Pumpkin spice.
Halloween. When I play this now, see what happens to my interface? I get actually a very Halloween-y looking interface.
Yes.
We're going to have a Halloween influence theme for you later on today. When we go over 3D game creation, there's a very Halloween themed game that we're going to create. I'll tell you the name of it ahead of time.
Okay.
Zombie Pumpkin Slayer.
I like where we're going with
ZPS.
this. Zombies are the hot thing.
A year ago, we did Dino Burger, where you shot a burger and killed a dinosaur, because that's why dinosaurs went extinct.
Ah,
if you didn't know
that? I assumed it had come down to them eating just poor burgers from time to time.
So we're going to do Zombie Pumpkin Slayer today. Yes, so this is going to be quite fun.
Okay.
I was talking about the Unity Asset Store here, so actually now is a good time to go over to it.
Absolutely.
This can be accessed through the web browser, or it can be accessed inside of Unity through Window Asset Store. This interface always takes longer to load up.
It's got to kind of pull in all the background data, get the latest updates to the store, what's hot and happening today.
Sometimes what I like to do is while that's loading, I just take that window and I dock it there just so it's always there for later. and that loads up. But typically my workflow is I go through the website. I like navigating this more.
Looks like a little more space to work with as well.
I might find, let's say I want a soldier character pack from Mixamo. Mixamo provides characters and animations in the asset store, as well as a couple other cool products. But you would say open in Unity, and it's going to say, hey, we need to launch this off in the Unity. Do you want that? Certainly.
Perfect. Deep links right back into Unity. Now it looks like we're...
Import, because this is already on my system, or if not, download and import.
Yes.
Bring it right in your project.
So it looks like it's basically a zip file containing all of the items that would be contained.
For the most part. It's a Unity package file, and we're going to look at that shortly, because Unity packages are pretty much everything when you're dealing with redistributable content in Unity.
Okay.
So that actually came into my, let's go back to my default view here, soldier character pack.
There we go.
So just like that, I've got a soldier. This one was free. You can buy animations in Unity's asset store and apply it to them. If I want, maybe, let's go back here.
Looks like you can search by categories and everything. Type in a text field for what you want.
Because, again, Halloween is coming up.
Yeah.
Scary, scary zombies. If I need audio for my project, same thing. Now, for the folks that are learning Unity, one of the things that you want to be very aware of here is they have complete projects here. And that allows you to go in and pick it apart and see things in here.
Beautiful.
Now, in order to do that, though, you don't open a project folder. So, for example, in Visual Studio, you open up a solution, or you open up a C# project file or VB project file. And here, you actually import it into your project. Same exact thing that we just did with the soldier models.
Okay.
You do here. You would go into a project. You would say open in Unity. Okay. It loads it up in Unity's interface here. I reset my window layout. That's why it's undocked now.
Okay.
And once it loads up, you basically bring it into your current project.
Yes.
Once you bring it into your project, you have to look for the files. And so rather than downloading a whole nother one here, let me just save this scene first. We'll Control S. We'll call this main. I'm going to open a project I just had. This one was called Demo, where I pulled in. Let's find my scenes. Remember I said the scene file icon?
Yeah.
Like the most important icon. I have to go in and look for that. I brought in one from the asset store called Destroy City Free.
Okay.
And in here, I can just search for my scene.
Ah, perfect.
I've got two scene files in here. I've got my main one here, which is just kind of an empty demo test scene.
Okay.
I've got Destroyed City. Let's go back to my default layout here, so you can see this a little bit better.
Now, will you often create a folder specifically for scenes? I mean, what is your way of organizing your project?
I do. I'll have a separate folder down here just for scenes, for my scenes, and you will find that a lot of packages you bring in from the asset store do things in their own kind of format. Yeah. So this is Destroyed City, and then in there they have a scenes folder. They have prefabs, which are typically the buildings and things you would place just like that. Okay. Place our own building in there. That's not really lined up.
But as long as the folder is inside the assets folder, Unity will be able to see it, correct?
Yep. Everything must be in the assets folder, your very top level folder. Just like that, for free.
Wow. Yeah.
Pretty cool.
Lighting, environment.
And in this level, I can jump like a superhero.
Perfect.
So just like that. Pretty neat, huh?
Absolutely. So now if I've downloaded some of these projects or scenes before, assets, how can I go back and get them again? Is there a bit of the interface that I can find them?
Excellent question. So going back into the asset store, and then we wait for this one to load up again. I should have docked it and kept it there.
Well, the store is pretty large in all fairness. Quite a few good things to find in there.
I heard, I'm not sure if it's true or not, that they might be rewriting this little interface here. So maybe the speed will be the same as the website.
Time is of the essence.
Time is of the essence.
Okay.
All right.
There we go.
So the asset store interface is here, right? We just covered that. If you want to see the packages you already own, you go to this guy right here. And here are all the ones that I've bought over time.
Perfect.
Caution, the asset store is like, if you're familiar with the shopping channel, QVC, or
yes, of course.
Any of the... so they always have really cool specials in there, and they are real specials like this. 24-hour deals, $75. In 24 hours, this will be back to 150. So when I see these, I was like, ooh, I've got to buy them.
Yeah, I'm equally as guilty.
Hence my asset list kind of grows and grows and grows.
Yep.
All right, let's talk about next game objects and components in your scene.
Okay.
Game objects are everything. Everything. Virtually everything that's in a scene is a game object. So whether you're talking about lights, particle systems, those 3D models we brought in,
okay.
Heads-up displays, everything is a game object. If you are a .NET developer, think about system.object in
It's really like
.NET.
the most base level thing we can get down to.
Yep. In .NET, virtually everything, not everything, but near everything inherits from system.object. You can kind of think of that same concept in Unity as a game object. It's simply a name, tag, and transform, and I'll show you those properties inside of Unity.
Okay.
And the transform is very, 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 very important.
Yes.
Now, on game objects, we have components. And that's what makes things happen. Because a game object itself is a simple object. Name, tag, and a transform.
Right.
It's
basically a container for everything.
It's a container, right? It's an empty location in space. Game objects come to life by having components added to them.
Okay.
And that includes a whole variety of different components. And your own custom components as well. You can develop mesh renderers, sprite renderers. If you want to do audio in your scene, that's also a component, an audio source component. Your camera comes to life by being a component. Everything is from components. This is actually a guy from something that we're working on here called the Reaper Wraith. This complex 3D object, if you look at him here, on the inspector, he's got an animator, a capsule collider, a rigid body. He's got some scripts on there, things for navigation. So everything comes to life through these components. So let's look at what a game object is, what some components on it are, and hopefully that'll kind of fit together a little bit more here.
Okay.
Let's go back to Unity. And I'm going to create a new scene here, because remember, we can have many, many scenes in our project.
Like you said before, scenes are the equivalent of levels.
Scenes are the equivalent of levels. Some folks actually have multiple levels built into one scene.
Right.
You can do that. I typically break them apart by one scene equals one level.
Yes.
My title screen will be one scene. Level 1 is a scene. Level 2 is a scene.
Yep.
Typically named like that too. So here I'm back to an empty scene. On the game object menu, I'm going to create an empty one. So I have an empty game object. Notice right here these properties. On my inspector, I have a name, a tag, which is just some text to assign to the object. And you might be saying, Adam, why would I assign text to an object?
Yeah, why would I? It sounds like I'm overcomplicating things right now.
Because typically in Unity, when you ask the system to find another object,
Yes.
maybe you're a zombie looking for the main player. You
Okay.
typically don't ask for an object by name. You can. You can say gameObject.find and give it a name of an object.
Sounds like it might be kind of expensive if I have a lot of things in my scene.
It's expensive, and some scenes have thousands of objects.
Yeah.
So searching by, and also game names can change. So if you're trying to do gameObject.find on a name,
Yeah.
if you have a cloned zombie, maybe you're creating at runtime multiple instances,
Okay.
his name is no longer zombie. It's zombie parenthesis clone.
So it sounds like they're like doing that and incrementing numbers perhaps as well.
So you don't want to do it by name.
Right.
Unless you know that the name won't change.
Yep.
So the other thing is here, using a tag. You can add your own tags. Unity gives you a few built-in ones. If I want to add my own, I say it's an array, so I have to kind of size it out here. This could be zombie. Or maybe I want to find my gravestone, as we might be doing. Not strong. Gravestone, as we might be doing later on today. When I go back to that game object, or any game object, I now can see that that's there.
Okay.
So game object, we have name, tag, a layer, and a transform. Transform is basically the most important property inside of Unity. This
I would
is
agree.
where your position is. So notice as I'm moving this guy around, my position's updating. The rotation of this and its scale. Now these equate to these buttons on the toolbar here. So this is position. This little widget here, I'm moving my position by that icon. And notice I can click on the center here and move it around, approximating 3D space, because I'm working in 2D space, but it's approximating 3D space.
Yeah.
Or I can do it by direction, by clicking on the arrow tip. And this is what I do 99% of the time. I use the arrow tips to kind of just really gently place my objects where I want them here.
Yeah.
This one here is rotate, and now it turns into, we get these spherical lines here that we can click on a line and rotate a game object.
Okay.
And then this last one is scale, if we want to scale it out. So if I create, let's go back and create a cube, which is a game object.
Looks like you can scale on each axis as well.
I can go like that, scale it out there, or I can just then scale it. Now, caution, scaling at runtime can be an expensive operation. Sometimes you need to do it, but typically you want to make sure your assets are scaled coming into this.
Okay.
All right, so now our components here are what brings us to life. This is an empty game object. Notice we have these properties right here. Every other component will have, every other game object will have these same game object properties,
Okay.
plus a bunch of components added to it here. So my camera has a camera component, a GUI layer, audio listener, flare layer. My cube has a box collider. We'll talk about that in very, very shortly.
It's like you're adding more functionality here as we're going
Adding
along.
more functionality. If you're a developer, if you ever heard of the decorator pattern where things kind of add on,
Yes.
similar, although this is kind of a visual aspect of it. If I want to add codons here, we'll look at that very shortly. We're going to use these components as well too. So and again, save early, save often. Control S or File, Save Scene. So we want to call this, after I get my caps lock off, level 1. Okay. Next, let's talk about prefabs and packages. This is how we reuse things inside of Unity.
Absolutely.
In the Unity interface, we can have we can create our zombie.
Okay.
If we want that zombie to go outside of our game, and or we want to use it in multiple levels, we have to create it in some redistributable way.
Right.
We might have downloaded it from the asset store. In that case, it's already in a distributable package.
Okay.
But we're going to show you how to create those right now.
Okay.
Ready?
So reuse is essentially what we're trying to sell here.
Reuse. Prefabs allow reuse across your scenes.
Okay.
Also within your scene. So you might have that zombie you want to duplicate a bunch of times within your scene. The advantage of using a prefab is if you update that root prefab, everything else that was formed from that prefab gets updated.
Perfect. So make a change to perhaps its speed or its health size.
Yep.
Affect all.
As long as you click that prefab object, everything else gets updated.
Perfect.
And now Unity packages is a separate concept. That's actually a .unity package file as opposed to a .prefab file. When you download something from the asset store, it actually gets cached on your system locally in a folder as a .unity package file. You can click on them. I have a whole folder of them that I use for reuse on my project. You double click on them, and it imports in Unity.
Sounds like it's going to save you a lot of time.
Tons of time. Tons of time. So let's look at a quick demo of prefabs and packages.
Perfect.
Let's open this old city again here.
Okay.
Because this would be a good example of how you'll find some content gets distributed to you. Let me zoom back here a little bit more.
Yeah.
So if I look in the destroyed city, here's a prefab folder. And if I click on this, notice it says something.prefab here. I click on that prefab, drag it into my scene. So I can now reuse it. Let's just say on this building, maybe I want the sound of wind coming from just this building, or all my buildings. Some audio source. I can add an audio source here.
Right.
Now, I added it here, not to my prefab down here. I added it in my scene. So there's two ways this workflow can go. If I look at my scene's prefab right now, it doesn't show my audio component.
Right.
So I can actually push from my scene back down to this guy, which in turn will update all of my other buildings here.
Okay.
So if I click on another building, there's no audio component. If I click on this building, it's right there. So let me click on Apply. It's now pushing it down here, and it should have pushed it back out to every other one that stems from it.
As long as
Look
your
at that.
character gets closer to these buildings, you can start to hear the sound effect and noise coming out of them.
Yep. So now as I click all these other buildings, notice there's an audio source on them.
Yeah, you must have 20 or 30 buildings in there, so it
Lots
sounds like
of
it saved you a
buildings.
lot of time.
Absolutely. Especially when you realize you made a mistake and you
Yes.
need to correct it. So let's create really a simple one so you can see. We'll do a new scene. Don't save that. I'm going to create, let's do a cube and an empty game object. Let's duplicate that cube a couple times. Move this guy over. We've got two cubes. I'm going to rename this game object to awesome, can't type today, awesome cubes.
Okay, so game object is the default name for any of these.
Game object is the default name. You got it. So I can take these cubes and I can do one thing called parent them, so I can drag them into here.
Okay.
They become a child of that. Now that means that any time that I basically move this parent object, the children follow. You see them both there kind of following with it. Mm-hmm. Now I say these are the best cubes of all time. I want to reuse these all over the place. So
Very fine color.
very, very fine cubes. So if I take these cubes and I click on them, notice they're white or kind of this grayish color. We'll call it white text. If I click on them and drag them down, let me create a folder here called prefabs, just so we can be a little more organized. Create folder, prefabs. Go into that folder, and now let's take this guy right here for my hierarchy.
Okay.
And just simply drag it down. I'm going to drag it down here, drop it. Notice his color turns blue. That's telling you this is a prefab. This has a shared instance somewhere. AwesomeCubes.prefab. Now I can drag this AwesomeCubes.prefab all over my scene.
Yeah. Looks like they even took a little snapshot for you, too.
If I, kind of see these little guys here. If I expand that, I can see the children that they contain. Okay. Maybe on one of those cubes, I want to add, just like we did before, an audio source. So I added just an audio source to this guy here. Not in my scene yet, but look what's already happened. You see these little speaker icons?
Yeah.
All of them now have that audio source on them. Audio source.
So it looks like you have the option of editing all of the prefabs, or if you want, just one at a time.
Yep, absolutely. Now, if I want just this one here to have, I don't know, audio chords, let's actually do a rigid body, because we'll be looking at that next. If I do a rigid body on this one, because I did it in my scene here, it's not going to apply to anything else, which is exactly what I want. I just want this one to have it, nothing else. So the rest of them don't have them, just this one. If I want the rest of them to have them, click on Apply. It gets pushed down to this guy, and then back into my scene, so all the rest of them should now have the rigid body component, and they do.
Looks good.
Very, very easy. All right. So architecture on Unity is something that I think everybody needs to understand, how this fits together. Inside of Unity, we have a couple major components. We have the editor. We have MonoDevelop, which is the built-in code editor. It's a cross-platform code editor. It's not made by Unity. It's another third-party company.
Yes.
And that's used. You can actually download that and play with that as a whole separate product. And it has a game engine built into it. In the editors we saw, we can test right inside of there. You can extend it through scripts. It's a very powerful way of developing your game. The project structure, we looked at the folder on disk very briefly. In there we have the assets. That's always a top-level folder you see in Unity.
Okay.
Everything you bring in your project goes in there or a subfolder thereof.
Seems simple enough.
Yep. Now, all the other folders, library, project settings, and temp, that's for stuff that Unity does. If you don't know exactly what's in there, don't mess with it.
Right. Probably best to leave it alone.
I list there on the screen if you're interested in knowing what Unity does with that, but it is best to leave them alone.
Okay.
Compilation. Well, we're running code, so something has to get compiled.
Right.
We're doing objects who can have code on them, so behind the scenes, something happens. Mono is always used in Unity to compile your scripts. Now, compilation in Unity might be different than your final build.
Okay.
So Unity is using Mono. Maybe if you're going to Windows Store, your final compilation will be actually .NET.
Right.
So just know that Mono is what's used to compile the scripts. Unity licensed a version of Mono, and so that's what they maintain and use for the editor.
Okay.
Your exported Visual Studio project, like I said, for something like Windows Store, that could be generated by .NET. If you're doing a desktop build, it could be generated by Mono. So there's different ways that can be used inside of Unity.
Okay.
Compilation varies per platform.
Yes.
Multiple levels of compilation. In the editor, mono, as I mentioned.
Seems simple enough.
When you then export your project from Unity, as Jason will show you guys later on today, how to bring your game to Windows, those game assemblies are then generated by it's either Mono or .NET, varying cases.
Okay.
Then in turn, let's say you compile your Visual Studio project, or if it's a Windows standalone build, Unity will actually compile that for you. And that's generated then by potentially another one. So there's different passes that happen here.
Okay.
Sometimes it's important to understand which, because there are different API. Windows Store supports a different API
right.
than, say, desktop build.
So it sounds like some pretty low-level stuff, but do you think it's worth very beginners to spend time on this, or is this kind of once they get further down the road, maybe they investigate some time?
It's good to spend time when you do your first build, because
yes.
That's typically when you're going to get bit by it. So speaking of build and compiling everything in code, let's talk about code.
Okay.
Game loops are per game objects. So in Unity, you have this concept, and actually in game development, of a game loop. That's where everything happens. The C# that's supported, since we're going to talk about C# today in Unity, supports pretty much most of all the major constructs you'd be used to in developing with C#.
Okay.
You can do link, lambdas, anonymous methods, events, etc. Do you have to code? Some folks watching today might not be coders.
Right.
I definitely recommend. I think it's great for everybody to learn code, but not
yes.
everybody codes. You don't have to. There are other third-party plugins for the Asset Store. Playmaker, Behave, Rain AI is a free one.
Yep.
So Playmaker and Behave are paid products. And they're kind of visual scripting trees, so you don't have to code to be able to use them.
Right. And I think it's one of the big selling points for Unity itself is that it's not as intimidating to a lot of developers out there because it's so appealing to artists and designers as a whole.
Yes, absolutely. Unity has 2 physics engines that they use.
Okay.
One, they've licensed the physics engine from NVIDIA, which is used by a bunch of companies. So is it any good? Well, Unreal's using it, Unity's using it, Game Real Vision, etc. There's a whole bunch of folks using it.
That's right.
And a lot of folks today may have heard of Box 2D. Mm-hmm. I know we've all heard of it going into before we even knew about what was going on with Unity, actually. And that is used for the 2D engine inside of Unity, and a bunch of other companies are using that as well. And 2D physics are typically faster than 3D because you are...
One less plane to calculate.
One less plane to calculate, you got it. All right, so let's look real quick at coding, physics, and particles. And actually, as we go to Unity here, I do realize there was one quick thing that I left out last time.
Okay.
I mentioned I would also talk about exporting packages. You've created your prefab. You realize this is awesome. You want to reuse it or sell it or give it to someone else. You just simply right-click and export package.
Okay.
There you go. This will export package into a .unity package file. We'll put it on my desktop where everything goes. Call awesome.
And now people can use this in their other projects as well.
Now you can use it in your other projects. You can just double-click on it. It will import right in your project.
Perfect.
Of course, I already have it in this project, so we don't see anything. For this code demo, we're going to, we've got all sorts of cool options here. We're going to do this guy here. So code in Unity. Let's create a new scene again.
Okay.
We'll call that level 2 for the last one.
Simple enough. I like it.
We're going to create another cube. It's a real easy base primitive to work with. If I want to create code in here, I like to create a new folder, and I call that folder scripts.
I do the same thing.
You don't have to. You can drop it like I did here.
But it's good to stay organized.
Good to stay organized. Right-click, create, JavaScript, C#, boo. Let's go ahead and create C#. We'll call this my debug demo.
Okay. I always like that you can see the code itself on the right-hand side, too. Very appealing. This way you can quickly glance at what you're doing.
Now, we could use mono-develop here, but since we have made Unity VS for free, I've installed it on the system. That shows right here. You have to import it into every project. So Visual Studio Tools.
It's a package like anything else.
Import it in. It's going to create a folder down there. Unity VS, we're good to go. Double-click on this guy.
Yep.
Now this code, as of right now, is not going to be doing anything. What we're going to do, Unity gives us 2 methods. Start, for when this particular object, whatever this code is assigned to when it initializes, debug.log starting.
Okay.
And over here, we've got something called update. This runs every single frame. So that how often is that? Depends on how fast your game is running. It could be 60 frames a second, 230, just all depends. This changes all the time.
Absolutely.
And what we're going to do here, since I mentioned that transform is probably the most important property,
right,
we can just reference it from whatever this code is assigned to.
Okay.
You'll notice this inherits from mono behavior, and that basically allows you to integrate with these game objects. So let's use this code. Right now, it's not being used at all.
And you can see right away it's updated on the imported object on the right-hand side.
You got it. As soon as I switch back to Unity, it detects a code change, does a background compilation with mono.
Yes.
So I'm going to drag this script onto my cube. As soon as I do that, I can see it's just another component here.
Perfect.
This tells me this code is going to be run on this object. I click on play. I can see it moving.
Yes.
Every frame it's actually being called. And let's go to my console, which is kind of like your debug output window, and I can see starting. Got called once there.
Okay. So we know that function was executed, that start function.
And so this little guy here, transform.translate, this is saying we want to move our transform. And we could actually do, if we look transform.position, we can see our .x, our .y, our .z. And that represents where we are in the world. We saw that as we move an object around, it updates these. So when I say transform.position.x, it's giving me that. Transform.position.y is giving me that. Every single frame here, I'm coming over here and just simply saying, I want you to move forward. This is a predefined vector, it's called. We'll talk about vectors a little bit in our 3D. And this is saying, hey, every frame, we're just going to advance this by a little bit in the forward direction. Forward, in this case, is wherever the object is currently pointing. So if I come in and I rotate this object here, notice it's forward. There is a world forward, which is always the same direction.
Yes.
This is the local forward. And that's why we actually use this translate call. We're saying, hey, go to whatever's forward for this current object.
Okay.
It's forward as opposed to our world forward. So we have several different coordinate systems here. We have our world space, and we have our local space.
Yes.
And we can say move forward in world space or move forward in local space, which is what we're telling it right here.
But relevant to that actual character or object.
Debug.log updating.
Log is your friend because it'll constantly keep you informed of what's going on behind the scenes for your project.
And let's do this. Set a breakpoint. I'm going to say attach to Unity. Build. Go back over to Unity. Give it 1 second here. It's doing this background attach. Wait for it. Are you waiting for it?
I'm waiting. I am very patient. There we go. Looking for Unity. We found it.
Connect to Unity. And it looks like at this point in time it's having a problem connecting. Of course, the demo gremlins came down from the cameras right into my system. That's OK. So what we will do here is we will... Everybody's seen this before?
That's our task manager, so we can see how our machine is utilizing different parts of our project or our assets at once.
So I closed Unity out. It happens on occasion. It's I would call it more rare, but always save your work. Save early, save often.
Actually, we'll have an entire course on this very shortly in the agenda.
Absolutely. So what I want to just show you was how we had attached code to any kind of game object. We can just literally take it, drag it on up, and that code runs for it.
Yes.
Second last thing we'll talk about real quick, physics.
Okay.
We're going to go into this more depth in our 3D course, and then we'll cover particles. So physics, real easy to show. We'll take a game object here. Actually, I think we added a rigid body here. So our game object, we did a cube. On that cube, we added a rigid body component. What is a rigid body? If anybody remembers from high school physics, this is what's giving your object mass.
Okay.
And it's allowing it to understand gravity by default.
Okay.
If I click on play right now, this guy's falling.
Look at them go. All of them.
All of them. They all have that because I added that to that prefab before. Now, they don't understand collisions yet. So if we want to add a collider onto there, it's actually a box. Collider's already on our cube. But we can add colliders. And I think Carl's going to cover that in 2D next, and I'm definitely going to cover colliders when we go over the next session.
We don't want to get ahead of ourselves.
And lastly here, let's go ahead and create a particle system. Just like that. Notice these are coming out like wireframes because I have my mode there to textured wire.
Ah, there we go.
Look at that. Just like that, we've got a particle system coming out. I can say my start size. Maybe I want more smoky effect, make them bigger.
Yeah, look at all the variables it exposes to you and how easy that is.
50. There we go. We want smoke. You got smoke. You want small particles like that. Perfect. You can apply so many different parameters here.
Rotation, speed, color over time.
You got it. I mean, you can do so many things in here. What people do with the particle effects, amazing.
Yes.
There's a great tutorial on Unity site, like an explosion. One particle effect creates a ring. Another one creates an explosion effect out of it, so you can overlap the two of them together and do some really, really neat effects.
It's really part of juicing or increasing the quality of your game, having something as simple as that.
Absolutely. That brings us to the end of this fine session. We talked about intro to Unity, the architecture on there, how we can just simply add code onto it. Now, granted, our code example was pretty simple to hear. We don't want to start out too strong with the code on that.
One step at a time.
One step at a time. Carl's going to cover it more. I'm going to cover it more. So we're going to definitely look at these concepts a little bit more in depth as we get into actual game development as we go on.
Okay.
Talked about game objects. Everything in your scene is basically a game object.
Yep.
Near everything.
The asset store.
Asset store. Components, because components are what brings your game objects to life. And are you excited for what's coming next?
Absolutely. We've got 2 more days of this. Today, tomorrow, and I believe on Thursday, we will have other guests in here.
Yes. Now, I want to mention that this module is currently being recorded, and it will be available in about 2 to 3 weeks on Virtual Academy if you want to rewatch it then as well, which I highly recommend.
Absolutely.
The entire course, everything you see here today and tomorrow. Thank you very much.
Hello.
and welcome to the next session. In this section, we will cover how to make a 2D game. We're very excited about that. How we can actually use artwork from the asset store and create a game in less than 40 minutes.
So right here is Carl Carquoy, who's the head of Uni Evangelist, and I'm Tobias Marks, who's the game evangelist at Microsoft. Why don't you tell us about yourself, Carl?
I've been working a long time in the game industry. I'm very excited about that because I used to work on AAA titles, and then later on I went to work on indie titles. And there I found my passion. And from there, actually, I joined Unity to share the knowledge of our community, through our community, for our community, and share the knowledge of our devs to our community too. It's very exciting. In the last years, we've seen a tremendous growth on a lot of indie games. And I keep playing them, keep buying a lot of games, thanks to the community.
I'm all about indie games as well. When I graduated college, I started my own game development company making mobile games, and I was able to run that for 4+ years or so until I joined Microsoft as a game evangelist, where I get to talk to game developers like you guys out there and help them out and do cool stuff like that. And I'm based in Mountain View, California. You can find my blog right there if you want to find information. So what are we going to cover today?
Today we're going to cover how to make a 2D game. I can show you actually my screen here. It's a simple game where we press the play button here in Unity, as Adam talked about. And what we see is here we see the game. We can start the game and then start to play the game. When we pick up objects and jump. And what we're going to do is we have to avoid also some objects here. If I don't avoid it, I die and I get my points. I can play again. So we're going to create how to create here a menu, how to create a character, the animations. Okay. So I'm going to open here the scene next that I have here. This is the scene. Mm-hmm. Let me go to here. So this is the character. Okay. And what
this is a 2D scene too, so the settings are all set up for 2D.
So you can see here the button 2D. Okay. And I can click on that, and I see now the scene actually in 3D. But I can go to 2D here. Okay. And what we're going to have to do is first we're going to have to create this environment. Okay. Like one of those building blocks. Mm-hmm. I have here a prefab. Okay. Another prefab here. And move this around. Like we're going to create those building blocks. Okay. And what we're going to do is we're going to have to make an endless runner. See the character running. So we're going to have to move those objects forward. When my character moves one of the components here, we're going to move that forward. Mm-hmm. Yeah. What we also have to do is actually create our character here, place it in the scene, and make the different animations for it. And also define when we're going to run, jump, and fall.
Between those animations.
Exactly. And then the cool is the game aspect we're going to create is picking up those objects. Like here we have a fuel can. Mm-hmm. Okay, here you can see, maximize my screen a little bit. So you have the fuel can here. We're going to have to pick up that fuel can, and we're going to get points for that.
And that's actually going to involve some scripting too.
That we're going to have to create scripting for. Right? The basic will be really focusing the beginning for the artists, like how to bring in the artwork, place it there. And then we're going to have to do the scripting of the character moving, the character picking up, but also playing the audio file, and then avoiding the dangerous part. I have here let me show you here the lasers. And where we have lasers, so we're going to have to avoid those objects and jump over. Otherwise, our character game over. Exactly.
All right, sounds great. Where do we start?
We're going to start with the artwork. So what I'm going to do is I don't want to start with a whole project here finished. I like to start with a total empty project so that you can see everything from begin. So you don't have to. You can start from the beginning, really scratch empty plate, and we're going to start with that. So you don't have to know something really from the beginning. So what we're going to do is a new scene, a new project actually. Okay, we can give it a name here. We're going to give it here. 2D game. Okay, and we're going to start with that.
Yeah, remember to make sure the setting's set for 2D.
Oh yes, this is a very good point to point out here. We have here the setting 2D or 3D. The 3D and 2D, it doesn't mean you're going to make a 3D game or a 2D game. It's all about just make it easy and fast. When you're going to make a 2D game, it's the import settings. Okay, so to show
you can change those after you make your project. So if you make it the wrong way, it can be done. But for the defaults, we want to make sure everything's set to 2D.
Yeah. So what I'm going to do, I'm going to put it wrong. And I will show you how you can change
Just to show where those settings are?
Yes, exactly. So we're going to create a project. And we don't have to save this project. Okay. And we're restarting Unity. So we have an empty project. Okay. And what we see
looks
is
like it's 3D at the start because we did the wrong setting.
Yeah. Oh, sorry, I clicked the wrong shortcut here. So what we see is here, it says here 2D, but it's actually a toggle button. Very good to point that out. So when you click on the 2D, we see nicely here the screen now in 2D.
And that's just changing the way we're viewing the scene in the editor. It's not actually changing the project settings when we hit that.
Exactly. You can combine 2D and 3D in one project.
So where do we change the import settings?
Very good. So we can go here to Edit, and in the project settings, the editor, this is how our editor behaves. Okay. There we can say, instead of a 3D mode, we can say, when we import textures or images, put it 2D. Okay. But I can first show you the differences, so that you really can understand what the benefit of that is. Okay. You're going to go here, and I have here all images that I have for my game ready.
All the ones we just saw in the previous project?
Yeah. All those images will be available on the Asset Store, totally for free to use. Okay. So I'm going to go here maybe to one of my environment objects, and there you can see I'm going to take here one, and I drag and drop that into Unity in the Assets folder. That's how we import an object. Okay. You see it here? If I want to drag and drop that now in my 2D scene here, it doesn't work.
That's because it's a texture.
Exactly. This is a texture here. I can think of the texture here. So in order to bring a texture into my scene, I have to actually create a 3D object. And I actually like a quad or something, a plane. Okay. To zoom in, I frame on this object here. Okay. And what we're going to take that texture and drag it on top of there. Okay.
But that's what you would do if you're doing a 3D game.
Exactly.
But for a 2D game, there's a much easier, more optimized way.
Yes. So let me show you the differences. Like, I'm going to put it here to a transparent so we see the object here. What we're going to do, we're going to duplicate this object for the moment. And what we're going to say, instead of a texture, we're going to put that to a sprite.
And that's, you're changing the actual asset in your assets folder from a texture to a sprite.
Exactly. So this is an asset that we can use over and over. It's in our project folder. This is actually our hierarchy. The hierarchy is then what's actually in our scene, in our game, okay, on level based.
What instances are currently in the scene?
Exactly. That's a really good way to put it. So here I'm going to put it to a sprite, okay, and I'm going to press apply. And I'm going to take that object and I drag it in here. It's a bit bigger. We can scale it easily, but there's a huge difference. Okay, and let's look at that. Okay, this is a sprite, and this is done with a mesh render, and this is done with a sprite render. Okay, what the difference is, and I'm going to show you here when we go to our overdraw. Okay, there we see the differences.
So what exactly are we looking at here?
Okay, so overdraw is basically the amount of pixels that are drawn on the screen or on top of each other. Okay, what we see in order to draw this object, we have to actually draw all those pixels here.
The two triangles to form a quad 3D object.
But we putting this all on the GPU to render all those pixels here. In this, we're only rendering actually the object itself.
Much more optimized then.
Way more optimized. And this is actually done because this object, when we go here to wireframe, so here we have the wireframe for this. It covers all the area here. So we're rendering actually all this alpha channel here. And here not. We remove that. We only keep the mesh for that.
And it's all handled for you automatically. You just drag and drop the sprite into the scene. You're good to go.
Nothing to do. Just drag and drop, and it all gets optimized for you.
Excellent. And if you had done 2D as your default settings when you create the project, all the image files that you drag into your assets folder will automatically be set to sprites.
Exactly. So if I go here now I'm going to delete this all. I don't need this. So I'm going to go here to my project settings in the editor. And we're going to change that to 2D. Okay. What happens now is when I import...
Can you show us where that menu was again? Just
here.
Emphasize it. It's under Edit, Project Settings,
and the Editor. So it's how the behavior of our editor. That's what we want to change. Okay. And what we're going to do is now we're going to import all that artwork in one shot. So that's really cool. You don't have to drag and drop one in there.
Just grab a whole folder.
I take hold the folder, drag in the assets folder, and nicely they get imported all of them and automatically converted to a sprite.
Excellent.
Yeah.
Very handy.
So let's give it a second here. Okay. And the cool thing is, even when it's a sprite, you can always change it afterwards to a texture. You can duplicate it. You can use for multi-purchases. So, and there we have all our images now. So look, we have the environments here. So let's start to create an environment for our game here. Okay. And I'm going to take here my environment and drag it in here. Okay. We don't have to have wireframe. Just going to see the texture mode. So what we see is here. This viewport is my scene where I'm going to actually make my game. Okay. This is the viewport to my game. That's the final result we see in the game itself. So I'm going to place this object here. Yeah. And let's take here the beginning. Okay. Let's take this object, drag it in here. Okay. And let's take this object here. That's the foreground. Okay. So what we see is the object should be inverted, and that's really cool. You can actually just do -1 here.
So you're changing the scale and the transform.
Yeah. So instead of in this way, I want to actually in this way. So I do it -1.
And exactly -1 would be exactly mirrored.
Yeah. But actually, you can do it faster. You can actually select all the objects here in the scene and scale them all. There's no transformation. So we're going to do it here in here, but we can do it multi-select here and then put it all to
in your scene view.
Yeah, -1, and that's done here now. So, and we can place it nicely, snap it to there, place it there. Okay, take this object and we're going to place it here nicely. So we have already created that beginning aspect. Okay, what you start to see is here, look here in the game, it looks incorrect. It's rendering this object in front of there.
Yeah, because the game view is what your camera is seeing. And the scene view is just your editing view.
Yeah. So it could be more dramatic if I start to, like say, I'm going to go here to my character and I take one of my characters here. In here. Oh, I'm sorry, I'm going to put in the scene here. So it's flying on here on top. But here in the game, it doesn't know what's rendering in the front or in the back. So why is that? Well, when I look here at my 2D viewport, everything is actually
all
flat.
on the same plane.
Yeah. So I could move things forward, but I don't want to do that because everything was designed as flat. And if I bring things forward, it could be closer or farther. I just want everything nicely flat. So what we can do for that is very simple. I'm going to show you what we're going to do. We can go to... we're going to keep our character here for the moment. Okay. We can actually, like in Photoshop, create layers. Edit. Project settings. And here, tags and layers. Tags and layers. Yeah. So what we see is here sorting layers. You're going to open
There's
that.
a lot of different kinds of layers in Unity. So we're talking about the sorting layer specifically.
Yeah.
And the sorting layer just deals with sprites, right?
Yeah. It's very good you point that out. The layers is actually, this one is for the scripting part. Or we can maybe see later if I have much more time. But I'm pretty sure the team members will cover it over the next 2 days.
We're not going to worry about it for now.
No. We have here the sorting layers. Okay, and what we're going to do, we're going to add here 2 layers. We can maybe call it here the level itself. And then here like the foreground, that could be our character. Okay. So look here, our character. We're going to select our character now and say, like, actually when you render in the layer, you're going to render in the foreground. And the other objects, you can multi-select them and say actually in the layer level. So this shows already our character nicely being in the front of this.
So it's going to render all of the sprites that are in the background layer, and then it will render all of the sprites in the foreground layer, which will then mean that the foreground layer is drawn last, and thus it's on top of everything.
Correct. So you can, when we go back here to our tags and layers, what we see is here, the foreground layer is layer 2, is rendered on top of the layer level.
And you can drag those around too if you have a bunch of layers and you wanted to sort them more specifically.
This is actually something I want to point out. By default, if you create something, it will be created in the default layer. So I don't want that. Because in the default layer, it will show it always in the background.
Behind the level.
Yes, exactly. So what I'm going to do, it's just going to drag and drop it in the foreground. So when we import something new, it will always put in the foreground so we can see it. We don't have to worry where it is, the object. Now, when we look at this object, maybe this object should be in front of our character. So we can create another layer, foreground. So we're going to go to our editor. I'm sorry, to the tags and layers. Oh, I'm going to go to the correct menu. open this, and let's rename this character here.
So we're going to have 4 layers this time. We'll have level, character, default, and now
foreground. Yeah. So what I'm going to put my character in the layer character here. Okay. And then this one in the foreground.
So that way the foreground is in front of the character.
Yeah. So now look nicely, my character will come when it comes in the scene.
It's in between.
In between, exactly. There's one problem we have though. Look, I'm going to show you here. I'm going to take one of the other environment objects. Let's say this object. We're going to drag it in here. We also do -1. Okay. I'm going to place it here. Okay. And
it's by default on the default layer, which is above the character layer.
Yeah. So what we're going to do is just put it in the level 1. Okay. But what now is when we put it over there, sometimes we don't know it should be nice in front a little bit or in the background. And especially here with this object also, this is sometimes, you see now, it's rendering in the back, it's rendering in the front. I want to specify that. Okay. But what I don't want to do is create like tons of layers, like level 1, level 2, level 4. It will be too much to manage that.
Yeah, that'd be a crazy amount of layers.
Yeah. So it's really simple in Unity what I did. A very smart trick here. Look here. If I select this object here, okay, what we have here is in the sorting layer, it's set to 0. So in the layer itself, we can sort it again. So it's set to 0. If I'm going to take this one and I'm going to say, well, I'm going to put it to 1 up. Press enter.
This is just an integer value.
Yeah, it's individual. Yeah, it's
whole numbers.
Yeah. So now look, it nicely renders always on top of that.
So it always renders 1s on top of 0s.
Yeah. So the higher the number, the closer to the camera basically rendered. But it will stay in that layer. So this foreground layer will always render on top of that. So in that way, we can easily create here nice structured levels. And let's add a little bit more elements to it. We're going to go here to our environment. And let's say, look, I'm going to take another object here. Maybe this one again. Okay, I'm going to scale it -1. Oh, I'm doing everything. Okay, I'm going to select this one. -1. Okay, nice. I'm going to place it here. Okay. And one of the artists we used, Curtis, I'm going to drag and drop this object in here. Or I think this object. So we can do a little bit differences in there. Place this, I'm going to delete this one, select this one, and we're going to place it there, and nicely we can start
cover up that window.
Yeah. So now what we're going to do, we're going to select multiple objects here, so we're going to select this one and this one and this one.
Make sure they're all in the level sorting layer.
Yeah, that's really good. So what we do here, we're going to put it to level, and take this object and put it 1 up again also. So nicely, it's always on top of rendering there.
So it's always going to be on top of things that are rendered at 0.
Yeah. So what you can do this, duplicate. You can now multi-select also in Unity and duplicate that and place it here.
Oh, look at that, we extend the corridor very easily.
Yeah, and I'm going to place it here. And that's how we start to create our level here. Simple, simple. Okay. Always save. I'm going to save my scene and I'm going to call it to...
Yes, always good to remember to save.
Yeah. Software has never crashed.
Yeah.
Okay. So we have here our level now created. What I'm going to do, I'm going to create like one little button so I can select all the objects in one shot, so I don't have to multi-select it always. So we're going to create here an empty object. Okay, place it here.
So this is a brand new game object that appears in the hierarchy.
Yeah. So it's an empty object that just has a transform on it. Okay. What I'm going to do, I'm going to select all those objects from the environment and drag it just like a Windows Explorer in that object. So it's when I select this object, I can select it at all.
So when you move the parent game object, it moves all of the children, and thus keeps the level piece together.
Well, the problem is that I don't see that object. It's hard to find it in the scene if I want to select it. So we're going to create a simple button for that. And how you do that is here. There's you have this cube here. Okay. When I click on that cube, I can create a button for it. Let's say here a blue button, and now we can call it.
Now, is that going to appear in my game, that blue button?
That's a very good question. No, that's the real beauty. So it appears here, and when I move that object, you will never see it in the game itself. You can make it visible by activating the gizmos here.
So just for debugging purposes.
Debugging, yeah, exactly. So now we're going to place it here. Okay, my camera. Okay, I'm going to place it here in the beginning a little bit. We can change that to ortho. So right now it's perspective. We can put it to ortho, and then we can change the size.
So perspective camera is you're seeing from a three-dimensional point of view. So objects that are farther away will seem farther away than objects that are closer to the camera, whereas orthographic kind of removes that entire z-axis and smashes everything down flat.
Yeah, and because we are making a 2D game, we really want everything flat because in Photoshop our artist designed it and totally flat. So what we want to do is we want to keep that flatness there. Okay, so that's why I changed my camera. You can nicely see that here when I go to a 3D viewport. This is the camera in 2D. If I change the camera to perspective, it's like you see there's perspective eye here. Here. Put it back to ortho, and there we have it. Okay, we're going to go back to 2D. And there we have nicely our level already created with our the beginning of our character. Okay, and I don't need my character for the moment. We're going to delete that. Okay. Okay. So this is the beginning of our level. Let's put the props in there that we might be able to pick up. So I have somewhere a fuel can here.
Mm-hmm.
Okay, and let me go here to I have here a fuel can here. Okay, but what I see right away, and I'm going to delete this for the moment because I don't need those objects here. Okay. Okay, this is really interesting now. What we see is the artist create a sequence of images, and when I play them fast, actually, I get the impression
that it's spinning.
Spinning. If I take one image in there and I place it here, and I'm gonna press play, nothing will happen. It's just
a single frame of that animation.
Yeah. So what we want to do is we want to rotate that. Hey, we want to have that same animation. We want to have that sequence of images. Mm-hmm. So how can we do that? This is fantastic done. It's mind-blowing, I find. You select the first one, and you select the last one, and you drag and drop all those images in one shot here. And notice, is that an animation? Is that actually a sequence of playing those images? Yeah, I can say fuel can rotation.
So it automatically generates an animation, which is why it's prompting you to save.
Yeah. So maybe I can make it a little bit bigger so we can basically better see it on the screen. Okay. Okay. And when I press no play, what we see is this object is nicely...
Now it's spinning with all the images.
Yeah. How can I see that? Look here, I can select that object, and I can go to the Windows animation here. Window, animation, and get the window here. And I can now scrub in the timeline here. So we see nicely the animation. When I open this here...
Each of those little diamonds represent one frame of the animation.
Yeah. This is actually called a keyframe, and each of those keyframes represents one of those images. And here we have the sample rate, the speed. I can change that if I want to rotate faster. I can put it to 24. So when I press play, it runs much faster. So pretty cool to have this already.
Very handy.
Yeah. Okay, so we have one of the collectible objects in place there. Let's put the laser tags in there. Okay, let's go to the obstacles, and we should have somewhere here the laser. Okay, I'll delete those objects later on. We're going to come to that, what it all means. So I'm going to select again. It's here. We get 1, 2, 3, 4 images. I select them all, drag and drop that into my scene. Okay, and I'm going to call it my laser. Okay, and there it is. I can maybe place it here. We can also scale it -1. Okay, let's frame to that object so we have it there. Can put the laser there. What we're going to do, we're going to duplicate it, bring it down.
So now we have 2 laser objects.
Yeah. So we cannot sneak under it. Okay.
And you put the second laser object as a child of the first one, so that when you move the first one, they move together.
Yeah, so I don't have to multi-select, or I don't have to separate select them, move them around. I can do it in one shot. Okay. So when I press play now, what we're going to see is we see the lasers here, and we see the collectible object here.
Awesome,
Okay.
we already got some animation in the game.
Exactly, it's really easy and fun. So this is our first part. What we want to do is now actually duplicate that. Mm-hmm. Because then we can select here the environment, and I don't need the 2 first objects here, the intro. So this is the object I want to duplicate over time in my scene. Mm-hmm. I'm going to make those 2 objects, the collectible, the fuel can, a child of that level, and the laser too.
So there's always going to be a fuel can and lasers in every segment of this level we're generating on the fly.
And what we're going to do is on the fly then say, when we enter one of those prefabs here, activate or deactivate the can. or activate the laser. So we always have, it's always different. It's never the same. Okay. So we have this game object here, and save this. And what we're going to do is we're going to call that like maybe a prefab 1 or something. Prefab 1. And we can now duplicate this. Okay. And I call it prefab 2. Okay. And I can move it to here. See? So now I have 2 objects and I can pool them, so I can later on move one of the objects. But let's first start with the character here. Okay. So I'm going to go to my character here, and I'm going to make my first animation just like I did with my fuel can. I can go here to the run animation. Okay. And
you're going to select all of the images as part of the run.
Yeah. So we have here run 1, 2, 3, 4, 5, up to 13. I'm going to select them. First and last one. We're going to drag and drop it into our scene here. Okay. And again, it's going to ask for an animation. And I'm going to call it run. Okay. And I'm going to go here to my run character. And what we see here, it creates a file run and an animator. Okay, I'm going to quickly explain what it actually is. Okay. So when I press play, what we see is here, we see the animation playing. Okay. In the animation, that has created a file run, and it plays those animation file. It plays those sequence of images. With my character selected here, I'm going to go here. What we see is, here we see the animator. The animator defines which animation will be playing at what time. Okay. So when I select that animator, and I go to the animator, here now we nicely see it. And it's playing the run animation. It's visual stating which animation is playing. When I double click on that, we see the animation here run. And it's click here run.
It's all automatically generated for us when we drag the run in.
Yeah, nothing to do. So it's super easy. And orange means that is the default animation that will be playing when we start the game.
That's when it'll start first.
Yeah. So look here now when I press play, I see my character running. Okay. But it's not moving forward. There's no physics applied to that.
No, it's simply just animated in that way.
So let's start with that. What we're going to do is select our character here. Okay. I can rename this here. I'm going to call it character. Okay, it's easy to find that in my game. And what I want to do is I want to add some gravity to it, because later on I want to jump and add some force up to it, and then we're going to land down.
So we're going to have to code our own physics engine now?
No.
Oh, Unity makes that easy?
That Unity makes it easy. There's a box 2D fully included for it, and just apply to it, and that's it. We made it easy.
Awesome.
So look here, how we do that actually. Let me show you here. Okay, we have our character. I'm going to add a component. We go to physics. We have to watch out here. We have physics and physics 2D. Okay, physics 2D is when you're really going to make for 2D games, and physics is the physics for more 3D games. Of course, you can combine that in games, but I'm going to use here the 2D physics, and I'm going to add a rigid body 2D. Just like gravity. So look, when I look at my game here, and I press play now, what's going to happen is our character falls down forever. Okay, I can show you that here. It's really fun. Okay, when I zoom out here, press play, our character falls down.
Because he has gravity, but there's nothing for him to hit yet, because nothing else has any gravity or physics.
Yes. So what we're going to do is, look here, our character, or here, we can select our level here. Okay. Delete the other prefab, I don't need it actually yet. So what we can do, we're going to add here a little physics to it. So add physics 2D. We don't have to add gravity. The object will stand still. We're going to add a collider to it. So look here, I can do here an edge collider. Okay. Or I should add actually something that I can see, because it's a little dot actually. So I can actually, physics 2D, let's add here a box collider to it. But it's just, it's very small here. You see it's here? Because it's
around the game object, the empty one that we made.
Yeah. So what we can do is hold on Shift, or we can here the size here, move it bigger.
Scale it up in its X and Y.
Yeah, so we can then nicely make it the size, okay, like this. And let's put the center a little bit down, so we're going to place it nicely here. So what we see is here on the floor. So when I press play, our character falls down, but it doesn't hit it with it. Why is that? Our character needs also a collider. It's not just the floor. Both have to collide against each
He
other.
has physics, but he's not colliding with anything because he doesn't have the code for collision.
Yeah. So we're going to select here my character. I'm going to add a component, physics 2D, and I'm going to add a box collider to it. Let's also make it a bit smaller. So the size, we're going to make it smaller here. And the Y too.
So making the collision box around the character a bit tighter.
Yeah. So look, now when I press play, what we're going to see is the character nicely falls down and hits the floor.
Excellent.
Okay, super simple.
That's exactly what we wanted.
Yeah. The next step, what we want to do is actually move that character forward. Okay, how are we going to do that? Also, we're going to do that actually through a script. Okay, look here. You're going to have to import some scripts. You can create the scripts really simple by here, create, Java or C#. This class will be mainly using C#. I will use one JavaScript to show the possibility of that.
It's also worth noting that you can mix and match. You can have some objects with JavaScripts and some objects with C# scripts.
You can mix and match, but they cannot communicate with each other. Yeah.
They be black boxes to each other.
Yeah, exactly. So we're going to take here some scripts, and I'm going to drag and drop hold the folder in there, so I don't have to one by one import each script. Yeah.
Same way we imported the assets earlier, just drag and drop.
Makes it
It's pretty easy to do.
okay. Just to make sure. Okay, so what we're going to do is here take the script character final we can actually use. Okay, and what I'm going to do, I'm going to take that script and open this here. And open here with Mono. Okay, you can also do it with C#. Okay.
In Visual Studio.
Yeah.
It's a C# script, but you can open either one.
Okay. And okay, let me maybe explain it here. Okay, and close the window for the moment.
Well, it's taking a bit to load.
Yeah.
So this is a script you wrote ahead of time.
Yeah, this is a script I wrote ahead of time. Okay, just let's take a bit time here.
So tell us what the script's supposed to be doing.
The script is the character is moving forward basically. It's just physics that we're going to apply in the y and the x-axis, so the character can actually move forward.
Applying a vertical force, a force going in the horizontal, I should say.
Yeah.
In the x.
Yeah, so I'm just going to try to work on it here for a second. Okay. And
get that script open.
Yeah.
And a script is just a component that you can add to any object, just like we add the animator component or the box 2D physics component. You just attach it to an object. And so you can attach multiple scripts if you want as well.
Yeah. So look here, I'm going to explain the script from here. What we're going to do is basically, the first thing is on collision enter 2D. So I'm going to take that script and I'm going to apply it to our character.
And that's a function that's going to be triggered when a collision happens. It's built into Unity. It will trigger that function when the box 2D colliders.
So what we're going to do the moment it hits the ground, I'm going to say it's grounded. Because
that's just a boolean that you're setting.
Yeah, because later on, what I want to do is here. This is really interesting. We use here a function update. A function update runs every frame. Okay, and we have a function fixed update here. Why the differences? A function update runs every frame. Fixed update runs a certain interval that we can set, and that's where we're going to use our runs our physics in, because it's really more computing, and that's why we're going to do it on a fixed update. Function update, okay, is here when I press the fire button, and that's now becomes really interesting, because this is something that works multi-platform, cross-platform. If I'm going to put that now on my Windows phone, when I touch the screen,
it's going to trigger the Fire 1 event.
Fire 1 event. If I do it on my Xbox One, it's exactly the same. My Fire 1 button will trigger this. Okay, so it makes it super easy.
So that's an internal Unity command, Fire 1, as a label for your input.
So, and this here, you can find it here. You can go to Edit, and you can go to your input settings. Okay, and here you can say Fire 1 is actually my left control. Okay, but Fire 1 I have it declared also here as my joystick button 0. The same as my when I'm on Windows Phone when I touch the screen. So you can add there your own inputs too.
So this automatically will do a touch input then on touch devices.
Correct.
Excellent.
Super easy. So you don't, for multi-platform, when I create when I make an Xbox One game. And
That's great that you don't have to have all these if statements of
Yeah.
if I this control on that platform, this control on that platform. You can kind of have these tags that will work cross-platform, so you don't have to code once.
yeah. So again, here on the collision enter 2D, what we say here ground is equal true actually first, is I want to be sure when that I only jump when my character's on the ground. And here as I do when I press the fire button, and if I'm on the ground, okay, then I can jump. Otherwise I cannot jump. Okay. And then the fixed update, when jump is true, what we here say is jump is true, we'll add a force to it. Okay, a jump force. Now I didn't say like 10 meters or 50 meters or yards. I declared outside here
Is a public variable.
as a public variable as 10. Okay, and what is the benefit of that? I'm going to show you here. I'm going to take that script and I'm going to drag and drop it on my character. Okay, that script is now applied to here, and I see a jump force of 10.
So automatically it says it uses all of the public variables, and it shows it to you in the editor so that you can tweak it. So having that jump force of 10, you're like, well, I want it to jump a little bit higher. I can set it to 15 in the editor. I don't have to actually go into the code and tweak it.
Yeah, this is one of the, I think, the strengths of Unity. The artists and the programmers and designers can all work together thanks to exposed variables. Such as you can see here on our screen. Here we have the jump force. Now I can actually nicely slide this. Okay, and I can then tweak that. So press play, and we're going to click here, and we're going to jump. We see our character is jumping pretty high, so we can maybe put it to 8. Press play, okay, and then jump. Jump high enough. So I'm going to put my character a little bit lower, so it doesn't fall down in the beginning. Press play, the game starts, my character is running, click, and I jump.
Awesome.
Okay. So I'm going to put my character here nicely behind the screens, okay, and we're going to put that in the layer character, so that our character nicely will come.
As we did before.
Yeah. So in the game, press play, and there we have already the character running and jumping over the objects.
Awesome.
Super simple. But what we want to do is also, we want to have the correct animation playing, the jump animation. So let's go to the character here, and we go to the animator here, and we have the run. We want to add a jump animation to it. Okay. So I can go to my scene here, and I can go to my art assets for my character here, and select all my images of jumping, and drag and drop them in, such as done before. Okay.
Now, do we want a second jumping character in the scene?
We're going to delete that actually.
Yeah, so we just want the one object, but the easiest way to make an animation is to simply just drag the images into the hierarchy, because it'll automatically give you that prompt, you save the animation file, and then you're done. And you can just remove that extra jump character you created.
Yeah. So look here, I can show you again. I drag it in here. I can call it jump. You're going to overwrite this, the one we had done. And this image now, look, if I press play, of course, we're going to see the jump animation here on this object. Okay. Press play. But we don't need it. We only need that animation file. That is actually nicely created here.
Already saved in our folder, right?
Yeah.
Press access.
So look, you're going to delete this now. Delete, yeah.
And deleting the character from the scene does not delete the jump animation asset that's what we just created.
Yeah, look here. Here you can nicely see the jump animation file is still there. Okay. So what we're going to do, I'm going to go here to my character again, go to the animator. What I'm going to do, I'm going to actually take that animation file, that jump one, and drag it in here.
Awesome. Now we have two animations on the character.
Yeah. And this is really cool now. Look, if I want to go from run to jump, the only thing I have to do is look here. Make a transition from the run animation to the jump animation. Make a transition from the jump animation to the run animation.
And you get that menu just by right-clicking the boxes.
Yeah, just right-click in the box and make a transition. So look, I'm going to select here my character, and I'm going to go here to my scene. And what we're going to see is that automatically I'm going to play one. Let me just make the screen here a little bit bigger so we can see. Okay, yeah, and then we're going to put this to the animator and select my characters. Press play. What we're going to see is we're going to see the run animation. Automatically goes to the jump animation.
So he's running, then he jumps, and then he runs, and then he jumps, and it transitions back between the two automatically.
So, but what I want to do is I don't want that automatically plays run, automatically jumps. I only want that it plays jump when I click the jump button, basically.
Makes sense.
Yeah. So look, we can say here, okay, well, we're going to trigger something.
So we have that parameter setting in the bottom corner there.
Yeah, and I'm going to say here jump, okay?
And we're making a trigger type.
Yeah, and that's actually a very good question. If you say, well, what's actually a trigger or a boolean? Okay, if you do a boolean and you say to this as true, then you have to write in code later on the act A, not false. If you do a trigger, it will automatically just do the opposite. It will one time true and automatically back to false.
So it's similar to a Boolean, and you handle it like a Boolean.
Yeah.
But you just have to set it true once, and as soon as it does that animation, as soon as it triggers it, it automatically sets it back to false again.
Yeah. So what we see is here the run to jump. Okay. Here we're going to say, well, that only will happen when jump is true. When will I go from jump to run? On exit time. Because that means I play the animation jump and automatically goes back to run.
So no matter what, we do the full animation for the jump, and then we just go back to running.
Yeah. But when I press play and I press jump, okay, just by accident it worked. Oh, no, it works. It works.
The script already had the code
yes,
for that.
the code has already added to it. So when I press play here, look here, click and I jump, play animation, and it goes down. Okay, how does that work? We're going to just look at the script here quickly. So we have the script attached to it here.
The cooking show magic of the script already being finalized.
It's really simple. What you only have to do is here. Set the trigger, jump.
So anim.setTrigger jump.
So what's the anim part here? Here on, before my game starts, I actually go to the component animator. So it goes here to, and here in my character.
So that's just a local variable to that object that references the animator component.
Correct. So it goes to the animator component, here the controller. Okay, opens this controller and goes to this parameter and activates this one time to true. And that's why we're going to go from run to jump.
Excellent.
Yeah.
Pretty simple.
So what we're going to do is, now look here, I'm going to take the camera, and I make the camera a child of my character. Okay. Press play. And then my character is jumping. Oops.
So now the camera's moving just because we made it a child of the character. Because that way the XY position is relative to the parent object, just like everything else. So as the character is moving, the camera's going to move in proportion to that.
Yeah. But I made it a little bit more interesting here. What I want to do is with my camera, I only want to happen when my character comes here in the screen, like comes in, runs, and then starting from here, my camera will follow. Okay. So what we're going to do, we're going to take here, like set here, and I'm going to create an empty game object. Okay. Place it here. I'm going to say, starting from here. So I'm going to make that object a child of my character. And what I'm going to do, I'm going to say reset position. So it's perfectly matches there with that.
Okay. So it's in the exact same position as the character.
Yeah. I'm going to take my camera and make a child of that. Okay. So then I can set, when the moment my character is the same value as that object or higher, then follow the...
So you move those around. So you have, at the top hierarchy, you have the character and the game object that you set to be the exact same X, Y, Z position of the character.
Yeah.
And then a child of the empty game object is the camera.
Yeah. So what we're going to do, I have a little script here. Okay. And camera follow. Okay. And I'm going to take that script and you see, okay, here we can see if the camera position, if the character's position is more than 10, okay, we're going to then follow. So we're going to drag and drop that on my script. I'm going to drag and drop that on my game object here. Okay. What's my character? This is my character here. Okay.
So that character is just a variable that you have in that script, which we see in the code.
Yes. So the character will run here, but of course the camera starts to follow at a certain point here. Okay. We could start to tweak the script that it actually follows exactly that point here in the script here. So we could start to change those variables and expose them. But I know we're under a little bit 5-minute time constraint here. So what we're going to do is just going to focus on the pooling to make it an endless runner, the game. Okay. So later on we can then come back to this and work more with that, or make an extended movie file for our community on it, everything. So we're going to take the camera and just make it a child of the character.
Just for now, just to move along with the lesson.
Yeah. So what we want to do is we want to start to pool this. We want to make this an endless runner game. Okay, how can I do that? Okay, I'm gonna take this object, okay, and I put it as 0. And take another one.
That's the one that we named prefab earlier.
Yeah.
But we didn't actually make it a prefab yet.
Exactly. It's not a prefab. Okay. For this case, we don't need to make it actually a prefab. I'm pretty sure that Adam and Matt will cover that really in depth. So what we're going to do is here, we're going to take this object and I'm going to duplicate it and I'm going to call it 1. Okay. And I move this object and I place it here. Okay. Okay. Place it nicely there.
Make sure it's all lined up.
Yeah, we can use snapping. I'm going to duplicate this and I'm going to call it 2. Okay.
So now we have 3 different versions.
Yeah. And why is that? Okay. And I'm going to move it up to here. Okay. What we're going to do is when my character runs here over the screen, the character starts to run in the first level. Okay. The first prefab here. Then when it hits here, I'm going to make here a trigger. When it hits that trigger, I'm going to move that object to there. Then this object will be here. Then I can say the moment I hit, I'm going to put a trigger here, like an object that when I hit it, I will move this object 6 units forward or 10 units forward. Okay. Why I put that object here? I could put it here. So I'm going to move them each time this length forward. Okay. Because then I have to put this object behind it, and I just want to make it super fast for myself, that I don't have to put objects behind or in the front, just move things forward.
Just make it clear.
Yeah. So I'm going to go back here to my menu. Okay. And what I'm going to do, I'm going to make a trigger in this prefab here. Okay. And this prefab too, I'm going to delete it for the moment because I'm going to make exactly the same prefab for it. So we're going to create here, and let's say we can do a 3D object, a cube. Okay, place it here and scale this object. Okay, so that could be my trigger. That's the object I have to hit, and I'm going to say move this object forward. Okay, so I'm going to call it trigger. Okay, and I take that trigger object and I'm going to make it a child of my prefab. So when I move that prefab, that trigger moves with it. Take that trigger here, okay. And now I'm gonna take here a script. I have somewhere a script called pooling here.
You could just make this an empty game object and add a physics 2D collider on it.
Yeah, exactly. So in the script here, I'm gonna say on 3D, on trigger, enter 2D. When that object enters that object, you're gonna have to do something. Then we're gonna do this. Okay. So we're gonna take that script and I'm gonna put it on the trigger. Now that script here, let's go back. Pooling. Okay. So first I'm going to do here, we're going to declare an object, a game object, outside. So in any object in my scene. And what I'm going to do, I'm going to move it 72 units forward. I can later on tweak that. Okay.
So you're just changing the X position of the previous prefab.
Yeah. So what we're going to do is this trigger, okay, I will take this object, but I want to keep this object because I have here nicely the entrances and everything. So what we're going to do, we're going to take this prefab and I'm going to duplicate it and place it here.
Trigger and all.
Yeah, and that trigger, what will I move forward? This.
You can rename that prefab to prefab 02.
Yeah. Yeah, it's just going to better make it clear for me.
Make it more clear in the
scripting. Yeah, this one too.
Movie.
Yeah, and this one will be 1. Okay, yeah. So I'm going to select here my trigger, and what will I move forward? This object. So the trigger...
for the trigger for 2 will 1, prefab 1, and vice versa.
So you can drag and drop it in here. Okay. And then I had something here from the fuel can and a laser. Let's look at that. I'm going to go here to my pooling script. Okay. What I'm going to do is randomly, I will activate the fuel can or the laser.
Saying them the true or false.
Yeah.
So they're always going to be in the level, but they may not be active in that copy of the level.
Exactly. So here you can take here my trigger. Okay, and what I'm going to do, the fuel can, the laser here, I'm going to put it here. And
you're just dragging and dropping to match.
Yeah. The fuel can and the object will be this one. Okay, and then here in my trigger, this one is just the opposite. It's the fuel can from here, and the laser from the other one. Okay, so now my character, when I press play, okay, what we're going to see is we're going to run, and we start to tumble here. Okay, why is that? Because this object has to be a trigger. Right now,
you're just colliding with it.
Yeah. So I'm going to select them both, and I'm going to both set them to. I'm going to select them here. I'm going to say this is a trigger.
You need to set a box 2D trigger too, or a 2D.
Yes.
physics.
Yes, exactly. So we're going to remove this component, and we're going to say here this is actually add a component, physics 2D.
Just for fun, you made it a 3D object, but it still needs a 2D collider on the 3D object to actually collide with the other 2D.
Yeah, because we used the function on enter 2D, and our character has the 2D collider on it. So as a trigger here, and this trigger...
So that's just a checkbox under the box collider for is trigger?
Correct.
Now, what's the difference between a trigger and a normal collider?
Okay, when it's a normal collider, it will collide and hit it against it. If it's a trigger...
It's like our floor, it will stop.
Yeah. The trigger basically will just go through it, but trigger, it will say, okay, you can on trigger enter and evoke the scripts.
So doing some code, but not actually stopping the physics object anyway.
So I'm going to add a 2D box collider to here, and also a trigger. Okay. So press play, and what we're going to see is here, we're going to keep running now. And, okay, there is something there.
I think it's tripping you up when you go from one to the other.
Yes. So what we're going to do is select our character here, and a very simple trick is here, fixed angle.
Set that to true. Fixed angle to true.
Yeah, so that cannot roll our character. So press play. Okay, I'm going to jump here a little bit, and when I go here, we're going to hit the trigger here, and now we see is here the object moved to there, but exactly the same. It moves this distance forward. So in script you should change it maybe to way more. So I'm just going to check here in script here. This trigger pooling script. So we have the script here, and we should then basically change those values here, the 72, to move much...
Start one ahead of time.
Yeah, we should multiply by 2.
You pre-bake the script to go to that position of that first one.
Oh, it's just it takes this object.
Yeah.
Okay, and it moves it 72 units forward basically. Okay. So just going to check here. This trigger will do this prefab 2. If you can that, and it has to move it. So what actually it has to move. If I have this prefab, okay, this prefab 2. So right now it's in 56, and it should go to. So it should be about 50 units forward, I think. Okay, let me just check here. Click here. We hit this. Oh, jump here. We hit the prefab. Okay. Yes, and what happens is our prefab 2 went way too far.
It went a little bit too far.
Way too far. So we should.
But this is something that you could tweak as part of your code later on and make it sure it lines up exactly, and you would measure how big each segment's going to be, and you can even set that as a variable in your code that you can adjust in the editor, just like the other ones, to make it exactly right.
Yeah. So. I think we only have 2 minutes left, or
I think we're actually 2 minutes over. So
okay,
I think we might have to cut short here.
Yeah, what we're gonna do? Let's open the project here and let's go quickly in depth over there. Okay.
So you're just showing the final version. What it would look like after you tweak the scripts, make it all lined up exactly. And also one thing we didn't get to cover was adding the scripts to the pickup objects itself, like the laser and the can, that when you hit it, it'll add points or restart the game.
So what you see is here the character now will put the colliders invisible, and then it moves this object to there when I hit the collider.
And it's lined up exactly right, so it looks seamless to the player.
Yeah. And then how we do the pickup object, it's really simple. Let me go here to the pickup objects, like I'm going to say here the fuel can. Okay. We add a simple script here. No, we add it actually to the character. Okay. To our character here, and we have a script here, pickup. Okay, and it's a really simple script. Okay, where on trigger enter, if it's a can,
it checks the object that I'm colliding with a can.
Yeah, And then we set it to deactivate, so we don't see it anymore. Give ourselves a point. And then we actually send this also to our text here, so that we can see how many values there. This is the canvas. In the 4.6, we have our new GUI system. Definitely check out the blogs afterwards at Unity. We will record this tutorial more in depth with everything. And there we can see then this value here. I sent a value to those text to show it there. And we also have here a menu mate that when I press play, that it comes in, animated, and then you can click play again to play the game again. Okay.
Awesome.
Everything of this project will be tomorrow available on our asset store. Check out under the 10 Planet 2D art. The level, the scenes, and the scripts will be all available for the community.
So you can mess with it yourself, make your own endless runner game.
Yeah.
Awesome.
Thank you so much.
Hopefully you guys learned something. And stick around for the next session. We'll take a quick 10-minute break.
Hi, welcome back to Developing 2D and 3D Games with Unity on Windows. I am here again with another good friend of mine, Matt Newman, for what is, to me, I think the most exciting session of the day, just because I'm a developer, and I think I'm okay on the development side, strong on the development side, but on the art side, I can draw a mean stick figure, and I think that's about all I can do.
So we actually get to create some stuff, too, which is pretty cool. I think everybody likes to see that, too.
Yes. So Matt actually put out, well, tell us about yourself first.
Okay, so my name is Matt Newman. I run a small little studio called Subscience Studios out of Tustin, California. We're an indie game studio. We recently completed work on, there's a game for the band Avenged Sevenfold, if anybody's heard of that. It's called Hail to the King Death Bat. That's launching on mobile devices very, very, very soon. Before that, I worked in another studio called Mad Menace, and I created a game called Grave Stompers, which you can find on all mobile devices nowadays. It's on iOS, it's on Amazon, it's on Ouya even. It's everywhere. So definitely check that out. It's a really cool game that I made. And then, today, basically, we're just going to get together and do some 2D assets and create some stuff. And I kind of wanted to show you my process, my workflow, and like what I do when I create assets for the games. And then we're just going to go run with that.
So this is indeed Module 3, 2D and 3D asset creation. And you put out something interesting out into the chat room earlier, asking the folks.
Yes. So, we put a question out there saying, what kind of character would you guys like to see me create? And we got a bunch of really interesting kind of choices out there, and different, everybody had their different characters and what they wanted. What I thought was cool was Triceratops, just kind of, I don't know, I love dinosaurs. That really kind of struck me. And then we kind of tweaked it from there. We did alien Triceratops, cyborg Triceratops.
Kept going with it.
Yeah, and then we ended up going with a barbarian, cyborg, alien Triceratops, like hybrid creature. So anyways, I kind of doodled a little bit while the comments were going on, and we did create a version of that, which I can actually bring up here and show you. This was just a really, really quick sketch of something that I was working on. But right here, this was just literally while the comments were happening, so I just kind of came in here and started doodling a sketch. But we'll get back to that when we get to the 2D creation, and I'm going to refine that and actually show you my workflow of taking this sketch and actually bringing it in to Illustrator, creating the different pieces that you could then make move and do different things to create like a skeleton-based character for a 2D game. And also doing it in vector too. So when you do things in vector, it's really important, I think, to do your character designs in vector, because not only will you have these great crystal clear assets that you can use in Unity and other places, but you can export it in all kinds of different resolutions for marketing materials and other things like print and whatever you use it for. So it goes beyond just the game. So it's a really, really great way to do your character. So we'll get to that when we get to the 2D character creation. But I think to start,
both of us have young kids.
Yeah, we do.
And so you ever seen Despicable Me?
Oh, yeah.
I'm Vector.
Oh, yeah.
Every time I hear the word vector, which is often that goes through my head. So let's talk about a module overview, what we're going to be covering today. Matt's going to be going on a title screen. So
we're going to start with a title screen creation. We're going to show you the different elements that make up a title screen when you do make a title screen. We kind of came up with a concept for this event, and it was really, really quick. We did it over the last, I think 4 days. We kind of knocked this thing out. But we came up with, it was Zombie Pumpkin Slayers, which is basically,
Yes.
it's kind of cool. Just like a
Yes.
off the cuff, zombies are cool. Halloween's around the corner. So it was the perfect type of game to create in the last minute. But we basically, we created a zombie character. We created some enemy pumpkins. A level, we created a cool branding for it, a title screen, all the elements that you need to basically kind of start your own kind of indie game. We just kind of wanted to get it there, give you some cool stuff so you could run with that. We're going to have all the files available after this that you can download and kind of see what we did process-wise. We'll get to that later on where everything's going to be. But yeah, to start, I kind of wanted to show you guys, I always start with the branding. Whenever I create an indie game or a concept or a character, I start with doodling the character, obviously, but then you got to think about, what is the title of this? What's going to grab like the user when they see this game? And so with this, we wanted to start with the title screen of the game. So for Zombie Pumpkin Slayers, I'll actually pull it up right here. Let's see if we go. Just give me a second here, and we'll load this up. I wanted to do something that was very in the vein of zombies and pumpkins and slaying and all that. So I'll show you right here. This was kind of the end concept of what we ended up running with that we really, really dug. We wanted it to take place in a graveyard. I did make grave stompers back in the day, so it was a perfect scenario for this to take place. And the loose kind of theme in the story for this mobile game was we wanted these evil pumpkin patches to basically be spawning pumpkins and taking over the cemetery from the zombie. So you're actually playing the zombie, protecting your cemetery from these evil pumpkins. Hence, you are the zombie pumpkin slayer.
So tell us kind of the overview. What would I do if I want to create a title screen?
So to create a title screen, first there's different elements that you're going to need to create a title screen. One, you're going to need the logo, obviously, which we have here in Illustrator, this kind of zombie pumpkin slayer awesome thing. And then from that, you're also going to need your options buttons. So, play and options and all that different kind of stuff. And you probably want to style those or choose a font or anything that's kind of in the vein of what you're doing. I think a lot of people,
Sure.
It's very, very common and they just don't have the right font choices in the things they do. So you just want to kind of keep everything in sync and kind of in the realm of what you're trying to create.
There's lots of great font sites on the net they can download fonts.
Yeah,
right?
Absolutely. Abstract fonts, I use that all the time. There's Duff Font. There's all these different sites out there that are great and they're free. And there's lots of freemium fonts to use and take advantage of those. Go through and what's great is you can actually type in the name of your game, whatever game is going to be, in a lot of these font sites and preview the fonts and go through the different categories and kind of say, oh, that looks good. And you can kind of see what it looks like. And then from there, you can download that font, create it, bring it into Illustrator, and then start tweaking it and making it how you really want. Now, for this game, I kind of did something different. Usually, I did kind of a hybrid. I used one font that I found off a font site for the Slayer portion because I just wanted that really crisp and clean, like a Slayer. But the Zombie Pumpkin, I kind of just wanted to go off with my art skills and do something kind of different. So for the zombie portion, I actually sketched this all out. This is kind of my process I use a lot. This whole thing was done in Illustrator. As you can see here, there's all these different, it's just all vector graphics. It's all traced with a pen. I do things in different layers, and then I'll cut things up and just kind of piece it how I want to and piece it all together. I use outlines a lot to kind of just reinforce the different elements. And then I also do collective outlines to kind of really just bring it all together. But for this, I'll show you the sketch here. So if we go into Photoshop, and first thing I did, I like to start on pencil and paper. It's just kind of my way I do things. So I started with this, just a really quick pen mock-up of a zombie logo. Like, that's where it started.
So this is the first step you would do in creating a title screen.
Yeah, the absolute first step, and I'll just bring this into Illustrator so we can see it kind of side by side. Let me just grab this whole thing here so we can do that.
And how long did it take you to sketch out that kind of little quick text there?
This didn't take too long. I would say this is probably less than 10 minutes of work, just kind of going through and just thinking about, and it's not perfect. I mean, you look at it, it's just very, very loose, right? It was just kind of like zombie. Because I know with Illustrator, I'm going to use this as my reference layer. It's like a template layer. But from there, I can actually take this graphic I made and really refine it and do something cool like that. So you can see the finished product is very, very similar to the sketch that I initially created. But doing that, having this kind of loose sketch as my guideline gave me the ability to really kind of start playing with the elements and adding things like, really refining the look of the stitches and just kind of like cleaning it up and making it crystal clear. And what's cool is, obviously now it's vector. I can use this on anything, right? T-shirts and games on the side of a bus, like whatever. And it's always going to look crystal clean and great.
Stands out no matter how big you make it.
Yeah, exactly. And then with pumpkins, I was kind of like, well, okay, I'm going to try to incorporate pumpkins in there somehow. And, I was thinking about the shape of the pumpkins and the coloring. And so, I kind of threw some little pumpkin nods in there with the shape of these peas and the way that the pumpkins look in here. And kind of just wanted to do that. Like, it almost looks like it's carved out of there, kind of like a pumpkin, just to kind of reinforce the differences between the two factions in the game. You've got the zombies and you've got the pumpkins, and they got to look different, but have it in the same logo. So I think together, and then from there, I added these little, I thought just the pumpkin vines would be pretty cool, just as like a detail element on the logo. You want to have something in there. I might even go back and add some actual evil pumpkins on the side or something like that. But I thought this kind of really helped tie it all together. And then the Slayer, just for me, I figured it needed to be something crisp and clear, like,
cool.
Like a Slayer would be.
A Slayer would be.
Yeah, right. Like a blade. I wanted it like a blade or some kind of weapon, like just something that really reinforced how
absolutely
the Slayer feel. So yeah, there you go. You start with that. You start with these different elements. When I'm in Illustrator, and I bring an element like this, I always, if we look at our layers in Illustrator, right here, so you can see there's this little option on the side. If you go over here, and you can make it a template layer. So I always make, and you see everything kind of goes like translucent when I do that, right? And so that gives me a nice guide to work from, because it's not harsh blacks and whites, because you can't see what you're working on. It gives you kind of a gray and white version of what you're trying to do.
It's almost like that's your tracing layer, almost?
It's like a tracing layer, absolutely. So you can bring your sketches in and then use it as a tracing layer. And I use that not only for the logos, but all the characters I make and the different things. I use that exact same thing to basically, trace what I'm doing. I mean, you're really just tracing and refining and making it look crystal clear and nice.
Yes,
right?
the advantage of computers, you can refine and erase and refine, erase.
Yeah, and I would say the main tools I use, so, when I'm in Illustrator and I bring that sketch in, make it the template layer like we did, you always want to make a new layer above it and call it whatever, just keep it layer 2 for now, but I'm notoriously bad with naming my layers, which many people are, so don't feel too bad. Yeah, and people I work with, they always say that, the layers, I have an issue with that, so I always go back, but I think that's the artist, right? That's the artist in you, the creative. Sometimes you just want to run and get things made, and that's what you have to do. But I do suggest naming your layers. I don't not do that. But yeah, from here, we can see, okay, I have this zombie logo. It's kind of grayed out here, the template layer. And I always just grab my pen tool, and I fill it with black to start. And then I just start tracing out the logo, And Illustrator has some pretty good lock recognition going on. So it kind of knows when you're tracing over something where to lock certain things. So you can kind of go through and trace each individual element. And then you throw them off to the side, too. So I made that Z, I throw it off to the side. Then I go back, and I want to do maybe the O, I'd rather just use the ellipse tool, and I can just...
That was my next question. How do you do the irregular kind of shapes like that?
Use some of the tools that they have. The direct selection tool, right here next to the actual selection tool, is how you select, almost like in 3D, where you select your verts. This just kind of gives you a really good area where you can, grab a portion of it and kind of contort it to the shape you're trying to get. So I have that kind of oblong-looking O.
And these same tools exist in virtually any of the vector graphic programs, right? So the free one, like Inkscape,
Absolutely.
Illustrator.
You can do the same. I would be shocked if they didn't,
Yeah.
because this is pretty much how it's done nowadays. But from there, you get your shapes. You want to block out your major shapes on your logos. So I'm just kind of going through and tracing these different elements. Just kind of getting those shapes, those big shapes. And I always just kind of throw them off to the side, And once you make them, just kind of throw them off to the side and then arrange it later, because you just want to get these. You don't want to be drawing over things, Just take one piece at a time.
I'd like to buy a B.
Yeah, a bee, right?
Vowel.
Yeah, you just come through. And for things like bees, I always use these kind of triangle shapes like that. And then there's another tool in here called the anchor point tool, which allows you to get these really nice arcs.
Oh, cool.
So, and that kind of goes in hand with when you're doing custom shapes. You can get nice curves on them and things like that. So with that bee, you can just get all the shapes you want. Just kind of go in there and you do each piece, and then when you're ready, bring them back in or bring them back into position, and you can add more points to them too, because that's a very simple shape at the moment. But if I wanted to, add some more curves to it, kind of like what you see in the logo, it has these nice little arches and curves and different things like that. I just go through and add more points to it. Start using that anchor point tool to kind of make some curves and different things just to kind of make it unique.
Pretty cool.
The same goes in font creation too. When people make fonts, it's the same process. They're sketching things out and they're just building it in Illustrator and bringing it over to font programs.
Oh, that's how they do it.
Yeah. So that's essentially in a nutshell how I create the logos. And then each piece I do. So we'll just start with the Z right here. Let's just say that was finished and I was happy with that Z. I wanted it a green color, so I'd actually choose the color picker and turn it to like a nice green shade I wanted to. What I like to do is kind of outline my my pieces just to kind of get a nice defining shape for them. So I'll just duplicate that Z, which is Shift-Alt, if you happen to want to know the hotkeys. Yeah, I'm a hotkey madman on these things. So Shift-Alt is the way I duplicate it, and as you can see when I do that, it gives me two versions, and I kind of just arrow it around until I get it in place or snap it into place. I always send it back to the background, and just to make a quick outline, you can just take that piece you just made, add an outline around it, and then just increase the stroke on the outline. And you just kind of get these nice letters, right? And then from there, you can just start taking this shape and maybe cutting it up to make more shades and shadows. And like there, I cut out like a little part of the Z to make a nice little shadow on that. And just kind of like think about, how light would hit something and just kind of make it more animated. It makes it, just kind of cooler. And that's kind of my process, really. I just do that about, 500 times. And then you have
repeat, refine.
Exactly. Just repeat, refine, repeat, refine until you have what you're looking for. And then you get something cool that you can use and then save it out as a PNG, bring it into Unity, use it on your title screens, use it everywhere. And you can, if you want T-shirts done, anything, it's great. So Illustrator, highly, highly recommend if you're going to create assets for Unity. Some people are different. Some people say no Photoshop all the way, or they might be using another image editing program. Yeah. I just like the crispness of Illustrator. I think it gives you a really nice animated quality. And you have all these great vector pieces that you can really kind of build a library of and arrange them on a page to build sprite sheets and different things that you can use over and over and over again.
So then you'll just export those out, take those images, drag and drop those images in Unity, and
absolutely.
place them in the scene.
Yeah, when we get into the 2D character, when I actually kind of build this on the fly right here, I'll just show you how I do that. We'll do some different chunks and pieces of them, save it as a sprite sheet, and then you can use those pieces, bring them into Unity, kind of get it all skeletoned up and have it move around and do different things.
Skeletoned up.
Yeah.
Brilliant.
Skeletoned up. I guess that's my term, yeah. So I think next we're going to move on to the
2D character creation.
2D character creation. Well, let's show the actual title screen, right? So, now that I finished this logo, there's a couple different things you're going to need on the title screen. So, we have this great logo, it looks great, but we need some type of splash graphic, I think, to go along with it because we really want to reinforce the idea of these pumpkin slayers and maybe the world that they live in. Yeah. So with that, I created this little, go here, I'm always losing my files, but when I go here, let's see, we have, no, that's not it, the home screen, right here. So we created this home screen, and once you're done, there you go. So once you're done with the logo,
nice.
A lot of times, I'll mark out like an HD size, like 16 by 9 or just 1920 by 1080 version of like a home screen, right? A blank canvas. I start bringing in my elements. So I bring in my logo from Illustrator, and then I'll start creating new assets in Illustrator probably, or even drawing them in Photoshop. And so this was kind of our just really, really loose mock-up of what we were trying to do for the game. But we wanted to reinforce a couple things. We wanted to reinforce the world that this game takes place in, which is this kind of funky cemetery, right?
Halloween-y.
Like an animated kind of quirky cemetery. And then we wanted to reinforce the enemies, like what are you fighting in this game? So with that, we thought it was a good, using these little silhouettes of these pumpkins, I thought was really, really cool. And that's something too that, if you're doing a game on that home screen, you always like to do something on a home screen that kind of has a consistent kind of animated repetition. So it's not just static when it's sitting there, it's doing something. So not for this, but down the road, you could take those pumpkins and have each one kind of like constantly laughing here and there. Each one would move and
glow
laugh
a little bit.
Yeah, and add little sounds to them and stuff. So you kind of get this. You really get a sense of the style and the world and what you're trying to create. So, in a nutshell, that's what we did for the home screen right here. It's basic, but we kind of have a couple elements in here that kind of reinforce the theme and what we're trying to do. We chose a font that's kind of a little more of this kind of retro horror aspect of what we were trying to do for the play game, and just kind of threw this together. So very, very simple, but if you're going to start an indie game, you got to start somewhere, and that's always with the title screen. And with the title screen, you got to have these different elements and lay it out.
That's the first thing to hook a person once they've opened it up.
Yeah, they want to see something cool, and you got to have a really cool logo that hooks them right away. You got to have just all these elements ready, and then from there you can start making your mobile game. So
part of the challenge is getting them into your game.
Yeah.
I will talk about that later. And then once they've got into your game, you got to hook.
Yeah.
Hook, line, and sinker.
So next up, I think we're going to get into 2D character creation.
2D character creation, indeed, which is another thing I can't wait to see because that's another big mystery. Like I said, I can do a little mean stick figure, but as far as creating it past that,
yeah,
that's where I defer to you.
So we got some comments from the people on the boards when we were first getting this thing going, and I think we posed the question of, what kind of character did we want? And I think the winning candidate was a Triceratops Ninja Barbarian character. So from there, I did this quick little doodle just as the comments were coming in. I kind of collectively chose a couple people's different opinions to create this. But from there, you can see it's a super rough sketch. Like, I never am extremely fine-tuned in my sketches. I really just kind of go off the cuff and create something. I think I did this in a matter of 2 minutes. Just go fast. Make what you want. Take pieces, cut them up, make them bigger, make them smaller. Just kind of get the roughed-out shape and the silhouette of the character you're trying to make. And then from there, you got a really great guideline that you use just like in Illustrator. You have this template layer to start refining on. So I always start in Photoshop. So right now, I did my sketch. And I definitely recommend using a drawing tablet of some kind. If you have a Surface Pro 3, or if you have a Cintiq, or an Intuos tablet, these are great for on the go. Definitely use a drawing tablet of some time. It's just going to make your life way easier when you do this.
Take us through. So we've got a slide on a great kind of overview of some of the steps. Talk about kind of some of the things that's required as per what you would do each step of the way.
So when you start, you want to start with your initial sketch of the character, right? And this is kind of what we have here in Photoshop. You can do it in Photoshop like I did with this with my Intuos tablet, or you can do pen and paper, on the fly, get it ready. And then from there, you want to create your template layer, right? Which is just your base layer. Don't think of it, don't get overcomplicated with the term template. All it is just a base layer. So imagine like the tracing layer that you're going to use. Your main kind of just rough sketch sits on below, and then you're going to basically build up on top of that, right? So from there, we've got here's our rough sketch. We're going to make this our template layer. I always start, it's just on white right there. Nothing's separated. Nothing's crazy. We just have our sketch right there. I always just make a new layer on top of that. And I'm not working in a really high resolution. Another thing to note, when you're creating characters that you're going to eventually be tracing in Illustrator and other programs, you don't need to go like 300 DPI or 600 DPI and go crazy with the sketches. Just keep them low res. They're just reference layers. That's all it is. So that's going to help with a couple things. If you got a system that doesn't have, the really hardcore guts to really push the graphics and stuff with your high resolution images, you can just, you can do it on a low res device. So you can do it on, tablets with pens or whatever. You can do it in the Surface models are great. I love the Surface Pro 3, has awesome drawing tools in there. And you just want to get that sketch done and then bring it in from there. You bring it into Photoshop, and just with any resolution, you just want to get the general shapes and the general things done, and then bring it into Illustrator and actually start refining them, and just like we did in the logo, right? Tracing each element and making them usable elements, usable vector elements that we can then kind of piece out and kind of create this almost like a marionette, right, of all these different pieces that we're eventually going to bring in Unity.
Each separately. And
they all have anchor points that are going to move, and then you can even do variations of those. Like if we're doing the eyes separately, you can do eyes that blink, eyes that are scared. You can do mouths that are talking, mouths that aren't talking, all kinds of different pieces. And it depends on the character you're trying to do. But when you do that, it's going to give you a ton of flexibility, especially with Unity's 2D tools. They got really, really great animation tools. And I think it's using Mechanim behind the scenes to do it. But the blending's awesome. You can actually separate the layers of blending. So the top of your character could be doing one thing, like attacking, while the bottom's running. All kinds of stuff. So, but back to the character creation. I know people want to see exactly the process of what
I want to be selfish here, and I watched you kind of in the room over there sketch some of this out. And can you just show us even roughly
Roughly?
Roughly, like how you would even start that. Like I see this kind of quasi-refined thing that you're working on here, and I'm like, wow, geez, where do you even start to draw? Like that looks pretty good to me. Way better than my stick figures.
So with that, honestly, it's really as basic as just grabbing the pen tool or the paintbrush tool in Photoshop, the airbrush tool, and just kind of just going nuts. And you just want to get your shapes down and just kind of, you don't have to go crazy with it. You just want to kind of define like the shape and maybe even just do some general shapes to kind of get like what you want the character, like his proportions to be, and just kind of different elements, right? And,
so you find you always use kind of a lot of lines just to kind of
I just go rough, and for me that's just my loose. I always do that when I'm sketching. I like to keep it loose because I'm gonna get rid of this anyways, right?
Yeah.
This is just for me. Like I'm thinking, okay, like what are these sizes gonna be? Like how big is the head gonna be? What are the arms gonna look like? Different things like that, and from there you can then start just even going over that and like refining like these different shapes, right? So I know like a Triceratops, he's got these horns and these different things. So this is just really, really basic stuff. I'm just going in and just kind of doodling, like nothing crazy. Like I'm not using my best artistic ability.
But this is already better than I think I can do. Like when you draw an outline and you immediately go for the Triceratops and you kind of do the horns on him like that.
Yeah.
Have you practiced drawing dinosaurs in the past? Like will you take time as part of your kind of training routine, so to say, and just say, you know what, I want to try to draw a dinosaur today?
It depends. I just tend to. I've always loved dinosaurs ever since I was a kid. So I was, when I know what a Triceratops looks like, I know what different things look like. And if you have that vision in your head, just start going nuts and sketching it down and
just kind of refine it as the time goes on.
Yeah, and even as a teacher, I tell my students when you're working on it, you really just want to be loose and just get that shape of the character, get the silhouette going, get the general shapes going, and then you just start going in and working on top of that and building it up. You don't have to be super, super refined. I think for this guy, we talked about barbarian. So at first I wanted to have this like kind of big barbarian Triceratops with like an axe, but then people were like, oh no, make him a ninja, make him a cyborg, like do all this stuff. So I was like, okay, let's
make him a Ken doll Triceratops driving a car.
Yeah, exactly. So I was like tweaking different elements, right? So I started with the head because I figured, okay, it's Triceratops, let's at least get that point home. And then we do that, and then from there we start kind of blocking out the shape. So I wanted these big kind of arms that you got going on here. I wanted maybe like this kind of more cyborgy chest piece with like some kind of diode in the center, and the same with the arms right here, representative of maybe some other video game characters or other cyborg characters people have seen, and just little elements. Well, I don't know what happened there. From there you just start building your character out. So yeah, I think it's a pretty good reference layer to work with, and I'm gonna get rid of those sketches I saw, even though that was actually looking kind of cool on the side right there, but I'm gonna actually use that head, which is great. This is why you sketch, right? So you kind of have these elements that you can use. Actually, it was pretty close.
That's pretty close.
So,
nice.
This is just my process. This is my workflow. I'm very, very loose on the things I do, but when it comes to refining them, that's when you really take the time and make it look great, right? So, we've got this really, really base kind of template layer that we want to use, and from there, we're going to start like refining this character, right? And even, you don't have to go to the point where it's so refined in Photoshop that you're just like, this is perfect, I'm going to use it as is. Some people do that. Some people just love to paint in Photoshop, and more power to them. Like if you can paint, if you can bump this thing up to a high resolution of 300 or 600 DPI, and then you could even do this in layers in Photoshop and do more of a painterly. If you're going for a painterly look, let's say the game you're making has this kind of hand-drawn quality and everything's kind of painted in the game, you can use Photoshop to do that and add custom brushes and make really nice painted characters and do the exact same thing you're doing in Illustrator. I'd recommend bumping up the resolution if you're going to use those pieces anywhere else, like marketing materials or whatever, which I think you always got to be cognizant of if you're an artist. You want to make sure that the elements you're producing you can always reuse, because you don't want to use them once and just be done with it, right? It's always important to kind of get the most leverage out of the things you create. So, getting back to what we're doing here, I think that, for the terms of what I'm doing, I'm going to show you like a really crisp kind of animated quality.
Okay.
Just my workflow for doing that. Sure. But again, like I said, you could use Photoshop to do this if you bumped up the resolution and kind of did the pieces on different layers and whatever. So, we've got some good pieces here to start with. We'll just make this our template layer. And what I do is I always just make a layer on top of everything. We'll name them for the sake of people following along.
You're going to name them now.
Yeah, I'm just going to kind of imagine that as just stacking layers. That's going to be my template. I usually fill it with white, and then I just reduce the opacity on it just to kind of give me like a that's just, for me, helps me just create like a nice guide. So anything in my sketches or anything, I just stuff down below it, and then I keep this nice, like tracing paper, right? You just take a piece of paper, stick it over the top, reduce the transparency so you can kind of see this translucent image to work from, right? So same thing, we'll create a new layer, and then we just go through in here, and this is just refining these shapes. And I might not go through and refine everything, maybe just some things that I know that I want to refine that are important to me. But, like the arms, maybe I'm a little tighter in my sketching and just kind of go through and get these different elements that I think,
like the popping elements, you want those to show out more. And
yeah, exactly. So I'm going in here and just kind of want to, define like some of these cooler elements and visible elements that I want. And I'm not being super, super tight with it, but I'm being, a little bit better than just crazy rough sketches, right? And then, I want people to see these different elements. And I actually, from day to day, I actually work with a Cintiq most of the times. I'm actually doing this on the screen, so excuse me if it's not perfect.
So with that, you're drawing.
I'm drawing actually on the screen, yeah. So today I'm actually using Intuos, which is fine. For years I used an Intuos, and it's kind of a little hard to go back and do it again, but it's actually kind of fun.
You were cruising last night. I was watching.
Yeah, I was cruising. You were getting that thing done. It was awesome. So you see here, I'm just kind of going through and picking the pieces I like and just kind of refining them and making it look how I want it to look. And it looks good for an arm. And then maybe I'll make another layer and call that our arm. All right. You don't need to separate. This is just for reference for me. You don't need to separate these, but I'm just going to do it for the sake of the demo.
Just to be a little bit more organized in the
program. A little more organized. We have some different pieces here. Just go through and...
Your team members will say, Matt, good job on the layers.
Right, yeah. And I'll show you, there's actually a method to my madness by doing these layers when we get into Illustrator. But as I go here, I'm just making these different pieces. And, because you got to think of the character. Now you're kind of sectioning them out, right? You're going to have these different pieces that you're going to fully develop and use to be more of like an animated character. So you got to think beyond just the sketch. You got to think like what's behind the head? Where does the neck connect? Where do the arms connect, right? So we have this kind of body in the center, and I know my head's going to sit on top, but I kind of want to rough out, the shape of this body. So we have this, because when that arm's moving and he's running or he's attacking, you're going to see more of the character. It's not just going to be a static character. And this is strictly for skeletal character design. So when you're doing characters that have more of a skeletal look, not a skeletal look, but have like the skeletal tools that you can use in like Unity or Spine or any of these plugins that people have, you just want to be cognizant of the character and the different elements, and that you're going to be able to see all this stuff. If you can imagine pieces that are layered on each other as they move, you're going to reveal parts that you didn't see before. So like I said, I'm just kind of going in here and refining this up, and I might just separate these all as different pieces. I think this was chest.
So all different body parts kind of come off into a different layer.
All different body parts. Absolutely. So we're going through here, making another arm on the side. I'm getting the reverse side of the arm right here.
Actually, right now with the arm and the chest piece, it looks like a robot.
Yeah, it kind of does, right? He is a cyborg barbarian ninja, so I'm trying to reinforce that. So, I'm just doing the different pieces right here.
You ever start out drawing something one way and you're like, you know what, this really looks like something different, and then you just take it in that direction?
Oh, absolutely. All the time. I kind of piece them to where I think maybe they work a little better. And don't be afraid to just arrow things around and kind of get it right. I'll just call that arm. And sometimes I reduce the opacity, just like I was doing with that template layer on certain pieces, because I'm trying to just get those shapes and define the areas that I'm going to be making. So, as I'm going through here, I'm just making new layers and just tracing all these elements I have. I actually really like this second head I was making right here. I thought that looked cool. So same thing. We'll just go in there and start building out these shapes, building out these characters.
And so all these separate layers that you're creating here, you'll import these as separate layers then into Illustrator?
Yeah, you could do that. You could absolutely do that. And that's actually what I was going to do, because I think it's going to just make things easier. And the great thing about Photoshop and Illustrator is I can just drag these layers right in, and they'll just come in as image layers that I can use. As I go through here and just kind of getting the look of this character and what I want him to look like. just defining these different pieces. Just making them look cool.
Draw out the crest.
Yeah.
Horns.
Yeah, you want to get, just kind of getting that style as I go too, and maybe the style even kind of develops as you're going through with it.
It's pretty amazing kind of seeing the whole process done. It is something I haven't spent enough time with, so it's kind of a mystery. I know the tools that are used, but to see it actually done in person is pretty cool.
Yeah, and I'm just going really fast here just for the sake of the demo, just to kind of get this done. I might spend more time refining it, but I want to get into actually creating this so I can show you like what I'm doing.
And we're going to post out some of the code and assets that we're going to be using for the game out on our websites the next couple days.
Yep.
We're going to do a GitHub project out there, so we'll be posting those details out to our websites.
Yep. So yeah, you just want to make sure you go in here and you get all these pieces, and if things look weird, go in and just kind of fix them and tighten them up. And I think I wanted to do like a big tooth on this guy or something that just looked different.
Big ogre tooth almost.
Yeah, right. Almost like an ogre triceratops or something.
Barbarian ogre triceratops. Ninja Ken doll.
Yeah, and your style is your style, right? So, I think a lot of people get afraid or they try to copy other people too much. Just go for it, like make what you
see how it develops, kind of.
Yeah, just go for it and sketch it and see how make the character you want to make, right?
When you were learning drawing, did you sketch a lot of other things, drawings that you'd see? Would you kind of trace over it and sketch it just to try to learn the motions, or would you just look at it, do by eye, or both?
I think as a kid I would just draw like all the time, right, and just create all kinds of different characters and monsters and you name it, right, and I would just go for it and just make whatever I thought was cool.
Pretty cool.
I was the kid in class that was always, I was drawing when I wasn't supposed to.
Yeah.
Just paying attention, and I'm drawing, some character and showing it to all my friends, But, we have some elements here. I think that's a good start. I don't think we need to go through the full character just for the sake of time. I just kind of want to show you my process of making these. So for here, this is actually kind of good how we have it laid out. We've got two arms here to work with. We've got a chest piece. We've got another arm and a head. And we want to bring this into Illustrator and actually start making it and tracing the pieces. And so we're going to do that the exact same way we did the logo, right, on the title page. So, you save your image out. Always be sure to save and all the things you have.
Save early, save often.
Save early and save
Best
often.
motto of all time.
Triceratops, Ninja, whatever it's called, right? And then,
very nice.
Yeah, be sure to open up Illustrator, and then make a new file. Bring it in here, and we're going to place. Grab the Triceratops, Ninja. Was it on the home page or the desktop? There it is. Triceratops Ninja.
Spot.
Yeah. And then when you place it, you can actually kind of size it. So, I got this canvas to work with here. So I will put it in. There's our piece. And then the same thing, just like in Photoshop, right? I'll take that in my layers. If I get my layers right here. And then they have actually a template function in here. So I just click template. That gives me my template.
That's your tracing layer.
Yep. And then I just go in and I actually start, zoom in on the area I want to start making. And literally you can do it two ways. You can actually use it with the pen tool if you want to. I'm more classic Illustrator. I love the direct pen tool. So I love making the points and actually kind of defining these shapes. But you can go in and just start, making the pieces you want, right? And I just kind of go one piece at a time, and I build this entire character out. And so, just like before, I'm using the pen tool. I'm always using the pen tool for everything I'm making just to kind of get these shapes. And like when you're in here, the character might kind of refine itself too as you're going in. You get these kind of nice pieces, and just go piece at a time. It takes time. It's not something you can get done super, super quickly.
Interesting. So you don't do it really all at one shot, all little pieces, just like you do all the letters. These are all eye, horn, etc.
Exactly.
Guys.
And I'll, for example, like the eye right here, right? I'm coming through, and then maybe I'm just adding like little details on it and different things that I think are just going to kind of make it look a little cooler. You're just kind of going in here. You're using your tools. You're making the shapes you want, like just different cool stuff. Maybe I'm taking shapes and duplicating them to make other shapes. So I actually want to make that eye in there. Just get in there, kind of place it where you want it. We'll add some little glass reflections in the eye. You know, just using simple shapes. Just give it like an animated quality. You know, and the more you do it, the more you refine it, you'll start getting all these different shapes and building a character with all these different pieces. And I think what we're going to do is, you know, we're not going to go through the whole character right now, but just to give you an idea of my process and what I do, I'll finish this up and we'll throw it on the files you can download, and then you can actually look at the sketch with what I do with the vector graphics and the full completed thing. And
you'll draw it out, export it, bring that image into Unity, and
then we can use all those pieces and make a character. I might even throw a sample character together in Unity so everybody can see exactly what I did. Triceratops, and then just perfect.
Very, very cool. That was neat.
Yeah. But in the interest of time, you know, we're going to move forward to 3D creation.
3D asset creation.
3D asset
also
creation.
Another amazing area. I'm amazed
Absolutely.
by both 2D, 3D. So I think this is going to be really cool. So maybe take us through kind of the overview.
Okay.
Creating some 3D assets.
Yeah, absolutely. So again, you know, I think it starts with the sketch of the characters and what you're trying to do. I don't have the zombie sketch with me, unfortunately. I wish I did. But we needed a zombie character done for the game. We needed it done quickly. And I use Maya for everything I do. If I'm doing characters for games and whatever, Maya, I think for illustrators, is just really, really a great tool. 3D Studio Max is amazing too. I just happen to be a Maya person. I think people are split on which one they want to use, and that's totally fine. Either one's great.
Some folks in the studio that use Blender as well.
Some people use Blender.
Talk earlier.
Blender is very different. I think
Very
if you're
different.
used to one type of program and you move to something else. Yeah, from that, you know, I took some screen caps really quickly of just what I was making. So for the zombie character, we kind of just we roughed out this this little zombie guy that we wanted to use, and this is all done in Maya. And just, you know, to show you kind of my process, you know, I roughed out the general shape of the character and the pieces that I wanted to make, used the tools in Maya to do it, and then from there, you know, just put some basic textures on them, right? Nothing really crazy. Just kind of get these simple shapes and characters. And it's almost like when you're doing something in sketching in Photoshop, right? You want to build these chunks and pieces and then just start kind of tweaking them and making them work for how you want it to work and give it a style.
All separate, so you can kind of tweak them all separately.
Exactly. Like keep all your elements separate. So, you know, when you're working in Maya and you have all these different elements, you want to think about like the arms and the head and keep them all separate. Oh, that was really bad. You know, your head and you want to keep your eyes separate, all the different pieces separate, the legs. I always separate like my torsos and my legs and my arms. Like all these pieces are just all separate and they're kind of
So they all move independently.
They move independently, but you can stitch them together if you need them, or you can just keep them separate and build it all as one model with a bunch of separate pieces. You can combine it all together. Like don't feel like everything has to be, you know, seamed together perfectly.
Yeah.
But from that, you know, as you can see, as I start building the model, there's other variations of it as it comes, and I'm just, you know, I'm adding details on it. I start adding eyebrows and little hairs. You know, he's a zombie, so he's kind of decayed, and he starts to get that look and has a style to him. And maybe try to model your elements more kind of like, you know, how you would draw a character, like into the style and what you're doing with your character. And then from there, you know, we also need an enemy, right? So, boom, you start
pumpkins.
You start sculpting, your pumpkin, and this is kind of just the process for what I would do to make a pumpkin. I would build my pumpkin. I think I start with a sphere, and I extrude off the top of the sphere, and then I just use booleans to kind of cut out the different elements. So, you know, I'd sculpt like, you can see right here, I sculpt kind of this mouthpiece out, right? Put it in there, do a boolean subtract, and then just start tweaking your verts as you go, and then I'd make a triangle piece, because pumpkins are easy, right? You're just cutting out basic shapes on them.
A lot of the
right?
same tools that exist in vector graphics, right? You can
Yeah.
kind of add, subtract,
Absolutely.
cut out.
Absolutely. And then you start getting the shape, and again, like with pumpkins, I'm just using booleans because we need these awesome pumpkin enemies, and I think they're hollow and they have all these cutout elements. So as I'm going, I'm doing that, and then you start to actually get the character you're looking for.
Now, when you're drawing this in Maya and you want to see it in Unity, how often do you kind of do that workflow? So Unity will support the .ma files, Blender files, etc.
Yeah.
As long as it's installed in the same machine.
Well, that's a great thing about Unity is the cross-platform. I mean, was it cross-platform? No, cross-software support. I guess the software support, back-end software support it has. It works with Maya, which is great. It works with 3D Studio Max as well. But you know, it supports those files, so I can make a file in Maya, throw it into Unity, into my scene, start moving it around and even resizing it, going back and forth from Maya and saving, and I see it updating in real time in in Unity.
That's pretty cool.
So it's great for level building. It's great for getting the size of the characters you want. There's a lot of bonuses to having that backwards compatibility. If you're working in large teams that are using multiple versions of 3D editing, always save as like OBJs or FBXs so everybody can access them, because if one person's using Maya and somebody else is using 3D CO Max, it can be kind of a headache if other editing needs to be done. But if it's just a Maya only team, go for it and just use Maya files. I mean, that works. Or if it's a hybrid team, go for more of the FBX OBJ approach.
FBX OBJ. I noticed a lot of things that come down from the Unity Asset Store come down as FBX or OBJ that you pull down.
Yep.
And those are just file formats that contain, FBX can contain model data in there. FBX can contain, I think, up to 5 animations inside of there.
Yep.
So different things you can pack into those file formats.
Yep. And I'll show you really quickly, just for the sake of what we're doing here. There are pumpkin enemy. This was the different files we have. Not sure if we have. There we go. Maya. So when I create an enemy, and I do all these different animations for the enemy in the game, we needed all these different things to happen, right? We wanted the pumpkins to bounce. We wanted the pumpkins to bite, attack the player. We wanted the pumpkins to get hit. Idle, do cool like little things when they idle. You can do 2 different things. One, you can put all those animations on one giant timeline within Maya or 3D CO Max, and then in Unity actually go through and sequence out all the different animations.
Tell it frame 1 to 40. Is this animation?
Exactly. You can. Exactly. I think that just takes too long.
Yeah.
I also like to. For me, I just like to keep things organized and have the separate files when I need them. There's bonuses and drawbacks to both ways of doing it. But for me, I like to just create a file and then create the different animation files as separate projects, basically. So if I need to edit a particular animation, I can just open the file, go in, edit it, save it out, done. I don't have to go in and redo all these different animations and stuff.
So if you were to do something like, I don't know, a tombstone.
A tombstone?
If you were going to do something like a tombstone in a 3D tool, what would be your process to start it out? What kind of shapes would you start with?
So for a tombstone, we can kind of look at what we did in the game, right? Do we have the game here, or do you have it?
Game is on this one. I could actually load it up on here real quick.
But yeah, it doesn't. Unfortunately, it doesn't look like Maya, so I can't really show you real time what I do modeling wise. But for a tombstone, I'd use basic shapes. I'm using cubes, definitely using the cube tool. I'm adding edge loops on it, and I'm just kind of extruding it and just making it and defining the shape that I want. If that makes sense, use your basic shapes as a starting point. There's a really, really good.
Here's a preview. We're gonna wait. We're gonna wait to show this, but this is your first
glimpse
view
of the project. You'll be able to download and play.
I'm not going to run it now. You guys will have to wait for the 3D session to see that happen. But this is it here. So there's the tombstone. So you would, in the case of, let's take, I guess we could do the center one here.
Yeah.
Talk us through what you would do to create this process.
For that, I'm basically just using 3 shapes that are all kind of stuck together, right? I've got a hexagonal shape for my bottom platform.
This guy there,
right?
yeah.
It's just very, very simple. There's nothing going on that except for just a simple hexagon shape, right? Hexagon polygon shape. And then from there, on top of that, it's just a cube right on top of that, right? And then I've just distorted the cube a little bit to kind of give it a little bit of a flare, right? This kind of
I see along this kind of beveled edge.
Yeah, this kind of it's all it is. Very, very simple shapes. And then on top of that, I'm also using a cube for the cross part, and even the little platform lip on the top of that. They're all cubes, right? So that cross on the top, I just started with a cube in the middle, extruded the top, extruded the bottom, extruded the sides to get a really simple cross out of cubes, and then just extruded more to get like little beveled edges and different things, and then you just unwrap it. Yeah.
So you'd kind of take, so this is in Unity, which I did mention earlier is not really a 3D modeling tool, but you might take, let's go up.
Yep.
And then you would create another cube kind of.
Or I just create edge loops on that cube, and then extrude from the different shapes I create just to make the shape you need.
Little kind of square right here, and then you would pull that square off to the side.
Yep. And then you can just run with that. And I think the texturing goes a long way, right? So don't think too much on, I've got to have all this crazy detail in the model. Like, yes, if the model is great, that means you don't have to work as hard on the texturing. But if the model is simple, right? And let's say you're doing a mobile game and you really need to be conscious of like your verts and your tries, and you really need to keep those low. What you can do is just really concentrate more on the texturing that you're going to put on those. So for that, I mean, you're looking at, I think it was like 300 tries total for that whole cross piece. But with the texturing, you can get a lot of leverage and you can get a lot of leeway out of taking this simple model, but adding all these really cool details and taking your time texturing it.
And by tries, you're talking about all these little kind of subdivisions on here.
Yeah, so
Probably a little bit in the 3D course, but that's all the triangles that make this up here.
Yeah, tries are just the triangles that make up a model, right? So when you ever hear that term tries, they're talking about the triangles that make up a model. There's 2 tries in every square, in every face, basically. So, that's basically all you're doing is you want to be conscious of your try count. For me, the mobile games I'm doing, I always like to use, this is just my reference, but if I'm looking at the amount of tries on mobile devices, I want to target a large mobile device, right? I want to do all kinds of different devices of every speed and whatever, at least like current gen models, right? I always want to target around 30,000 tries, I think, for my baseline of the amount of tries I want to see on the screen at any time. Anything over that, you're definitely going to get the newer devices will run that fine, but I think lower devices, which is your huge audience pool, you want to keep that as like your guideline. I always say 30,000 tries is like the limit. And then from there, you just want to be conscious on the characters themselves, right? Keep the try counts low. I always like to keep the try counts on my characters. If I have a lot of characters in the game, let's say it's like a hack and slash game and you're running around and all kinds of stuff, I would say I'd keep the try count on each character around 2,000, not go crazy on that. That's always worked for me, and that's just me. Right?
It all depends how many of those characters are in the scene.
Yeah,
too.
You could go higher. There's a lot of games out there with these really high characters, but there's maybe only 2 characters on the screen. So they can get away with all kinds of tries and all kinds of detail out of just 2 characters. But if you're doing like a huge epic like RPG style game or a hack and slash, and there's tons of characters jumping in the screen, you want to be very cognizant of the modeling of those characters and the tries that they account, because that's all memory, especially on mobile. It's going to fill up that memory really, really quickly. So just some little tips, you want to be cognizant of when you're building your mobile game. But yeah, I mean, that's pretty much my process when I'm doing things.
That's pretty cool. I noticed that some folks in the industry, you see that they use a lot of different tricks. Like, let me see if I've got one here.
Sure.
I don't think I have. We do have a palm tree here. So I can go ahead and place a ton of palm trees on the scene. And these look like they're all 3D models, which I just placed 10,000 of them on my scene here. That's the awesome button there, mass place trees. I love that. So if I was to drop a little character on here and start running around, you would think that it would be incredibly inefficient on here. But one of the tricks used in the industry is called billboarding, which Unity will do behind the scenes. So rather than showing you these 3D models, you can actually go in and specify some of the options here. And it will, in turn, basically create a 2D image that no matter where you rotate, kind of rotates with you. It looks like you're viewing a 3D model, but it's really just an optimized 2D image. And then as you get closer to an object, it'll show you the full 3D model, so you get that full kind of high-res detail. So all sorts of little tricks like that to optimize your scene.
Yeah, and there's another, like level of detail is another, and I think we're going to be talking about that when we get into the optimization module. But basically, you want to think about your models too. You can do high-res models if it's only going to be like one thing you're seeing on and we're just talking mobile here, right? Yeah. If you're doing PC, go nuts, right? Or Xbox or other things, go crazy. But on mobile devices, you really want to be cognizant of the elements you're putting and the elements you have on the screen at the same time, and doing level of detail, which means you could do a high-res model, like the highest you can, but then maybe use a tool like there's a tool that I use all the time called Topo Gun, where you can bring in a really high-res model and then retrace it at a really low resolution and low try count, but bake in all that detail from that high-res model. So it's almost like you're faking what you see, but you're also optimizing. And then you can do different levels of that depending on if you were doing far up and there's characters in the distance, you could have a really low try count because you're not seeing all that detail. But then as it gets closer, it's actually swapping out different models, and you're getting, you're eventually getting that high-res model. So,
are you saying we might see some of the topo optimizations in our optimizations module?
Oh, absolutely. Absolutely.
Little hints of some things to come. Yeah. And that's module 6. That's our first module tomorrow.
Yeah, that's tomorrow. So yeah, we're going to do some really cool stuff with that.
Amazing, absolutely amazing.
But meanwhile, I will get the Triceratops with the cyborg barbarian Triceratops alien thing.
Yeah,
I'm gonna get that finished. We're gonna throw it up probably tonight or soon that everybody can download.
In the next couple days, definitely we'll have content.
In the next couple days, and then I would love to throw that in a Unity project, just really simple to show you how I take that, create a sprite sheet, take all those elements, and then you can animate them and stuff.
I see. So even more cool things to come after this session today.
Really, really cool.
Well, thank you for joining us. Just a reminder, we're going to be taking a meal break. We'll return in about an hour, and then we're going to be covering 3D games. So we'll see you then.
Cool.
Hello, welcome back to our day of Unity learning session 2, developing 2D and 3D games with Unity on Windows. I am joined now by another good friend of mine, David Crook, as we talk about this next section, one of my favorite parts. We're going to be talking about 3D. I did my intro before. I'm Adam Tuliper. I've got some added info on my slide at the bottom there. If you want to follow me out on Twitter, I'm always adding tons of cool stuff on there, Unity tips, training. And I want to mention that I have a 4-part session on Unity development coming out in MSTN Magazine. Actually, the second one on 2D just ran. 3D's coming out soon. And then we have the 4th one on building for Windows coming out next month. So that's enough about me. You are new to this, so welcome for your first session here. Excited to have you. Tell us about yourself.
This is my first MVA session ever. I'm David Crook. I'm a technical evangelist for Microsoft based out of Raleigh, North Carolina. Focus on gaming, cloud, development operations. I'm an ALM ranger and did a lot of development operations consulting at various Fortune 100 companies before being a evangelist with the Microsoft Consulting Services. You can reach me at the indiedevspot.com or also on Twitter at davidcrook1988.
Very cool. Welcome to Module 4, 3D game development. I'm excited. Are you excited?
I'm really excited. 3D game development is one of my personal favorites.
It's where the scenes come alive, right? What we're going to be talking about today in this module is 3D in Unity, of course. This is the module on 3D. Physics, vectors in Unity, reading input, creating zombie pumpkin slayer. So we'll kind of take some basic samples, piece them together, and you can understand how the actual final game was created there. It's still actually a work in progress. We are going to upload these assets to GitHub, and we'll have the assets available through GitHub, and we'll post those links out to our websites the next couple days. So you can see how everything was done. 3D in Unity. 3D.
It's awesome.
3D is simply X, Y, and Z. 3 coordinates. Unity actually has the left-handed coordinate system, so if you hold up your left hand, you can see we've got Y, X, or I should say X, Y, and Z is depth. In other words, into the screen, back out of the screen, that's Z. Very easy. If we remember high school math, you typically worked in 2 dimensions with a little graphs there. You had X and Y, and now with games and 3D stuff and really fast engines, we now have Z that we worry about. I don't want to say worry about, that we have to our advantage now.
I kind of like to think of 3D more like 2D top-down, just with the little extra component coming out.
Another way, too. Some of my favorite games, like the Command & Conquer series, like Red Alert, and good times.
Love it.
Let's start talking first about physics in Unity. The 2 main components dealing with physics in Unity, rigid bodies and colliders. You don't have physics in Unity without those 2 components. And as we talked in the first session of the day, they are just simply components added to the game objects. Rigid body and collider. A rigid body is what gives your object mass. Without it, your object doesn't have mass. Gravity must have a rigid body. Your object will not fall if you don't have a rigid body component on there. So mass and gravity. You don't have to have a collider on it, which brings us to next, what is a collider? If you want your object to recognize collisions with something else, you have one cube going to another cube, there has to be a collider. So without a collider, your objects will just fall through each other. They will understand gravity, but they're just going to pass right through each other because Unity doesn't know how to calculate that. So 2 main things required. Rigid bodies and colliders.
So what if I want to have a game with 2D and 3D components? Can I have the 3D colliders on my 2D or vice versa?
The 2.5D game?
Something along those lines, I suppose. Yeah, you know, sometimes I see those games where you've got the 2D platformers and the 3D models, or 3D models and 2D.
You can mix up colliders. There are specially built colliders in Unity optimized for specific purposes, though. So if I'm doing a 2D sprite in Unity, I want to use the 2D colliders. I think you can actually shoehorn the 3D ones on top of it and vice versa. But typically, if you're on 2D, you use the 2D version of the colliders, and if you're doing 3D, you use the 3D version of the colliders. And we'll look at what those components look like inside of Unity. So let's get to a demo here with some physics and go over to Unity. For this one, I will create a new scene. And this is going to be similar to what we saw in the first session here. But we're going to add a couple more details onto this. I just created a terrain that has a built-in collider. It's something that we can work with. In fact, if we want to make it look a little bit better, I can just add a texture that's already in this project. And I believe that I saw...
So this terrain tool, it comes built in to Unity, doesn't it?
The terrain tool is built into Unity. Last year, for the Microsoft Virtual Academy session, I did a whole section on using the terrain tools here to basically sculpt out your environment, where you can just raise, do everything that you want on here.
Oh, cool. We can even add little stars. This is great.
Stars, which is a good mountain shape on here. But let's use this little world to kind of talk about some basic concepts. If my mouse will actually click and let me move over here. There we go. All right, let's take a couple cubes on here. First, let's zoom in a little bit more. All right, so let's take some cubes. And got 2 cubes here. Unity has dropped them right there, which that will work. As it stands now, if I play this game, my camera's probably looking somewhere else. In fact, I can see my camera's looking over here. That's okay. We're going to switch back to this view. I'm playing my game. I'm going to switch back to my scene. My game's running. Notice, I have a floating cube right now. Crazy, huh?
Yeah. Who would have thought you could have a floating cube in a world?
So Unity, this is simply a mesh with a texture on it, just floating in the sky, or shader on it, I should say. 2 of them, actually. If we want physics to happen in this scene, what are the 2 things I said are required?
I think it was colliders and rigid bodies. Yeah.
So let's go ahead. Let's move this over a little bit. Oops.
So what happens if I leave one of those guys off?
We'll show you. We being me in this case.
Yeah, I don't have anything up on my box.
So in this one here, I'm going to do a rigid body. And in this one here, we're going to add a collider. And to your question earlier, what about the different types of colliders? If we look at under physics and physics 2D, under physics, when we add a component, we have all the various 3D colliders. These are the ones that originally existed inside of Unity. And you generally use these based on whatever objects you're using. If I'm using a cube, I want a box collider. If I'm using some sort of humanoid or zombie, I want a capsule collider. So you try to choose the one that matches. There are other ones like mesh collider, which will wrap the entire shape of your mesh. Very, very exact for physics. Very, very expensive for computation time.
So I can use a couple of sphere colliders maybe if I got something that's double sphered.
Yes. And let's say you have a big
dinosaur.
Monster boss. Dinosaur.
Yeah, dinosaurs
For monster
are great.
boss in a game, you can take different colliders down the legs and arms, and you can use multiple colliders to kind of flesh out the collision zones on that character. So on this one here, let's do a box collider, and this one we have a rigid body on the other one. So I'm going to click play and come back to my scene, and you notice what happened here. This guy.
It looks like it fell.
It fell.
And
Actually,
it looks like it's rotating and hitting stuff.
I made a minor, let me double check something here because I think I made a minor boo-boo. I added a double collider here. The cubes by default actually have a collider on them already. I added 2 on there, not a huge deal, but that's why it was actually bouncing as it went down. If I remove that, so this is my rigid body, I'm going to remove that collider. Let's just get rid of it. Remove
Yeah,
the component.
completely. I love enabling and disabling the parts, though. It's fantastic.
And
Holy cow, it went through the floor.
right through there.
I'm going to file a bug against you.
That's a common beginner mistake, too, because either your objects don't have a collider, or let's add a collider back onto this. Add a box collider onto it. But I'm partially through my terrain. If you're already touching in the kind of the collision matrix,
Oh.
like let's do hold on, this is going to be problematic here because of my...
The collision system's a bit faster than your mouse,
It is faster than me here. Let's try this guy here. See, it's acting funny now. It's popping up. Anyway, so one of the common things that you'll find, you place like a character controller, which we'll talk about shortly, objects on here, and they pass right through. And that's typically because the collision zone is sitting just a little bit beneath the surface here. This is probably happening because of my raised terrain here. So I just want you to understand the basic components here. Rigid body gives your object mass, and you can actually assign a greater mass here to your object. This helps when one object is hitting another object. Who's going to win? Who's got the greater mass? That's what that affects.
Elephant versus the balloon.
That's right. Use gravity is checked off by default here. And you have other kind of more advanced options, like to be able to tell Unity, hey, don't rotate my object when it falls. I want to keep that rotation. And that comes in handy quite a few times. We'll look at that when we look at the game further. So what I did here was just a rigid body and a collider. Now let's take this a little bit further here and talk about vectors.
All right.
Like I said to Matt on the last session, Vector from Despicable Me. Did you see that movie?
I saw one of the Despicable Me's, but I was more enticed with the Minions.
Minions, love those guys. Vectors, they're just values. They sound confusing, and in math, they could be confusing. In Unity, they can actually take the place of a bunch of different things. They can be used to represent a rotation. They can be used to represent a direction. But in a nutshell, a vector is nothing more than a point, just two values. It's called x and y, but actually two values that by themselves have no meaning whatsoever. If you create a new vector, it's nothing more than essentially 2 points stored in an object. There's nothing special about it. A vector 3D object, which exists in Unity, just contains three values, x, y, and z. And again, they're just numbers. The fact that it's called x, y, z means absolutely nothing. They could have called it q, h, and a. It's just they try to map it to what you're using as your coordinate system in Unity. Vectors can represent different things, directions, values, forces. They can represent a rotational value. They're just values. And they can be relative too, which is something very important to understand in Unity. There's forward space, which if you were to hold up your left hand and we had x and y and z was depth. When you open your scene, you have these world coordinates. They're global. Forward is essentially z everywhere. Take a cube. Forward could be however that object is rotating. And you have the option of choosing one or the other in Unity. You can say, hey, in my world, I want to go z. Or I want to go z wherever my object is facing, which is actually forward. And so we'll look at a little brief example of that. Related to vectors, though, typically in Unity, you'll see in moving objects. And there's a bunch of different ways to move objects. In my MSDN series this month, I had, I think, 7 or 8 different methods listed of moving an object inside of Unity. And there's questions like, well, which one do I use? And the answer is it kind of depends. Typically, you add a rigid body to an object, and you move that rigid body by setting its velocity. So the first code example here shows we're setting rigid body velocity to, what did I say vector was? Just hold some values, right?
Yep.
So here we're saying 7 in the x, 0 in the y, and 0 in the z. In other words, move at 7 meters per second in x. Now, in the next one here, we're saying, same thing. We're setting the velocity on an object, but this one looks a little bit different. Sounds a little bit more complicated. The top one goes in the world coordinates. So the top one where it says vector 7, 0, 0, that is in my global world space, how that object's moving. In the example at the bottom, we're setting the velocity to transform direction. And that basically makes it local. So wherever that object is rotated, it's going to move forward in that direction. So one way of dealing with world, one way of dealing with local. And they both come into play in different cases.
Yeah, that's a pretty cool trick. I hadn't actually been using that. I'd been doing all of my stuff off of trying to translate it myself. So cute, cool little tip even for me.
So let's look at some essentials in Unity here. The way I want to kind of structure this, since we're going to look at a more advanced but still kind of basic game that we pieced together, the zombie pumpkin slayers. What we're going to do is talk about the basic components required for that. So input, movement, vectors, and collision. So let's go ahead and look at that demo. And I have another scene set up here called Cube Me. We don't need to save this one. So what is in this scene? I have a terrain, which I created in the last one, which is simply create a 3D object terrain. Gives us just some base to work on. I have, it looks like it's kind of a little bit textured here. This is just a rock texture. This is actually a completely flat surface. Even though it might look like it's not flat, it's completely flat. I have a few awesome cubes. And what I've done with these cubes is they have a box collider, which is there by default. I've added a rigid body to each of these cubes. Aeons. In the first session, I mentioned tag. It was simply a way to assign a text string to an object here. I tagged them as enemy cube. And we'll see why we do that in a second here. And then I have a cube with controller. So this is the special guy right here. This cube has its own component on there, a script. Let's look at what that script does. We have two code methods we're going to use here. We have update. Let's increase this font size just a little bit.
There we go.
So we have update. Now, in Unity, when you want to read input, there's an input system in Unity. So if you want to read however you're moving horizontally or vertically, you call input.getAccess with this name. And what does that name map to? So if it's using a string here, horizontal, well, if we look over in Unity, under our project settings, input. And there's a bunch of preset definitions here. Horizontal, the name horizontal means we're looking at the left and right arrow, or the A and the D key. Think of the common keyboard gaming keys. A and D move you left and right.
So why do I want to go through this instead of using the get key, input.get key code? I
like using an axis because axis you can map around. It's easy to, for me, conceptually represent horizontal and vertical. And then I have a whole input manager. I can easily swap them out and change them, or if I want to assign to a joystick.
So if I want to configure my own keys, it makes it a little easier?
Yep, absolutely. You can just set them right in here. You've got your own custom key definitions. So I'm just going to read horizontal here. And this is going to be a value between -1 and +1. And when you hold the keys down, Unity will actually scale that object, those values. And it kind of ramps it up pretty quickly. You can control how quick it ramps that value up. Let's just see what those values look like here. Let's run this. And I'm going to view my output here. Right now it's 0. I'm not moving anything. Let me find that cube. Oh, you know what I did? I turned off my camera. Turn that guy back on. All right, so I've got this cube right there. Input is currently 0. Now notice, as I press the D key or the right arrow, either one, I can see that cube kind of pressing over a little bit. And these input values, they scale up and scale back down again. Unity's actually collapsing these debug messages here. There we go, 0. So that's how we read our input. Now we can take that and we can map that to something. So we've got some value between -1 and 1. We can say, you know what? We want to move in our Z direction by some value. In other words, whatever we're reading from our input. So we press the keys, we get this horizontal value. It's a pretty small value, so we're just going to multiply it by some sort of speed. In this case, I use 10. It's an arbitrary number. You kind of find what works for your game. And that becomes our movement vector. Again, it's just a value. It's 0, 0, and yet 0 for x, 0 for y. And in z, we have some value. And we're going to set our rigid body's velocity to move in that direction. So that takes care of moving over. Next, because we have a collider on this object, we can actually hook this method here, which is behind the scenes. Unity uses reflection to see if you have these methods defined in your class. And it calls onCollisionEnter and passes you this collision object, which is based off of whatever you've collided with. So I'm doing a little debug log, this.name collided with whatever I've just collided with. Now, I said I was using a tag. And why am I using a tag? Because you can collide with tons of things in your game. Your cube can drop and collide with your terrain. It could collide with another cube. It could collide with all sorts of things. I only want to do something when I hit an enemy cube.
This kind of goes back to an earlier session when we were talking about prefabs, because the name, if we went off that, is possibly a clone, right? So if they're all tagged the same.
Yes. So in other words, I could say if collision.gameObject.name, but that name can change. To David's point, if I'm using other prefabs, we looked at prefabs in the first session, and I create one dynamically, which we use the instantiate call to do that with. If I create one dynamically, its name can change. It could have a parenthesis clone after its name. So we look for things by tag. And so I've tagged those cubes as enemy cube. If it's an enemy cube that my main cube collides with, I'm going to just destroy that enemy cube. Now, we're not destroying our collision object. Collision is a component. We have to pop up one level and destroy the root game object. This is something you'll see all the time. Since the game object is your root object, that's really what you want to destroy, and thereby destroying everything underneath it. So let's see what this looks like. We're going to run this guy. Move over to the side here, and that cube disappears.
You got that cube.
I got that cube. Got that cube? Oh, yeah, I'm on a roll. I got 3 cubes. I'm cubed. Yes. So, now what do we want to do next? Notice I've got a little text here, increment score.
Oh, there we go. Yeah, you always have to have scores in games.
So, we can easily create an integer value called score. And next, we're going to want to create some reference to text on the screen. Let me delete what I have here so I can show you from scratch. This is Unity 4.6 beta right now, hopefully to be released shortly. You can get this beta on their website. This is everything I'm showing you today can be done with the free version. And I'm going to create, under the UI menu, text.
Ooh, this is that long-awaited UI that everyone's
UI,
looking for.
initially called UGUI, now called UI. And so we'll see if that's the final name. But UI is what it looks like it's going to be. People waited a long time for this because the old system was kind of painful to use. Now you can drag and drop objects. It's so much nicer. So I'm going to create some text here. And you can see it creates this canvas element here. If I double click on it, there it is. Now let's take this text. I'm going to go into my 2x3 mode here because it makes this a little bit easier to see.
So you have to essentially drag that text within the bounds of that white square to make sure it's on the screen. Is that what I'm gathering?
We can see it over there on the side. So this represents my screen. And this can actually see how it grows and sizes. That canvas dynamically changes to whatever size, essentially, device that you're on. So what I'm going to do here is I've got a couple fonts in my project. And you can just go over to, we were talking about earlier, something like thefont.com. Find a free font there, download it. I'm using one that Matt put into this project here, Ghoulish. Let's bump this size up a little bit. Now, I can type in a new size, or it's a little discoverability thing in Unity where any number, you can actually click on the name, and it becomes a slider.
There we go. I like the Ghoulish.
We'll call this score 0. All right. Now, I need some way to update this score when I do something. So let's go back to my code. And in my code here, I've got a score. Let's get a reference to that text box. And I can create it private, because I might not want it exposed to the world. And this is a text element, which by default is actually not there. You have to bring in. By default, it's not going to be found. So if I right-click on it, I can just resolve the reference. It exists in this namespace, unityengine.ui.
It's one of the nice things about using Visual Studio.
I love it. So we have this element right here. Now, this is just a private variable. How do we set it? Well, we can search for it when this game object starts up. But I'm going to use one of my favorite features of Unity, and I'm going to display this field in the editor. If I make it public, it will automatically show up in the editor. But then it's public that other classes can read that value. I don't want that. I want this still private, but I want to expose it in the editor. So I'm going to add the serialized field attribute to it. And simply by doing that, if I go back to Unity, and I look at my cube with controller, what we'll find here, notice,
there it is.
I've got that text box there. It's not assigned, so I will just drag this on over. Voila. It's assigned. And now in my code, after I do my collision and destroy, I can say, hey, I want to update my text. It's a text box with a text property. To, now you could use string.format here, which I would typically do, but just to save a second or two here, I'm just going to say underscore score dot toString. Alrighty, let's see what happens, shall we?
I'm excited. I'm hoping we get 3 points.
All right, now let's try moving this over. Oh, you know what I forgot to do?
What's that?
Increment my score. Score plus.
You even had your comment in there for it, too.
Increment score. That meant the overall process, which the UI is so essential. But so is the other, right?
Yeah, you can't forget to increment the score, yeah.
All right, so let's move this guy over here. 1, 2, 3. Easy enough. These exact same concepts we just did right here. where we read input, move an object. Typically, you'll actually see this done in fixed update.
Why are we doing it in fixed update?
So, update calls per frame. If your game is running 40 frames a second, that's running 40. This code is getting called 40 times a second. With fixed update, the physics engine in Unity works at a fixed time step, which you can define in Unity. I think it's 0.02 of a second, so 50 times a second it runs. And because physics, they need a consistent value to do it in. So this method gets called basically 50 times a second. It's a fixed time, and that's good for physics. There's rules sometimes we can use one or the other. I cover that a little bit more in the MSDN magazine article because sometimes you want linear motion, sometimes you want scaling motion, so one's good for one, one's good for the other. But typically, anytime you move a rigid body, I should say often, you'll see in fixed update.
Makes a lot more sense now.
So now, these same concepts here, colliding with an object and moving an object and updating the UI, they are essential concepts, which will bring us to, when we create our game, piecing all the elements together. But first, people are going to notice when I run this game, they're going to say, all right, this is a 2.5D game. We're talking about 3D here. How do I run around in a 3D world? And I just want to show this real fast because it's so essential to understand the options that are out there. So that's going to bring me to something called character controllers. And if I go to my Unity project, the same one I was just using, I'm going to disable that camera. And I have brought in Unity's sample assets, it's called. Right here. In the asset store, you can download sample assets. And there's an AI character, AI car. They've got this little first-person and third-person controller. So I just imported that into my project. Once I did that, I can come over here under standard assets. Under sample assets, characters. Now I could do a first-person controller, and I could just simply, let me find one of my cubes so I can place this right near my cube. I can drag and drop this guy right here, run my game.
Oh, we have a game.
And I have footsteps. I don't know if you can hear those or not. I can jump. So I can do that with a first-person controller. I can delete my first-person controller. I could come in here with a third-person controller. And I could run around with that third-person controller as well.
And these assets are really great just to bring in and take a look at to see how they're actually building these assets.
Now you'll notice the funny thing is I'm reading input on the cube, and my characters are reading all of my full input. That's why you see both of them running around. And look at that guy runs into the cube, knocks him around. So really, really cool things you can do easily. Since you want to get up and running in a game fast, I highly recommend downloading those asset packs and checking it out. For what we did in this next game, Zombie Pumpkin Slayers, we kind of wrote our own code on there using the exact same principles that I just showed in that demo scene there. Exact same principles. So first, let's cover what we did on the title screen here. So our title screen that we did, let's run the game here so you can see it. You guys are going to see the game now. At least we'll see the title screen first. We'll slowly unveil it.
It's always the best way. You can't give away everything right away.
Give away everything. You got it.
It's kind of my favorite music track, too.
I love the feel of this music for this game. It's just
Zombie
right.
Surfer dude.
Zombie Pumpkin Slayer. We've got this animation going on here. Got some UI elements here. When I click on this button, my scene will load. So before we do that, though, let's just kind of do a walkthrough here. This is nothing more than some UI elements placed out here. Let's go like this to unveil what this really is. Remember, on that last level, when I added a text box, it added a canvas element for me. That's what this new UI system does. Any UI elements add this canvas here. So what's a UI element? If you take an image and drag it on your screen for what Carl was doing, for example, that's a sprite running around on the screen. That's not a UI element, typically, although it can be. When I think of a UI element, think of a heads-up display in a game. You know, you've got a score in the upper left-hand corner, and it shows you your power-ups in the lower right-hand corner. That's, to me, that's a UI, a GUI system. They're fixed on the screen, although they don't have to be. With a new UI system in Unity, they can follow characters around. You can actually have any UI object anywhere in your scene. But for the sake of this, for what I'm doing here on the title screen and for the score and whatnot in the game, I'm using the UI system. And anytime you add any UI component, it creates the canvas for you, and this event system, which is how it detects what you're clicking on. So under the UI menu, you've got a couple basic things. You have a panel, which is nothing more than an image. You have a button, which is nothing more than an image with text and a script on it. You have text, you have another image. So a lot of these are based off of images. And literally everything I have here, except for nothing, actually, except for this button here. So I've got these images right here. Let's see each one. So I've got my background. Let's zoom in on this guy a little. You can see that bluish image in the background I disable. That's nothing more than an image right here. And early on I talked about a game object being this name and tag and a transform. With the new UI system, you have a rect transform, which is a different object. Similar to the regular transform, but this is fixed more for 2D. You have a whole anchoring system on here that you can anchor things in the corners so they will stretch with the screen. Very similar to what you'll find in Visual Studio for when the new .NET stuff came out and the new Windows Forms and XAML, how you can take elements and dock them in there. Very, very similar to that.
So I can dock elements inside of other elements as well then?
Dock other elements inside of elements, inside of other elements, inside of other elements, make them all scale out in front of each other, do some really cool things there. So these are nothing more than images with a script on here, which basically just says, hey, what source image is this? And it's just a sprite in our scene. When Carl was doing the character animations, they were just sprites. These are just sprites assigned to this script. Same thing all down the line here. We've got pumpkin row, right there, those pumpkins. We've got the blue glow, just nothing more than a glow. Blue glow. Pumpkin row.
That sounds like a band.
I know, I was thinking
Pumpkin row.
Now you've got Skid Row stuck in my head. Thanks. We got the logo, Zombie Pumpkin Slayer. Notice here, we can set, if we want to stretch, see how it's stretching with it and is growing?
Oh, that's beautiful,
because
too.
I've set that in the horizontal direction. I want to expand. I can expand in horizontally and vertically if I want as well. So and down here is a button, which is nothing more than an image and a script on there. With these scripts, it can detect a click and call new a method. There's a couple different ways of doing this in the UI system. And also, you can have different transitions. So when you mouse over your button, you can play a different animation. These are just 2D animations, just like Carl showed in the 2D session. And they will create these for you. When you basically create a new button, let's just create a new one to see this here. UI button. If I go to animation,
look at that.
Auto-generate animations. If I click on that, it says, hey, what animation names do you want this? And it'll create them all for you. So it's real easy to do. And the button, again, is nothing more than an image with a button script and a text component underneath. So real basic components that make up this UI system to do some powerful stuff on there. Now, when you click on the button, again, there's a couple different ways to do this. In my button script, I'm saying, this game object, I want you to send a message to it. Send a message. And again, there's several ways to do this. I can think of actually 3 off the top of my head. A direct reference. You can hook into this event in code. Actually 4. You can use your event system, or you can specify a method here. So this send message function says, give me the text of a function name on this component. So it exists in code somewhere on here. Let's open the code. This function is what I'm going to call when you click on the button. So let's go back to that. This here is going to call the play clicked button, the play clicked method, I should say. And in order to load a new level, in other words, load a new scene, they should probably call this load scene. It would make more sense to somebody first learning this. You give it the name of your scene. Now that scene has to exist in your build. File, build settings.
With a check mark next to it.
Yes, file, build settings. This is where all the goodness happens. This is where you can select all your platforms. It's also Control-Shift-B if you like hotkeys. It's the same hotkeys Visual Studio. And in here you can say, I want this platform, set that as my default. These are all the scenes here. You don't have to have them all in here.
Ooh.
You can kind of keep them all pretty simple if you want. Let's do this here. Remove a bunch of these. And actually, just to show you this is how the empty dialog box is right here to start. I can add on the current scene. We've got that one. Okay. Now I've got the title scene in my build. Any other scenes I want, I can just take those scenes, maybe drag them into here. And that's
Pretty
it. So
cool little shortcut there.
these are the names of the scenes that must exist in order to call that code. So I need a title or arena, Atom main. Now let's run this guy. So we have our title screen. When the game runs, we'll click on that. It calls application load level. Now we get to unveil. What do we get to unveil?
The actual game itself. You guys ready for
Zombie
pumpkin
Slayers. All right, let's look at this. Now, let's kind of dissect all this out here. Before I do that, let's make sure we get the right slide here talking about this because this is of epic proportions. We don't want to miss this. Demo, creating zombie pumpkin slayers. This is going to be the gameplay aspect of it. This is going to model all of the basic components that we just looked at with those cubes. It might look complex-ish. Let's run this and see what happens. Actually, let's make this bigger when we run this. So you can click maximize on play. Let's run that. So we created this over actually the last few days. We had a bunch of different ideas. So these guys come up to the tombstone here, and they try to attack it. There's some particle coming out of that tombstone. There's randomly spawning pumpkins here. They're playing different animations. And your job is just to keep smacking the heck out of these pumpkins that are here. Let me eliminate these real quick.
What an awesome set of graphics on
there
here as well. Talk about the power. Cool lighting effect.
So the Matt is I did all the code integration behind this. Matt is the mastermind behind, of course, all these graphics on here. So let's pick this apart here. Let's see what we've got in this scene. We've got more guys coming here. This is what I was talking about way, way earlier, though, so I can just show you while I'm here. We can do per frame advancing here. You can see my little guys running each little frame there. So if you need to do fine-grained debugging, you can use that a lot. Okay, so let's pick this scene apart. We have a world that's a 3D model. Let's go in the wireframe here. You can see it's kind of it's a little bit dark in there, so we can see in the background here. If I go like that, actually, let's do textured wire. So we've got a level. You can buy these off the asset store. You can make them yourselves. We're going to talk about this a little bit in the optimization session tomorrow. We've got more 3D models that are just kind of plunked in here. If we look at this guy here, just a mesh render.
Pretty simple,
It shows it's very, very simple. Our pumpkins are just also meshes. And they have a little controller script. They have a rigid body on them, so they're on the ground, moving across the ground. They have a pumpkin controller. It's got a speed. And I simply have a variable defined here for hit colors. If you notice when I was hitting it with the hammer, it would flash a color. And when the pumpkin gets smashed, we play a particle system. Remember I showed earlier, real quick, I did a particle system. So this particular particle system I used on here was part of the Tune FX pack, which is a really cool particle system on there. You can find some free ones and pay ones on the Unity Asset Store, some really neat ones. And I basically say, hey, I need a reference to a particle system I want to play here. When this pumpkin starts up here, we find a couple components. So this pumpkin has animations. We need a reference to our animator component. That's going to control what we're going to animate, what we're going to do. I need a reference to my renderer element. Well, what do we do with our renderer element? We're doing nothing more than flashing a red color. That's why we need this component. Now, movement, I'm just a little caching a reference here. Sometimes we'll cover this in optimization section. It's best to cache certain things, saves on what's called garbage collection and allocating memory later on, sometimes if you do things up front. We'll talk about that again more in optimization section. I have a game controller object in my scene. Game controller is just essentially a near empty game object. It has no visual properties. And a game controller you find in a lot of games. It's a script, an object in your scene that has some code methods responsible for doing something. It's kind of like the coordinator in your game. In this game, this one is responsible for updating the UI for a score, exactly like we saw on the cube demo. And we have some random stuff, some random spawning.
It's kind of like the orchestrator.
The orchestrator, yes, exactly. Now our pumpkins, let's click on this pumpkin here. Matt designed this pumpkin, and with them we have in our enemies folder a bunch of pumpkin enemies. So we have a model for this pumpkin. Let's find, here we go. This is the model that Matt created for the pumpkin. And then separately are all these FBX files, all the animation data contained within them. Actually, in these cases, these are .ma. These are dropped in right from Maya, but they can also be FBX files. And in here, if I expand it, I can see I've got some sort of data in here, a bounce animation. It's going to be pretty tiny here. But you can tell something's bouncing up and down there. So the animation data is simply combined in these separate files here. So what we're doing with that animation data at runtime is we have an animator component. Let me shift spacebar here to make this bigger. And what the animator component does here is this simply will take a animation state. And let me get out of this again to show you what an animation state is. These are simply, these little cubes here, these rectangles, do nothing more, absolutely nothing more than point to an animation file. These are the files that your animator creates, or you get from the Unity Asset Store. You can get literally tens of thousands. I think Mixamo in their catalog has over 10,000 animations available.
Wow.
So these point simply to an animation file. If we click on one, we can see what it points to here. Bounce 1, bounce 2.
What's this system called, by the way?
This is Mechanim.
Mechanim, okay.
In Unity, you had several different animation systems. You had the legacy animation system and Mechanim, which introduced these ways of blending animations together and these state machines. It gives you a nice visual way to kind of see everything that's going on. So, for example, let's take our zombie kid.
Ooh.
So our zombie kid here, let's run this. And let me actually make this not maximize. And we've heard the soundtrack many, many times. So let's mute that. I'm sorry.
There goes our...
I know, it's cool. So Zombie Kid here, we get this auto live link. And we can see what's playing right now. Idle's playing. And in code, I can control it. I can say, as soon as I read input, transition to run. Well, how do I do that? I can set up little variables here. I can create a new variable. A Boolean variable called whatever I want. And I can control these in code through that animator component. So I could say, I want you to transition to get hit when I set hit equals to true. How do I know when hit equals true to transition over? I click on the arrow. And I'm saying right now the default is play animation, go right to this one. I don't want that. That's saying play the animation idle, and when you're done playing it, go to get hit. I want to actually trigger this only when hit is equal to true or false or whatever. As soon as that value becomes true, it switches. And you set those values in code. So if I go over to my project here, let's go back to our pumpkin controller. Right here. So let's say, for example, this was the get hit. If I wanted to call that animation right here, that was the hit variable I added, the hit Boolean value. If I wanted to trigger that animation, all I would say is animator dot set bool and give it the name of it, hit, comma true. And that would actually transition that animation state. And you can mix them a bunch together. You can do some really, really cool things. As I mentioned early on, I think in the first session, that Mechanim allows you to have a character potentially shooting from the upper body and running with a lower body. And you can actually take multiple animation files and mix them all together. The sample assets have a great example of that. They use a whole bunch of different animations for running and turning to blend between all those
where you kind
states.
of tilt over to the side a little bit while making a right turn.
So we've got simply some code that's controlling the pumpkin state. And that code here, let's go back to this. Fixed update, the movement of the pumpkins, all we are doing. The pumpkin's entire existence says as soon as we come to existence, whenever this fixed update, remember that runs with the physics step that happens 50 times a second. Whenever we call fixed update, we're setting the velocity of our pumpkin in some vector. The forward vector, and since we're using this transform direction, is the forward vector for our pumpkin, meaning wherever our pumpkin is rotated, we're moving them that way. So how does that come into play in this scene? I have 2 spawn points. They're just random. A spawn point is nothing more than an empty game object. That's all. It's an empty game object. There's no properties to it whatsoever. And I can simply, when I spawn something, just create it at that location. So I've got 2 spawn points here.
Spawn left and spawn right, I guess?
See them right across opposite sides of the tombstone there. Spawn right, spawn left. So all they do is an object gets created right here and just starts moving in its forward direction. I create an object here and I rotate it towards the cross and it just starts moving in the direction. All that is accomplished simply by 1 line of code. Set its velocity to move forward. That's it. Now, the main character, so that's the pumpkin. They're pretty dumb. I hate to even call it AI because it's really, 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 really basic. The main character, Zombie Kid here. Notice when I highlight Zombie Kid, what do we see? On his little hammer there, I've got this big green box around it. That big green box just so happens to be...
It's a collider, isn't it? Ooh, he's far down that chain, too.
Yeah, and you'll see this a lot. When somebody gives you a 3D model, there are actually many levels nested deep of various bones, so to say, various aspects of this character. So if we look at Zombie Kid, we've got body, root, lower back, chest. You can work your way down. So right clavicle, right shoulder, right elbow, wrist. It comes like that. And typically when you get models and somebody gives it to you, they're already auto-generated like that outside of like Maya or whatever the tool is. You can control that in that particular tool, but you'll see this quite often. And so what I did was I just found the club in here, and all I did was I added a box collider to it right here.
So I could do the same thing and put one around his head for headshots.
You could put one around his head. Now the reason I added the box collider here is because I want to know when this hammer hits a pumpkin. So I added the box collider here, and my pumpkins, on the other hand, they have a sphere collider.
Ah.
So when this hits that, it triggers an event. Remember we saw the events before?
Well, it's kind of hard to read, too.
Code here.
Can we get it a little bigger?
Crank this code up a bit.
There we go. Now
Remember, anytime that we call collision events here, on collision enter. Now there's actually, what I did in this case was very slightly different. And you might notice here that this checkbox is checked off on our collider. So a collider can serve 2 purposes. A collider can be for physical interactions. We saw when we took our cubes and ran them into each other that they literally pushed one out of the way. It had a velocity, hit the other one, and moved it. That's a collider. And a rigid body, because we have mass. You can also have a collider as what's called a trigger. And what you are telling Unity is do not do any physical interaction but notify me. In other words, when one object comes within range of another's collider, don't push it out of the way. Let it go through. But you notify me in code that something has happened.
You can start whole event sequences using this.
Exactly.
Conversations or...
Exactly. So in this case here, I don't want this pumpkin to get pushed out of the way. I want this really animation to go right through it. But I want to be notified that that trigger happened, and then I can decrement count and just destroy my pumpkin. To your point, what you said, you can spawn off conversations, right? If I have, let's say you could converse with a zombie sitting here. I could just take this guy and add on let's just do a sphere collider, just as an example here. Scale this out a ton and set it equal to a trigger. Unity will now notify my code event. I have to have, I'll show you this here.
One important thing to talk about is it's notifying the code event for that particular object.
For that particular object. And when you have a trigger, it's no longer on collision enter, it's on trigger enter. Very similar purpose. It's just one notifies you and there's a physical effect. One notifies you with no physical effect. So all I'm saying here, let's say your character comes in within this region. Bam, your zombie comes to life. Or you start conversing with it. That's how regions are detected inside of Unity and many other systems as well.
Now we can have him stop talking to me if I walk outside of that too.
Yeah, so there's 3 with a trigger. You have 3 events typically used in that case. You have what we're doing here, on trigger enter. You have on trigger stay, which fires near every frame that you're within here. So this on trigger enter gets fired once. when you move into this range. As long as you're in that range, on-trigger stay keeps getting, and then you'll get on-trigger exit when you get on out of there. So 3 events that you can use for that to detect exactly what the state of that character is in there. We added score. So let's do this. This is on our player. This is on our zombie kid. As soon as that hammer hits something called a pumpkin, we're checking to see if we are currently using our smash animations. Why would we do that? I'll tell you why. If we're standing there not doing anything, and a pumpkin runs right into our hammer, do we want it to apply damage?
Yeah.
Kill all the pumpkins. We could do it that way. I wanted somebody to run around this game and always have to hit them as opposed to stand there and let pumpkins run into them and die. So I wanted to make sure I was playing a smash animation before I would dole out any damage. That's all this code does right here. If I happen to be playing a smash animation, then I give me a reference to that pumpkin's controller, and I call a method on there called apply damage, which does nothing more than we basically had on our...
So you could take these same concepts and apply them to other types of fighting games, per se.
Absolutely. This is exactly how it's done.
Perfect.
You call apply damage, it reduces the amount of your health. If your health gets less than or equal to 0, because maybe multiple things are hitting you at once, you always want to check if it's less than or equal to, then you start a coroutine. And this is kind of a weird-looking thing.
Die.
But so not only die is a weird-looking thing, but start coroutine. A lot of folks, if you're joining us today, happen to be a .NET developer or C or C++, whatever, and you're used to spawning off threads on a system, the question comes into play, how can I do threading inside of Unity? You don't spawn off threads in Unity. You start off coroutines. Unity works off a coroutine-based system. You can read about it on the net. It manages all of that for optimization's sake on the back end. So you basically tell Unity, I have the intent to start a routine. You give it the data, and it will schedule it in its preemptive system on the back end. And so that's start coroutine. So I'm essentially saying, do the equivalent of starting off some other processing thread here, but in Unity use coroutines. And I just call my die method. And die does
Exactly like it sounds.
exactly like it sounds here. I have some comments because we're going to build upon this more tomorrow. Die instantiates my particle system. And in this case, it actually deactivates the pumpkin. And we'll talk more on that tomorrow, why we would want to do that when we do our optimizations. And then we simply game controller increase score. And that's where we get our pumpkin count increasing on there. All the same concepts. So what we're doing here is we're using a rigid body to move our pumpkins. We are using a rigid body to move our player and our... I should have just overall bumped up the font size. Right here, we are doing the exact same thing on our player. We're reading the input from your keys and mapping that over to its vector. Same thing that we do with the cubes. And we have some other code in here. This guy right here.
This looks a lot like 2D, just with an extra Z, doesn't it?
All I'm doing right here, yes, exactly. So this is really a 2.5D game. It's a 3D world. But what I want to do here is I want that character to run back and forth. I don't want him to go anywhere else. So I'm really constraining him to some dimensions here. I also don't want him to run outside of the world. That's where you can use things like the math.clamp function. This code will all be available for download. I'll have some extra comments in here. The main thing is here, we're doing all the exact same stuff that we did with our cubes. We move an object, we detect a collision, we increment a score, and we destroy an object. And potentially, when we destroy an object, we spawn off a particle system. It's really a really easy process. Everything else just is on good graphics, good gameplay, tying that all together and making it something that kind of looks very interesting. So thankfully, the asset store, you can download a lot of cool stuff from there and use it, or hook up with an artist. Really cool ways to do that.
I gotta find me a Matt Newman.
Gotta find you, Matt Newman. Very, very talented fellow. So, that is it for the magic of a 3D game. That brings us to the end of our 3D session today, and we're going to have about a 15-minute break this time before we continue on with the next session, and that's going to be building your games for Windows, and we will see you then. Thank you very much.
Sounds good. Thank you, everybody.
Hi, everyone. Welcome back to developing 2D and 3D games with Unity for Windows. My name's Jason Fox.
I'm David Voiles.
I'm introduce myself. I'm new to the group here. I am a technical evangelist for Microsoft as well. I focus on gaming, cloud, client technologies like Windows Phone and Windows Store. I've been doing development for about 13 years after leaving the military, and I've done a lot of stuff. I've done video games. I've done graphics programming, natively, DirectX, OpenGL. I've also done a lot of data visualization and UX design. Dave, you want to introduce yourself?
Sure thing. I was on briefly earlier today with Adam Tuliper. I'm also a technical evangelist based out of Philadelphia. My background was in web development and gaming. Previously, I was at Comcast working on their Xbox applications, and now I'm here joining these wonderful folks at Unity and Microsoft to help these projects get off the ground.
Great. So we are in Module 5, building for the Windows platform, using Unity to target Windows Store and Windows Phone. So what we're going to talk about is we're going to cover the stores. So there are two separate stores right now, Windows and Windows Phone. And we're going to talk about exporting your game to each one of these platforms. And then we're going to talk a little bit more about the hardware, what's involved, what kind of hardware you can target. And then we'll talk a little bit about platform-specific features at the end and how to make use of those. So let's delve into the stores. We have a pretty vibrant ecosystem now.
Yep.
We've been working to expand this the past few years since we launched the platforms. We've got over 500,000 apps now across Windows and Windows Phone. We've got, at any given point in time, over 100 million active users. That's a great 250% year-over-year growth from last year. We've got developers joining the platforms in droves. 89% growth year-over-year from last year, over 640,000 now. And we've continued to grow our MO partner billing throughout the world. I mean, globally, with different countries in China, Europe, and that's very important with mobile operator building to attack those markets where instruments for purchasing things are not really readily available.
Yeah, I'm glad you bring that up because a large issue that game developers commonly run into is they only seem to target the countries they're from. And obviously Microsoft, we're here in America. So many developers, I'm sure you see this as well, in your location, they tend to just focus on America.
Yeah.
Like I said, China, Brazil, a lot of third world countries are a huge target for Microsoft at this point, especially with lower powered devices. So as Jason gets deeper into the talk, consider that your game doesn't necessarily have to be the most beautiful or gorgeous thing in the world, but often considering a lot of those low-powered devices that are in many of these emerging markets as well.
Yeah, and talking about these emerging markets and instruments for billing, a lot of these credit cards are not really available to these people.
Right.
And so mobile operator billing is super important for them to be able to make in-app purchases and buying games from the store. So let's talk or go over some real quick games that are out using Unity on our platforms. Driftmania. We've got some pretty large, big IPs who have used Unity on our platform. Temple Run, that Frozen Freefall.
Yep.
My wife plays that like every day. Anyways, just to give you an idea of what the capabilities are on our platform, there's some great games out there already. Thousands of games.
Yeah, a lot of diversity
with Unity.
There. And easy for students or even professionals and AAAs to get on board at this point as well.
Yep. So let's try to understand the way that the app stores are broken down here. So we do have two stores right now.
Yes.
We've got the Windows Store, and this applies to devices running Windows 8, Windows 8.1. That includes the Windows RT devices like the Surface RT tablet and the Nokia 2250 or 2520, whatever, the Nokia RT tablet. It also delves into the tablets, all-in-ones, desktops, laptops that are running Windows 8 and Windows 8.1.
Okay, so we've got a pretty broad spectrum there then, right?
Yeah, pretty much any PC or tablet running Windows 8 and above.
Yes, really, anything from...
That's what the Windows Store, that's how you're going to get your apps onto those platforms.
And definitely something to consider when you're starting to put a lot of this together, whether you're going to have touch controls, game padding controls, because, like I said, people may be playing on a flight, on a tablet, or maybe at home in a huge desktop with a standalone GPU inside there. So really think about this as you're starting to put some of your products together too.
Yep. Now, the other store is the Windows Phone Store. This is going to have a slightly different reach. It's targeting devices like the Nokia Lumia line, now Microsoft. Mm-hmm. HTC, they just launched their great flagship phone, the HTC One M8.
Yep.
Huawei.
I use a 1520.
Samsung, right? These are all these emerging market phones that we don't necessarily see here in the United States. Operating system-wise, Windows Phone 8, Windows Phone 8.1. Mm-hmm. The Windows Phone 8.1 is the new operating system update that's rolling out globally. I think the last I saw, about 25% is there.
Yes.
And the operators continue to push that out over the next few months. What do you think? Maybe by the end of the year, we should see a large majority of the market on Windows.
Yeah, probably more than 50% at that point.
Yeah.
And how about the revenue share? Why don't you discuss that?
So revenue share, we have a 70-30 split, which is standard across any app store that you deal with. So 70% to the developer, 30% to the store for platform fees, publishing fees, and what have you.
Yeah, not a bad cut at all, especially when you consider the number of developers you now have access to.
Yeah. So let's talk about the revenue models and which ones we support on our platform. Advertising, of course. We've got a multitude of advertising platforms available, which we'll cover in just a minute.
Yep.
In-app purchases are huge. While I'm going through these, if you'll pay attention to the bar chart on the right-hand side of revenue source, you can see the trends and where we're at right now. And this data is fairly recent, as of July of this year. In-app purchases are trending upwards in both markets.
Yeah, absolutely.
So phone, much more so now, but Windows Store is also trending upward. And the paid model, the old paid model, is trending downwards.
Yeah, which is definitely like a stark contrast for what something like you and I may have grown up with, right?
Yeah,
sure. As a child,
exactly.
Right, we grew up going to the physical brick and mortar stores, buying a game for $50 and $60, and you expect that was going to be the end of it all. But now you see it's actually going quite the opposite direction.
We're in the 26% at the bottom of that bar chart there.
Yeah, so we're kind of like the...
Yeah, I would personally would much rather buy a game, but the market is trending towards in-app purchases. And these are, consumables, durable goods, right?
Yep. So like a currency exchange.
Yeah, so things like, what is it, the frozen free-for-all? Mm-hmm. If you fail, you can buy a new turn in the game.
Right.
Right. In-app purchases like this, that this new generation of mobile user is keen on buying to continue playing and enjoying a game.
A lot of psychology behind that too. So it may befit the developer to get into understanding the consumer's mindset and what would make them want to, in fact, go after an in-app purchase, like kind of dangling that carrot in front of them.
Yeah, I mean, again, we're not going to delve into the deep into it in this session, but there's a lot of research, a lot of information available on the internet about in-app purchases and how to model it correctly. In fact, Tobiah and I are going to be doing a talk tomorrow.
Absolutely.
On this exact thing, monetization, how to do it the right way to make money. The other model is paid, right? This is the classic model. I go in, I purchase the game, I download it. We have different price tiers, 99 cents the minimum on both platforms. Mm-hmm. We have $1.29, $1.49, and it just kind of bumps up and up and up in increments like that. And I think the maximum maybe $999.
Yeah.
Right.
Yeah, not bad deal at all.
If you want to do that,
full application suite or something like that.
And one thing I do want to note is if you do choose the paid model for your game, please leverage the trial system that's a part of our store. And it's really, really easy to set up from the developer portal. Mm-hmm. You can set up time trials. So I can say that my game's trial is going to expire in 1 day. It's going to expire in 3 days.
Right.
It's up to you to decide what works for you. My guidance on that's usually if they can finish your game in less than a day, don't give them a 1 day full trial. Give them a trial with some limited functionality. Maybe they get the first 2 levels of the game. Right, and then they need to purchase it. So that's another aspect of it that you need to consider. Trials do afford you a lot more upfront downloads.
Yeah.
So, people download your game, play it, decide if they want to purchase it, as opposed to seeing, some big hefty price tag on the front of it. And, some of us may not think 99 cents is a hefty price tag, but a lot of people do. And there's no trial. They won't even bother to download and take a look at your game.
Exactly. And, something I wanted to point out about the in-app purchases really quick. Security is obviously always a big concern, and how do we deal with this monetization, how people are getting paid? Well, Unity developers on Microsoft platform always have the option of having Microsoft handle that currency exchange. So people can have in-app purchases, it then goes through Microsoft's system, and then at the end of the month or billing period, that money and those funds are then distributed back to you as the developer. So you don't have to worry about handling the money. The consumer doesn't have to worry about the security behind it, because it's all handled by the same model that they use to actually purchase the game in the first place.
Yep. And then, of course, the other model is free, right? If you're making your game and you don't feel like you need to monetize it, it's maybe a hobby. Of course, you can always release it to the store for free and get feedback. In fact, I know some developers that do this as a kind of a beta testing.
Yeah.
For a game concept. They'll just release a free version, and they say, hey, does this work or not? If it does, then they take that concept and they refine it into a monetized product later on.
Mm-hmm. So now we have free down. Why don't we discuss a bit about advertising and additional ways to make revenue?
So advertising, we have support from several platforms, right? We've got some pretty major ones on here. I think mobile-wise, AdMob is a pretty big one. The Microsoft ads. Ad Duplex is a really cool one. It's an ad exchange platform that's specific to Windows Phone.
Okay.
And what they do there is they exchange advertising between apps, and you can also purchase ads for your apps on that.
Ah, perfect.
So,
and if there is anything that you notice is missing here that you'd like to see on the platform, please, we implore you to reach out to the tech evangelists so we can then go back to the product groups and work on getting these built into your apps.
Plugin wise, you guys have probably heard about the Prime 31 plugins already. If not, they are free to download. Prime 31 is one of the major providers of Unity plugins. We made a deal with them earlier this year to make all of the Windows platform plugins free, and that's including the Microsoft ads, if I'm not mistaken.
Yes.
Just not the AdMob.
Right.
But the platform plugins, interacting with the store, live tiles, and then Microsoft ads.
Yeah, and Azure as well. Adam and I will be giving a talk on Prime 31, how to integrate their Azure plugin tomorrow at about 2 o'clock. So be sure to come back for that as well.
And then one more thing I wanted to mention on this slide is Ad Rotator. Is a cool little device that lets you plug in all these different ad platforms, and you can feed it some parameters. It'll actually cycle through different ad providers in the same space in your application, in the same control, or in your game. So you can actually start sourcing out for different ad platforms for better fill rates, better click-through pricing, right, that stuff. And it kind of maximizes your impressions. And I'm sure that I think Tobiah is going to cover this more in depth tomorrow. But
yeah,
let's see what's on that.
So why don't you talk a bit about in-app purchases and best practices about that without getting too deep, because like you said, we'll leave Tobiah to do that tomorrow.
So I guess we could talk about the support on the platform for in-app purchasing.
Consumables, durable items, things of that nature.
I mean, it's all managed through our developer portal. You sign in, you go submit your application, your game. You have the opportunity to set up your merchandising for your game. And you can choose these products like these consumable items. These are the items that users can purchase over and over again repeatedly. So it'd be like in-game currency, more lives, health potions, what have you. And then the long-term durable stuff would be something like unlocking a new level in the game going forward. And you can set that to expire. So it'd be almost like maybe you could do a subscription with it.
Yep.
And you have anything to add to that? Or?
So Atlee Hunter, who's a prominent Windows Phone and Windows 8 developer, he has several hundred apps on the platform. He actually gave a really good talk about this at Philadelphia Code Camp several months ago. And I'm sure he has another good blog post about it. Again, it's Atlee Hunter. And he spoke in depth about consumables, the psychology behind it, and best practices, and how, despite not having an incredibly large user base for one of his games, he still managed to make a very good living off of it, just through repeat engagements, fair practices, and really intelligent ways of getting consumers to take advantage of consumables in a way that feels fair to both sides.
Great. All right. Let's, again, here's the in-app purchases. I just wanted to mention also that you could use any third-party commerce system that you want. It doesn't have to be the Microsoft Developer Portal commerce system. So if you're using some kind of game service backend to provide your in-app purchases, you can do that. That's certainly we're capable of supporting.
Yep.
And one other important note, if you do have a trial version of your application, it does not support in-app purchases. So it would have to be a full-blown either free download or a purchased or paid version of your game.
Okay. So now we have the two stores. How do we kind of merge or combine our products in both stores?
That's what we're going to talk about right now. We did introduce this new concept back, I believe we announced it at Build this year, of combining your games. So you can take your game in Windows Phone, and you can take your game in the Windows Store, and you can link them together into a single purchase. And so that's very attractive to people who leverage both platforms.
Yeah.
Right? So we all, Windows Phone, you've got a Windows tablet or PC at home. And I've got an example here of Halo Spartan Assault. That's something, a first-party game that Microsoft put out. If I purchase it on Windows Store for $4.99, I also get to download that on Windows Phone.
Without any additional cost.
Without any additional payments or cost.
Yep.
So it's a great experience for the consumer to be able to do that. You can certainly factor that into your pricing, I think, right? I mean, you can charge $1 extra to make it available on both platforms as opposed to making, so you can do like $1.99 on each platform. You can merge them and charge $2.99.
Exactly.
Right? And then you get better coverage, better install coverage across devices.
Especially with universal apps and Unity, it kind of makes it easier than ever because largely you can have one build process spits out files for both platforms and you're good to go.
Yeah, and that's the universal apps, which we'll cover here in a few minutes. So let's talk about the method of exporting from Unity to Windows.
Okay.
Here's this big chart of prerequisites. We'll try to demystify this the best we can.
Okay. Seems complicated at first, but I'm confident we'll break it down.
Yeah, we'll break it down. So Windows Store, we covered that. We also have a Windows Phone 8 platform and store. So we highly recommend Unity 4.5 or higher for these.
Yes.
Tons of great bug fixes, performance improvements, new features included in those versions. To build, so to run the SDK, you've got to have Windows 8 or greater. For both Windows Store and Windows Phone 8.
If somebody doesn't have Windows 8, what is a great way to actually get their hands on it?
Let's see, what do we have? We've got BizSpark.
Yes.
We've got DreamSpark.
For if you're a student, DreamSpark is essentially our school equivalent.
We have the new Unity developer offer.
Yes, for both level 1 and level 2 developers.
Yep, and we can go over that later, I believe. So you do need that. You also need Visual Studio 2012 or greater.
Which again is included in each of those offers as well. So we'll often handle the operating system cost for you, and in most cases handle Visual Studio licensing for you.
And as with anything, we always recommend the latest version of anything.
Absolutely.
So you can get your hands on it, right? It does require the SDKs for each platform, which are included in the installation with Visual Studio. So not a lot of extra work there. Now, Universal Apps is a new concept that was introduced earlier this year, in spring. Now, Unity 4.5.3 is the version that supports exporting to Universal Apps, and that's live now. You can go download that on the Unity website. That does require Windows 8.1 and Visual Studio 2013 Update 2 or greater. I think we're on Update 3 now. And then the SDKs, again, get installed with Visual Studio. So, and we'll cover what Universal Apps are in just a few minutes. I don't want to delve into that just yet. But you also need a developer account to be able to deploy these, test them on devices, along with also publishing to the stores.
And again, those fees can often be waived through DreamSpark or BizSpark memberships. And I have to point out it's quite a bit cheaper than what many competing platforms charge in terms of developer accounts as well.
Yep. And, if you look down at the bottom right-hand side of this chart, we've got register for $19 for an individual, $99 for a company. That does cover both stores.
Yeah.
Again, BizSpark, I think some versions of DreamSpark Premium offer, the Unity offer. We have several ways of, again, getting that to you for free.
Right, waiving these fees.
And that's just engaging an evangelist or applying to one of these offers that we have online.
Absolutely. And, I thought we were doing right by developers a couple of years ago when we had Xbox Live Indie Games, and it was $100 per year per platform. Now we're dropping it down to $20. It's just getting better and better over time for developers.
Yep. So let's do a demo, and we're going to export the great game that Adam and Matt made.
Okay.
Zombie Pumpkin Slayer, whatever
I like it.
It's called, right?
Yeah.
We're going to export that to a Windows Phone 8 Visual Studio project so we can see what that looks like.
And we just happen to have a phone here to test it as well.
We do.
Yeah. So what is your weapon of choice? Which phone are you using at the moment?
I have a Nokia 1520.
Good choice indeed.
That's my personal phone. It's great. I love it.
I'm using the same thing as well.
I don't think I could go back to a smaller screen now that I'm on that.
Right? People ask, how do you use such a large phone? And my response always is, well, I don't typically use my phone for conversations, right? It's email or OneNote and ways of staying organized. So when 90% of my time goes towards staring at a screen, I need it to be as large as possible.
So I'm going to just get this project open here on the desktop.
Okay, so we're opening up Unity at this point. Okay, anxious to see how this turns out, because I know I have been working on it. I saw with them drawing new art earlier today.
Yep.
Not gonna lie, I get kind of jealous when I see someone with such talent when it comes to drawing art. We're both programmers here, so our art skills tend to be lacking at times.
I'm terrible. I bought a Surface Pro 3 so I could do some drawing.
Yeah.
And it's not gone well.
I'm sure it's better than anything I could come up with at this point.
I'm pretty sure my 3.5-year-old son can draw better than I can.
Hey, there's no shame. There's no shame. Yeah. We've all got to start somewhere, so this is a perfect opportunity.
I go to school and see what he's been working on, and he's just putting me to shame.
Granted, he has tools available to him today that we didn't have as children. So
Okay,
so walk us through this project.
We have Zombie Pumpkin Slayers built by Adam and Matt. Okay, I'm going to open build settings real quick here. And I don't see that I have any scenes actually in the build. That's very important when you're exporting a Unity project.
Right.
So kind of an easy way to do that is I'm going to open the scene folder, and I don't see scenes at all.
Perhaps they removed them on you. Or they just kept it in the base assets folder.
Maybe I have a bad export of a project here. Bear with me.
I will find out in just a moment. So like Adam mentioned earlier, when you're or had asked during the first session, as we're starting to build our scenes, we may have 13 scenes in our entire folder, but we're not necessarily using all of them at once. Adam, for example, had brought up that he has 13 scenes, but he's only actually using 3 at any given point for his project. The rest are often just used for testing here and there, going for best practices, maybe seeing different kinds of performance.
Well, you know what? We'll use a different project.
Perfect.
We'll move on from that. We'll use, hopefully this is what Carl was using earlier.
Okay.
Looks like it.
All right, his little auto runner that he had going on before.
Okay. Let's look up.
Kind of looked like some Don Bluth art.
We've got
there
a
we
scene.
go.
Yeah, here we go. Okay.
Again, the art kind of putting us to shame.
So build settings, we have scenes.
Beautiful.
In our build. That's great.
We have a start screen and the first level.
All right. So the first demo I'm going to do is actually exporting to Windows Phone 8, and the reason you would want to target this separately, and we'll get into Windows Store later.
Okay.
We are updating our install base to Windows Phone 8.1.
Yes.
But it is taking a little bit of time, and it probably won't be completed until later this year.
Things don't happen overnight.
So if you're doing a Windows game or Windows Phone game and you plan on publishing it maybe in the next couple of months, I would go ahead and separately target Windows Phone 8 as opposed to a universal app.
Okay.
And that way you maximize the available install base of Windows Phone, right? You don't want to
kind of limit your potential
size,
at that point, yeah.
So I'm going to switch platforms to Windows Phone 8.
Give us a moment to build. It's going to compile our entire project, put the scripts together, the images.
And you'll notice here we have a development build checkbox that we can check. And that's there in case I want to be able to connect the profiler.
Okay.
And I can profile on a Windows Phone device.
You kind of test performance, do some debugging, and whatever else.
Yeah. So I'm going to skip that. I'm just going to create a new folder.
Always wise to stay organized and have a build folder for separate platforms.
And then I'm going to create one for WP8. Okay. I'm going to let it do its thing.
Builds surprisingly very quickly. I like it.
Mm-hmm.
All right, here we go in just a moment. Post-processing player. So it's putting together our entire scene, and the player is actually what is wrapped within the Windows Phone or Windows 8 application. So the player is all of Unity that's handling our inputs, the draw loop, the update loop, things of that nature.
Right. And we're done. You see we have this WP8 folder, and inside this folder we actually have our Visual Studio solution from our game that we just exported from Unity.
Okay.
So I'm going to open this up just to get a quick look at it, to kind of see what's
kind of going on under the hood over there.
Yeah, exactly. And what Unity exports, it is a full buildable Visual Studio solution. It's got all the right build targets and everything for Windows Phone.
Okay.
For Windows Phone, what it does not export are the icons and stuff for the tiles.
Right.
That's something you actually have to set up in Visual Studio.
Okay, not a problem.
Right. And you would do that in...
It looks like a very basic
your
Windows Phone
manifest
application at this point.
Yep. And so it exports a XAML C# based Windows Phone project.
Okay.
For those of you familiar with the platform changes, this would be called a Phone Silverlight project.
Yes.
Windows Phone Silverlight project.
So that
The
file
old
you just
Silverlight
opened
model.
up right there, what was that? That was app manifest?
This is I've got mainpage.xaml open here.
Okay.
Just to kind of show you what's going on. We do have a XAML page that wraps the Unity player. Okay, and then it has this drawing surface background grid, which is actually the surface that the Unity game is going to be rendered on.
Okay.
So that's our render target, essentially. Okay, and then you can come into the app manifest. This is where you would declare or set up your app icons, declare the resolutions that you plan on supporting.
Right. Perhaps the orientation.
Right.
What if you only wanted to play landscape or vertical? This is where you'd set those settings.
Yep. And also, when you're getting ready to upload to the store and publish, you'd actually come in here and set up these values here for packaging once you get them from the developer portal. Okay. So I'm going to put that aside for a second. I'm going to go back to Unity.
Okay.
And let's look at build settings for Windows Store. This is the next one.
Looks slightly different. You have a few more options at this point.
I'm just going to advance my slide. Okay. And I'm going to go back to Unity. Go back to build settings. Windows Store. This is a little bit more complex. And we'll go through this real quick. So we have a type selected here of XAML C# solution. If you feel more comfortable in C++ and native,
yes,
then you can certainly export a C++ solution. I prefer C#. I've done way too much C++ development in my lifetime.
And I'm also using Prime 31 Azure plugin, and I know that requires C# XAML as well. So often you have to look at some of the plugin requirements because they may have specific features like that.
Yep, and you can also do very easy interop code between Unity and C# on the platform using #ifdef precompiler commands. So it's pretty handy for that. I can select the SDK version that I want to build against. You'll notice we've got 4 of them now. We have Windows 8 SDK. We've got a Windows 8.1 SDK.
Okay.
We've got a Phone 8.1 SDK. And then we have the Universal App SDK.
So is there one that you suggest developers target at this point?
I will say that it's probably safe to target 8.1
yes,
for Windows Store apps. You certainly won't hurt anything to target 8.0.
Okay.
Just in case there is still an install base that hasn't updated to 8.1 yet.
Okay.
Right. So for that sake, I think we'll just stick on 8.0.
Perfect.
Just to prove it works, right? Again, we have the development build. option.
And like you mentioned,
we can
the profiler
auto-connect
is
the
right there.
profiler. Another cool feature here is that I can include the script solution or the script projects for my C# scripts into my Visual Studio solution for this project type.
This way you can kind of edit the C# scripts within Visual Studio as soon as you open up this solution.
Exactly. Yep. So again, the same thing I did on Windows Phone. I'm going to go and I'm going to create a build directory for this.
Okay.
I'm going to call this one just Windows Store Apps or WSA.
Okay.
This is just my way of organizing.
Yeah, so the naming scheme actually doesn't matter here. It's just a way.
It's whatever makes sense to you.
Exactly.
Yeah, exactly. These are demo naming schemes for me. So again, I'm gonna build it out into a Visual Studio solution.
Yeah.
You'll notice why that's going on. There's also a build and run button, and that does enable you to go ahead and build and then debug without touching Visual Studio.
Perfect.
Which is pretty cool if you're not real comfortable with Visual Studio.
Yeah.
Simplicity
is key.
Mm-hmm. And it's available on phone as well, so you can debug to a phone device right from Unity.
I like it. Again, building the post-processing player, which is actually the target that our XAML app will
That's
now
the executable, if you will.
Exactly.
That runs the game piece.
Yep.
Yep.
It kind of builds it, secures it, locks it within the application itself. Here we go.
So we have a Windows Store app solution. I'm going to open that up in Visual Studio. And you'll notice that I need to get a developer license. We didn't do that before.
So it's going to go ping the mothership,
so
come back.
This is something that the first time you load up Visual Studio for Windows Store apps, Windows 8 development, that you'll have to do.
Yeah.
You've got to get a developer license. And it's a one-time sign-in. I agree. So I'm going to go ahead and do this here.
Yeah. So it's basically just verifying that you are, in fact, a developer, that you have an account. And again, reach out to us. We'd be more than happy to set you with something like BizSpark or DreamSpark to help waive some of these costs and make your barrier to entry as low as possible.
Okay. Yep.
Now you're signed in.
Preparing the solution. It's going to ask me if I want to target to Windows 8.1. I'm going to skip that for now. It is really easy to do later on simply by right-clicking on the project.
Right.
And saying retarget to Windows 8.1. So if you kind of mess up and go, oh man, I really wanted to target 8.1, but I don't feel like re-exporting, you can go ahead and do it from here.
Okay.
One thing I do want to note that I forgot on the first demo was every subsequent time you export from Unity now, after you have the first Visual Studio solution export, let's say I need to go back and I need to make some changes to my level.
Okay.
You know, maybe I need to reposition something, add some new objects, add some new scenes, right? Change my scripts. Anything I do in Unity, when it goes and re-export, it's actually just going to change this data folder.
Right.
So it's not going to touch the rest of my Visual Studio solution. It's going to leave it all alone so that any changes you make, let's say in your manifest file or your main page, maybe you've got some custom elements in your main page XAML. Maybe you've got a Microsoft ad control in there. Unity's not going to touch that. It's just going to update this data folder for you. So Windows Store apps, one thing to be careful of is that it is going to export to ARM-based architecture by default.
So essentially tablets.
So that would be, like a Windows RT tablet.
Right.
If you plan on debugging on a Windows machine that's x86, x84, or x64, you're going to have to come in here and change it to x86.
So here is the configuration manager next to the debug button.
Yep. So
this threw me off my first time as well.
Yeah, it still gets me to this day.
Yeah.
Because I'm expecting to just export it out and run it and go. But now I've kind of got this in my workflow. If I go to the debug, drop down here, configuration manager, I'm going to change the active solution platform to x86.
So you only have to do this one time, essentially. It's the first time you build that project.
Right. Now, another note here is if I'm getting ready to publish my application, and I'm going to upload it to the store, or I'm going to send it to some of my friends to test it out, I want to build it in the master build configuration.
It's not, in fact, release, which is what you're generally used to.
Yeah, you notice we've got release and debug, those are the standard Visual Studio configurations. Unity has added this new level called master that removes absolutely all debug profiling hooks from the app. And I've seen frame rate drop.
Absolutely.
Release, right? So super important to remember that little tip.
Yeah, you're removing profilers, removing any console.logs, things like that.
Yeah, and so like if you're testing your game on a phone,
Yep.
and the frames per second's down, in the 20s, and you're like, what's going on?
Yeah.
Just go back to Visual Studio and double check and make sure that you've got the master configuration.
Right. You're not actually in debug mode.
Right. All right. So the next demo. Actually, let's talk about universal apps real quick.
Okay.
All right. So as we mentioned before, universal apps, something that we announced this year as part of our ongoing effort to combine platforms.
Yeah.
So we've got the solution now where we can export one single Visual Studio solution for Windows Store and Windows Phone. And they do some really cool code sharing between the platforms. It makes for nice code updates, code changes, easy code changes.
Right.
And Unity's taking advantage of it now. And you can export to universal apps. It does require Windows 8.1 and Windows Phone 8.1 targeting those devices for universal apps. And so I'm going to show you how easy that is to export. Again.
So really it's the same data model that we're keeping, so same information. And the only thing you may ever have to change on your universal app would be perhaps the front end or the visuals that a person sees when loading an application.
Mm-hmm. I'm going to change my SDK type to Universal 8.1.
Okay.
Right? And I'm simply going to do build again. I'm going to create a new folder for this one called Universal. If I can type. It's getting late in the day.
That happens to the best of us.
It's certainly coffee time.
Yeah.
I can tell you that.
Well, we are in Redmond.
Yeah.
So it's amazing to see how much easier it is to actually develop games at this point where you can literally drag and drop and hit a button to deploy to a specific platform. When you think about how much
it's
different
fantastic.
and
Yeah.
more difficult it was years ago in the C++
It's incredible.
days.
And Unity's making it easier and easier
Yeah.
with each release, it seems. I started playing around with Unity about 6 years ago, and to see the evolution over time of how many platforms it's targeting is amazing.
Yep.
When I first started looking at it, it was Mac and PC only.
Yeah.
And now, I think there's 16 different platforms that you can target with Unity, which is phenomenal. And as a game developer myself, I want to be on all platforms I can that makes sense for my game, so that I'm maximizing my revenue, my install base, all that stuff. So again, here we see we've got the same style solution that's going to be set up for universal apps.
Hope you have a beast of a machine over there because you've got 3 instances of Visual Studio running at once, and Unity. Look, this folder structure looks a little bit different, so why don't you walk us through this real quick?
So let's take a look at this, and we'll zoom in here a little bit so we can see the structure. So we've got a couple different things going on here. We've got this shared project, and in it you'll see that our main page and our app.xaml are there now. Mm-hmm. But our data folder is there now too.
Right.
Unity, right? So that means that Unity is exporting essentially shared code for each platform.
Yes, the
platforms.
same Unity project, as it were.
Right. And so now I've got a Windows 8.1 project. So this is going to target those Windows Store platforms that we talked about.
All right, whether it's ARM tablets or
the
a
PCs,
desktop.
right? The touch computers. And then we've got a Windows Phone 8.1 project here. And these are going to be the phone projects. And now it's going to have the main data folder, right? It's going to have a data folder for each specific platform.
Right.
And anything that needs to be built for that platform. You see these manage assemblies.txt. Mm-hmm. And then the platform-specific assets.
Okay, so those things like store images, live tiles, things like that.
Exactly. And then, each platform is going to have a different manifest for uploading to the store.
Right, basically a configuration file.
Mm-hmm. These are those script assemblies that I was talking about that it generated out. So if you're using Unity VS and you've got the plugin installed, you can manage it all from one single instance of Visual Studio, which is great.
Exactly.
And you can attach and debug from this. And again, if I export, it's only going to export and change the data folder from Unity from here on out.
Easy enough. I like it.
So let's You want to run one of these things?
Yeah, I want to see this. We've been talking. Let's actually put up some of this work.
All right. Well, I'm just hit debug. And I want to do this. I did this on purpose. I forgot to change it from ARM to x86.
Yeah, threw all kinds of errors down there.
This is what we were talking about a few minutes ago.
Yeah. If
you don't go and change. So I'm going to go ahead and fix that. I'm going to go to Configuration Manager. I got all this spew down here in the console.
It did not like that.
All right, so... Oh, it couldn't find all this stuff. Yeah. That's because it's on the wrong platform. It's looking for ARM. All right, so I've got that changed. I'm going to run local machine.
Here you see it building all of our scripts.
Oh, did I change it? I did. Okay.
What did Carl do before? Yeah, you may have to clean that solution.
Do a clean, build. Oh my goodness.
It's missing something.
Yeah. Well, it's got this this crazy
ellipsis.
Dot underscore.
Oh, yeah. I actually saw someone with that problem several weeks ago. Do you want to try the Windows 8 project? See how that deployed?
Yeah, let's see what's going on.
Because we were building somebody else's project on the fly. So let's see how this worked out. Did Carl miss something earlier?
That's a risky venture, isn't it?
Oh, yeah.
Yeah.
So Carl may have missed something earlier. Again, this is the joys of doing a live tech demo.
Yeah, for the sake of moving on here.
So we don't have Adam's original project, but perhaps we'll have more time to show that off tomorrow. But again, we're building Carl's Unity project, so he may have left out a script or two along the way. So I'll have to take an opportunity to kind of build through that later on.
I'm just going to create a new project here.
Okay. In the meantime, you're going to put together a new project for us?
Real fast.
All right.
Test my live coding skills.
Yeah.
Right. So I'm going to create a cube. Okay, there's a fancy cube.
That was a nice
camera. I'm going to add a light to the scene so that it's lit. All right. Okay. Maybe do some translation on the cube to make it a little more interesting.
I like it.
Right. Okay.
Between you and Adam, I mean, I don't know who's making better cubes today.
I don't know. Mine's pretty good. Save my scene.
Okay. So every new scene, you're going to add this scene to your actual build, right?
Yep.
So there's our asset.
There it is.
Scene 1.
All right. Let's export to Windows again.
We have our C# solution. Targeting Windows 8. Let's see how this takes off. Again, it's always smart to stay organized with these things, so that's why you see Jason has a build folder for all of his project builds.
Yeah, I just kind of made a habit of it now.
Yeah, so do I.
I typically try to put my scenes, animations, everything, and it's something that I've seen other people do in demos, right? It just seems like a good idea to organize. I've seen some of these projects get pretty ungainly over time as you build them out. So I'm going to check my build configuration. Here we go. Debug local machine.
Okay, here comes our new project. Building, building, and there we go.
All right. This thank you help for telling me that I can switch between apps.
Just slide to the side. And there's
our scene there.
Oh, I like that. Look at that lighting.
Yeah.
Woo!
So that's our fancy cube. I put a little abstract on it. I tilted it. I don't think Adam did that.
I can tell you're trying to go for that little Unity logo there. Very nice. So there it is, our app.
So, evidence that it does run on the Windows platform.
Perfect.
Okay.
Okay, so with that in mind, we have our exporting to Windows Phone, Windows 8, and then Universal Apps. So why don't you tell us a bit about...
Let's talk about running Windows Phone real quick. Let's go ahead and do that.
Okay. Try the same
thing. Got time.
Make sure it approves.
We do have time. So I'm going to switch back to Windows Phone, and I'm going to do that again.
The proof is in the pudding, as they say, correct?
Yeah. Yes, sir.
Okay, so saw how easy it was to make that nice, beautiful cube scene.
Mm-hmm.
I did like that lighting, though. So let's see how it comes out on Windows Phone. And for Windows Phone, there are actually two ways of testing this, right? I mean, we can use it in the simulator.
Yeah. So we're going to use the phone emulator.
Yep.
And then I'm going to can connect my 1520
Okay, your choice.
right to the machine, and we can run that, and we'll get a nice camera shot of doing that. But I want to do the emulator first.
Okay.
Let's make sure it runs.
Building, building, building. So the emulator is actually running something called Hyper-V. So that's virtualization in Microsoft technology that allows us to basically emulate having a phone running on your computer. So all the touch inputs are there. So if you have a touch screen, you can actually touch your screen and it'll interact with the phone screen. Or if you have a mouse, you can then click and you can see round points throughout the application to see where you're actually touching. You even have multi-gesture support. So you can hit that button there, and it'll make it seem as though you're touching with 2, 3, or multiple fingers at once. So here we go. We're loading our application. I noticed before you had different options for the simulator there. Can you explain that for us real quick?
Yeah, so we have our different device configurations, right? So you can see here in the background that I'm targeting a Windows Phone 8.1 with a 4-inch screen and 512 megabytes of RAM.
Okay.
That's a very common configuration in the field in our install base in those emerging markets we talked about earlier. Right. These are those low memory devices that you definitely want to try to target if you can.
Mm-hmm.
Okay, there's our cube. I rather like it in landscape mode.
Yeah, and again, you can lock it to landscape mode in the app manifest,
right?
Just to be clear.
Yep. We do have a little debug screen up here for our frame counter.
Yeah, frame counter, fill rate, things like that.
Look at that. We got, 66 frames per second.
I like it.
1080p.
Beautiful.
That's better than next-gen consoles, right?
Yeah.
Okay. I can also debug this on a device.
Okay.
I'm going to hook this up.
So you can plug in your actual phone you walk around and carry in your pocket every day.
Yeah, and once you register for your developer account,
yes,
and you have a Windows Phone device, and we'll tell you a couple of ways that you can maybe get one if you're developing a great game.
Yeah.
Otherwise, they have some pretty cheap options with the 520 series
Absolutely.
For less than $100.
But again, you can reach out to your local evangelist and see how they could potentially get you hardware for you or your company to test on as well.
So I'm going to run this.
Okay, so it looks like we have your phone connected at this point.
Let's see what happens here.
So from Visual Studio, it's connected via USB to your phone. We see Unity launching, and there we go.
Yeah, there's my cube.
All right, you still have all the same debug information that you previously had.
There it is, landscape. Right, so I'm debugging live from Visual Studio onto my phone.
Beautiful. And back, and it goes right back there.
It is important to note, though, that if you want to debug on a phone, that you need to register that phone with your developer account so that you can sideload applications and deploy from Visual Studio.
Right.
Okay. And that there is a tool with the SDK that allows you to do that.
There's the Windows Phone SDK, which you can download for free at our Visual Studio website. So what's next on the agenda?
So let's talk about hardware real quick. And I totally skipped that slide. Hardware overview. We do, our platforms do target a large scope of hardware.
Okay.
In particular, when we're talking about Windows 8. So let's talk about that. So Windows Store, again, these are the apps that target tablets, all-in-ones, desktops, laptops. Essentially any device ranging from those tablets to full-blown gaming PCs. So the specs are all over the place.
Yeah.
If you've been in game development for a long time, the same concepts apply.
That's right.
Know your platform. Know what your game can run on.
Know your demographic, who you're trying to target.
Right. So don't go build Crysis and expect it to run on an ARM tablet.
Right. That was the ongoing meme in 2007.
Kind of
Can it run Crysis?
Right. So these are some typical minimum specs, right? We've got ARMs, x86, x64 platform processors. Yep. 1 gig of RAM's typically the minimum I've seen recently.
Okay.
GPUs. It's important to note some of our ARM-based devices, like the Surface RT, are DirectX feature level 9.1. So there's a lot of missing shader support, modern shader support on
tessellation, things like that.
So you're essentially kind of constrained to shader model 2 at that point.
Okay.
With that level 9.1. Now, again, if you plan on targeting stuff like that and you've got very simple graphics in your game, it's not really a problem.
Right.
Right. So it's just advanced rendering techniques that you're going to run into issues with.
Okay.
All the way up to the latest DirectX 11.2 and all the goodness there. Minimum resolution on a Windows 8 machine is 1024 by 768.
That's the old school 4x3 look.
Right, yeah. And there's not many devices out there that range in that level anymore.
Okay.
Input-wise, mouse, keyboard, the standard PC inputs, touch becoming more prevalent, right?
Yeah.
With tablets and all-in-ones, and even touchscreen monitors. And then also gamepad controllers, which is awesome, right?
Absolutely, and that's built
So
into
you
Unity
can factor,
itself.
it's all, you kind of just get it out of the box, gamepad controller support with Unity.
And before we skip over touch, I just wanted to point out that previously touch was a requirement for Windows 8 applications. But in the last year, we've actually dropped that requirement. But it's still best practice to at least inform your users that they no longer require touch. So if, for example, you need gamepad control, it's good to leave a little note right there in the description of your application in the store so that people with, say, a tablet don't download your game and not have a gamepad connected and suddenly assume they can play on a flight when they're just touching with their fingers.
Right. Windows Phone 8 hardware. These are the minimum specs. We've got all of our phones have Qualcomm processors. The minimum is going to be the S4 dual core, very capable processor. Minimum 512 megabytes of RAM on these phone devices. I do want to note that if you have trouble getting your game running on one of these devices, you can opt out of that. We have a session, I believe it's later this week, with Jaime that's going to go way more in depth on this stuff.
Yes, that's on Thursday morning.
As far as all the technical details of exporting and how you configure your Visual Studio solution to do things like this.
Little workarounds for everything. Get a little more oomph and power out of your device.
Again, GPU is going to be constrained down to DirectX feature level 9.3. So it's going to be like shader model 2 with a couple extra little features added in. These are the standard resolutions. We do the 800 by 480 ranging up to 1080p. And then sensor-wise, if your game makes use of sensors, we have the standards: accelerometer, light, proximity. Some phones have gyrometers, magnemometers, so you can, it's just compasses. It depends on the platform. And if you're going to target any of that, just make sure that you're using robust coding to make sure that your game doesn't crash if that doesn't have that sensor.
Yeah.
Another note, Windows Phone. It is a requirement on that platform to have a back button.
Yep.
Right. So it used to be a hardware requirement. Now it's just a requirement. Some of the new phones actually have soft buttons for back.
Right.
Right. The HTC One.
Very good point.
Right. Some of the new Nokia phones they just announced are going to have soft key buttons. So, typical behavior is the app's going to pop in the back stack. So if I've got a app that I'm navigating through and I hit the back button, it's going to go backwards.
Yeah.
If I have a modal dialog, it's going to dismiss that.
Yeah. Unfortunately, Unity handles all this for us out of the box.
Yeah, it does. It will pick that up. I'll show you some code on the next slide to kind of how to handle that in your Unity script.
Okay.
If you're on your home page and you hit the back button, it's going to exit the game or the app. If you're in gameplay and they hit the back button, it's a good idea to maybe throw up a pause menu. Right? I've seen a lot of developers handle it that way. You could do I guess you could have some fun with it too.
Yeah, definitely.
Depends on what you want to do with your game. The back button in Unity is actually the escape key. It's mapped to the escape key. So I can just check, hey, am I hitting escape? And you can kind of handle it the same way. So if I'm on a PC and I hit escape, usually that brings up the pause menu. And so you could do the same thing in your phone game. So here's just some basic code to show how to do this. So the first sec here is, hey, this is how I'm doing a back press event in my phone page. And you can see that I'm going to cancel that event because I want to call Unity and tell it that the back button's been pressed.
Okay.
Right? And so in your update or wherever you handle input, you can get the get key down state for escape, and if it's been pressed, I can handle it there. I can quit, or I can pause my game, whatever I need to do that fits my game.
Okay, I like it.
Hardware APIs, right? Again, these are all built into Unity. There's nothing special you have to do to get this functionality.
I think it tests these all in the simulator as well, once you actually deploy.
Touch, microphone, webcam, the sensors, and location services.
Okay.
And you can access all of these from scripting like you would do any other platform. So it's nice, great, seamless, easy to do. Let's talk about some platform-specific features. And these are features that can kind of make your game stand out a bit on the platform.
Absolutely.
Right? Some of those include live tiles and notifications, and that applies to Windows Store and Windows Phone.
Okay.
Right? So I can have high scores. I can tell you that your friend has played his turn.
Yeah, using push notifications, things like that.
You can use these push notifications.
Excellent use of Azure Mobile Services, might I say.
Yeah, nice plug for your module tomorrow. Make a good splash image for your game. That's going to be presented every time your game is launched, right? No matter what. Contracts. So setting charms, share charms. These are all those Windows 8 charms.
Yep.
That
kind of pop out on the right-hand side as you cover your mouse.
Maybe. I'm in presenter mode, so I don't think it's going to work. But I can do things like I can share out to my social networks from my game using the share charm. And that's a platform feature that comes with Windows 8 and is available to Windows Store apps. Snapping. It is important that any application can be snapped on the Windows Store.
Right.
Windows Store app platform.
Gracefully handle, half screen views.
Yeah, you have to handle it. A lot of times if I snap something, it'll get put into like a half screen view or even smaller than that. And there's ways to set a minimum width on that. But just handle that gracefully, don't crash.
Right.
I've seen some pretty innovative stuff where people have changed the gameplay state or mode to a smaller, maybe vertical mode on the screen.
Not a bad idea.
For example, solitaire. I'm playing horizontally, and I put it in snap, and it rearranges the cards up into a vertical arrangement.
Maybe even a game that only plays through snap view. I always want to see something like that. Maybe I can have a snap view game, so I'm playing a Tetris-like clone, and then on my three-quarter view, I'm kind of watching YouTube in the background.
Cloud storage, again, Azure Mobile Services. I can sync gameplay state across the cloud.
So pick it up, maybe save on your Windows 8 device, then switch over to your phone, and you pick up exactly where you left off.
Windows Phone, a lot of the same things. Back button, make sure that's handled gracefully. That is a platform feature that users expect to work. Live tiles notifications, again, a good splash image for my game. Launchers and choosers, these are things that are be able to pick photos, launch websites, good monetization models, and then screen recording. I can take screenshots of my game, share it out. Some of the newer services that let you record clips of your game and share.
Not a bad idea,
right? Stuff like that, and that applies to any mobile platform, really.
Okay, so it sounds like it'd be a lot of work to get a lot of these going on our platform. So there's got to be a better way, or has someone come up with some sort of tool or plugin for us to use?
Well, Prime 31, right?
All right,
it's a great we can plug the Prime 31 plugins again. Again, free. Download at prime31.com.
Good for the next year.
Go to the plugins page, and you can pick Windows or Windows Phone and download them.
Yep.
Here's that.
And coming around the home stretch, we only have a couple of things left here.
$400 plus.
Yeah.
Okay. And let's talk about plugins real quick and what that architecture looks like in your assets. So when you're adding plugins for the Windows and Windows Phone platform in your Unity project, this is what the folder structure needs to be. So assets plugins, that's a standard in Unity. Right. All of the plugins should be there. If I'm targeting Windows Phone 8, I've got a WP8 folder. For universal apps in Windows Phone 8.1, I've got Windows Phone 8.1. For Windows 8, I've got Metro or Metro Win80.
Yeah.
And this is all new if you've done anything before.
Right.
This is stuff they've added in recently. And then again, for Windows 8.1, I've got Metro or Metro Win 8.1. If I need to discern between the two versions of Windows 8, I can do that within the Metro folder.
And to be clear, it's Unity that requires us to have these this naming scheme, because it's specifically looking for a plugins folder and then specifically looking for a plugins/WP8 folder. If you name it anything else, it's not going to know which platform it's for.
Yeah, and the plugin vendors are really good about when you install and import into your Unity project. They map out this folder structure at the installation. So this is here more for informational debugging purposes in case you run into any issues, or you need to manually update your plugin DLL later on. Other third-party plugins, we have over the course of the past year run into some that do not support our platform out of the box.
For a number of reasons. Mono support, .NET support.
Right. So the editor runs Mono. Other platforms compile against Mono.NET. Windows Store, Windows Phone compiles against .NET for WinRT and Windows Phone. And Jaime's going to go in again into that in more depth on Thursday. And what the runtime differences look like. So if you're nerdy,
low-level developers.
If you're nerdy like us, and you want to delve into that kind of thing and see how the guts of the runtime works, definitely tune into that on Thursday.
So I think there's actually a tool to help us really discern what will and will not work on each platform. iOS, Android, Windows.
Xamarin's good. Xamarin, scan.xamarin.com. They've got a great tool to upload a DLL and select your target platform. And hey, is this API set compatible with that platform?
How mobile is your .NET, right? Will it work everywhere, or will it just work on these specific platforms?
And it's really great for that. Thank you, Xamarin, for publishing that out on the web. I've used it many, many times.
You can look at executables or dynamically linked libraries, DLLs.
And so I've used it many times.
As have I.
I will say the plugin library is growing and growing and getting better. If you run across one that is not working for you, please, again, reach out to an evangelist at Microsoft, and we can engage those developers and get them working on our platform. If it's something you need and you're working with one of us, definitely let us know so that we can address that. Loaner devices, let's talk about that.
Okay, I like free hardware.
So, I need a little bit of wording here on the first bullet point. Your local evangelist can likely loan you a developer device.
There are no guarantees in world.
It depends on what region you're in, what part of the world you're in. A lot of moving parts to that.
How many are available at that point?
How many are available? Right. So the best way to find out is to find your local evangelist. We've got this great directory on MSDN that helps you do that. I've got the link here, aka.ms find my evangelist, so you can find one of those. I'm in Dallas, so if anybody from Dallas is watching, please reach out to me at Jason G. Fox on Twitter or jason.fox@microsoft.com for any of this stuff, loaner devices, any advice on Unity, publishing your game, anything like that.
We're here to work with you and help build communities around gaming and game development in many of the larger cities around the country and the world.
And we can also help out with BizSpark programs.
The
Unity developer offer. So
beautiful.
This is new. You can get a device through this. It does require that you publish your application first. It can be in a beta state, so you can put it out into the store as a beta. So it's not actually released to the world yet, but you can add your friends' accounts on there and let them test the game. Once you get to that point, the person running the offer will be able to send you a test device to start debugging on.
As part of our own ongoing relationship and growing relationship with Unity and Microsoft.
And so it's great, the level 1. Level 2, let's go. Oh, there's no slide.
Windows Phone, so WPDevCenterOffers.com will have all the information.
Let's actually just go to the site.
Perfect.
Since we don't have...
Looks like we have 2 tiers at the moment, level 1 and level 2. Why don't you zoom in a little bit real quick there, so I can get a better understanding of what level 1 and 2 actually entail.
Okay, so create or port your game. So if you've got a great innovative game on another platform, that meets some kind of minimum download requirements,
Yep.
then we definitely want you to apply to this. You get this is a great way to get Windows 8.1.
Yep.
$100 voucher to the Unity Asset Store. That
Sounds good to me.
right? I could go buy ProBuilder or whatever right now, right?
Right.
With
or any additional plugins you just don't have or are looking
Yeah.
at. I mean, Shader Forge just won a bunch of awards at Unite 2 weeks ago, so
that one developer device bullet point there. That's what we were just talking about. So you can choose a phone. Priority review for Windows Store promotion. That's huge.
Yeah.
For marketing, discoverability, user acquisition, all these great terms for getting discovered in the store and selling your game and
Right.
making money.
Level 2 looks like it has everything Level 1 has and even more. So why don't we go into detail about that?
Yeah. And so once you get through level 1,
Yeah.
you can get promoted. And I think, there's a selection process for this up to level 2. And we're looking for the universal apps on this at
Yep.
this point, right? Again, if you go down to the benefits, we get 1 million impressions from Ad Duplex.
Can't say no to that.
$1,000
I like it.
of free advertising. That's awesome.
Anything free is for me.
A voucher to the Microsoft Store, so I can go on there and maybe I can apply that to a new device, or
Yeah.
maybe I don't have an Xbox One yet. I can put it towards that.
Perfect. We
Or
just
I
had a nice
can
price
buy-
drop for it,
I can buy the collector edition of Destiny.
which just came out today.
Came out today.
Yeah, we should actually go play that as soon as we
Did you
got
bring
it.
your Xbox One?
No, but I thought about it, though.
Yeah. Darn. Okay. Anyways, so feature placement in the Made with Unity gallery. Again, that's huge advertisement for your game.
Absolutely.
That is on the Unity 3D website. People clicking through and they go, oh, okay, I've got a Windows Phone. I want to see what games are available for Windows Phone from Unity.
Yeah.
Or built with Unity.
It's essentially their showcase.
Yeah, and you get into that gallery. It's great. And again, the priority review for promotion.
Okay.
Top 3 candidates each month.
This is the biggest selling point for me.
Unity Pro license.
I like that.
It's fantastic.
Yeah, can't say no to that.
Up to $1,500 in value.
Holy cow.
The other thing that I thought was interesting,
And this is brand new.
this is really cool. I just noticed this the other day. Top 3 candidates get priority consideration for the ID at Xbox program.
Right. So it doesn't mean you're going to the program. It means that they are guaranteed to take a look at your title and work with your team to understand where your current goals are.
Yeah, that's great. That's all I have. We
Yeah.
got anything else?
No, I think it's been a fantastic day of kind of working together.
Thanks, everybody. I think do we need some promo for tomorrow? Okay. Please take the poll.
Yep, so if
That's
you
been
notice
put
at the
out.
bottom of your chat screen right there, there'll be a poll asking questions about perhaps where you're located in the country, where your current role is, whether you're a student, a developer, or even a Microsoft employee. So please take time to answer those questions.
Thank you for attending today. We do have 5 more modules of great content tomorrow.
What time is that starting at? Do you know?
9 a.m., right? Same time, 9 a.m. in the morning, Pacific Standard Time,
Yep.
U.S., right? So we'll see you tomorrow.
Yeah, thanks again, everyone. This is Jason Fox.
Thank you.
I'm David Voiles. Thank you for joining us today.
There's a little preview of some things to come. Welcome back to developing 2D and 3D games with Windows. With Unity on Windows, welcome to day number 2. We also have a great day of content for you. I'm just as excited today as I was yesterday, and I was pretty amped yesterday. So this is going to be a good day. We've got all sorts of great topics, but Matt, a little bit about yourself first.
So I'm an indie game designer. I have my own studio called Subscience Studios. We're based out of Orange County, California. Recently completed work on a game for the band Avenged Sevenfold, coming out soon for all mobile devices. Before that, I did a game called Grave Stompers, which was kind of a zombie-based game, which fits in nicely with what we're doing today. You can check that out on all devices. And then, I've worked as a digital artist for about 12 years in the industry. Started in music and entertainment back in the day, kind of got into websites, and then fell into games about 4 to 5 years ago, and I've just been doing it ever since. So love games and excited to show you guys what we got going on today.
Pretty cool. And definitely check out your website, MatthewNewman.net, where you have some cool tutorials up there. The Rhino, I think, is going to be posted up there from yesterday.
Yeah, the Rhino from yesterday. So if anybody saw what I got started with yesterday, we're actually going to have the full
Very
version
cool.
of that up probably, by the end of the day today, we'll show that off and people can download that. And also, there's a lot of speed painting tutorials and stuff like that if you want to see that. But anyways, let's get started. And
I'm Adam Tuliper. I was here for a lot of the day yesterday, going to be here for a lot of the day today. Great day. I'm a technical evangelist with Microsoft. I'm out of Southern California. Been working many years as a software architect. Check me out on Adam Tuliper at Twitter. And why don't we get rolling to talk about some really cool stuff and where we're going to go with the day today. We're going to start with optimizing your games. Then we're going to go into ALM and Unity, learn about Visual Studio Online and source control with Unity. Tobias got a great talk on marketing and monetizing your application, an area that developers greatly lack in. Using Prime 31 to connect your Unity game to Azure comes in Module 9. And finally, in Module 10, adding the finishing touches, integrating with things like live tiles and some platform features to make your game just pop a little bit more.
cool.
All right, let's get started with optimizing your game, shall we?
Yeah, the single most important part. Before you
part.
ship your product or anything's done, you always have to optimize. And that's just to guarantee a couple things, right? One, you want to make sure your game runs super smooth, and this is the best way to do it. You want to make sure there's no hiccups or any extra memory hog issues, anything like that. This is what optimizing your game is all about. So there's a couple of topics we're going to copy on this, but I think to start, we're going to go over baking lights.
Baking light, we're going to do optimizing draw calls. We're going to be doing compression, coding techniques. We're going to be talking about terrain and skyboxes.
Yep.
And reducing geometry. Now, this is not a completely all-encompassing list, but these are some good things to get you started.
Yeah.
And so let's go ahead and start with baking light, what baking light is all about.
Absolutely.
So baking light in Unity, there's a third-party engine, Beast, from Illuminate Labs. This essentially, baking light calculates lighting for all the static objects in your scene. Static objects are objects that aren't going to move, as opposed to ones that are charged with electricity and shock you during the winter. Mm-hmm. These are static objects. They're not going to move anywhere. Calculates the lighting for them, how light is going to hit them, and opposed to doing it at runtime, calculates it all ahead of time, saves it out to a texture. So the pros for that is it gives you much better performance because it's not having to do all these calculations at runtime. And while hardware has really come a long way and it can do a lot of this at runtime, it's better to save it for the cooler stuff in your games, like little zombie guys running around and stuff like that.
Absolutely.
The downside of this technique is it takes up potentially a lot of space to calculate. You'll see in your project, it can definitely grow quite a bit, and it also does not apply to dynamic objects.
Yeah.
This is just static, but we are going to talk about dynamic objects with light probes and how to handle light probes as well.
Now, there are some techniques to kind of fake that whole process, but make it seem like it's actually running in real time, which is great. So we'll show you those as well.
Let's talk about the process here. Very important to do things, for the most part, in this order. And so it seems sometimes when I go through this, I kind of miss a step at a time. So it's good to have it kind of written out. Must mark all the objects that you want lit up as static. And we'll show you a demo of this shortly. If you don't do that, they're not going to be included in this little map that Unity is going to create. So if you want dynamic lighting, then you need to place what are called light probes around your scene that detect how the light is going to hit those points at various times for your dynamic objects. And Matt's going to show off a demo of that shortly. The other important thing is turn down ambient light in your scene. Now, Matt, why would you want to turn down ambient light?
So your ambient light is kind of like you can think of it as like the shadows in your scene, right? The darker you make your ambient light, the darker your shadows are going to be. It's kind of the places that aren't lit, essentially. There's a lot of cool things you can do with ambient light, and a couple of those would be, you can actually change like the whole tone of your level just by changing the ambience and changing the darks and the color of the darks. Maybe the darks aren't essentially black, maybe they're more of like blues or reds, just to kind of give it a different feel. Things with that work greater when you're doing like daytime lighting, or if you're doing like kind of mood lighting in different settings for night and stuff like that. Yeah, absolutely.
Set the mood of your game. I mean,
right. Essentially, yeah, you're creating mood lighting for your game.
Lit.
Yeah, no, absolutely. Yeah, candlelight, you'd probably want to do like nice like dark reds and stuff. Yeah, absolutely.
Dinner on my mind already, and it's still early morning. More importantly, what are we having for dinner today?
Yeah, right.
So then you'll want, after you turn down your ambient light, so kind of like the background, the glow in your game, Unity always has a little bit of light color in your scene. So you're going to turn down the ambient light, then you're going to set your quality settings, because you can really define on how hardcore you want that light calculation to take place, how good you want all those light and shadows to look on there.
That's something to keep note of too, because when you work on the quality settings of the light, that it really depends on the PC you're using too. If you're using like a really, really hardcore PC and you want to really get amazing lights baked, crank those settings up high, it's going to take a while. It's going to take you hours probably to get a really, really nice.
Yes.
Yeah, the higher the settings, the longer the baking process takes. But if you're using like, a laptop that's not exactly, up to snuff, it's like a rendering machine or anything like that, maybe crank the settings down to do a quick bake. But what that'll do is that'll give you an idea, right? And when you're looking at your level, which we'll go over when we go over the demo and light baking, you're not going to get an exact result of what the baking is actually going to look like when you have your finished product. It just kind of gives you an idea even when you're not baked. You're just kind of getting a loose reference. That's why you want to do a quick bake at low settings, just to kind of get an idea of what the lights are going to look like. And you're going to have little refraction errors and different rendering errors in there because when the settings are so low, it can't process all that information.
It's
right?
a trade-off. Those maps are smaller.
It's a trade-off. You have smaller
faster.
maps. Exactly. So the memory, it's not going to do it exactly how you want it, but it's going to give you a good idea. So I always recommend when I'm doing my baking, first thing I do is when I'm baking, what you're doing, it's actually like baking. Like you're putting something, you're setting a timer on it, you're letting it go, and then it finishes, right? And you get the finished product.
We're going to put in our cake into the Unity oven and cook it at 350.
Yeah, exactly.
Cake, food, dinner.
But baking takes a while, right? Just like normal baking takes a while. So you want to do a quick bake first, kind of just see what it's going to look like, and then once you kind of get an idea, okay, that's going in the direction I want. It has the colors on there I want. Then you can crank those settings up, or maybe go to a higher powered machine, really put some heavy settings on there, and get a really good bake done. And I recommend that for just before you go to production, right? I mean, not production, but release, right? When your release candidate's almost ready, that's when you want to take the time and get those really, really great light bakes going. And that's like your massive light bakes for your levels, like the overview light bakes that encompass everything, right? And it's going to take hours to get those done.
What's the longest that you've ever had to wait for light to bake in a scene on a game you've worked on?
I think the longest so far, I've only been doing mobile, but to get really good ones, I think the longest one I did was like 12 hours.
12 hours?
And that was like a really, really complicated level with lots and lots of lights.
I'll bake this, I'll get
thousands
I'll come
of lights.
back, this will be done, and we're just waiting.
Yeah, like the shadows were out of control. There was all kinds of things going on. So
after you bake the light, one of the important things to remember, turn off the lights in your scene when you're done baking.
A lot of people forget to do that. So what you want to do is after you do your light baking, you've got this really great, well-baked scene, which is essentially, light baking, I don't know if people know, what it basically does is it's applying almost like a vertex color layer over all of your geometry. So it's essentially faking a layer of lit color over everything. So it appears that everything's lit, but essentially it's not. It's just kind of faked. And nobody will know when they're playing the game, right? Unless you're doing dynamic lights and like the sun's moving from one point to another, that's when you're going to use actual lighting. And even then you might do a combination of light baking and some type of other dynamic lighting system. But one of the things you really want to remember is after you get that light baking done, always go in and turn your lights off because you're not going to need them. Like it's just extra. There's no reason to have them there unless you're going for a specific effect that requires those lights to be on. But if you're not, turn them off. It's going to look great and it's going to run a lot faster. You're going to save on a ton of draw calls and your game's just going to be sped way up.
And turn your ambient light back up afterwards. So beforehand, you turn your light down.
Good call. Yeah.
And then bake it, turn your lights off, turn that ambient light back up. So you got to remember that initial value, and you'll demo that when you kind of go over this here.
Yeah, and I would say I always do forget to turn the ambient light back on, but you'll notice right away when you play your game and your characters look very dark or the color of like the shadows, and you're like, what is going on? When you do light probes, you won't notice it as much, but definitely turn that ambience back up because it's going to do two things. I think it's, from a stylistic standpoint, it's going to kind of improve the visibility of your characters and overall characters in your scene, and anything that's dynamic, you're going to see a little bit better. So it's a rule of thumb for me. I always go back in, have a little note to myself, go in, turn that ambience back up, and then you're ready to go.
So
turn those lights off.
This slide deck sheet that we have here, print that up and tack it to the wall.
Yeah, absolutely. It's a good rule of thumb. Yeah, absolutely.
Remember, all the red. Turn off lights in the scene. I should actually highlight in red there. Turn ambient back up. So let's go on and move on to a demo for baking light and setting light probes. And we're going to switch over to Matt, and I think he's going to show us how to do that in a scene inside of Unity here.
Okay, so
looking scene.
If anybody didn't see this yesterday, this was our demo project we created for the Virtual Academy lesson. This is the zombie pumpkin slayers.
Yes.
And
ZPS in the house.
ZPS, yeah. We kind of came up with this at the last second, but Just a quick overview. The game's about a zombie protecting his graveyard from invading evil pumpkins.
Evil pumpkins.
So for the demo, we made a quick little graveyard scene, and it's just kind of a straightaway right here with a central element that you're here to protect, which is your cross. And what we want to do for this purpose of this demo is we want to light bake this scene and make it look great, right? So what I did was, you'll notice in here I've got a couple lights, and these were kind of like mood lighting elements that I wanted to highlight certain things. And you're going to notice that when you're light baking your scenes, you're going to get like, a rough kind of representation of how the lights are going to look. It's not going to be exactly how the finished product's going to look when you export, but that's why you do baking, because baking is going to give you that final result. So what I do is in here, you can see I've added all these lights into my scene. And this is to kind of give my scene a certain type of look, right? I wanted the directional light, which is your main light. I wanted that to be a certain way so that the shadows were cast across the area that you're going to run, just to kind of give it a feeling, another feeling of ambience. And maybe the moon is kind of where you're looking from. I wanted to add kind of more of a green tone, because from a stylistic standpoint, I thought that just kind of fit with what we were doing. And just little kind of lights here and there just to kind of dress up the mood and what we're doing. I kind of added this warm light right here from these fake God rays that I put into the scene.
So to be clear, those are just... Explain what those God rays are.
So essentially all it is just, it's basically, you're protecting this element, right? And I wanted to create a visual piece that kind of identified that element in the center of the game. And so all those is just a nice visual element to kind of guide you of, this is the thing you have to protect, right? This is the holy element that is the center of your protection of your game. So your zombie has to defend off from the pumpkins that are coming in and trying to fight this. And
what are those made up of? What exactly are the God rays?
So all this is just a fade in Photoshop in the texture over my UV shell. So I have a UV shell, and I just did a little fade graphic on it and exported it out as a transparent graphic on a PNG. Use that. When we get into optimization, I'll show you how I used the fade graphic for those little rays also on my plants and everything else, which is part of optimization. You want to cram as much stuff into a texture as you can to save on draw calls. But from there, let's get into the light baking and show you how light baking process, how it actually works, right? So we have these different lights in our scene, right? We've got these point lights kind of for little mood lighting and highlight areas. I kind of want to highlight the path a little bit. We have a directional light, which I chose kind of a bluish color because it's nighttime. Wanted to give it almost like a moonlit kind of feel.
And the directional light is kind of like a sun in the sky in a sense, a little bit of...
Exactly. And I usually use 1 to 2 directional lights in my scene, depending on what I'm doing. If I'm doing like a space kind of thing, you have light kind of going in different directions, so I'll probably use 2 different directional lights, maybe cast in different directions. Whereas if I'm doing like a daytime or nighttime scene, I'm going to use 1 directional light just to kind of get that main source of light from your outside, wherever, into a scene where you can cast your shadows, really see those shadows nicely.
Cool.
So for here, we chose 1 directional light. We kind of did a bluish color. Wanted to cast it, make it look like a moonlight. And then I kind of just added some extra point lights to give it, a feeling, a style. I didn't want it to be just blue, just moonlight. Wanted it to feel like, it was kind of this zombie-ish cemetery. So I figured green and blue worked really, really well for that. So let's get into light baking, right?
Yeah.
So what we're going to do is, now that we have our lights in our scene, what I like to do always as a rule of thumb, anytime I create lights or main lights that are going to be baked into a scene, I always put those in a folder called lights, right? And what I do, and you can even write a note to yourself on that, like, for example, always turn off before build, right? And that's just to know that, like we said before, you always want to turn those lights off right here. That's your lights. There's your lights folder. There's all my lights inside. I've got my directional light and all my point lights. You want to turn that off right before you do your build, right? And even when you're just testing, you want to turn those off too, because you want to keep them on, an eye on your draw calls and things like that.
And by turning off, can you show kind of the little checkbox in the upper right-hand corner there? Maybe zoom in on that so the folks can see that.
Absolutely. So you'll see I have my lights folder selected here, right? And if I want to turn those off, right here, where my lights are in the inspector, there's that little checkbox right there. All you have to do to turn those off is just click that off. And then you see my lights go off on the scene. You can see right now, because I haven't baked my lights, there's a pretty dramatic difference between having your lights on and having them off.
Definitely.
So as I turn them on and off, you'll see on, you see all the lights, and you can even see the rays and the radiuses of all those lights and where those lights are being cast. And you can see them off with nothing but the ambience of the scene.
Lighting makes such a difference.
Oh, it does. Absolutely. Absolutely. And there are times, some people there are reasons to not even use lighting sometimes. It just depends on what you're trying to accomplish in your project. So for now, for what we're going to be doing is, like we said, light baking. So let's turn our lights back on. You make sure here that you've got those on. Always make sure that your lights are check marked. Again, put them in a folder, kind of like I did, and that just helps keeping things organized in your project, because when you start getting 4,000 to 5,000 things in your project, you really, really want to start organizing and putting them down. I mean, in our environment alone in here, you can just see that there's tons of stuff that we have in this environment. Yeah. So it's just a good idea to really start organizing your things and putting them in different folders.
Just create a game object, drop them all into that game object, and away you go. Organize.
Absolutely, absolutely. So to get started with light baking, all we're going to do is we're going to go to Window, Light Mapping, and that's going to bring up this light mapping window. And this is essentially the window you're going to do all your baking in. And we just want to make sure that we have all our lights selected, which they are.
And to clarify, I think baking is a pro feature, if I recall correctly on here.
I do believe that's correct. Yeah, baking is only available to the pro versions of Windows, or I mean of Unity. So just make sure that if you want to do light baking, that you are using that pro version.
One of the advantages of pro version. So we're going to kind of do a mix of things today between some pro, some not pro. So just keep in mind, some of the things we are showing today are pro. Some of the techniques are not pro.
Absolutely. So when you're in this light mapping window, the next thing you want to do is go into the Bake tab right there, right in the center. Go to that Bake tab, and then you're going to get all these different options. And to start, we've actually kind of reduced the amount of options that are in there, but I think when you initially start, this will probably be the lock atlas and the resolution settings will probably be at 30 pixels per world unit, I think is the default. And then, if you can see right there, when you initially open it up, that'll probably be at 30. I've actually knocked that down to 2 because this is more of a mobile kind of simple game, maybe a browser-based game. So I definitely want to reduce that. And what that's going to do is essentially the higher that resolution is, the more light maps it's going to produce, right? So when it's set at 30, it's going to know that, oh, I can go all the way up to 30 for the resolution of these light maps I'm going to create.
And it's going to take a lot longer.
Yeah, and what it's doing is essentially it's creating 1024 by 1024 resolution images that are your light maps that are using to layer over this entire project.
Oh, cool.
It's taking all those UVs and making these basically shaded elements that fit over everything. So what you want to do is, just as a rule of thumb, just get in there, knock that down. Especially when you're making a test light map, it's a good idea to knock that resolution down too. Your gather rays, I think when it starts, it's set at 6,000 or 8,000, or maybe 4,000. I know it's definitely higher than 1,000, but you want to knock that down too. For a rule of thumb, for me, 1,000 always seems to be a pretty good start. You could go even lower than that if you just want to test, but I'd say 1,000 usually gives you a pretty nice result to start, and it's not too taxing on most of the machines I've used. So you want to kick that down to about 1,000 as well.
Oh, cool.
And then from there, I usually do. To start, I do dual light maps because the result is a little better. But if you're doing a mobile project, you probably want to change it to single light maps, and that's just going to give you one light map, right? It's gonna try to reduce everything into one light map, and that will change when you change the resolution too. It will actually make more light maps depending on how many you have. But for now, let's start with dual light maps. Let's set the quality to high. I've never really experienced too many problems of setting low or high quality, so that never really seemed to be an issue for me. But to get started, we'll show you what you do. Once you get those settings set up and you have your resolution down and your gather rays, which are essentially all the rays from the light shooting in different direction, turn those down. We'll knock those down to 1,000. You just want to click Bake Scene.
Actually, you know what? I believe I misspoke on something. It was reversed between this one and the next one. I think the light mapping is included in the free.
Oh, okay.
The static batching is a pro-only feature.
Oh, okay. Well, there you go. If you have the free version, you can light bake away.
Very cool.
So if you're following along, so here we are right now. We're in the bake settings. We've reduced our gather rays. We've reduced our resolution settings. And now you just want to go and you want to click the Bake Scene button.
Bake Scene.
And you'll notice in here there are a couple different things. There are a couple different options. There's selected probes. You can actually bake objects alone by themselves if you just want to bake a particular object. But for now, we're just going to bake the scene, and we'll get into baking probes a little bit later in the optimization module. So for now, we click Bake Scene, and you'll see it brings up the exporting to Beast dialog, and then it bakes the scene. You'll notice there's not a lot of progress things happening. You don't really know like what's going on. Just look in the corner, and you'll see this little progress area, which basically tells you it's being light baked. And for now, I got these two light bakes. It gave me 2 light maps, right? But you'll see they kind of look a little light. And on here, I'm not really getting those shadows that I really wanted. If you notice when I had the preview, I could see some shadows and some different things. And that's because my ambient light was not set. And these right here, these are dynamic shadows. These really, really dark ones those are dynamic shadows being cast from the lights that are currently on in the scene. So you know that those have nothing to do with the light map that's being baked. So what I'm going to do is I'm going to rebake this light map, and I'm going to turn my ambience down. And it's a good thing that I did that, because you see how light the light maps are. That's kind of a good indicator that, oh, my ambience was actually too high. So what you want to do is go into your edit up here, and then in edit you want to go down to your render settings. Once you click your render settings in your inspector, you're going to get all these different options: fog, fog mode, linear fog, ambience. And this is what we want to concentrate on, is your ambient light. And so from your ambient light, you'll see it's kind of a light gray color I have in there now. That is what we talked about. That's kind of like the ambience.
Setting the mood.
Setting the mood. So what we want to do is we want to go in there, just click in the color of the ambient light, and it's going to give you this color box dialog, right? So if everybody does that, you'll get this, and you'll see it's set to, right now, this kind of light gray color. And we want to turn that down. So we open that back up. Let's do kind of like a darkish blue color. So we'll take this slider and move this down to about right there. Select that, and you'll see my ambient light is now a dark blue. And I'm just going to rebake my scene really quickly with that new ambience light. And if you can see the scene now, let me just back up.
Ideally, you're just trying to move this to a darker color.
Yeah, I really want to get those shadows, right? I didn't get those shadows last time, so this is what this is going to do. So you'll see I don't really see those shadows, but I want to see them. So now we're going to rebake this, bake the scene. And you'll see it has your little calculation in the corner. It's baking the texture.
Baking. 350 degrees for 7 minutes.
And now you see it's a little bit darker.
Look at that.
And the resolution of the shadows isn't great, but I can definitely see them a lot better. And that's because I knocked my resolution down so much, right? So I'm not getting that super high-res shadows, crisp shadows that I wanted to. The higher resolution you make this, the more detail you're going to get on those shadows. So for now, the longer
it's going to take.
Exactly. This kind of gives me more of that mood I wanted to go for. It's more of a nighttime look. Kind of gives me that kind of zombie feeling.
Fits well with Zombie Pumpkin Slayer.
Exactly. So there you go. You have your light maps baked. And then from there, after you've got those done, you can look at your light maps. See, it gave me 2 light maps right here. You can see my bake settings, what I had. And sometimes it's a good idea just to write down the bake settings you used. If you do like a particular setting and it works great, just write down those values and just have it as reference to use later on. So we'll close that window. You can look at our lights and see how it turned out. It looks pretty good. Then you want to go to your lights, and you just want to turn off those lights in the scene, right? And you see now I turn off those lights. I have all the lights baked. They're on there. It appears that the lights are still on, but they're not, right? The lights are turned off, but you'll notice my characters are dark, right? And that's a good indicator of the ambience. The ambience is still too dark in the scene. So from there, we want to get this character lit back to kind of our normal standard so we can see him. What we'll do is go into our render settings, and then under the ambient light, like before, we're actually going to click that color, and we're just going to bring that back up. And that's because this is a dynamic character. He has no lights on him right now. Right, so we want to bring that ambience back up. So first of all, we can see the characters.
Sure.
And if we decided not to use light probes, it's a good way to kind of pump up those values of the characters not using. It's great for animated characters or characters that aren't getting a lot of light in a certain game. Bring that ambience back up so you can really, really see them. They'll pop out from your scene. So from there, we've brought that up. He's now has his ambient light. We can see the character. And I think that's exactly how you do just basic light mapping. And then from there, are we going to...
Why don't you talk about the light probe script and the light probes?
Absolutely. So we'll talk about light probes. So now it's like we have our characters lit, our scene is light mapped, but we want to cast some light on our characters. Like we're just not super happy with how the characters currently look in our scene. They wish they could actually get some of that greens and some of that blues as they run around. Maybe as they go under these god rays here, they kind of get lit up a little bit. We want those kind of things happening to add a little bit of drama and just kind of feeling to the scene.
Realistic.
Yeah. It just makes everything feel a little bit more complete also. You just want to have those different elements. So what I'm going to do is, for the purpose of what we're doing, I don't think I have too many lights actually in the row of what I'm doing, so I'm just going to bring these lights back on. I'm going to build another just dramatic light so we can see exactly what I'm talking about.
Okay.
So for right now, let's just take this this extra light I have, we're going to duplicate that. We're just kind of going to bring it into the path of where these characters are going to run. So right now they're running down that way. We're going to put it in the front, and basically what this is going to do is this is going to show these guys lit up as they run by it, right?
Cool.
And for now, let me just do it as a color so we can really, really see the difference. So I'm just going to do like this really, really orangey color, just for the sake of the demo and what we're doing, so you can see that, so you can see the process.
Plus, it's very Halloween-y.
Yeah, exactly. So we'll kick that orange color up. We'll increase the intensity. These are your colors of your lights right here. So you just want to make sure you increase the range, increase the intensity. And as you're light baking, you're always going to want to be going to your different lights too and changing those settings and keep baking and rebaking and getting the result you want. You know, it's all about playing with the lights and trying to get that feel of the game. So, you know, we'll increase the intensity pretty high on this. And the range we're also going to increase too, because we just want to really see the effect of what the light probes do to your characters. And this is just a dramatic way of showing that. So we'll increase that. Maybe I'll make it more of like a yellowy color, kind of like that. And we'll increase that, increase the range of that point light. And real quick, I'm just going to go back into my light baking settings. And now that I have my lights back on, I'm going to do a real quick rebake just to have that new light in that new bake we did. So we'll bake our scene. We'll see now. It's going to rebake the scene. Oh. You know what? Actually, let me turn that ambience down. Like I said before, you always forget steps. Always forget about that ambience. Go back in your ambience, turn the ambience back down.
The good news is if you happen to not catch that slide, these are going to be recorded and online in a couple weeks, and you can go and take a screenshot or download a slide deck and tack that up on your wall.
Absolutely. So you can see I brought the ambience back down. Now I'm rebaking the scene. It's calculating, doing its work for the light baking. And it's baking the texture at the moment. And now the light bake is done. Cool. And you can see right there, you know, see the result of putting that light in there. It kind of gave this really intense kind of lit area, which is kind of nice because that's our goal, right? We want to protect that. And so that gives us a kind of a beacon for our characters to know where they have to go. Now we'll turn the light mapping off. We will turn our lights off. We will go back into our ambient light. And this is kind of like a 2 to 3 step process every time. You want to turn that back up, bring those characters back.
Sometimes it helps to write down those initial values that you have just to get them exact before and after, so your scene kind of stays the same. But
absolutely. And then you'll see, okay, I've brought the ambience back up. Now I want to do some light probes. And light probes are a very tedious process. So it's not something that happens quickly, but there are some scripts available out there that make it much, much easier.
Because normally you have to place them all by hand.
Normally you have to create a light probe, you have to grab that light probe, create another one, and space them equally apart in huge areas of your project, and it takes forever. But there are some really great scripts out there that people have written to make this process much, much easier. And one of those scripts I found was this script called Light Probe Helper. And you can find this script for free online. Just look for it in the Unity forums and stuff. Everybody knows where it is. You can get it. And then from there, you download that script, you put it in your project, and you're going to make a game object called Light Probe Group. I just called it Light Probe Group for the sake of the project. You can call it whatever you want. And you attach this script, which is your Light Probe Generator script. I think that's the name of the script, Light Probe Generator.
Light Probe Generator.
But I think if you just Light Probe Helper, you will find it.
That's how I found it.
Most people know it as Light Probe Helper. Add this script, Light Probe Generator script, to your Light Probe group. And then I think on your Light Probe group, you also want to go to Components, Rendering, and then you want to make it a Light Probe group.
And that adds that other middle component underneath your transform over there.
That brings this one up right here. So right now, it'll actually come on when you actually add that light probe group to that light probe group that you created in there. So create your game object, go to component,
and it tells you that when you download the package, there's a little...
Package has some instructions in it that kind of give you those instructions, but you want to create your game object, add that light probe group, and then you basically right here, you'll see that it puts this light probe generator script in your game object. So from there, you'll see in here I have all these light probes. And what that script did was actually take an area. It lets you define this square. You have like the positioning of the square, and then you have dimensions of your square, your X, Y, and Z variables. And if you go in here, you can kind of see right here in your probe volume, it gives you the
text
space.
Kind of gets a little scrunched in there, but that's the talk about those values there?
Absolutely. So yeah, I don't know what's going on with that right there. But basically it tells you the center values of where this volume of light probes is going to be. And you set those values. And then these bottom ones right here are going to tell you exactly the size of this kind of volume of light probes that you're going to make. It's a really, and trust me, it seems a little tedious, but using this is so much easier.
It looked like
than doing it by
hundreds
hand. Yeah.
of
You can see
probes.
doing that by hand would just be, it would take forever.
Wow.
It would take forever. But some people do it. Some people do it. So anyways, get this script. It's really, really going to help you out. Once you generate, you do those values, and you have this kind of, you'll see right here, I have this big red kind of outlined volume. It's going to make that volume. You want to center it along the area of where you're going to put all these probes, right? So right now, for the sake of what we're doing, I actually already pre-generated these probes, but when you're doing this before, you're not going to see those in there. Once you do that, you're going to click Generate, and it's going to create all these probes within this grid. And for the sake of time, I already have those in there just so you can see what it's going to look like when you initially do
Cool,
that.
okay.
So make sure you get your grid set where you want it, and that's that red box you're going to see right here. Once that's done, then you click Generate. Then you're going to get all these probes within that volume that you created. And basically what you want to do is just put those probes along the path of where your characters are going to run. And don't worry about having the probes go underneath your scene or anywhere else. You just want to make sure that they kind of more or less fill the area of where any of the characters or anything that's dynamic is going to be moving within your scene. And then from there, once you have all those light probes set in the area that you want, you're just going to go into your window settings, go back to the light mapping window that we had before, click on the Bake tab, and then instead of doing Bake Scene like we did before,
Let me guess. Bake.
we're actually going to go to Bake Probes. And then you click Bake Probes. It's going to go through its process. And then it's a lot quicker than making the scene.
Wow,
it's already
that was
done. But now we have our probes baked. And so from there, you can actually, you want to keep your light probe group off, but just click something else in your scene and you won't see all those light probes. You're only going to see those if you click on that light probe game object. And be aware too, the more probes you have, your scene will start to run very, very slow. So if you have a bunch of these different volumes of light probes, I recommend doing the same thing I do with lights, is I would throw them into a game object, because if you have a bunch of these, your scene's going to run very, very slow. And this is one of the things you want to do probably near the end of when you're actually going to go to release. So just be aware of that. Sometimes it crashes if you have a lot of light probes. You've got thousands of them running at one time, it will crash.
Okay.
So just be aware of that. It's just kind of a good rule of thumb. But anyways, now that we have those, we can test the scene out and actually see these light probes working. So, you also want to make sure on your characters, anything that you want affected by your light probes, you want to click on those characters, click on the model of the characters, and there's a little option under your mesh renderer. You'll have cast shadows, receive shadows, and then make sure use light probe right here is selected. There's this little option right here that says use light
Got to be
probes.
checked off, or
That has to be checked off, or they will look like nothing's going on.
okay, cool.
So with that being said, we'll test our scene and just enter your play mode. And you'll see my little guy right here. As I run, was he being affected by the lights? Does that run through here?
Was that light off when you baked it? When you
No, it should be there. It should be, actually, here. Good way to test is we can bring our ambience down and really see if these light probes are being affected. So right now, actually, it doesn't look like he's being affected by those lights at all. So what we can do is go back into our light probe group. Let's make sure that everything's working.
recheck the settings.
Yeah, recheck the settings, make sure everything's on. You want to make sure your light probe are working. Let's regenerate just in case. Generate. Light probe's working. Okay. That's working. Let's go back into our window settings. Turn
That's
our
the thing.
lights.
Sometimes there's a bunch of steps. You got to make sure every step that you get.
Always a bunch of steps. There's always 10 steps to make sure something happens. You always want to make sure you recheck to make sure it's working correctly. Make sure your lights are on. Go to window. Go to our light mapping. Go back to our, just to be safe, let's bake the scene real quick. Or we'll bake the probes. And then we'll also, okay, go back in. look like those are good.
I'll tell you what, while you check that out,
Okay.
we'll cruise on and start talking about reducing draw calls, and then we'll switch back to that demo a little bit towards the end. So since we got a lot of subjects to cover here today, we'll move on to the next one. We'll start talking about optimizing draw calls. You can check out that scene. We'll loop back to that momentarily. Sound good?
That sounds great. Let's do it.
So, optimizing draw calls.
Actually, you know what? You can see. You can see
Got
here.
it?
Yeah.
All right, perfect.
You know what? I think
that.
my lights just aren't as intense as they should be.
Okay.
But if you'll notice my character, it's very, very subtle at the moment.
Oh,
I
yeah,
don't think
I
my
see
lights
there.
are very as close to the character as they should be. But you'll notice even when I run through this green right here, you can see that he's subtly being affected by those green
Yeah,
lights.
I saw it right when he ran kind of on top over there.
Yeah, and you can see
Right
here
there,
he
yep.
kind of actually gets hit right there too. And that probably has to do with the fact that my lights aren't as close to the character as they should be, and the intensity should have been brought up way, way up. But yeah, you can see as I go to the end right there, he actually is being affected. It's just a very, very subtle lighting effect. So that's just, I should just turn my lights up and that's what you want to do. You want to play with your lights and get the result you want.
Okay.
So what I'll do is, Adam, as you're going through your next thing, I'll just kind of turn those up and show what that looks like.
Perfect.
So they get an idea.
All right.
Great.
Thank you.
No problem.
Cool. All right, let's go back talking about draw calls. Draw calls are one of the several major things to look out for. A draw call happens when there's a call issued to the graphics API to draw an object. And I like to think of it as the computer has to render out your scene. Every time you have to paint out a texture, it's essentially like changing a paintbrush. The system's really drawing with textures. Each model, typically by default, without any kind of optimization techniques, has one draw call. It's going to be constantly switching from one texture to paint this object, one texture to paint another object. Now, draw calls affect CPU. The more draw calls you have, the more your CPU is affected. So on mobile, you typically try to target about...
On mobile, I try to, depending on the device I'm going for, if I want to cover all devices, you want to stay within that 50 to 90 kind of range. 90's pushing it. Maybe you only have some hiccups here and there where it spikes up to 90. But as a rule of thumb, in general, you kind of want to keep around 50 to 60.
And the lower
devices, you want to keep around 30 to 40. I wouldn't even go higher than that.
Gotcha.
And that's just, this is what optimization does. A good way to really tell if you're getting those draw calls or not is within Unity, when you test your game right here, if you want to look at my screen, as I test my game, you'll notice that there's this little window at the top called stats. You'll see that right here. What you want to do is click stats and you'll see in here the draw call. So right now I have all my lights turned on my scenes. I'm going through it, rebaking, and you see I have some dynamic shadows from all the enemies. You'll see that draw calls right here is really, really high. And that's because I have all those lights happening on the scene at once.
So we're going to talk about some cool ways to reduce those draw calls.
Absolutely. And if you're doing next gen work, it's okay to have those. You can have thousands of draw calls.
But mobile's different.
But mobile it's a totally different beast. No pun intended.
So reducing draw calls is the key.
Yeah.
Definitely, that's the target there. You want to reduce draw calls.
Yep.
So let's talk then about atlases on the slide deck. If we take multiple images and we pack them together to a larger one, that is what we have as an atlas. You'll hear in game development texture atlas or atlas a lot, and that's essentially nothing more than taking multiple images, adding them to a larger one. And so as opposed to the system painting these separate textures out and having to load up multiple textures, it has one texture and it can just map to different objects. Like one, you'll show when you do the Rubble demo, part of that texture, if we look on the slide deck there in the lower right-hand corner, part might be mapped to one object, part might be mapped to another object. So that reduces draw calls. On the UI elements in Unity, what they initially brought out as their new GUI system, and actually 4.6 beta that's downloadable now, that has a brand new GUI system on there. We looked at some GUI elements yesterday in creating a 3D game. Those are Auto Atlas is what it's called. So that kind of packs your images together on the back end just to save on performance. And Unity does have a sprite packer that you can use for your 2D assets to help optimize those a little bit more. And I'll show you a little bit demo of that. But let's talk about some ways to reduce draw calls. In reducing draw calls, static batching. We're going to look at a demo of that. That was what I was mentioning is a pro feature. And that will basically take your objects that don't move, and we mark them as static. That behind the scenes combines your geometry for those objects, optimizes drawing them out. Now, dynamic batching, that is free, in the free version, that works automatically. So those are objects that are running around, moving around. That sharing happens automatically. The batching happens automatically. You don't have to worry about that. But there are a couple things that you do have to worry about. That has to be the same material shared. So if you have zombies running around, those zombies have a shared material. As long as there are less than 900 vertices in that zombie, this will happen automatically. And also as long as those objects don't have any real-time shadows on them. Ideally, you want to atlas everything you can, right? Take your sprites, pack them together, your textures, pack them together. And I know you do this quite a bit, and you'll show that when you look at the rubble one shortly.
Absolutely.
In Unity, they have the old GUI system. It's still, you can use it in the new versions as well. And that old GUI system, you kind of did things by code. You had an on-GUI method. You drew things out to the screen. And that was not very performant, so to say, for draw calls. So we want to try to use their new GUI system. Some folks call it UGUI. In the Unity editor, you actually see it called UI. That's the new one that you want to use. That's definitely quite a bit more optimized.
And that's really, really, really going to help in the draw calls too. I mean, packing all those sprites together as a single sprite sheet, you're going to have a dramatic difference that you're going to see in those draw calls. You're going to go from probably 20 or 30 down to 1.
Let's look at some performance enhancements from reducing those draw calls,
Let's do it. Yeah.
All right, so let's switch over to my computer here. We're going to look inside of Unity here. I've got a scene opened up in ZPS, Zombie Pumpkin Slayers. Woo! So I've got the scene loaded up here, and let's go ahead and run this real fast. I think I've got my music turned down. Okay, so my draw calls are really low right now because my lights are off. I haven't done the baking on here. So my lights are on, and let's kind of see here. We've got 190 draw calls right now. That is a lot. Very, very bad for mobile. This will be bad. Now, right now, I've already got some saved because some of the objects on the scene right now are already optimized. Unity is telling us how many have been batched together to save draw calls. So we've got 115 calls that have been batched as opposed to having them on this side. It's saving those. So we want to increase this number and reduce this guy right here. So let's take the environment here, organize quite a bit, and taking all the crosses. So if we just click on the cross here, we've taken all of these crosses and put them under one game object here. Now, these guys will not move at all. So I know I can come in here and mark them all as static. How do I do that? I put them all in a parent game object here, just like you were showing us with the lights. So what I do here, everything is in a game object. I've got crosses, we've got plants, trees, all organized, because that helps us to just come over here. Let's undo this first so I can show you how we do it. This guy right here, static. We want to make sure we check this off. We know these objects aren't moving. You're telling Unity this is highly optimized, it's going to be optimized. This isn't going to move at all. In fact, you get weird effects if you try to move an object that you actually have marked as static. For example, if you were to put a cube in your scene that was marked as static, you would see your collider move, but the actual mesh would stay still. You get some weird effects. So you want to make sure that these things are only ones that stay still.
And I'd say that's a common problem, too, when you're developing. If you attach scripts to certain things that are dynamic, and let's say if traps in your level or different things that are going to work, and they're supposed to be moving a certain way, but they're just kind of acting funny, always remember to go back in there and check that static setting and make sure that's checked off if it's dynamic or on if it's just going to be a static object that sits in your scene.
Good point. Now, because I've got all these child game objects underneath the one called crosses, it says, hey, do you want to enable this for all the children? Yes, change children. That's what that says there. Do we want to enable static flags for the children? This one is what we want. Yes. Change children. They're all marked as static. Just like that. Let me play the scene here. Notice. So let's go and undo everything here. Check this out. Save by batching, 51. I checked it off. Come back over here. 115. So without it, 51. With it, 115. Now, again, we see these draw calls being so high because my lights. Let's assume I baked my scene. Because right now we were at, let's look at that value again. So I've increased this by checking off static for my crosses. My draw calls are still huge, 193. I'm going to assume my lights now have been baked. Run that again. And now I look at this here. I'm down to 26 draw calls. Very mobile friendly right now. Very mobile friendly. Perfect. Save by batching is lower because we actually have the lights combined with a lot of other objects off now. So that's why we're seeing this other optimization there. All right, now secondly, let's talk about the atlasing built into Unity. I'm going to create a new scene for that. And in here, I'm going to take, I've just got some 2D graphics here to show you what would happen with some 2D stuff. This concept works with really any 2D. I'm just going to take these and throw a bunch into my scene. I'm going to go into 2D mode here, this little 2D button here, just so I can drag and drop my textures into there. These are 2D textures. In a 3D project, when you bring in a texture, it actually comes in as texture type texture, which you can't drag and drop into a scene. On a 2D project, or if you change it on a 3D project, if you want to be able to drag and drop them into your scene, you want to make sure these are set to 2D and UI, in other words, a sprite. Now I can just drag and drop these. As I drag all these in here, notice I'm starting to increase my draw calls down here. Now, I don't have much stuff here, so it's not a ton. Actually, I don't want to create an animation. That's why it's asking me that, because I dragged a bunch of my sprites in there all at once. So my draw calls kind of start to increase here a little bit. So what I can do with all these guys, let's assume I've got many, many 2D assets in here. I can take all of these here, and I've enabled the sprite packer. So under Window, we have sprite packer. Sprite packing is disabled. Enable it in Project Editor Settings. So let's go ahead and enable that in Project. Edit, Project, Editor Settings, Sprite Packer mode is disabled. I'm going to say I want this always enabled. Now when I go back to Windows Sprite Packer, we have our Sprite Packer enabled here. And I'm going to want to click on this first button there, which is Pack. But in order to do that, I need to have told Unity, how should I pack all these together? You kind of want to keep similar colors, similar groups together. These are all fairly similar. So I'm going to come in here, I'm going to tell Unity, all of these guys right here, I want a packing tag. It's just text. We're going to call this platforms. This is how it knows how to combine everything together. We'll call that platforms, apply. So Unity is going to say everything with this packing tag of platforms, just text, we're going to squash together into one atlas so we can draw them all out at once. Now we come into the sprite packer, now that we've set our packing tag, and we just pack this guy. Pack, filtering out to atlas 1 of 1. Let's increase the size of this a little bit. And if we look here, now it's taking all those images, and it has one texture with a couple different pages in it. So these are all now on essentially one image, and Unity knows behind the scenes how to map each of these to each object over there. So it's a real easy way just to come in here and kind of pack everything onto there. I mean, of course, I just have a real generic scene here. So that's one way that you can use to pack all your stuff together inside of Unity. You can also do it outside of Unity as well. Prior versions of Unity, the sprite packer was in preview mode. That is now out of preview mode. We don't see developer preview only or whatever it used to say on there. In 4.6, it's now just listed as sprite packer. So Matt, why don't you take us through, since we've looked at the 2D side, we've looked at batching as well, maybe take us through how you might do something in the 3D world. I know you had a really cool rubble texture on there that took advantage of the 3D laying out into a 2D, right?
Absolutely. So a lot of things I like to do when I optimize the objects in my game, and I want to make sure that you want to have all your objects kind of sharing different textures. You know, don't have too many 3D objects with all individual textures, because when you do that, those are essentially draw calls, right? So each object you can think of as one draw call. So it's better to take, and draw calls are based on materials, right?
Yeah.
So the more materials I've ever seen, every material you have is essentially one draw call. So you want to try to combine as much as you can. So for the sake of what we did within our demo, we'll look here. Let me just turn my ambience back up so I can see what I'm doing.
Lights are everything.
You'll look that I've got a couple different objects in here, and I wanted to save on the draw calls, because if I had each of these as individual materials, it would be a lot of draw calls happening at once. So what I did was combine things. And this is really great when you use things like transparent elements, right? So for transparent elements, I have a couple things going on. I have my plants right here that are based throughout your scene. And then I have these little like God rays elements right here, right? And you'll see what I did in those particular elements.
And normally they would all have a separate texture, each one's separate.
Absolutely, they would.
Each a draw call, they're all separate.
But in order to save on the draw calls, I wanted to combine those elements together. So what I did was in 3D, when I made these objects in 3D, and you can see kind of right here, the actual 3D kind of wireframe I used to make that, I went in to the texture. we go into the actual plant, you'll see right here, there's two things happening in this texture. I'll try to open that up. And it's a little hard to see because of the background, but you'll see that I have my plant leaf that I painted, but I also put that fade for those rays also in there. So these two objects are essentially changing or using the exact same texture. And the reason these ones are is because they both share transparency. So, you know, with transparency, you have a transparent element and you can see through it, right? And the same with the rays, they're transparent and you can see through it. And I would suggest if there's little elements like that, if you have fades or any elements like that in your scene that you're going to be using a lot of, put them all on the same texture because those are really going to kill performance and add probably even more draw calls because of overdraw and things like that. So you want to make sure on your transparent elements, you do the same thing. Now for actual kind of solid elements in the game, I did the exact same thing and I try to be creative with my textures as well. And you want to really think of that when you're creating your levels and doing things. So for the rebel, right here, I have all these rebel pieces on the path as the character runs. You've got all these different bricks and different pieces that sit in here. But for these, I did the same thing. These share the same texture with this giant cross in the middle. So I have this cross, and that's the element you're to protect and everything. But on here, I did a couple creative things. I said, well, this base actually uses the same repeatable texture over and over again, this kind of triangular little piece right here. And then I have the elements I cut out for the cross as well. But then I had extra space on this texture that I created. So you can see right here, I have my cross. I've got the base for the cross, the different pieces. Here's the base of the texture. And instead of using a ton of different sections for that, I just made one, repeated it over and over again, and all those different UVs kind of use that exact same spot. And that freed up a lot of space on my texture that I can use to do different elements. We'll zoom in here so you can see. So over here, I've got my rubble pieces, and those are those pieces I have that are kind of littered across my stage. And then I have some other pieces for more rubble. I had a lot of room in here to do a lot of different pieces. And so you just really, really, really want to be careful as you're making things. To create UVs, you don't need, you know, specific textures for different things. They can all be, if you have room on textures, take a piece and create it in that texture you're already using. I did the same thing with the trees, and that's probably a really good example because you can really see the two defined elements. So right here was the tree I made. And you can see the texture for the tree I made, which was right here. And essentially what I did on that tree was I just made one texture for the bark of the tree, the central element, and then I reused that piece over and over and over again to do all the branches. It's kind of in the distance, you don't really see it. So I have just that one element, and all those pieces are using that exact same element, which is this whole piece right here initially was the trunk that I cut out, and then I used part of that trunk to make the different branches in 3D, right? And then on that space, that gives me a ton of room, because if you were going to do a tree and have all these different added textures and stuff, it'd be kind of littered across your texture and they'd be all over the place. But doing that gave me tons of room on here to add more elements. So I put a huge boulder in here and textured that as well. So because these two elements are using that same texture and they're marked as static, I have all of these trees scattered around my project. I got one, two, three, all in different locations, different sizes, different, I skewed them differently to make them appear as they're all different, rotate them differently, but they're all exactly the same. And because they're all marked as static, you're getting one draw call because it's batching all of that together. It's basically thinking of that as one material and one thing it has to edit. And so you're basically, I think maybe one, maybe two draw calls it might get, and that just depends on the CPU. But when you do that, you save a lot. I did the exact same thing with the wall back here too. I did one texture for the wall, and with that texture, open it up here, I've got a couple things. Yeah, cool. I've got the wall itself, which I used to do this repeatable texture for the wall, and that's this right here. And then for the top of the wall, I used this repeatable texture right here. And then I took that model and I cut it down and did a variation on it, and I used this area of my texture to do kind of like that broken part of the wall, right? And then from there, I wanted to do a column of the wall too, and so I made this third model. Oh, whoops, get back out of there. I made this third part of the model, which was this column right here, that I used the exact same texture to kind of use the UVs and repurpose that texture to make more elements. So from there, I was able to get three kind of unique models. I did a broken wall, I did a flat wall, and then I did a column with a cross on top of it that are all using the exact same texture. and that's one draw call. And you have all these elements.
All
You can do
combined
all kind of
together, very
unique
cool.
things. Yeah, and do really, really cool stuff with it. So that's just a really good tip, and you want to be very cognizant of that when you're building your levels, that you can take all these pieces, combine them, combine as much as you can to build a lot of unique pieces with one material.
And save on performance, because remember that draw calls affect CPU.
Absolutely.
Reduce that all out. Very cool.
And these work really great when you're doing things like castles and other things like that. You want to make sure that you just throw all that stuff into one material that all these objects can use. You're really going to save on your draw calls, and you're really going to get great gains out of the performance of your game.
That's
as
cool.
well. Yeah.
Very cool. So very important tips to remember.
Yeah.
Let's move on to some other tips that we've got here. Compression. Compression, typically very easy inside of Unity. You can compress inside of Unity per platform. You can figure out which devices you want to target. So if you're going to be going to Windows Phone versus Windows Store versus iOS versus Android, etc., you can change your compression on there. Now, universal apps don't support compression per platform, and I'll show you this in a second. And this affects not just Windows. There's other platforms that have the concept of universal apps. But the idea is that when you want to take one texture, it might be a high resolution on let's say you're going to be running on a PC. If you're going to be running on mobile, you want that compressed down quite a bit. And inside of Unity, let's take some of those textures that I had before, like some of those platforms. If I click on them right over here, Unity shows me the quality right now. So let's say I'm going to build for the web. I might have, right now I have a default size of 1024. But let's say on Windows Phone, I want to override that value and come down to maybe 256. Let's just look at that real quick here. Kind of notice the resolution that's on here. I'm going to override for Windows Phone, and you just drop this value down here. So I'm going to take this just for the effect so we can see it more. I'm going to chop down, that's 3.8 megs. And then how do you change your actual platform to see that? In your build settings inside of Unity, Control-Shift-B or File Build Settings. When we come in and we change them, right now we're defaulted to Windows Store. If I want to go to a standalone build, I would switch a platform there, or down here to Windows Phone, switch platform. Let me actually go back and switch Windows Store since I'm on Windows Store here, and change that down. There we go. Because that's my default platform I'm building for. Now we see the effect. That went from near 3 megs down to 15K, and we can see the size and quality has been reduced quite a bit. So I probably wouldn't use it on anything with a big screen. This is probably a good setting for phone. The idea is on these settings per platform, whatever platform you're exporting to that Unity supports, you can override that per platform and change those settings up a bit. So it's kind of a little bit of experimentation. Alchemy Labs has a really cool product called the Multi-Platform Toolkit, and that kind of gives you an easier way to support compression inside of a platform. So for example, a universal app in Windows where you can have one build that's going to target inside of Unity, you're going to export universal apps for Windows Phone and for Windows 8.1. What you can do is separate them out inside of it. You can say, oh, we're going to Windows Phone 8.1. I want maybe this texture, and if we're going to be going to Windows Store on Windows 8 style, maybe bigger devices than a phone screen, I want to target this size texture. So you can definitely mix that up quite a bit on there.
Just to show you really quickly, if you want to cut back to my screen, what we were talking about earlier with the light probes, this is the effect you'll get. So when you look at your character on the screen, as he runs around, you can see there's kind of that general ambience out here, but as he gets closer here, he starts to light up. So you'll kind of get those vertex shading on your character where it lights up and kind of just gives you a little more of that ambience as he runs around.
I see.
So he's kind of general ambience, and he goes here and he starts to light up, and you can see those colors kind of hitting him. So just, light probes are really, really good to give you that added kind of dimension to your characters and a little bit of shadow and feel to them. So just to show you
some added info. Very cool.
Just some added info to kind of give you an idea of what that looks like.
Awesome. So back to compressing textures. We can change it real easy inside of Unity. Just check those off and change them per platform. Audio is easy as well. Unity supports a bunch of different audio types, WAV, MP3, OGG or OGG. So the idea is that if you have long bits of audio, you kind of want to rethink that strategy a bit. Either you have to highly compress them, and I know you came across this when you were playing kind of full songs on long audio tracks. You found out that you had to really...
Yeah, you want to keep your audio tracks down to basically loopable, maybe 30-second tops tracks, because when you have these very, very long songs that play, it's a major memory hog, especially for mobile devices. You're going to get major, major memory loss that you could potentially use for other things like graphics and everything else when you have all that memory being filled up by this audio. And it also reduces the loading time a lot on your game. So when you have these huge songs, right, that are in your level that you have to load, and you want to reduce that, just put it in a loopable track. Makes it a lot easier. The levels will load up a lot quicker because it doesn't have to load in all that audio at once.
Some folks might notice that on the settings for audio in Unity, there's a, if we switch back to the slides here, this guy right here, stream from disk. That sounds like, well, hey, I don't have to load it all in the memory. The purpose of this is to increase, to make your game load faster as opposed to have to wait for that audio. It plays faster. The downside is there's a lot of hits to storage, and that is also a drain on your game. So there's kind of trade-offs as a best overall strategy. Like Matt said, you want to keep these clips to lower length, loop them, and then switch in and out other clips to kind of mix it up a little bit, right?
Absolutely, absolutely.
All right, let's talk about coding techniques next. So in Unity, you can do all sorts of coding optimizations. As a general rule, some folks might say don't premature optimize. So there's all sorts of different tips and tricks and different times you may or may not want to use these. So I'll just talk about some of the basic ones here and kind of when you might want to use them. Remember that inside of Unity as it stands today, you're going in your code from this kind of managed code over to native code, back again. So if you say to Unity, hey, I want to do something in code with this GameObjects transform, it's going to the native engine, getting an object, and sending it back to you. And anytime you cross those boundaries, you hurt performance. So we're going to show a way that we can cache those up front. When you use techniques like GameObject.find, they scan every object in your game to try to find an object. They're very slow as well. Component references. We looked at in the demo of getting a reference to an animator component. In those, if we're constantly saying, hey, get me my animator component and do this with it, give me my animator component and do this with it, over and over and over again, maybe multiple times a frame, that's going to really kind of hurt performance. So you can cache these references up front. We'll get some code ways of doing that. In the editor inside of Unity, we can cache out a reference to there. We did that yesterday in the 3D game. We basically drag and dropped our little text box into the Unity editor, and I'll show you a code example of that. And ideally, you want to avoid lookups and loops. Not trying to go back to Unity and asking for data in a loop, maybe inside of your update frame. Since it gets called so many times a second, you don't want to loop inside of your update calling out as well. And also, object pooling, huge. If there's one thing to take away from today, object pooling. Pool your objects, pool your objects, pool your objects. And you say, Adam, what is object pooling? Well, I'll show you that in code. Let's hop over to a code demo here. Yesterday in ZPS, we were doing things like spawning out all of these zombies one by the pumpkins, one by one by one. These guys all start coming around. Let me
zombie pumpkins.
Zombie pumpkins. Clear this guy. So all these pumpkins that were coming out, they were all being spawned at several times. I would destroy one. It would go away. It would get destroyed. New ones would spawn. That's very, very, very expensive for performance because you have to spin up new objects every time. In addition, you have to the runtime will do garbage collections every now and then. And when it does garbage collection, in your game pauses. So you want to allocate as few objects as possible. The idea is you want to use...
When we were initially testing this, we had the pumpkins just kept coming. There was hundreds, maybe 200, 300 pumpkins because it just kept spitting them out. And, so it started great. The game would start great. It would run like super, super smoothly. But then as those pumpkins started coming out and they started filling up the screen, you saw this major performance hit. And then it was like running like a dog. It was just running so slow. So
I got down to like 4 frames a second here.
Exactly. So this is what object pooling is all about. You kind of want to limit the amount of objects that are on the screen at once. And it kind of counts up that. And basically, this is what you're doing.
Yesterday, to your point, this is exactly what we were doing here. We're basically coming in here and just constantly instantiating over and over and over again in a loop. Create the number of zombies for us per wave. Then we waited a little bit. Created another wave. I'm sorry, pumpkins. Zombies on the brain.
Zombie pumpkins.
So this is in the code that you're going to be able to download. I have spawn without pooling. That's what I was doing yesterday. Today, I'll show you my spawn with pooling. And I'm using one here called Trashman, which, just to show you the URL here, was also by the fellow from Prime 31. You can write your own object pooler. You can download a bunch from the net. There's tons of them out here. This is just one I kind of like how it works. It's pretty easy to use. All you're doing here, rather than getting a brand new object, what you're doing is you're downloading the Trashman component. You're adding a game object to your scene. I called mine Trashman. And you have this Trashman script over here.
Great name.
It's a recycle bin and a trash man. You drag your prefab on here. So I took the pumpkin, dragged it on here, and it created a recycle bin for a pumpkin. Said, all right, how many do you want to pre-allocate? Well, I'm matching this to my wave size. I want 12 pumpkins to come on my screen at once. And here I'm saying, you know what? I don't ever want to go above 12 pumpkins. I'm going to wait until that player has to destroy them, even if it's time for the second wave. What this does is when you ask the pool for another pumpkin, if there's already 12 out, it's just going to return null. There's not one available.
So without having that checked, it'll do 12 at a time, essentially, and then that could add up and be even higher than 12. But if that's checked, it'll only make sure that there's only 12 at once.
Yep, it can go higher. In that case, then it has to allocate more. What I've done in this case is I've said I've got a hard limit of 12. Do not give me any more than 12. Now, this number doesn't have to match the above. I could say start out with 12. I could make this 20, and then it's going to cut off at 20. So kind of fool around with it. I'm going to make this match my wave size just for, I think, for performance. It makes sense to me that way. In the code, it's really easy. We say, trash man, give me a pumpkin. That's all we do. And then, let me search here, and I will show you where we despawn. Once we kill a pumpkin, we call its die method, and all I do here is I despawn that. Now, I am kind of, I could respawn my particle systems here. This is kind of a no-no, I would say. I should actually recycle my particle effects here. So right now, Trashman despawn my game object. Now, whenever I want to create a new one again, I spawn it, and then I just happen to reset the values on there. And if I look at my pumpkin here, I just have a little reset value that comes in here, sets its health back to its initial health, stops any running coroutines, just to start those values out again. You always want to make sure you reset your object's health or whatever values you need to reset in there before going again. Now let's run over to Visual Studio here again. Stay in Visual Studio, I should say. And I just want to show you a code optimization script. Just a couple techniques in here. So one, up front, we did this yesterday. As soon as my object, before its first frame is ever even rendered, when this object first starts up, there's one called before start called awake. We can use void start. This happens right before the first frame. Other objects are generally initialized by this stage. As of now, with the awake method, I only know that my object is awake. I have no idea if there's any other objects instantiated or not. In this case, it's early on in the process. I know I can get a reference to my own animator component. I'm going to use this all over. So I want to get that early, cache it up front, so I don't have to go back and forth asking Unity for it. Now this here, another one. When my game starts up, I'm doing this in start because now I know other objects likely exist at this point in time. In other words, I know my player is going to exist by the time my start method's called. Start is right before the first frame for this pumpkin is rendered. So I know that my main player at this point in time is already awake. It might not be rendered yet, but it's safe to call it here. I'm saying find me my player. I'm caching that reference. Now anywhere in my game, in this code, I can use player without having to search for it all the time. You'll find that some folks will do things in their update method like that. Every frame they're searching for it. Very, very, very bad for performance. Do this up front, cache those references, use them later. Again, caching reference here, I'm calling transform.position every time. The ideal way, and this is being called an update, it's happening every frame. The ideal way here is to go up top of my code and do something like this. Cache the reference to that transform. And I can use that later on without having to go back and forth between my code and Unity's native code. Saves on performance there. So all these places here, rather than using transform, I would be using my cache transform like that. So that's one way to save on those calls.
It's a good tip.
Now, finds. Just like we found our player in the beginning. So let me scroll up here. On start, I cached a reference to my player. I'm doing the exact same thing here. GameObject.find zombie kid. you don't want to do this every update. GameObject.find searches through every object until it finds one. Now this one here is a little bit more performant. This only searches objects that have a tag set on them. Find GameObject with tag, and I'm looking for my player. Again, I don't want to do this in update. I only want to do this up front. And as I showed you in the beginning here, my animator component, so if I right-click and I go to definition, I'm just creating a private variable here called animator. And when I wake up, I'm getting a reference. I'm calling get component. So it's a little bit slower. It's got to search that object for that component. I don't want to do that every frame. Cache it up front, and then wherever you use it in your code, you can just use that private variable and reference it. A couple little tips that go a really, really long way. Object pooling. Let's go back to that slide here. Object pooling and not searching for objects in update, cache those references can really, really help for performance.
Great.
All right, let's move on to almost to the last subject, terrain and skyboxes. We'll just talk about real fast here. Unity terrain, it's got a really cool terrain system in there. When we get to the demo for the next section, reducing geometry, you'll show a quick demo on there.
Absolutely.
It's a cool system, but it generates many draw calls. So you can experiment with some of the built-in settings in Unity. They have some of these settings we can see on the slide here. Reducing pixel error can actually reduce the number of draw calls for terrain. Terrain is really hefty. You can drop a terrain in your scene. Next thing you know, you have 300 draw calls. Really draw call heavy. There are some really cool third-party tools. T4M, Terrain for Mobile, to help optimize your terrains. You're going to do a demo with TopoGun.
Yep.
Skyboxes. Yesterday, we looked at creating a sky in our world. Skybox has 6 images that get tiled around your world to make it look like you have a sky. That's 6 draw calls. KGFS Skybox has a kind of a cool little plugin that you can use, get from the asset store. That will reduce it down to 1 draw call. There's probably some manual methods you could do as well. For me, I love using the asset store. If I find a cool package on there, I download it and I use it quite repeatedly. In fact, virtually any studio, any developer I've ever talked to who's made professional games, they've got several assets they love from the asset store.
Great.
Lastly, reducing geometry. Some might say one of the most important subjects, this and reducing draw calls, right?
Yep.
Well, geometry, polygons and triangles in your game. It's important to know that polygons in your game are drawn using triangles. So when you model your character, you have what people refer to as polys in there. Those are actually drawn using triangles. Unity uses triangles. Your graphics card actually draws triangles. If we look at this cube on the right-hand side here, we can see this cube surface is actually 2 triangles.
Quad is 2 triangles.
Quad is 2 triangles. What a coincidence. So even 2D images use triangles.
And this is where that term tries, when you hear people go,
Tries.
how many tries are in your level?
Yeah.
What's the try count? That's triangles. That's
Triangles.
it's just a nickname for triangles.
On the right-hand side here for the cool logo Matt created, Zombie Pumpkin Slayer. Guys, I didn't hear you. There we go. Woo! Look at all of these triangles that make this up. Even a 2D image uses triangles behind the scene, how Unity determines how to display this.
And
So-
I think you can edit those as well. They have an edit function where you can go through and kind of reduce the amount of points around an image if you would like to reduce those. You can also do that in a 3D program as well, like Maya or whatever, if you're casting basically a UV over a certain area. That's just one way to kind of optimize certain things if there are too many tries happening.
Cool. There's various tools you can do. You can do them manually. You can go into your favorite tool to do it. There's third-party tools like Cruncher. I'll show you a quick demo of Cruncher. Mixamo has a neat one. Decimator. Blender has one built in you can get called Decimate. There's third-party services. One of them is simplygone.com, where you can upload your model up to a site. It happens online. Really, really cool. I mean, there's plenty of services out there that do it, different ways to do it.
Another term is retopologize. So you're going to hear that a lot.
Retopologize.
You would like to retopologize your model. Look for that in 3D programs, and that basically means it'll trace kind of a cage around a model, essentially, with a lower res. And you can kind of set that res and play with it depending on the package you're using.
Very cool. You can also draw a separate low poly model for your mobile. So maybe your console game or I would hope your console game has a different model than your mobile game.
Yeah.
Your console versus maybe your PC-based game versus maybe your mobile, tablet. You can have different models for that, each one with different levels of resolution in them.
Absolutely.
So you can do that manually or use tools like TopoGun to kind of reduce that geometry. Level of detail. LOD is a pro feature in Unity, and that will allow you to take multiple models. So if you're up close to your zombie, for example, it's a kind of a high-def model. If that zombie's way off in the distance, why should you have to render all those? Why should I have to calculate and draw all those tries? So you can use LOD, level of detail, saying if it's a certain distance away, use that lower res model. When it's closer, show this model. Now, LODs is a pro feature in Unity, but there are scripts and plenty of ways you can find on the net that you can actually do it manually inside of code.
And that's great for games where you have tons and tons of like armies from a distance or different things like that. There's a ton of games out there that do that, and they'll actually have these really low-res models and thousands of them running around. But as you get closer, they pop in the high-res version so you can see like what they look like.
Cool. All right, let's move to our last demo for this session, reducing geometry. I'm going to show you a little quick tool that I like to use inside of Unity. It's a pay tool, so keep that in mind. Sometimes folks like some free features. The two tools that we're going to demo, I think you can get a trial of one of them. There's, again, many different ways to do this. You can do it manually. The problem that I found when I started game development, I don't endorse any of these particular products. They just happen to be things that I use. Because when I started doing development, I would find assets in the asset store that I would like. I would download them. And what I would find is that some of them really downloaded with really, really, really high poly count models. So, in fact, I was doing a game dev class, and this woman's like, oh, I got a shell from one of the third-party marketplaces for my game. And I looked at it, and it was like more than 50,000 vertices making up this little tiny shell. And I'm like, ooh, you have a couple of these in your scene, it's going to be really tough.
Yeah.
So, and that's the problem. Sometimes when you download these assets from the asset store, less on the asset store, because a lot of times you'll see the comments saying this is or is not good for mobile. But you get it from third-party marketplaces, and they're really nice models. And some of them are great for rendering scenes. You know, you might be doing an ad and you want these 3D scenes in your ad. That's different than running a game. In a game, you really want to optimize that.
And these are where you're going to use these decimator or retopology tools. There's two ways of doing it. You can use a decimator tool that's going to use an algorithm to kind of manually compute what it thinks it should look like if it were a lower res or lower topology. Whereas if you use a manual tool like Topogun, or I think there's a couple other tools out there that do the same thing, but that'll let you actually manually go in and create the cage yourself around your model, so you can actually specify where you want less detail and more detail shown. And that's great for character design and sometimes even terrain, which I'll show you.
Very cool. So switching over to my computer here, let's look at, we're going to do Cruncher on this guy. So I've got this kind of more high poly dinosaur here. I mean, look at all of those beautiful tries all over the place here. Tries everywhere. So you can come in here and specify a target quality, convert, and behind the scenes, see, now this is much more optimized here. Less tries making this up here. It's non-destructive. It will actually go into your base model, and you'll find that you get different versions of it created that have different different poly counts on it. Mm-hmm. So you can tweak this out a little bit, change them around, create different ones, experiment with the settings on here. Say, you know what, I do or don't like this particular. Maybe this is too much for me. In fact, I remember the zombie kid I was messing around with the other day, and I made took it way up, and he had like this little head that was this tiny little long cylinder. So you can actually go way, way overboard with this.
And sometimes you might not even, if you're doing low poly models from the start, like for example, our pumpkins and our zombie guy, they weren't exactly high res to begin with. They weren't a ton of tries. You might not even need to use these tools. These are specifically designed for when you have high res models, and then you actually want to reduce the poly count and make them more of low poly models.
Yes.
This is basically what that tool is intended for.
Look at this dinosaur, right? This was initially pretty, there were little tries all over this model. I just cranked these settings way down, and look at this guy now. This is probably pretty good for mobile. One might even say you could probably go down a little further, and you can see you get this nice blocky effect here, which you'll notice on a lot of mobile platforms, but generally it's a smaller screen, so you don't notice it as much.
And when you use tools like Topogun, if you notice what it did to his head, it kind of distorted his head a little bit in that model, and let's say you wanted to make that a lot more precise. That's when you use a tool like Topogun, where you could essentially retrace that head how you want to with less polys and get more of the look of the character that you're trying to do in more of a low poly look.
With that, why don't you show us a demo?
Okay, absolutely. So we're actually just going to use the terrain in Unity. Let's see. Do we have the terrain export tool in here? Let's see.
Want to show folks where they can get that?
Yeah, absolutely. So if you go online and just search for terrain export script for Unity, terrain OBJ exporter in the Unity community wiki, just look for this specific script. And it's going to give you two versions. It's going to give you the JavaScript and the C#. I always download the C# script. That's just the one that I always kind of use when I'm making my stuff. So you just want to download that script. And where is the download for that script here? Or actually, no, I think you just copy it and make a new script and paste it into there. So we'll just copy this script. And we're going to make a new script. We have to put into, do we have a scripts folder in here? Actually, we have to put it in editor. We're going to make a new script. We're going to edit this script. Yeah, just double click on it to edit. Have this load up. Can delete all this. Paste in our new script that we got. We want to call this terrain. There's a name for it that we have to use, which is exportterrain.cs. We'll save this.
Save that, rename it in Unity. Always good in Unity to make sure that your name of your objects, your classes, match the name that's inside of your editor. Sometimes you get some weird issues if you don't have it that way. And I think in this case, you can leave off the .cs on the end of that.
Oh, really?
I'm just kind of curious, did Unity take it off for you? Just out of,
yeah, it automatically does that.
Cool.
So I have my new script that I got down there. You see where you get it online. Just go to the Unity Community Wiki, look for Export Terrain. It gives me this new option at the top called Terrain right there, and that'll give me my export function. So we're just going to make a new scene here to demonstrate what we're trying to do. I'm going to create some Unity terrain. So we're going to go to our game object. Component. I forget, where's the terrain at?
Game objects. Now they moved under game objects.
Change it.
3D.
3D object. That's
They
right.
just reorganized these menus.
So we go to game object. We go to 3D object. We're going to go to terrain. Make our terrain. And this terrain's pretty substantial in size. So I'm just going to bring that down a little bit in my settings, which is over here in your terrain settings.
Click on the little gear icon there.
Click on the gear. 2000 by 2000 is huge.
Huge.
So I'm just going to bring that down to 200 by 200. And the max height we'll just put at 30. Maybe 60 for now.
Sounds good.
Go back in on our terrain. And then we'll use the terrain tools over here to kind of sculpt this terrain.
Okay.
And for the interest of time, I'm just going to do something really quickly here. We're going to get a brush, increase the brush size, go on here, and just start making some cool terrain, right? So we go through here, we make some terrain, maybe increase the opacity, do some bigger terrain, and we'll raise this higher, brush size, make the height a little higher than that. We'll do 30 on the height. Just go through and really start making these large mountains and different elements on here.
Pretty cool, just sculpting out some mountains on there.
Just sculpting out mountains and just kind of creating that terrain you want to create.
One of the few things that you can actually create 3D by default inside of Unity is the terrain. The terrain tools are pretty cool. As I mentioned early on, Unity is really not a modeling tool itself, not a 3D asset creation, with the exception of the terrain tools that are inside of there.
So I'm just kind of making this little area that we want that looks a little
cool. Very cool.
And just to show you some different, let's just make this down. We'll do some different height areas on here. All right.
That's pretty neat.
And that's always a good way if you're trying to make these kind of plateaus that you want your characters to jump down on and stuff. I always like to use the paint height tool, set the height, and then you can just kind of paint those heights. So you can have these multi-level areas that you want your characters to move on.
In other words, that just maxes out. You can't go any higher than a certain.
Exactly, and it'll even flatten it out for you too, which is great. So for here, I've got these different heights, and then I'm going to do another one that's maybe a little smaller. We'll do it at a 5, and maybe make it a little smaller so we can do like a crevice. We'll go through here, and we want this little kind of valley, right? And we want little areas in there that the character can kind of travel to and what have you. So we have this little kind of canyon that we've created right here. Now, when you use a decimator tool, there's things that can happen when you use that tool. One, let's say I want this very, very precise.
Because it's like an all or nothing tool, essentially?
Yeah, it's an all or nothing tool. It kind of encompasses your geometry, and it does an algorithm, and it just does it basically all at once, right? It's not very precise. It doesn't know that, you know what, I want the edge of my cliff right there, always, and it has to be that way, because I want, you know, when you use a decimator, it might actually round this out even a little more. It might even round these out so it's not flat in here. There's a lot of things that can happen that give you unwanted results, right? But if you're using it for geometry that's in the distance or other things, it's great, right? It's more, I'd say, distance-related stuff. It's a lot better for when you use these automatic tools. But let's say I wanted this exactly like it is, but right now there's just way too much geometry to get this to run on, let's say, a mobile device, right? And I want to really, really make it as good as it should be. What I would do is I would use a tool like TopoGun. And you'll notice a lot of big industry companies use TopoGun to do their characters, do high-res characters that you sculpt in a sculpting program like Mudbox or ZBrush. You can actually take that down into a program like TopoGun, get very close to the same result with like a third of the geometry, or maybe even a tenth of the geometry that you had before. You bake all that detail in. I always like to use it for characters, and then I found, you know what, I'm going to try it on geometry too. Like, how good would it be? And I found that it's actually really great to give me more of that custom, precise geometry that I want when I'm doing a game, which is really, really great instead of using these automatic tools. Because I noticed I would use automatic tools like T4M and other things, and while they're awesome tools, sometimes they would give me unwanted results. So for what we're doing right now, I'll just show it to you in TopoGun and how I use it in my workflow. Cool. Here's the geometry I made. Just really quickly, we kind of threw this together just to kind of show you what we're doing. And in here, I'm going to export this geometry using that script that we got. You're going to get this new option up here called terrain. That won't exist unless you have that script in editor. You're going to use that export terrain.cs tool. You're going to use that, go export to OBJ. And OBJ is a 3D file format that you can open in. One of the common formats, FBX, OBJ. Exactly. And you can open this. Once I export to OBJ, I can open it in Maya. I can open it everywhere. And it's going to give me the actual geometry I want. And it's going to give you two options in it, too. It's going to give you the option to export it as quads or the option to export as triangles. I'm going to export it as quads because most 3D model programs that you use, you can actually model in quads, and it makes it a little bit easier. Okay. Triangles becomes more of a headache. Even though Unity uses triangles, it's good to export this in quads so you have more of an editable model that you can use. I see. So you can also export it in a specific resolution, and it will degrade it for you when you do that. So we're going to export it in full resolution with quads. Let's export our model. We'll export it to our desktop. We'll just call it terrain for now. Export that OBJ. And then it's going to save out that OBJ for you. And it's a really, really great script that somebody wrote for this. This really, really helps out a ton. Highly recommend it.
Thank you, whoever wrote that script.
Exactly. Well, I think his name's on that Unity wiki. So if now that we have our terrain exported, we'll close Unity. Well, let me close some of this other stuff I have. We'll go into TopoGun, and this is TopoGun. And TopoGun you can get on topogun.com. They allow you to download a trial version, but you can't save out anything, which is, we won't be able to save this out, but I can kind of show you how to do it in TopoGun. So once we're in TopoGun, the controls are very, very similar to Unity and or Maya. If you use Maya, you use Alt to kind of navigate around and come in and out. You can use F to focus on things exactly the same way. You're going to want to set up a project, which we had already done. And then you're going to want to load in your reference object right here. So you click load reference. And then from there, we go to our desktop, we find that terrain object that we created, and we load that in. Then it brings in that terrain, and there's our terrain we exported from Unity.
Wow.
See it right there, right?
So it sees everything exported, okay, imported, okay. That's a good sign so far.
And what's great with TopoGun is you can have models that have millions of polys on it.
Millions.
And it doesn't necessarily it brings in like I guess a reference of the model. It's not actually bringing the model, so it runs extremely fast. You're not actually editing the model itself. It's just kind of using it as a guide. And then on here you have your toolbar in TopoGun, which are these tools right here. And this is just the tool that I use. There's tons of tools available. I've just found this to be the easiest. And what's great about this is you'll notice if I exported that OBJ and brought it into a program like Maya, I would have to kind of visually model along the side of that model, which is really hard, where this tool allows you to model and just create, it kind of sticks everything to the model. So as let's say I really wanted to get this valley kind of looking how I wanted to, I'm going to grab my simple create tool, which is right here, and I'll start just creating verts. And I can go along this model and just start kind of drawing out where I want these.
Kind of map out the lines.
Yeah, you're just making these verts as you go, these vertexes. And let's say, you wanted to save polys, you could do larger vertexes. And do these, really get in there and add these. And then you can move them around too, like that one's a little up. And what it's doing is it's actually modeling alongside my model. And you can see why this is really great for characters or terrains or whatever. And you just kind of go through here and do what you want to do. And then you can go up and just start going up the sides of these hills, just kind of tracing out how you want this to look. And what's great is you're manually doing this, so you have full control over what you want this to look like.
So by modeling out just a region there, what are you kind of saying? I mean, you're outlining it, but that's just going to be like one optimized region, so to say?
Yeah, and when you're done, it takes a long time to actually use this tool.
Yeah.
It's a very time-consuming process, but the result you're going to get is going to be really, really beneficial to your game. So as you can see right now, there's probably 1,000, maybe even more, maybe 10,000 polys that exist within just this region alone. I can go through here, and as I trace that out, I can just start making the sides of those the way I want and actually just start connecting these and really helping. What's great is, I'm just going to use the side of this mountain as a reference just to kind of show you how this tool works. But as I go through, and just use the simple create, you want to hold down Control. If you're using this tool and you've never used it before, you're just holding Control a lot, clicking the points and just clicking from point to point to point, going through.
So multi-select Control in a lot of programs is used for multi-select.
Exactly.
Same thing.
And as it does it, it creates. And then I look at that, and I can kind of look at that, and go, oh, okay, that's pretty good. Maybe it doesn't have some of the advantages of the roundness of the hill, but it's pretty close to what I'm looking for.
For mobile,
I saved
work great.
Mobile. It's fantastic for mobile. And I can come up here, and I can just kind of go in and start, adding in different elements that need to work for the geometry I'm trying to produce. And let's say we want the top. We wanted the character to be on top of here and just drop straight off and be more in line with what we were trying to produce. And same thing, you just kind of go in here and just kind of create those areas.
Fill that whole area in.
Fill it in. Yeah.
You always have to fill in the area?
Always have to fill in the areas, because it's essentially modeling a 3D model as you go and you do this. So you just want to be kind of diligent and get in there and fill in all these areas. And so basically, as you go around and you model these vertexes and everything around your entire model, it's basically creating this cage of your initial model that's super, super low poly, from what you had. And what's great too is if you're using things like vertex shaders, once you're done with this, it's got great tools to let you bake all that information into that low res model. So you can actually take all that high res data, like the shadows and the cavities and different things, build that into that low res model.
So it looks great.
And it looks great, and you can use different shaders and everything. So it's a really, really great tool in order to just create more of a low res version of a high res model. I'm just going to go through here, just like here's that pathway. You just kind of go through and then you can, use the bind tool here and just start going through and just creating these. And I use this all the time. Every day, I'd say I use this for custom terrain. You just get a better result than just a standard decimator. And that'll allow you too, if let's say you had a really high detailed portion of the map, right? But the rest of it was maybe kind of flat, and you wanted to have a nice seamless transition instead of just sticking that one high-res piece onto your model. You can, create these really low-res kind of areas with just a couple of tries, and then have a super high-res, like take a lot of detail and build that out right next to it. So just wanted to kind of touch on this. It's a really great tool to go through.
Once you build it out like that, what do you have to do then to use it? To
get it? So all you do is once you build the model out, and we won't build this entire thing, but it's just kind of an idea to show you how these tools work. It's just a really, really intuitive, just kind of easy tool. And the fact that it automatically kind of traces along your model as you go.
Very cool.
It's just awesome. Like I haven't seen anything that's as good as this. But really, once you're done and you have your model, let's say we've traced this entire map and it's exactly how we want, or even we only traced a portion of it and we didn't want all this stuff, right? We didn't want all this extra unusable terrain that's out here, and we wanted to just go along the edge, and we just kind of came through and just kind of did one of these around the edge and just cut this out, right? And we didn't want a messy cut like you do with just deleting a bunch of tries out of an OBJ, and we just wanted to kind of outline the edge of this map, right? You're just kind of going down here, and we're like, okay, that's good. We don't need all this extra distance stuff, right? You're like, that's perfect for my map. It's great. You can just model that, keep that all as one piece, and then when you're done, you just go to File, and on here they don't allow you. You just save your scene, put .obj as it, and it's going to tell you what folder you want to put it in, and you'll have that model. It won't put the reference with it. It'll just keep the actual model that you modeled in here. You'll have your OBJ. You can bring it into Unity or any 3D program.
Bring it back into Unity. And...
You can bring it into Maya. You can do a little more unwrapping on it, do some different things to it, bring it into Unity, do whatever you want. You've got a great usable piece of geometry to use, and it's exactly the way you want it. So just a really, really good tool if you're trying to optimize high-res characters and you want them to look exactly how your high-res characters look, but in more of a low-quality feel. Or it's great for terrain, too. Like here, you can go through, absolutely trace this entire terrain, make it exactly how you want with very, very little degradation and more custom to the type of feel and look you're trying to do with less geometry.
You mentioned the word kind of unwrapping inside of Maya. That's just a process of taking the mesh of your 3D model, flattening it out so you can kind of paint on that 2D surface.
So yeah, you basically UV unwrapping. Let's say you have custom things happening on your model where you've got caves and valleys and different areas that, if you were going to do a standard projection and unwrap, like you wouldn't be able to get into those. You can actually get in, separate those out into different UV shells, kind of be conscious of where the seams of those edges are going to meet up and stuff, but have more of a complete kind of model with perfect stretch. There won't be a lot of stretching, things like that happening.
That's one of the things I noticed in the terrain built into Unity, that when you do that, if I have mountains and I start painting textures on them, those textures get stretched way out.
Exactly. And so if you want to get rid of things like that, a good way to do it is trace the model in a program like Topogun or whichever 3D. There's a lot of topology programs that work. I just happen to use this because I think it's intuitive and very easy and very close to Unity as well. Once you're done with it, export the model, bring it into a program like Unity. Then you want to do your UV unwrapping in Unity, maybe in different shells, kind of be conscious of where the seams are going to be, where those UVs meet up, and then you have that texture map, then you can take that out, do more of the texturing in another program like Mudbox or ZBrush or whatever.
Very cool.
Export that, and maybe even use vertex shaders and different things to kind of blend it all together. So there's different ways you can do it. Yeah, but this is a really great tip on how to do that.
Great.
So.
Well, thank you very much. So this is hopefully an information pack. This is our longest session that we'll have of the entire series, but I think some of the most important information, so it's all very appropriate for what you're going to see.
Absolutely.
We're going to we'll be doing a 15-minute break. We're going to be coming back then after that with the next session. So stay tuned for some more exciting stuff today. Thank you very much.
Welcome back to Developing Games for Unity. I am David Crook. You can reach me on Twitter at DavidCrook1988. I'm a technical evangelist for Microsoft. I focus on gaming, cloud development operations. I'm huge on idea to delivery. Based out of Raleigh, North Carolina, ALM Ranger. I did development operations consulting at Fortune 100 companies. And you can see my contact information on the slide below. You can reach me at indiedevspot.com and also on Twitter at DavidCrook1988. And this is Dave Voiles again. You guys should be pretty familiar with him at this point. There we go. There's his slide.
So my second time back. I was here yesterday for a few of the courses, and now my first time back today, again with David Crook. So like David mentioned, we're going to be going over ALM, or Application Lifecycle Management. But Dave, you had mentioned before that you're an ALM ranger, which sounds way cooler than my last job, which was just simply an engineer. So why don't you take a minute and explain what an ALM ranger actually is?
So an ALM ranger, it's not really a job title. It's just occasionally we would do work on the side to produce documentation for how do you actually do branching and merging, how do you do source control, what is this TFS thing? So we'd find gaps in what's going on in the enterprise coding as far as process management and running actual source control, and we'd write the documentation for that.
Okay. So it sounds like you're the perfect person to kind of ask about this and have really a lot of hands-on experience for what we're about to go over.
About 3.5 years in the enterprise doing this, and it's just been a huge experience, and it's great to take that experience and apply it to video games.
Perfect.
So again, this is Module 7, ALM for Unity, and that's going to be exactly what we're talking about. Module overview, the first thing is, what is ALM? I've heard a lot of questions. Application lifecycle management. Oh, do you mean my game's paused? No, that is not what we're talking about. Second is, what is TFS? Project management, source control, and general development workflow.
Okay.
So the first thing is, what is ALM? There's a lot of things out there about what ALM actually is. There's release management, there's testing, your development process, version control, but at the end of the day, it's really project management. It's how do I build an application and how do I release that application? It's the whole end-to-end process.
So it looks like there are a lot of people consider it to be a lot of things, but really we're going to be very specific about what we're going to be covering today.
Yeah, we're going to cover the main key points, which will be version control, project management, and we're also going to talk about the actual development process and show some of the tools that I use in my day-to-day development on how we actually go about doing that.
Okay, so I guess project management could cover quite a few different things, right? But it seems to be similar regardless of what field you're working in. So why don't you go over what project management entails exactly?
Yeah, so before we get into project management, I want to talk about Team Foundation Server. This is what I use to manage my projects entirely. Team Foundation Server is the Microsoft suite for doing ALM and project management, source control. I like Visual Studio Online. I check everything into visualstudio.com. I don't always work with the same people, and when I do work with people, it's usually all over the place. I've got, well, you in Philadelphia. I was
both work
with.
remotely.
Yeah, so it's really great to use Visual Studio Online. People can get access to the tools everywhere. It's all about teams, project management, source control. There's builds, coded UI tests, just tons of stuff. So that's really the tool that I like to use for this. And project management. So what is project management? Why is this so important? Well, it really helps you with the high-level goals of what you're trying to achieve. What kind of game are we building? What are the features of that game? How do we break down those features into tasks? What are the timelines that we're trying to execute this on? I've got an entire workforce that's working on this. I've got artists, I've got coders, I've got maybe a puppet. I have a puppeteer. Yeah, I actually have.
Absolutely.
Yeah, so I got to see how they're actually executing against this plan and what our resource usage looks like. Are we actually using these people the way that we mean to, and are they performing their tasks on time?
Okay, so it sounds like a great way of just communicating and making sure that everyone on the team is on the same page, regardless of how large or small your team may be.
Exactly, yeah. I've worked on teams where a couple of our enterprise clients have over 2,000 developers, and organizing that many developers simultaneously is a bit of a challenge, and this is actually the tool that we use to do that. So at the beginning of project management, we usually do every day is a stand-up meeting. You know, you walk into a room and it's, what do we have to do? And we facilitate this with what's called the board. So we do our stand-up meetings, we work together, do our tasks, close them out, and go home. The board is the perfect place to do this. Over the past couple of days, I've started putting together a sample project to kind of show what this looks like, specifically for games. And we'll do a quick demo on what that actually looks like.
All right, so Eric's going to show us the board and what it looks like to visualize these communications.
So this is Visual Studio Online. This is the home page that you get. When I want to do anything that's work-specific, you have a little tab at the top that says Work. That's where you want to go to see what's going on with your work.
Okay.
So when I come over to work, you get backlogs, queries. I can see what my backlog items are, but you'll see this little note that says board. If I click on Sprint 1, this is the current iteration of work that we're doing, and I can see the backlog again specifically for what we're trying to do with this game during this sprint.
Okay, how would you define a sprint? Is a sprint like one day or several weeks?
So to really break it down, you've got a release which is formed of a couple of sprints, and those sprints are anywhere between 2 to 3 weeks long. I do a lot of side projects, so my sprints I try to keep 3 weeks long because I'm usually doing part-time work, maybe an hour or two a day, and trying to break into the industry can be really tough, so I always try to do about 3-week sprints for that.
Kind of pace yourself along the way.
Exactly, and that allows my team to have a fair amount of leeway, and if you can see, this is a really cool feature for looking at a typical sprint. You can see between 9.1 and 9.5, we did absolutely zero work.
Yeah.
So having those 3 weeks really helps you take a look at how you're doing and executing against your tasks and say, oh gosh, it's 9.5. I really need to execute some work. So it looks like on 9.5 we got a fair amount done, and we're back on track again.
Great way to track progress and make sure that, again, everyone's on the same page. We're constantly communicating. And so it doesn't just fall on the hands of one person. Instead, it's the entire team who's commonly looking at this board to make sure that they're all working on the same projects at the same time.
Exactly. And when we want to do these stand-up meetings, the first thing that we'll do is we'll all get together online. We'll use Link Online or Skype or some sort of tool like that.
Yeah.
And we'll pull up this board that you can see on my screen. And you can see that I've got a couple of backlog items. We got build the main character assets. We've got design the input. And then we actually have to go and build this input. And you can see we've got about 21 hours to do. The in progress is kind of scary right now. We don't have anything in progress, probably because we're out here recording.
Yeah.
And then on the done, you can see what we've completed in this sprint. So this first meeting will come in each day and we'll say, okay, what do you got to do? What's done? What's in progress? What's your status? Do you rely on anything that I've got going on?
Okay, basically dependencies.
Exactly. So one of these guys, RN, he's one of my friends that's working on this project with me. He's going to be doing a lot of the art assets. But we ended up having to reallocate drawing the main character, so he's going to be blocked on smooth move. So when we go and have these actual discussions, he's supposed to do the animation, but the main character hasn't been drawn. So these are the meetings where you discover those kinds of problems.
Right. This way you can kind of stop it before it becomes a problem, right? You can say, I've noticed you haven't worked on this in a couple of days, so should I be working on something else in the meantime? Exactly.
It helps you really tune your resource allocation. That's definitely very critical. So that's kind of the overview of what the board looks like. Let me get to the correct slide deck presentation here.
Okay. So, it sounds like this could save people a lot of trouble just by being organized with these projects, a lot of communication back and forth. And how do we get these board items on there? Are these things that you and I are both agreeing on at the same time, or?
So that's actually the next topic. So what we want to talk about next is actually putting items onto this board. We've got features, product backlog items, tasks, timelines, team capacity, burn down. We've said a lot of these words already, but let's start talking about what some of these actually are and put some of these in here. There's some new features. This is a brand new game that I'm working on, so there's a lot of features that need to be added. So, we're going to do all this live here. So let's start by talking about what is a feature. A feature could be, I've got a slow time component to my game. This particular game has a slow time. It's really, really buggy, so I haven't actually added it as a feature onto this game yet. And there's a lot of components that make up this slow time feature. There's graphical components, there's code components, there's management components. Those would all be product backlog items. So I could say that the time bar for, when we click the slow time button, that's going to start a timer and the bar is going to get smaller and smaller and smaller. Well, there's art assets and there's coding that goes into that. So the time bar would be the product backlog item. And the task itself would be somebody's got to draw the time bar, somebody's got to code the time bar, somebody's got to put the time bar into the game, and then they got to put it in all the levels. So that would be the actual individual tasks.
So a term I commonly hear for this is something like a story. How would you relate a story to a feature?
So a story would be like, as a user, I want to do whatever. As a user, I want to be able to slow time in my game. So I map features directly to stories, and then I break those stories down into product backlog items and tasks.
Perfect.
So to actually go about doing this, we're going to switch the screen back over to this board, and we're going to click on this little button here that says Features at the top. So when we click on this and we see all the features, we can see I've got a main character and I've got input for the game. This is kind of
pretty broad.
Yeah, pretty broad for the features.
Sounds like we have to break it down into smaller things at some point.
Exactly. So we're going to click on the backlog and make sure that you're on this backlog view. And you want this view here to show features. This will give you a little field right here under New, Type of Feature, and you can just go ahead and type a title. So we talked about slow time for our game, so we're just going to go ahead and say slow time. This is going to be our new feature. We're going to click Add.
Yep.
And it's going to show up automatically onto this little list down here. This shows us all the features in my game. So if I double click this, I can get more information about this. Who is actually going to be responsible for this feature?
Okay.
I don't like being responsible for things, so I'm going to give it to you.
Perfect.
Mr. Dave Voiles. And I think this needs to be completed. Remember, we were talking about releases and sprints?
Yes.
On the current iteration, you can see our project is Jack Round.
Okay.
We're in release 1 because this is a brand new project. We're going to push out our first release. We're actually in the initial sprint of this project. I think slow time is a big priority for us. We're going to put that as priority 1.
All right. Yeah, we don't want to fall behind at this point.
No, we're already pretty far behind from the looks of it.
Yeah.
So I'll go ahead and click Save. So that's going to have our feature in there, but it's not going to show up on our board yet. We need to actually make sure that this shows up on our board. And there's a little button here that says New Linked Work Item. So we talked about having these product backlog items that map to it. So I think we need to have a new product backlog item for the art assets for our game.
Okay.
So we click that little button. It says we're going to create a new child of feature. So link type child. And we're going to change this from task to product backlog item.
Okay.
And we're going to set this to art assets for slow time.
Okay.
And comment, we're going to need, well, we need a time bar. We need some cool filler and some animations.
So if we're going to tie this back to Unity, I guess you could say this is almost like having components attached to our game object.
Yeah, you could say that. This could be multiple game objects that need to get created. You could have multiple prefabs, the art assets.
Yeah.
I'd probably create a whole nother product backlog item for tying it all together. That might be a task, but bringing it into the game itself might warrant a whole product backlog item.
Okay.
So art assets for slow time. This probably won't be you. I don't really trust your art skills.
I'm a programmer. I wouldn't trust them either.
I'm going to give this to RN since he's our resident artist and animator.
Yeah.
So one of the really important things to tell him about this is when I assign a product backlog item to one of the people in my studio, I need to give them a little bit more of a description. They're going to end up being responsible for a lot of their own tasks, especially if it's going to the art department. I might just give an art asset assignment over to whoever's responsible for the art and let them break down the task. I have no idea what art assets are going to go into that.
Right.
I'm going to give them a direction. I'm going to say, make it disco-ish because it's a disco-type game. You know, we need a border. We need a filler. Some animations might be cool, and a few particle effects. And I'm just going to let that go off to them and let them come up with their concepts.
Yeah.
And they'll come back to me with some concepts, and we'll kind of break it out from there. And then our next day, we'll have a meeting about it or stand-up where we're talking about the board. And I'll say, yeah, we went through this, and we're going to allocate some more stuff.
It's a lot of communication, a lot of back and forth.
Exactly. So we'll go ahead and save that. And for a minute, I'm going to pretend that I'm RN. You know, I'm going to come and I'm going to look at this. And let's just close all of these out and go to our backlog items.
Okay.
And I'm going to see art assets for slow time. I'll be able to see this when I'm looking. I'll click on this and say, hey, that's new. What's going on here? Oh, this is assigned to me. I should probably do something with this. So he'll go ahead and click the new linked work item and start adding some tasks. So the first thing, I think this is really important, is just research and read.
Yeah.
That's going to be my number one. If I don't know what's really going on, I'm going to start assigning tasks to myself for research and read about it. He says, what is a disco? RN, I don't know if you know about him, but he doesn't speak English too well.
Okay.
And he'll come to me and say, what's a disco? And I have to explain to him, like, oh, you got the disco balls and the lights and the
music
and the grooving going on. Yeah, exactly.
Yeah. But I'm glad you decided to point out research and read, because I'm sure you've seen this before. People will often not allocate time to doing their research in the background, right? So you don't want your boss to think you're idle or you're not doing something, but in fact you are trying to get up to speed, make sure you are all on the same page.
Yeah. A lot of times what will happen when you're creating a project is that you'll just go in and you'll type out, oh, we just need particle effects and it needs to look like a disco. Yeah. And you say, well, what kind of particle effects? You know, how many particle effects?
Or you may not be familiar with the tool or the asset or the extension that you're using at that point.
Yeah. Would it make more sense to buy particle effects, perhaps? Maybe we should look to see what particle effects are out there. You know, that Cartoon FX2 out there was on sale for $5 the other day on the asset store.
Particle Playground, I use that pretty commonly.
Exactly.
So, you know, that's a very good point. You know, maybe our time is better spent researching better assets or tools to use instead of writing our own.
Exactly. So if we take a look back at my screen, what it'll do is probably say, well, that's going to be about 2 hours, and we're going to go ahead and save and close that. Notice that our iteration is still jack round, release 1, sprint 1. So when we close this out and we go take a look at the board and we click on sprint 1,
okay,
we'll go see that RN down here, he has build main character assets, there's design input, build input, but now we have art assets for slow time, research and read assigned to RN.
Okay.
So he can go and he can say, okay, well, we're going to mark that as in progress during our meeting.
Yep.
Once that's going to be completed, he's going to go and he's going to mark that as done.
Okay, and I see in the top right corner there, can you highlight that real quick where it says September 1st?
Our burn down.
Yes.
This is, so we talked about this a little bit more. When you create these tasks and these work items, they're going to go into this. So that 2 that we allocated, I have started doing actual hours. You can do pizzas, you can do shirt sizes. This actually operates off of a number. You can see that for the entire sprint, we have about 40 work hours allocated for this.
And our sprint is from the 1st on the bottom left corner there over to the 19th.
Exactly.
Correct?
So by the 19th, we should be done with this sprint.
Yes.
I also like to think of a sprint as an entire section, almost like a deliverable that I can showcase to whoever my managers are or whoever my
client or funding or something.
Exactly. If I got angel funding, I'm going to show them this. I'm going to say, look, we're perfectly on time.
Right.
And then they can go and dive in and look and see what's going on. It's a great visibility tool.
Especially for like building confidence for a team or a product itself.
Exactly. So that's going to be the burn down chart, and it's going to relate directly to what we have on the screen as far as the board and how many hours we have allocated. Something else that we'll do in these stand-up meetings is once he's marked this as done the day before, we'll go back in and say, okay, well, we did some research, we did some reading, and it turns out that you need to design some new input because, you know, your input mechanism is just not up to par with what we want to do. So I'm going to cancel this out real quick so we can see it. There's this little green button next to this product backlog item. You can click that from within your board and instantly add a new one. If you look at this links, its parent is going to be the design input. And Ruben could have come back and told me during this meeting saying, hey man, you really need to design some new input. We need a slow time button. We can't slow time if we don't have a button for slowing time.
So who's programming our inputs, right? We have to speak to that person as well.
Exactly. So we're going to go and say, you need to build button. And we'll probably say build slow time button.
Okay, be a little more descriptive.
Exactly. And I'll just say do work to build a button.
And this is just open to anybody at this point.
Yeah, so this one not assigned to anybody. This is usually my work area, so I'll go ahead and assign that to myself. We'll save and close that, and when I get back, probably next week, I'll go look at that and start building the slow time button.
Right, and I can see in the bottom right corner there of that actual item, it has the person who's actually assigned to.
Exactly. Great visibility for seeing who on your team is doing some work and who's not doing some work.
Okay.
Some other really good things to look at are this capacity. You know, a lot of times you'll go in and you'll start building this project and you've got this fantastic idea. You want to make like the next MMORPG. You want to have 50 swords and 20 variations of each sword. Yeah.
So I think we can make the next, World of Warcraft or MMO. What do you think?
I think we've got it. But hold on, let's type in our capacity per day. How much do you think you can work on this per day?
Pretty busy at this point, so I've got maybe an hour and a half at most.
You've got 1 hour per day. What kind of activities can you do this on? Can you do the deployments? Can you do the design, the development? Are you going to document it for us?
You know what? I'm not much of a writer, so maybe I'll just do the development. I like to.
We'll just do the development? Okay, so we'll mark you down for development. Okay, how many days off are you going to take next week?
Well, I'm a Monday through Friday guy, so yeah, let's do 5 days. I'll do 2 days off.
You'll do 2 days off. So we'll mark you for Thursday, and we'll mark you for Friday, too. Okay, so that means during the entire sprint, you can do 6 hours worth of work.
So I'm not making the next WoW.
Yeah, how you feeling about World of Warcraft these days?
Yeah, maybe I'm getting a little ambitious here.
Yeah, let's take a look. So Voiles I added into this project just for a showcase. You can take a look at our actual allocations of the 2 people on the team. I'm allocated at exactly 8 out of 8 hours for the rest of the sprint.
So you're kind of maxed out at this point.
I'm right on par with what I should be. My buddy Ruman, though, I guess he was thinking that we would build a nice big MMO for us. So
he's kind of picking up from my slack.
Yeah, 13 hours out of 4 hours available. I don't think he's getting that done anymore.
Yeah.
So, I think our next meeting on Monday, we're going to take a look at either hiring somebody else.
Or cut back a little bit.
Probably cut a few features. That might actually end up happening.
I like that it's color-coded in red on the right-hand side, too.
Yeah, this says, oh no, you've done something wrong. You need to go and look at your work allocation. So, like I say, in project management built into Visual Studio Online, absolutely fantastic for getting an idea of how much work you actually can do, as well as tracking that work.
Yeah. And like you said before, it scales very well because you're at Fortune 100 companies with 200 plus or 2,000 people on a team. We have a team now of just 4 people, and this tool is equally as practical then.
Exactly. It's exactly what we use in the enterprise, big projects, small projects. I do this for personal projects. There's a guy named Brian Harry. I don't know if you guys know him, but I was talking to him on email one day, and he said he runs his farm with this thing. So he's
not just for technology, then.
Not just for technology. You can manage just about anything. I mean, it's a great just project management tool that just happens to have a lot of really good software-specific features to it.
Okay, and this is built in or an added feature of BizSpark as well.
Yeah, so that tool is completely free to use also, so you just need a live ID. You go and log on with your live ID. If you're an enterprise customer, you can use your domain credentials as well. I know at Microsoft we have our own projects that we do, and I use my domain credentials to log into our own TFS. So,
as do I.
Yeah, it's and we do it on Visual Studio Online for some of these too. So I think we've covered quite a bit about project management. I think what a lot of people out there want to know, though, is source control.
Yeah.
What are we going to do about source control?
So what is source control? I hear this term all the time, especially used by programmers, and I'm just so confused by it.
Source control, well, I'll tell you one thing. It's not just making a zip file on a thumb drive and sharing it around the office.
So you're saying like my Dropbox or SkyDrive, those are not source control?
No, that is not source control. You can't right-click and view the history. You can't undo your changes. You can't branch. You can't merge. There's so many features that are just missing out of a solution like that that you're just missing out on a lot of stuff. And we'll go into some more on the whys as well. But it really boils down to, I'm going to make a change in my game. Maybe my character needs to have a sword instead of an axe. Axes are out, swords are in. It's time to really just do what did I say? Axes or swords? I don't know. Torches.
Yeah, well, that's the good thing about having source controls. We can just take a look at what we did before, go back, and view it there.
Exactly. So when we make that mistake, we need to go back and make him use a sword, an axe, whatever it was.
Okay.
We can just right-click and revert changes, and voila, it's back in.
So anything I did to break the game, I can just hit a button and it goes back to the working state again.
Yeah, and there will be a lot of times when I've been working on teams and somebody will check in some code that he didn't actually test. And yeah, it really breaks it. Or maybe they accidentally deleted a file, you know, maybe a app config file or some sort of certificate that we generated and we do all of our authentication off of, and it's really hard to generate that back again. So what do? Well, if you use Dropbox or you're just passing around a zip file, now you gotta go see who has it, maybe rebuild a hard drive like somebody out there I know. But if you had source control, you can just go view your history and bring it back out into your current version. So it's really important.
Yeah, you know, the way I kind of always looked at it was like those choose your own adventure books where you can choose to go this route or that route and it'll bring you down to another page. And I was one of those people who always kept my thumb on that last page, looked ahead, and realized I made a mistake, went down the wrong path. I just flip my page back and I'm back at the right route.
I never thought about it as a choose your own adventure, but it certainly can be an adventure if you don't use source control. Yes. What I say about source control is the rule number 1 of source control is use source control. Rule number 2 is to refer to rule number 1. And rule number 3 is to force everybody at your company to also refer to rule number 1. It is the most important thing that you can possibly do when developing software. Project management, definitely important, but if you lose your product, I mean, you're just...
Yeah, you're in trouble.
Yeah, you're in big trouble at that point.
Lost time, lost money, maybe an angry boss or some upset coworkers because they may be depending on you too.
Wouldn't know what to tell my investors if I lost the product.
Yeah.
So before we go into more about source control, I want to talk a little bit about some more Unity-specific things. Particularly, how do we integrate Unity with source control? There's 2 really important things to talk about, and this image will demonstrate that. It's visible meta files. These guys are important. The meta files can strike in all sorts of crazy ways. What it's going to do is it's going to split off the import settings or Unity-specific settings of your prefabs and your scenes and your textures and your assets and things like scaling them up or down from your import, not necessarily the source file, but the import of those assets. So on your disk and in source control, it will exist one way, but in Unity it will exist in a slightly different way based off of how you imported it. And splitting these meta files will allow those import settings to live side by side with those assets. So let's say that I had one developer who decided to change the source asset. He made it twice as big.
Yeah. And
then I had another developer who made it half as small from Unity.
All right.
Well, at the end of the day, it's going to be exactly the same size. So having these visible meta files will be really nice for merging things together. So if I modify a scene and somebody else modifies a scene, or we both modify import settings, we can go and we can see who did what, and it's not stored in the same file. Previously, it was in the library folder, I believe.
Okay.
Well, I have a page on that. I always have to refer to it anyways. You guys will probably have to do the same thing too. Here we go. So what do I check in? This is probably one of the most important lists that you can have if you're going to be doing source control.
Yeah.
At your root folder, you're going to have mostly auto-generated stuff, your CS proj files, other kinds of things that you just won't check in. You'll ignore your library folder if you split your meta files. That's going to be a local cache of your assets at this point.
Okay.
Your temp file folder is going to be all temporary stuff. The important things to check in are going to be your assets and your project settings. Your assets are going to be everything that's specific to your game. It's going to be your scenes. It's going to be your
art, your music.
Your code, yeah, exactly. And your project settings will be your physics and your input settings as well.
So right now it seems like it's all about keeping file size and clutter down to a manageable point.
Yeah, you want to keep all that down, but most importantly, what you check in, you want to make sure that it's something that somebody else on your team can go and they can pull the source control and they can use it. Or say that I'm doing work on my my laptop and it gets run over by a bus.
Okay.
I can go and I can pull that down and be back up and running from another box.
So it sounds like we want to keep it stored locally, but at the same time keep it stored off in a cloud somewhere too.
Yes. And that's kind of where we're going to get to the couple of different options, and this can get into a huge debate.
This is like very much a holy war of
Oh yes, this is the holy war of version control. It's Git versus TFS, and we kind of chose us two to do this presentation because I'm very much a TFS version control. I love centralized control. I think it's easier to understand. They're both fully supported in Visual Studio, but it's really that easy to understand for me that I like. I like the branching model. Yep. I like that it lives in one place on the cloud and it isn't, nobody else can mess with it. It's just there and I can control the permissions the way that I like. Yep. And it's just familiar for me.
So it's basically like the large entire project is kept together in one spot.
Yeah, so I'm not very good with the whole Git thing. I tried to look at it once, and it just confused me beyond all belief. So I'm going to kind of defer this portion of the conversation to our resident expert over here.
Sure. So Git is an alternative means of source control. It really started growing popularity in the last couple of years with something like GitHub, where people can publicly host and share their files. So the idea behind Git is that you don't need to check out the entire project, but instead just different parts. And along the way, you can add small specific features. So if we're working on our game, I can then make a copy of this project and branch off of my main tree, and I might add a feature like new inputs, so alternative controls for maybe connect. And this way I can make all the changes I want without ever affecting anything in the center, so you guys can continue to build your project, and it works just the same. Then once we've all tested it and make sure it's working okay, I can then send a message back to you to say, hey, this works, I've tried it out, so why don't you push this back into your main project? And it's doing a merge, we'll call it.
Exactly. And in Team Foundation Server version control, what you'll do, if you want to create a feature branch and you have something that you want other people to kind of look at that's separate from the main workflow, you can create a branch, but that branch will live on a central location. So everybody will be working off of the same one. You don't have this idea of a distributed version control like Git is. Git is going to be everybody has their own version of the repository, a full version, but you'll also have a master location.
Yes.
And that's the part that confuses me. I'm not very good with that portion, but you know, it turns into that battle, and we could duke it out forever. But just know that with Team Foundation Server, it's Team Foundation Server, not TFS version control, not Git version control, but you have those two options. They're both fully supported from the UI, and you get a GUI, so you don't have to use the command line tool. So if you liked Git, Team Foundation Server now has some really good tools for you to use from within the GUI. And I believe we'll take a look at that in a little bit. So, you know, one of the next questions that we get is, okay, I've got Team Foundation Server. I've picked my project type. I've picked my version control strategy. Now I need to actually connect to it, and I need to do my actual check-in. So the first thing you really need is you need to go to visualstudio.com. You get for free, you can have up to 5 people using it. And you can kind of rotate who's using it. So as I have people come on and off of my game development projects, I'll remove their permissions and then I'll give it to somebody else. So sometimes, you know, you bring on somebody and they're not really doing anything, and then you can have take away their permissions and allocate that to somebody else. Then you're going to need to download Visual Studio. You can either get Express free or Pro trial. You can get the trial or you can pay. And here's the link for you. We'll make these slides available. I'm not sure when. And then inside of Visual Studio, you'll go to Team, Connect to Team Foundation Server. And then you'll enter the visualstudio.com project URL. And we're going to go ahead and do a quick demo of what version control looks like. So The first thing we're going to take a look at while doing this is the project structure in Unity that we alluded to earlier.
Okay.
So you can see we have these assets, these build process templates. This is something that TFS version control is going to bring into. I am not zooming the way I had wanted to. There we go. Okay, so we've got the assets. The build process templates is something that Team Foundation server is going to bring into. We're not really going to talk about that a lot today. The library folder, the project settings folder, this TF ignore is pretty essential. This is something that you can use to ignore files. So if we, let's actually take a look at this. We can open this in Notepad.
Yeah, it essentially looks like a text file.
Yeah, it's basically a text file, and it's going to tell you, here's some of the files that I've decided to ignore.
Yep.
So you can see I'm ignoring the temp folder, I'm ignoring the library folder. At the root level, I'm ignoring pretty much every CS proj file, I'm ignoring the solution files. These are all things that are going to get auto-generated. If I check these in, and Mr. Voiles over here decides to pull down the code, he's going to get a lot of stuff that's specific to me and my workflow and my environment. I want him to be able to auto-generate that stuff himself.
Right, because often Unity and Visual Studio will optimize the game based on the specific platform that you're playing it on at that point.
Yeah, but it's going to be more around what kinds of builds I've done. Am I using Unity VS? Have I done specific settings into my Visual Studio? Am I using the light theme? Am I using the dark theme?
Right, preferences.
How did I split my windows up in Unity? I don't really want to force those settings onto Voiles because he has his own workflow.
Yes.
So those are really important things.
And then Git operates the same way with their git ignore file.
Yes, so Git has the same kind of thing. It's instead of tf-ignore, I believe it's .gitignore or git.ignore or something along those lines. You'll be able to see it in your project structure if you use that. I believe they use a very similar format.
Yep.
So if we take a look at my screen again, you can see what we have actually checked in. We have the assets, the build process templates, which we're not really going to talk about today, and the project settings. So if we expand the assets, you can see I've got audio, I've got editor, which is plugin type stuff. Rise of the Dough is a completely another project. But these are going to be the kinds of things that I check in. And when we connect to the team project, you want to go to Team, this little Team button up here, and go to Connect to Team Foundation Server.
When you pop up on the right-hand side there.
Exactly. So you'll get what's called the Team Explorer. If you're using Visual Studio Express, this is kind of your main living point for doing any of your version control. When you come into this fresh, you won't have already connected. You'll see this little plug button. It says Connect to Team Projects. You can click that, or you can do Select Team Projects. If you click Select Team Projects, right now I'm connected to it already, and I have it in here. If you don't have this, you click Servers, and you can select Add. So what it's going to be is the name of your instance that you did. Mine is Gero, Gero.visualstudio.com. So you'll type whatever the name of your project is, or your project collection, .visualstudio.com. And once you add that, you can get access to it, and you can see I've got my Impact, Day of Unity stuff, Project Gero, Jack Round, and some stuff that I just test on. And we're working on Project Jack Round, so I click the checkbox, I click Connect. We're already connected to it. And once I do that, I can click this here and add items to folder. This is going to be the important part. If you're doing an initial check-in, you'll do add items to folder.
Okay.
And you'll go and find the different items to folder. It'll show you everything that's in that folder as it is. You can do your assets, and then you're going to do your project settings, and you're going to ignore everything else. And then you'll do your initial check-in.
So this is, you're now taking everything that's stored locally on your machine and you're pushing it to the cloud so that someone else can grab it at a later time.
Exactly. And actually to demonstrate this, we put, I've already checked it in, and we deleted everything off of Mr. Dave Voiles' box. So what we want to do is show the actual pulling of that and show the project actually running on that box. And we haven't really tested this too well, so we're kind of crossing our fingers that it works out live. So let's flip over to Mr. Voiles and see how it goes. Do you want to do a pull for us?
Sure. Right now, we can see I'm in Visual Studio. I have my Team Explorer over here on the right-hand side. And you can see I have Jiro.visualstudio.com, and I'm currently connected to the Jack Round project.
One thing to also note is if you look at his local path, right now we've mapped it at least. It'll say not mapped if you haven't mapped it before. You click on that link and you select the folder that you want to map the project to locally. Pathing in Windows limits to 254 characters, so I like to put things at C:\project, something very simple and very short.
Right. So right here we have local path, like Dave mentioned, currently mapped. But if I go to that folder itself, I can open it up and I can see there's nothing in there at this point. However, I can look online and I see at our source repo, I have an assets folder, build process, project settings. So what I'm going to do is I'm going to take all of these things, which I can see he last put in on the 25th, and I'm then going to pull them down and push them in, put them in my folder. So right here, I right-click on Jack Round, and then Get Latest Version. It's going to pull down any changes, and you're going to see it update right here. So it's downloading everything, and I can see.
Yeah, let's switch over to the File Explorer and see how that's looking.
So let's see how this File Explorer looks.
And it's starting to pull down all the assets, project process templates, and even the tf-ignore file. That's a really good one to make sure it's checked in. It gets checked in automatically, but if you notice that that's not getting checked in, that's something that needs to make sure that you're there so other people aren't checking in garbage.
Right. So from here, I can take the project he has just worked on, go to Scenes, Level 1. It's going to load up Unity.
And what it's doing now is it's building the local cache of those assets in accordance to the meta files. So that could take some time. This is a fairly small 2D platformer project that we built, really, really quickly. So it should load everything, well, pretty quickly.
And you can see how I took that whole project that was on his machine. He then pushed it to the cloud. I can press play. And here we go. We have our project.
Yeah, let's maximize that. And to talk about some of the things for Mr. Matthew, just do it. This is all paint.net. Made sure I just did something that was really simple. It's really buggy, but if you have a poor art style and it's all kind of together collectively, it can actually look kind of good and kind of mobile-ish.
And look, there's that slow button we were talking about before in effect. I can unslow and then slow.
Yep, so I did implement that, I guess. So I should probably log that in my features.
Yeah. So it shows you how easy it is for David to save a project, push it to the cloud, and then I can pull then any changes that he immediately makes right there.
Exactly. So now we've talked about doing project management. We've talked about source control. I think one of the next more important things to talk about is going to be workflow. This is huge. You want to make sure that your teams are doing things in a way that makes sense, that they're not stepping on each other's toes. And how do you actually go about doing that? And some of these are going to be Unity specific. Some of these can be applied across the board to different organizations. If you're building software, you need to follow some sort of process management and workflow when you're actually developing your product. So for Unity specifically, we want to look at my slide deck and say, be wary of the binary assets. So there's something that you can do to make sure that they're not necessarily binary. You can go to that same setting where we set the meta files to be visible. You can force text on them. That will allow them to be mergeable, but it's still very, very difficult. So sometimes it's nice to force binary just so that somebody, when they try and check it in, they see the conflict and they're like, oh God, I should never do that again.
Right.
So scenes, prefabs, those are some of the things that you do that for. When you actually do work, you want to pull your changes first. You're going to want to do work. Then I like to pull my changes again, merge the conflicts, test, and check in. So if I'm working on a file, chances are that somebody else on the team might be working on the same file. They might be working on the same scene.
Right.
Maybe we're trying to test out the axe versus the sword. So Dave opens up a scene level 1, and I open up level 1, and we decide I'm going to give the character a sword, and Voiles gives the character an axe. So I pull in all the changes, I do some work, and Voiles does some work too. Let's say Voiles is a lot faster at doing work than I am. So he goes ahead, he pulls changes, sees nothing wrong has happened. He merges any of the conflicts, there weren't any, tests it, works great, checks it in.
Perfect.
So I'm, however, at this second portion where I'm doing work. So I've done work, I've done stuff with a sword instead of an axe, and I pull changes again, and I get a lot of conflicts. I get scene conflicts, I get code conflicts.
Yeah.
You know, maybe we had an interface for what a weapon actually is. And during Dave's testing, he found out that, hey, we need to change this interface because we need to make sure that all weapons have handles. You know, all weapons have handles. And maybe all weapons can be thrown too. So, yeah, you got to have throwable weapons.
Yeah, absolutely.
So when I pull those changes, I didn't think all weapons should be thrown. So I see in this list of changes that Dave said, oh, all weapons should be thrown. So I merge those conflicts, and when I test, I find out that my sword doesn't actually implement that interface. So if I checked that in, I would break everybody's build across the entire team. So yeah, you can't break the build. We have alarms that go off in some of our teams where if you break the build, everybody's coming down to your office and putting funny cardboard cutouts.
Looks like you're buying dinner tonight.
Exactly. So you need to make sure you test after merging those conflicts. I can't stress enough. People get really angry about when you break the build, and rightly so. That can really mess up a lot of things for other people. You have a huge code base. You mess up one thing and the code doesn't compile. All of a sudden, your team can't do work. So if you're working in a global environment and I'm checking out at 5 o'clock, I check in my code, I go home and I'm taking care of the kids, I'm eating dinner, I'm doing whatever I do during my home life, and my global team in a different time zone comes in the morning to do more work, then the code's broken. What are they going to do? They have to wait for me to come back the next day. That's an entire day lost, a code break, or they have to go and analyze that code themselves. And you can have the same issue with assets. So definitely pull changes, do work, pull changes again, merge conflicts, test, check in. The reason I like to do pull changes again, just like I said, is you never know what happened in the middle of doing work. You could infinitely pull changes, but merging conflicts takes a lot less time than doing work. So that's kind of why I like to pull changes, do work, pull changes again, merge conflicts, test, check in. I'm going to say that a lot.
Yeah. Almost want to print it out and put it on our board as we're working.
Exactly. Conflict resolution. So we kind of talked about this a little bit. We'll throw the slide up. Binary assets cannot be resolved cleanly. It's not a text file. It's a bunch of bits, and your merge tools don't know what to do with this. You know, and it says, I don't know what this means versus this. But if it's serialized in a XML type format or a text format, then all of a sudden you have something where you can take a look at it. So in scenes, the order of your objects in a scene doesn't necessarily matter. So you can take a look at it with a merge tool, and you can see, oh, Voiles just added an axe, and I just added a sword, and they're both not marked active. So we can say, okay, it's fair enough to keep both those objects in there attached to the character. That's perfectly happy. So we're fine to go ahead and merge that. The meta files, if you don't split those off, you're going to have issues in your library folder. So make sure that you split those off. We can take a look at it and we can see that, oh, we both modified the import settings. You know, Foil said 75%, I said 50%. Well, now we can go and have a meeting during our stand-up, take a look at the board and say, hey, we really need to mark this at 60%. And then we can also talk about, should we modify the source asset or should we modify the import settings? What's the advantages and disadvantages of doing it either way? So really important stuff to make sure you split that off. So having these things serializable opens the opportunity for more discussion with your project.
Okay.
So again, the meta file, I mean, I can't stress this enough. This really should be mandatory to split this guy off. You know, let's assume asset 1, we just talked about this. Asset 1, source doubled in size by person 1, asset 1 halved inside, merge conflict in library. If you take the meta file from person 1, the asset is doubled in size. If you take it from person 2, asset remains the same size.
Okay.
So, one thing to be aware of. And metafile strikes again, number 2. So scene 1 created by person 1, scene 2 modifications by person 2. If you don't split the metafile off, all of those are going to be stored in the same file in your library, and it's going to all be binary. You have no idea what you're actually doing. So you need to make sure you split those off so this doesn't happen to you. I was working on a 48-hour game jam, and one of my guys was building the title scene, and I was working on level 1. It was actually this project. This came out of a game jam. And, in 48 hours, you're not thinking, I need to split the metafiles off. And we didn't. So what happened was at the end of the game jam, we went to merge our stuff together. And we broke the entire project, and we didn't make our entry on time. So, lesson learned again, even on small 48-hour events where you're just trying to crank stuff out, I can't stress how important that is. The other important thing, excluded changes. You're going to go and you're going to add a bunch of stuff, and it's not going to get picked up like you do on normal projects. You're not adding it to the project file. TFS works really well with standard .NET C# type projects, so it checks that .cs proj file. So you're going to see at the bottom when you perform a check-in that there might be detected 1,265 adds and 2 deletes. I'm pretty sure you can imagine what would happen to the project if I forgot to add those 1,265 adds. Somebody's not going to get whatever plugin I just installed. That looks pretty familiar of a plugin. You check in plugins, you're going to get a lot of adds and maybe a few deletes to tweak some things. So make sure that you go through those adds and you ignore the files that you need to ignore, and you can do all that straight from there. So you can right-click the file that needs to be ignored and ignore it. And then again, here's the plugin I checked in, Smooth Moves. We decided instead of rolling our own animation system, we'll buy one this time.
Okay.
So it doesn't check in DLLs automatically. So you'll have to go and manually add those like we did with the initial check-in. So if you forget to do that, somebody's going to download the code, and that's not going to be there. So make sure you go through and look for any sort of binaries that get added to your project, especially from plugins from the asset store. And that's about all I've got for this. We're a little over time, sorry about that. But we're going to take a meal break and be back in an hour. I really hope you enjoyed this section on ALM, there we go. Yeah, I kind of got brain dead there for a minute.
You can tell it's lunchtime already.
It's lunchtime. I need to get some coffee and some food, so I really hope you guys enjoyed it. Again, I'm David Crook. You can follow me at David Crook 1988 on Twitter. And again, this is Voiles.
I'm Dave Voiles. You can find me on Dave Voiles on Twitter. My name is my Twitter handle.
And thanks.
We'll see you in an hour.
Hello and welcome back to Module 8, Monetization and Marketing. Now it's time to learn how to actually make some money with those apps. I'm Tobiah Marks again, and with me today is Jason Fox. If you didn't catch yesterday, I am a game evangelist at Microsoft. I've been working here for about a year now. Before that, I ran my own indie companies for 4+ years, making mobile games on all platforms.
Yeah, and once again, I'm Jason Fox. I'm a technical evangelist at Microsoft. I focus on gaming, cloud, and client. I've got 13 years of industry experience doing games, data visualization, graphics, DirectX, and you can find me on Twitter, Jason G. Fox, or follow me on my blog, jasongfox.com.
Very cool. So now we actually want to know how you're going to make some money with games. It was coming up yesterday a lot in the chat. People say, how do I make money with this?
Yeah.
So let's go over what we're going to talk about. We're going to say, okay, what is an indie exactly, and how are those indies making money? We're going to go over App Store optimization, which is, if you don't know that term, you will know it by the end of this talk. That's my main goal, so we're going to cover that a lot. And we're going to talk about apps as a service industry and exactly what that means. So first off, how are indies doing it? What exactly is an indie anyway? People were asking about that in the chat before. Indie is independent developer. That means that you don't have any publisher behind you. You really don't have any safety net. You make a game, and if it fails, it was your money. You know, if you're a big AAA studio, you have some funding, you have some investors. If the game's not popular, you might not get hired for a second time, but you're still getting your original paycheck. Indies are kind of out there by themselves. That's a broad term. It could mean a hobbyist, someone who's working, you know, 1 or 2 man devs in their home. It could mean a small team, 20 people, self-funding, and everywhere in between. But that's okay, because these indies, they're able to do it. They're competing with big apps on the store today. This isn't just, you know, small side projects people are doing in their own time, you know, getting a couple little, you know, extra pocket change. These are -- apps are indie made.
The way I define it is just somebody who is not contracted with a publisher to build a game.
Yeah, absolutely.
Right.
Publishers
and that's a huge scope of possibilities.
Mm-hmm. So these self-published games, these small studios, sometimes as small as one person or, you know, even just 2 people, are reaching the #1 slots in stores. They're making serious money, and they're competing with the big guys. They're competing with the AAA studios. They're not just competing relatively well. They're doing better than these guys that have sometimes $1 million budgets behind their game. So is it just luck?
What are some of these games? Can we...
Oh, I mean, like Threes is probably one I've been playing a lot lately. That's been super popular.
Angry Birds was an indie game.
Absolutely.
Right?
Minecraft is probably one of the biggest notable successes of all time, practically.
Yeah. Flappy Bird.
Yes, definitely.
For what that's worth. Yep.
You know, this isn't just, as I said, not, you know, 1 or 2 apps every now and then. It's very common to see indie apps top the charts. So those apps succeed not because, well, a bunch of apps release and somebody rolls the dice and they are lucky enough to be selected. There's a science behind which apps make it to the top of the stores, which apps make money, and which apps don't. Too many developers I see talk about, well, it's just luck. I made a game, this guy made a game, that guy's successful, I wasn't. It must have just been luck, right? Well, there's a reason why they stand out, and you can't just clone to succeed. Too many people say, well, Flappy Bird was successful, well, Angry Birds is successful, I'll just make a game like that, release it. Why wasn't mine successful? Well, that's already been done. It's already been seen. It's already been shown. You have to stand out. You have to be unique. If you search the store right now, you're going to find so many different Flappy Bird clones, or what's that helicopter game he just came out with? He came back after. It's already been cloned
I think
like
there were
a dozen times at this point.
I think they cloned it before he even published it.
Yeah, exactly. So what we're talking about here is not about, okay, we're going to do marketing. Here's where you have to spend money. Here's where you buy ads to market. There's all these traditional marketing ways that just involve dollar spends. We're not saying, here's how to spend money on your app. We're talking about marketing with zero budget. We're talking about marketing with nothing and having similar levels of success to games that have those big advertising budgets. So how do you do that? #1 way, App Store optimization. Have you heard about this, Jason?
I have. Through several of your talks, actually.
Most developers I talk to, when they're first getting into the industry, they don't really pay attention to this. So App Store optimization means your presence in the App Store. Now, whatever I say App Store, I mean any App Store. This could be the Windows Store, it could be the Windows Phone Store, it could be the Xbox page, whatever gateway they have to get to your app. In a digital distribution age, no matter where they find out about your app, if they get recommended from a friend, if you're the #1 in the charts, they just find you through search, they're always going to be funneled through this page. And that page will have your icon, your screenshots, and your description.
Now, do I need to optimize the same way for every store? Do the same general principles apply?
The same general principles apply. There might be some keywords that work better in one store versus another.
Okay.
But really, once you start thinking about this stuff, you're going to have a leg up on your competition in a big way. There's so many games out there that these developers will spend sometimes years of their lives working on it, perfecting it, making it better. And then when it comes to release, they have the intern write up a description in a day. They look at it, okay, that seems fine. Or, for example, the icon. They'll take an icon, they'll make a really nice looking icon, they'll show it to their artist friends, they'll maybe show it to some focus groups, and they'll say, this looks great, and then they ship it. But it looks generic compared to other ones in the store. It's not a gaming example, but I like to use a to-do list as an example when I talk about this. So many to-do list apps out there have a checkbox for an icon.
So we're going to publish Zombie Pumpkin Slayer to the store. Mm-hmm. We need to have a really great icon.
Yeah, something like that, right? Yeah, but no, exactly. It needs to pop. So let's use instead of my to-do list, let's use a zombie one. It's a great example. There's so many zombie games out there. If you have your zombie app as a picture of a zombie, and it might be a good-looking zombie, but if it's not going to stand out against all the other zombie apps, if I'm not going to look at a screen of not just your icon, but 50 other icons, and yours doesn't pop out at me, I'm not going to click it. I'm not going to be interested in it. It has to have that 10-foot test where I look at it from 10 feet away for half a second and know that is a good icon. That is interesting. That is cool.
Cool. Great.
Next is your screenshots. I have up here on the slide an example of Temple Run, which is a really great game. Most of you guys out there probably have played it. But even if you haven't, you can look at this screenshot and you know exactly what's going on in the game. It has a guy running. There's coins in a straight line. I can see there's room to the left and right where I can go and collect them. There's some enemies behind me chasing me. And it says swipe to turn, jump, and slide. Now, it's not giving me full instructions. It's not saying swipe up to jump and down to slide. I'm just getting the general idea. I can hold this in my hand if this were a phone. I can see my thumb moving back and forth. I know how this game feels. I know how it plays.
Yeah, that's a lot of information in that one screenshot to show you what that game's about and how you can have fun with it.
I mean, look at the water texture there, too. That's not a really good water texture, actually. That's kind of not the best, most pretty screenshot they could have picked. They could have very easily done this pre-rendered scene with the guy running into a temple, like Indiana Jones style, trying to grab his hat as he was sliding under a door. But they didn't. They used an actual screenshot from the game to show what the game's going to be like. Because if they had used that cooler screenshot, maybe some other people would have downloaded the game. But then they would have been not what they expected. Because they didn't know what to expect. Was it a third-person adventure game? You know, how does it play? And if it's not what they expected, it's not what they wanted, they'll uninstall it, or even worse, rate it badly. And that's going to hurt you in the App Store rankings. It's going to hurt you in the charts. It's going to hurt your monetization. So it's better that the only people who actually download your game are people who are actually going to be really engaged and want to play it. So you need to be as honest as possible. Even if honesty is not as pretty as you can make it, honest is more important.
Should I put a screenshot of my game menu?
No, really. I don't see why a menu is that important. Unless your game is about menus, you're some type of baseball management sim, you really don't need that menu. You need an example of what the gameplay is, and it's clear and concise in one image. Again, the Temple Run is a great example because it has all of the different elements of the game, and I know the nature of the game. I even implicitly know the goal of the game just in that one screenshot. And the more you can make it clear, and ideally in that first screenshot, the better chance you're going to get that the person who downloads it is someone who's going to be a player who will monetize well, who will stick the game, who will like it, or even just download it in the first place just because they know what it is. Last thing I want to talk about is the words, the description. Again, people just ignore this. They think, okay, this is a cool game. It's got 30 levels. It's awesome. Well, 30 levels doesn't mean anything to me. Does that mean I'm going to play it in 30 minutes? Does it mean it's going to take me 5 years to be able to master? You have to have a little more context here. You have to have a little more call to action as why your game stands out as unique, why it's better. But also it's got to have keywords because the first people who are going to read it are not humans. We'll talk more about that in the next slide.
Should I take the full write-up description of my game from my game design document and just paste it into my description? Is that a good idea?
Wordy is never a good thing. If your game design document is the one-page game design document, I've been to a lot of talks at GDC lately where they pitch, instead of having these big 500-page Bibles, if you can pitch your game in 1 page or less, okay, maybe then you can copy some of that in. But again, you have to think about the keyword optimization. That brings me to my point. Optimizing for search. How will they find you?
So like in Zombie Pumpkin Slayer, you just run around and you just slay pumpkins. Should I just put that in the description?
No, because there's so many games about zombies. Like you want to talk about zombies and pumpkins and all those things, right? But you have to have keywords of what the game actually is. Because remember I said, the first people to read the game is not a human. It's going to be a robot. It's going to be a search engine. Just like your Google, your Bing, whatever search engine you're using, they read the web first, and then when I'm on the store and I'm like, I want a zombie game, I'm going to search zombies smashing, or I'm going to search pumpkin kids game. And I'm going to find different keywords. And based on the search algorithm, whatever that may happen to be, whatever the magic sauce they use, they're going to figure out which games go up in that chart. And the higher you are in that search result, the more natural downloads you're going to get. So this isn't something that you can guess. This isn't something that you can write and in a vacuum say, this is good keywords. You have to do your research. You have to actually go to the store, look at other zombie games, look at other pumpkin games, look at other games in the type of category that you're in, and figure out, well, does this game stand out? What keywords are they using? What is the game that doesn't stand out? Rank 100, what words are they using? How frequently would they use a phrase like endless runner in a description? You know, did you use it once? Did you use it 3 times, emphasizing it? Well, when you submit to the store, you can submit certain keywords. Say you're doing some kind of trivia game. You can submit trivia or family, or you could submit family trivia. So if I'm searching for family trivia, the person who has those 2 words together in their key phrase, they're going to go up the charts higher. But if you search for family, they'll still appear if you only have the family trivia keyword, not quite as high. So you have to figure out what's important for your game. What keywords are most likely what people will be searching for to find it. Not the name of the game necessarily, but someone randomly searching on the store.
Right. So if I make a Flappy Bird clone, should I just put Flappy Bird in there, even though it's maybe something else, Flappy or some other?
Well, most app stores are kind of against the idea of you using another game's name in the title. So I would advise against that, but I would look at Flappy Bird. I would look at your competitions and look at how they describe their game and try to describe your game similarly. Because if how people are finding Flappy Bird, if they don't necessarily remember the name Flappy Bird, or just simply if they're searching for it, if you have similar keywords, you will appear in similar search results. Now, this isn't permission to copy and paste. I'm not saying to, spam as many keywords as possible. Anyone have like a WordPress blog out there and it just gets comment spam after comment spam of, 500 lines? A human is going to read this eventually. So you have to still be short, you have to still be punchy, you have to still have a call to action, but you have to also keep in mind these keywords and balance both of those when you're writing your description.
Great.
Next, let's talk about outmaneuvering your competition, which is really my fancy way of saying optimizing for your rank. Now, this part's kind of obvious, right? Like everyone wants to be a #1 app, but how exactly do you get to be #1? First, let's talk about how rank is determined. It could possibly, maybe, could be by some of these elements determined by downloads. Everyone knows that, right? Number of downloads is good, but that's not the only way it could be judged. Could be judged by the active installs. That's how many people currently have it on a device at any given moment in time. It could be judged by the velocity. That's how many downloads you're getting over a certain amount of time, a week, a day, whatever that happens to be. It could be the ratings, both the number of ratings and the quality of those ratings. I have a lot of different ratings, or I have a few very good ratings. And the usage. Doesn't help it if people have it on your phone and never use it, never open it, versus people who open the app every single day. That could go up the charts. Now, why did I say kinda, sorta, maybe? I don't actually know how the ranks are determined.
So the stores don't publish what their algorithm is for determining rank.
No,
I've never seen this before.
No, that would be
you just have to
silly.
Try to guess, right?
In fact, they actually change it up often just to try and keep people on their toes. It's as if, imagine if Bean released a press release and said, this is how we determine what the #1 website is. Every single website's just going to optimize for those specific things that they're searching for and just try and cheat the system to get #1. They try to make this a moving target so people can't cheat the system, so they can make the best game possible and have to optimize for all those different metrics in order to actually get up the charts. Because ideally, you shouldn't say, well, active installs is the only thing that matters. I can ignore every other metric as long as I have a good amount of active installs. That's not really good for the store. It's not good for the players. They have to change it up.
So help me out here, because my team, we're getting ready to publish Zombie Pumpkin Slayers to the store, and we want to maximize downloads. We want to have the most active installs. That's what you're telling me. So how do we do this? What are some good ways of doing this?
Well, there's always brute force. it has been, it's a tried and true method. You can have ads everywhere. You can buy ads. I'm sure you've seen some of the big mega games that spend literally millions of dollars on ads. Or for an example, in other medium, say you watch a new movie's coming out. You see a billboard of it. You see ads pre-roll before your Twitch videos. You see it on TV. And the theory of those ads is not that I see that billboard, I'm going to go watch that movie. It's I see that billboard, I see that pre-roll ad, I see that trailer before this other movie, and maybe that third or fourth time you see it, you think, well, maybe I might be interested in that, and then you actually go research that product, or you go want to see that movie, or you go download that app. And this has been proven by many studies. A lot of people who have marketing as their full-time degree that figure that out. And it definitely works, but it takes a lot of money to actually do that. It's not really practical to buy one billboard or one series of banner ads. So if you're only going to sink, just $1,000 into some click ads, probably not going to see very many results from it. So you have to be able to think creatively on how to optimize for those metrics. Now, I could talk for days, years, months on all different ways to think creatively. And bottom line, it really comes down to your game. Your game might have some better way to market than other games. Some games will do one thing which doesn't work for another way. You really have to think on a per game basis how to get this up, get this more popular. Those examples we were listing earlier had very different ways. Minecraft marketed very different than Flappy Bird, very different than Angry Birds. There isn't one universal formula. But they did keep in mind how they were going to get known. They did have a strategy. It wasn't just, well, we'll hope the community will market for us virally. They had some method.
So let's say that, we're going to release Zombie Pumpkin Slayer, but my friends are releasing another game. Can I cross-market with them?
Absolutely. Cross-promotion is a really good way to do it. I mean, if you don't know another indie developer, get in the chat and start introducing yourself to people, because there's so many developers out there who are in the same situation as you. And you guys are making games. It's a really great industry to be in because the competition kind of isn't really competition. If I'm making an app, if I'm making a to-do list, I'm making some calendar, I'm only going to have one to-do list, one calendar on my phone. So there's some real competition for that space. But a game, gamers play multiple games. If in your game you recommend your friend's game and vice versa, that player is just going to go to both. In my game, Blast Monkeys, when we were number one, we were cross-promoting with a game called Zoo Club. We were a physics-based puzzle game, and they were this management zoo tycoon game. So very different audiences, very different keywords. People were finding us in the stores very different ways. But in Blast Monkeys, there was a Zoo Club world, entire levels themed to it. And in the corner of every level of that world was a button that said, oh, go here to play Zoo Club. And in Zoo Club, you could get Blast Monkeys as an animal for your zoo. Theme matched perfectly, right?
Yeah.
As we were number one, they went to number 8. Because it wasn't just that we gave them players, but they were giving us players, and we both shot up the charts because of it.
So it's mutually beneficial.
Absolutely.
Great.
And this isn't just, this is something that because you're a small indie you're going to do and you can't afford real advertisement. This is what Zynga does. This is Zynga's secret sauce. They may have a really big popular game, they make a new game, and then they market that in their existing game for free and get the equivalent of $1 million ad buys for free because they're marketing to their existing player base in their previous game. Cross-promotion is a really good technique to build up momentum. And the more friends that you can get together to do it, the better. And I wouldn't just directly say, throw in a banner ad and you'll be good. Having that full integration is nice. Having some page that says, here's, games I recommend is nice. But again, exactly how you implement that has to be on a per game basis. You can't have a, Zoo Club world in every single game. It just worked really nicely for two friendly indie devs from the Bay Area who knew each other and had two animal-themed games.
Great.
Probably the number one thing that I would recommend, though, is preventing uninstalls. Too many people think it's just about downloads, just getting as many people to look at the game as possible. But if they're looking at the game and then immediately uninstall it, that really hurts your active install metric, and that matters a lot more than people think. So you want people to keep it on the phone as long as possible, because once they have it on the phone and then get rid of it, they're not going to keep playing it. And I know I say phone all the time because I talk mobile, that's where a lot of my experience comes from, but this is the exact same stuff if you're doing a PC game, doing a Windows Store game, doing an Xbox game, same logic applies. Once you have the game and then remove it, you're very unlikely to install it again. So how do you prevent it from being uninstalled? Number one way I found, keep the file size small. For phones specifically, if my phone is out of memory, which happens all the time, I go to my apps list, I sort by size, delete the top one. If your app is 2 gigabytes, it's going to get deleted first. I don't care how
that can
amazing
affect
it is.
downloads too, right? Because of the constraints that carriers put on download size.
Absolutely. There's I believe it's a 50 megabyte limit now. It might be been 25 for a while. I think they upped it. But if it's under a certain amount of size, you won't be able to download on a 3G connection. They'll need Wi-Fi. And too many people think, well, if I'm past 50 megabytes, it doesn't matter. But there's a big difference between even a gig and 1.5 gigs. Because the bigger you are, the more likely you're going to get uninstalled. And if you're really big, even if your game's awesome, even if I play it every single day, I'm going to remove it and get 10 other games from the store. Because those 10 might suck, but as a consumer, the new is always going to be more interested than the known. So for Blast Monkeys, we pride ourselves that every update we did, and we were updating every 2 weeks, every update we did for the first 6 months, we were adding content and made the file size smaller. I believe at our peak lowest, it was a 4 megabyte game, just to make it as tiny as possible. So when you look at that list of uninstalls, we were way at the bottom. Even speaking to the 3G download limit, if you're at 50 megabytes, a lot of games are in that 45 to 50 megabyte range because they optimize just enough to be under there. So if you're at 30, you're already under a significant amount of your competition, and you're just that much less likely to be uninstalled because people sort by size and delete whatever's on top of that list first.
And I'll just say that, this happens to me too. I'll go and I'll be mobile and I say, hey, this game looks really awesome. I want to download it. Oh, wait, I've got to wait for a Wi-Fi connection. Mm-hmm. So I forget about it. Sure, it downloads when I get home and my phone connects to Wi-Fi, but it could be days or weeks before I go back and revisit that game and notice that it's in my app list. So I just want to make that comment. That's something I've noticed before.
Yeah, absolutely. Next point I want to bring up is acquiring users intelligently. So whatever you do to get users, whether that's a traditional ad, whether that's these other cross-promotion ways, you have to figure out where those users are coming from and how long they're staying. You can't just get 1,000 users. An example I like to use is when you're doing ad buys, you can have analytics in your game to really know where that user came from and what their consumer lifetime value is. That is how much per average you earn per user. So you also figure out how much is cost per install. So if I spend $1,000 on an ad campaign, as an example, and I get 1,000 installs from that, you can say that it costs me $1 per install. Numbers are not going to be like that in the real world, but just using that as an example to make the math easier. Now let's say that's some banner ads that I bought. Now there's a video ad where I pay $2,000 and I get 1,000 installs. Well, now that's $2 per install. Well, if you're just looking at the cost per install metric, if you're just looking at the cheapest users possible, you would say that the banner ad users are better because you get $1 per, $2 per, cheaper is better, right? Yep. Not necessarily the case, because the 2,000 per, that was a 30-second video. That's a user who watched your game for 30 seconds, thought that game is interesting, and then they're going to install it. As per my point earlier with the screenshots, that user knows what kind of game they're getting into, knows that they're going to be interested in that game, and they're much more likely to stick with it. They're much more likely to keep playing. So if you calculate the consumer lifetime value of the banner ad user, that might be someone who just tapped a banner ad randomly. That might be just someone who saw a random screenshot, thought interesting enough, and downloaded it, and they didn't really stick with the game. So you might be earning 50 cents consumer lifetime value per user. But the video ad person, ideally, you would earn $2.01 or some amount higher than what your ad campaign costs. And in that case, you look, well, do I lose 50 cents or do I gain 1 cent? That's when you're golden. If you can get to the part where you're gaining money, that's when you can do a big buy. That's what the big companies do. They optimize their metrics. They start small. They get players in the game. They keep tweaking it. They analyze it. And they find the advertisement method that works for them. And they optimize it just enough where they'll earn 1 cent. That means that however much money I put into it, I'm going to get that investment back. And then they can just keep putting money in and in and in and continually gain very small margins, But eventually, they'll get that viral effect, get more and more people. And then that's how big bulk advertisement works. Even if you're not going to end up doing that bulk, you should think about this. You should put analytics in your game. You should analyze where users are coming from, how long they're sticking with it. If I ask you a question, say, well, how many of your users are playing the game today? How many quit within the first 15 minutes? If you don't know those answers, how do you know anything about your game and how well it's doing? Number of downloads doesn't really tell you much.
Well, let me ask you this too. I know we're talking about advertising, but what if the app store that I'm on comes to me and says, hey, we want to do a promotional deal with your app. Can you reduce the cost of it for a week?
Yeah,
is that worth doing?
Absolutely. In most cases, those kinds of deals are absolutely worth doing because if you can get that featured placement, you'll get so many eyeballs on your game. You'll more likely earn way more than what you would have gotten having it at full price. Another thing to note, too, is that if you're seeking out those promotions right now, but you haven't optimized your game for that stickiness, if people play your game for 15 minutes and then uninstall it because it's kind of boring, it doesn't matter how featured you are. It doesn't matter how many downloads you get. It doesn't matter if you get 100 million downloads. If they're all just users going to play for 15 minutes and uninstall, you're not going to make any money. 200,000 users daily active, way better than 10 million downloads in a day.
Yeah.
So that also brings up the stacking marketing. The more that you can do at once, the more marketing efforts that you can do, the higher up the rank you're going to go. If you can get your ads aligned with a store featuring and something else, the more downloads at once, the higher up the ranks you'll get because you'll have that higher velocity, and maximizing that velocity will shoot you up the charts. So if you can get a store placement, try and line up as many ads as you can at that point. Cross-promote with other people's games, post on different forums, do as much as you can at once because a big bump is much better than a small bump.
Great.
Next, I want to talk about beneficial behavior. Who's been in a game or an app or whatever it is, and they start it up, and you get a pop-up that says, hey, would you like to rate us in the store? You've seen that, right, Jason?
Yeah. Yep.
Is that annoying to you?
It's extremely annoying.
Oh my God, it annoys me so much. I do not understand it
They're
whatsoever.
asking me to rate the game before I've even played it, which is really, really annoying.
Games that people put millions of dollars in doing this same mistake, and it's clearly a mistake. Because let me rephrase how this works. I start your app. The only thing you know about this user is that they want to play your game. And you're giving them the choice, A, ignore it and go play the game, or B, don't play the game. So, say it's my favorite game in the world. I love this game. It is the best game ever. I start the game up. Hey, do you want to not play it right now? No, I want to play this game right now. It's the best game ever. Now, let's say I accidentally tap your game. I'm starting my phone, or I'm kind of bored. I'm messing around, and I click it. Hey, do you want to rate it? Well, yeah, I didn't really want to play anyway. I guess I'll go rate it. 3 stars, 2 stars. You're just asking for bad ratings. It's not about that quantity. It's not about just getting people in the store because you're just going to get that bias of negative ratings. You only want to ask people who are really going to be into your game, who are really going to like it, who really want that 5-star review.
So an example of that, if somebody's playing Zombie Pumpkin Slayer and they go through 50 levels of pumpkin slaying, and I can tell through the metrics that I'm collecting with my game that they really love the game, I'm going to ask them to rate it then.
Yeah, absolutely.
Great.
Even better is that as they're getting through, it's not just in between levels, like, hey, you want to keep playing or rate. You do it at a nice pause moment. So for my game, Blast Monkeys, we were a free game, so we had in-app currency to be able to unlock the next level. If you got enough points, you were able to unlock it, or you gave us money, then you could do it. Another option was you could rate us in the store to get a small amount of coin. So somebody plays Blast Monkeys. They don't have fun, wasn't their game, whatever. They quit, they're fine, they leave. Someone who really likes the game, someone who wants the new content right away, and better yet, they didn't want to wait for it or keep playing, they saw the button to go rate us in the store, and suddenly we got 300,000 5-star ratings. Because all the people who loved our game, we then asked at that strategic moment to go rate us. So figure out where that strategic moment is in your game and only ask there to go rate. This also goes with social. You can't just say in between levels, oh, hey, post this to Twitter, and the tweet message is, I'm playing this game. that's just saying, hey, could you please go advertise for free for me? Hey, could you please spam your friends for me? It's just asking for a handout, and people don't like doing that. A much better message is I'm playing Zombie Pumpkin Slayer, and I get a really awesome high score. I see on my charts that I beat you, Jason, so I send you a tweet and say, hey, I just beat Jason in the high score charts. I got this many points. Now you're getting a notification that says, hey, Tobiah just beat you.
Oh, man. I'm going to have to go back in and beat you.
Yeah, exactly.
Right?
It's a much better engagement. Yeah. You're interested in that message. I'm interested in sending it. It has value. It isn't an advertisement. It isn't value because I got 500 in-game coins for tweeting. It's intrinsic value that I wanted to tell Jason that I beat his high score, and thus I'm better than him, because that's how that works, right?
Yep. And then, in my competitive nature, I'm going to have to go back in and beat Tobias' score, because that is the nature of things.
Next, speaking of that negative messages, you want to have an outlet in your game for people to be able to rant at you. You want to have some email box that they can tap, pull up a message, and tell you something, anything. And I can tell you from experience, most of the messages you're going to get there is, this game sucks, or this is buggy, or I hate this. But that's great. And the reason why is that some number of those people who play your game and they don't like it for whatever reason, they're going to go to the App Store and they're going to rate it 1 star. But if you give them that outlet to say, hey, this sucks, they get it out of their system, they're fine, they send that message to you, and then they quit and they don't go and rate it. Even better, you can be tricky about it. You can have it automatically include in that email message what device they're using, what version of the app they're using, maybe some last error messages. You want to be really fancy. Then you can look at that list and go, oh, I see where there's a problem. So say you get a bunch of emails like, hey, this device isn't working. Well, wait, why is that? You can go get that device. Oh, wait, there's some screen aspect ratio problem. Fix the bug, push out an update. Even better, if you give an optional return email address field, you can contact them and say, hey, thank you so much for pointing out this problem. I think we fixed it. If you want, you can go try it out, but thank you so much for your help. Now, I guarantee you, if you reply to a message, no matter how hateful it is, 99% of the time, they're going to turn around completely. They're going to say, oh, thank you. I love this. It's awesome. You're cool. They're going to tell all their friends, oh, man, I knew this developer for this game. We talked. We're buddies because I helped them out.
A little bit of customer service goes a long way.
A huge way. Yeah. Having that communication with your audience is a big deal, and you want to make it as direct as possible. And so, again, speaking of communication, let's get to the last point in App Store optimization. Be remarkable, literally. I mean, you want to literally have your game something that people want to talk about. You make it as easy as possible for people. First step for that, make a press kit, make a website. You might be looking at this as like, oh, okay, I'll put a link to the App Store. And yeah, your App Store presence is needed, but you need something for people to talk about. Say I'm a reviewer for a magazine or some website, and I want to write about your game. If I don't have anywhere to link to, I'm less likely to want to write about you because it just seems weird to talk about this amorphous game project. Or even worse, say I want to write about you and I want to use a screenshot. I'm not going to open up your app, take a screenshot, and manually upload it to my computer. That's work. If you make it easy for me, if you give me a list of press-worthy screenshots, you give me a write-up, a description about the game and how it works, you give me the website to link to, make it as easy as possible for people to talk about you. Even if your game isn't popular yet. This isn't something you need once you get popular. This is something you need in order to get popular, in order to have people write about it.
Now, let's say I do this. I go through the trouble of sending my game for a playtest to a journalist, and they give me a horrible review. Should I just give up? Should I quit?
No, absolutely not. Games you have to iterate on. You have to continually build that up. You have to build a community around that game. Bad feedback is positive, is good. Look at Minecraft as an example. That game started in pre-alpha, completely buggy. You'll look at all of the early access games that are going on right now. Those games are popular not because they're perfect, not because they're amazing, but they're building up a community around it. Let it be okay that there's problems in your game and have that communication. Tell your audience, hey, this is what I'm working on. What should I work on next? This is part of having a website, having a Twitter feed. It isn't just for you to spam out one-way message and not get anything back. Start that two-way dialogue. even if it's like 10, 100 people, those are not going to be your hardcore fans and grow over time. This is an exponential growth. You can't just start off with hundreds of thousands of fans. You have to start with tens of fans in order to build up slowly and build that story and have that message. And playtesting in public is such a great thing right now. Everyone's doing it. You can Twitch stream your game development live. You can talk with people, and consumers love it. They want to know how the sausage is made. They want to know how games are being made, and they want to hear it. So tell them your story. It's interesting. You're a small independent developer. You have a great story right off the bat, no matter what you're doing or what stage of development you are. You have to be a lightning rod for success. A friend of mine told me that once. It's a really great message, because it isn't just about lightning's going to strike me and then I'm going to be successful. I'm going to be really lucky and go up to the top. You have to make yourself ready for that success, ready for those press releases, ready for both success and failure. Too many devs out there don't prepare for failure, because let's be honest, most apps fail. And so they prepare, well, okay, I'm not going to do this full time. I'm not going to, rely on this as my main source of income. But they also don't prepare for success either. They don't set up a website. They don't do a press kit. They don't do any marketing. They just kind of let it sit there because they're thinking, oh, well, it's never going to be popular. Well, if you think that, well, it will never be popular. You have to actually do the work as if it is popular, as if you're ready for it to be big at any moment ahead of time, and then ride that wave once you start getting it. One article could be that spark that starts the fire, that starts you going. But if you don't have any Tinder sent out, it's just going to be one article, one and done.
Okay, so then Zombie Pumpkin Slayer is the best game ever made, ever in the history of video games, and I'm just going to approach it that way.
Well, you can't just think like a developer. You can develop the best game in history, and if you don't do anything with it, no one's going to find it. If you're an indie, you have to think like a publisher. You have to actually market your game. You have to actually ship your game. You have to actually iterate in public on what's going on. You have to do what a publisher would traditionally do. We're talking about indies as not having publishers, but that doesn't mean you can skip out the publisher role. So you can't just develop the best thing ever. Because if I have the best game and no one sees it, no one knows about it, what's that going to mean? And that also brings up post-release content. I've talked to so many reviewers that will look at a game, and if it hasn't been updated in the last 3 months, they won't write about it, no matter how awesome it is. And they have told me, literally, well, if they don't care about their game, why should I? If you're not updating your game constantly, it shows that you don't care about it. Just as an example, go look at your favorite apps on the App Store. Go ahead right now, you can do it. You're going to see that they were updated probably in the last 6 months, more likely in the last 3 months, even if they've been out for years. Just continue with little updates, continue with little pushes, just showing that, hey, we still care about this game. We still care about this community. We're still adding new content. You have to think of your apps in this post-release cycle, constantly adding new things. And that brings me to my last big point. Apps are a service. So many people think of apps as a product. And you have to think of apps as a service industry. That means it's something that you continually do. It's something you continually update. A product is something you make and ship. Maybe you make 1.1 and you ship that. This is what you're used to. If you've been working at a regular job, most of the time you're in a product industry. The AAA games industry is a product industry. Apps are a service industry. You have to think about continually updating it. This applies to freemium games, but also to premium games too. You have to constantly add new content. Blast Monkey is my game, my company. We were updating it every 2 weeks. We had something new in the game. And that was key to our success, to constantly build up that community, build up more games. And it certainly wasn't the first game we made. A great example is Angry Birds. Everyone knows Angry Birds was the 52nd game made by Rovio. That's 51 games of relative obscurity, of barely getting by money, of thinking they're going to have to close down the studio and layoffs. 51 games. 52nd is the most popular game of all time ever. You can't give up early. You can't just release a game see that it doesn't go anywhere in 3 months and go, well, no one automatically downloaded it and didn't magically become popular, so it must not have been that good. Every game takes iteration. You know how many downloads, you know how high in the rank Angry Birds got in the first 3 months?
Top 100?
No, pretty terrible, actually. I think they got about 10,000 downloads, which isn't horrible, actually. This is a pretty good amount of downloads.
Yeah.
If you think about how it was a studio working on this game for a year, though, they were hemorrhaging money really badly. A lot of people I talked to, if I showed them the numbers of what Angry Birds was at 3 months in, they would have said, well, clearly this game's a flop, cut it loose and try something else. But they didn't do that. They invested more advertising dollars in it. They kept pushing it. They put new content out there. And then it started getting popular. Blast Monkeys, about 3 months in, not very popular at all. I mean, I would even admit we've had like 1,000 active users about 3 months in. 4 or 5 months in, we were the #1 Android app. Big differences can happen overnight. And it's not because 3 months in we started doing something differently. It's that exponential growth. Those tens of fans started turning into hundreds of fans, started turning into thousands of fans, and eventually turned into millions of fans. A great example is Antichamber. If you can look at the GDC Vault, there's a really good talk on Antichamber. I think he called it Overnight Success, 7 years in the making. He's working on the game for 7 years before he finally got it out there. And then he made, I think, $5 million in the first week or something crazy like that. Everything is a skill. This is the last point I want to leave you with. Everything you do is a skill. You know development's a skill. You know when you start coding, you're going to have to iterate on it. You're going to have to jump into it. You're doing a lesson like this to start doing something. You know, if I talk to an artist and I say, oh, hey, you're an artist? You learned art? So did you do art by analyzing what's in art galleries? What are the top artists? Who's being talked about? You made an art design document where you wrote up what your art piece is going to be like. You bought this amazing canvas and these super expensive paints in a studio, and you planned out exactly what you're going to draw, and then you finally took the paint and went to the canvas and made a masterpiece and were super successful. Sounds really silly, right? Sounds kind of stupid. No artist is going to think that's the way you do it. Why do app developers think that's how it works? Why do app developers think they can look at the store, figure out what the #1 apps are, say, okay, this is what I'm going to do. I'm going to write an awesome design document. They're going to jump into their engine for the first time, making their first game, spend a year working on it, release it, and expect that it's going to be the best game ever. You know, truthfully, the second thing you make is going to be better than the first thing. Your first thing's going to suck. The second thing's going to suck compared to the third thing. The fourth thing's going to suck compared to the fifth thing.
So, we're getting ready to release Zombie Pumpkin Slayer to the stores, and we're thinking about doing in-app purchases, but we don't really know what's going to work yet for maximizing purchase conversions. Do we just iterate on that?
Yeah, get it out there.
Do we try some first, and then we start kind of analyzing our analytics and saying, hey, what are people purchasing? What are they not purchasing?
Yeah, that's exactly the way you do it. You know, you could get a focus group of 1,000 people in a room, get a giant stadium, buy pizza, test everyone out, have them write awesome feedback, or you could just put it out there. Let it get 1,000 downloads in the store and monitor those people's what they're doing implicitly. Do it automatically in the background just as they're playing and using the app. Even if they don't like the experience, you'll collect that data that they didn't like it or that they quit, and that will help you determine, oh, hey, when they get to level 3, everyone quits. Why is that? Well, it's because they died 5 times without getting on. Oh, we need to make it easier, or we need to add more health packs, or we need to figure out some other way to balance it. The sooner you get out, the quicker you can do that iteration.
So if I'm serious about making money, then I need to have analytics embedded in my game.
Absolutely.
So something like Flurry, or that's the major one.
There are a lot of different solutions out there. You can even make your own in Azure fairly easily.
Right.
You can just throw up a PHP page, do a different call to it, throw a different tag. It can be as simple as that. It doesn't really need to be all that fancy. You just need to track the metrics you care about. Hey, when are people dying? When are they starting the next level? How long are they playing before they quit? That kind of stuff. And you just need to start doodling. You just need to start getting your game out there and getting another game out there and start developing over and over and over again. And the more you develop, the better you're going to be as a developer, just with every skill you're going to do. It applies with marketing too. The first time you try marketing a game, not going to be as good as the second time. You just have to keep marketing over and over. You keep experimenting over and over and finding what works. And it's okay to do something that doesn't work. You can just try again and do something else later. Or even take the same thing and iterate on it. Again, these games took years to make, years of iteration, years of being out there before they were successful. Wasn't Flappy Bird on the stores for like 8 or 9 months before it hit #1?
Yeah, it seems right.
Yeah, it was on for a while before it reached the top. So it is absolutely like never too early, I think, to get out there and build that community, build your audience, and just start practicing.
Yeah, talking about preparing for success, Flappy Bird was an overnight hit, and I think it kind of overwhelmed the developer a little bit, and he had to pull the game from the store because he didn't know, he wasn't set up to handle that. So
yeah, it wasn't quite ready for his success necessarily.
Right.
There's also an argument that he pulled back, and then everyone wanted to talk about it. Everyone wanted to talk about the next thing, and then he comes out with this next game, and it hits up in the media everywhere, right? So there was kind of a strategic decision there. It's like, hey, I don't need to deal with this right now. I want to focus on what's important to me. He wasn't just worried about, I'm getting this many downloads now. He was worried about long term. How is he going to set up his indie development in the future? And that applies to all developers. It's not just about that short term, how do I get downloads right now? How do I get known right now? The first things first is make your game great. Once you have a great game, once you have a perfect game, then you can start pushing it. Then you can start marketing it. You don't need 1 million users right now when you're starting out. You need a few users who are going to give you really good feedback, who are going to iterate on it, who are going to polish it. If you have a game that monetizes really, really well with only 1,000 players, it's easy to scale that up to 1 million players because you're monetizing well. It's doing that math, like I said earlier, where you can start ramping up the advertisement. But if you're not monetizing well, 1 million, 10 million, 1,000, it doesn't make a difference. Well, I hope that was you learned something about marketing and monetization. If you have any questions about that, I love getting questions. You can tweet me at Tobiah Marks or go to my blog, tobiahmarks.com, where I have a bunch of articles and information. Jason as well. You're Jason G. Fox on Twitter.
At Jason G. Fox.
So, ask us questions. It was a really hard topic to kind of condense in 50 minutes. There's so many different aspects to touch on. I know I went kind of fast, but hopefully you guys learned something and found it interesting. We're going to take a 15-minute break and stick tuned for module number 9. Thank you very much.
Thank you.
Welcome back. Hope you had a good, quick break after that last session. I know, again, I keep mentioning every session. I'm very, very excited to be here.
Yep.
And I'm back again today for the first time today with my good friend Dave Oyles again for our next session in developing 2D and 3D games with Unity on Windows, Prime 31, and Azure Mobile Services. How to do cool things like leaderboards by using the cloud in your application.
Okay, absolutely. Like Adam said, we're going to get started with one of my favorite topics, and that is Azure Mobile Services. And like you said, how to get tied in with your Unity game in particular. So I spent some time kind of creating, working with Prime 31 and creating, best to say, a sample to kind of work with your developers so you can better understand how to get this working within your application itself.
Prime 31 providing, of course, a year of free plugins for Unity for the Microsoft platform.
Yep.
Be it their Essentials plugin, do things like live tiles, which we'll actually look at the next session, Azure Cloud Integration, in-app purchases, things like that. So free for 1 year from prime31.com.
Absolutely. So quick module overview. We're going to be doing things like an intro to the Azure plugin, creating your first mobile service in Azure, understanding how Unity handles DLLs is a very eccentric and sometimes complicated method, so we'll work with you to get that done.
Eccentric, indeed.
We'll understand how to install the plugin, compile our actual project, as well as walk you through bits of the code. It can seem a bit difficult at times, but once you break it down into small, digestible bits, you'll have a much, much better understanding of how it works, along with the functions available to us. They're very, if you're familiar with LINQ or search queries, you'll be familiar with this as well. And finally, we'll wrap things up with what other options exist for developers out there. So without further ado, let's get started with an intro to the Prime 31 plugin. So like Adam mentioned before, it is Prime 31 has a partnership with Microsoft to allow many of his plugins to be free for us for over the next year. So I highly suggest head over to prime31.com and check them out.
They're normally like $70, $80 plugins.
Right now, this plugin runs across the Windows 8 store. The phone should follow shortly. We're working with Unity right now to get that built in too. It will run inside the Unity editor, but you will not be able to actually connect to Azure itself. Again, go to prime31.com/plugins to find it. I'll take you there real quick to give you a right understanding of what the navigating it actually looks like. Prime 31. We'll take a look at this. So the plugins page, you can't download the plugins directly through the app, through the site itself. What happens is I go to Windows Store right here. You see all the available plugins. See download now, download, buy on the right-hand side. And what happens if I go to click on these, for example, the Microsoft Azure plugin, click download, I'll have to first register. So it's my name, first and last, and my email address. And then after I actually register, I'll receive a link in my email to download any of these plugins. I've already gone ahead and done that. So let's take a step back into the PowerPoints and understand how to get this integrated with our project. So it's also a great time to take a step back and understand we need to download the Azure Mobile Services SDK before we continue with this. So this allows our Visual Studio project to then talk to the Azure Mobile Services backend. It's a NuGet package. So if you take a look at these slides immediately following this talk, or if you do a quick Bing search for Azure Mobile Services SDK, you can download it there, as well as from Visual Studio. I've gone ahead and done that already, so I'll save us the time there. So now, creating an Azure mobile service. So first of all, you're probably wondering, what is a mobile service for Azure? Well, first thing we can do is head to our Azure portal. And what that'll do is allow us to take a view of what's going on here. So go to Azure portal. So it's manage.windowsazure.com. When I click on that, it'll actually bring me to my portal, which you can already see here in just a moment.
I love that little progress bar.
Yeah, and we have actually a very nice preview that the Azure team is working on right now, too. I don't want to get too complicated, so I decided to just stick with the simple one we have at this moment, but in the very near future, you're going to see what else they're working on. So on the left-hand side here are all the services that are available to me as a Microsoft developer. So most commonly, I'm checking out websites, but in this sample, I'm going to keep it simple, go back to mobile services on the left-hand side. They even have a little mobile device, so you have a better understanding. And if I'm going to create a new service, I would go right here in the bottom left corner, this new button. Click New. Compute is the first thing that pops up on my left-hand side, followed by Mobile Service, and then Create. So now I'm prompted with another pop-up. I can then enter the URL that I want for this mobile service. It's not really going to matter because no one is ever going to see this except for you as the developer. So I could do something like test mobile service. And then it's going to add .azure mobile net at the end. So obviously this name's already taken. I'm not going to create a new one here because we currently have one. But generally what I'm going to do is create a new 20 megabyte SQL database. And the region is where you're located at this point in time. So I'm based out of Philadelphia. Therefore, most of my servers come from the East US region. And finally, the back end, you can use JavaScript, which then relies on Node.js. Or you can use the newer .NET version for other services, but for this particular plugin, it still requires the JavaScript version. So we'll stick with this for now. Once I make this plugin, or this Azure mobile service, I'll then be prompted with this beautiful screen right here. So you see the one I've gone ahead and made for all of you to use on your own is called Unity Win8 Test. Click on that. And now I can see which platform I actually want to hit here. So I can make different backends for different platforms. I can have Windows, iOS, Android. And this is continuously going towards Microsoft's idea of slowly becoming platform agnostic and working with developers of all brands and all kinds.
That's pretty cool. Seeing all those different platforms listed on there is pretty amazing.
Absolutely. And the fact it works so seamlessly across different platforms, web services such as HTML5 and JavaScript. So if you're ever confused at this point, we have Getting Started, which shows you exactly how simple it is to actually connect and run our app. And I'll even create a little sample demo app for C# or JavaScript for us. But up here on the top, I can find Data, where I can see the leaderboard that I've already created ahead of time. So if you're following along with some of my tutorials, which I also have on my site, I have many pictures of this, and you can see I'm constantly updating my leaderboard. So again, this is open to anybody who has access to mobile services at this point. This way they can add, remove, update scores. On the left-hand side here, we have an ID, which is automatically generated by Azure on its own. We also have a score, which is an integer, and a username. These are simply here to keep track of who's actually doing very well on our leaderboard at this point. So you can see I've already thrown some values in there. I've kind of manipulated them going along the last couple of weeks. But I've kind of kept them all beneath a certain number. So kind of under 200.
Built-in fields ID created at, updated that version. Those are ones you don't touch, you don't have no control over, all done on the server side by Azure.
Absolutely, that's correct. So even more up here, you can see we can have things like script, where I can add my own private functions in the back end if I want to manipulate this data in some way. We're not going to cover that today, though. I also have permissions. So, Adam, have you ever worked with Azure Mobile Services and permissions at all?
I have. In fact, when you mentioned about the scripts on there, it's kind of cool to note that it was initially provided you Node.js scripts that you could write on there. So you could use server-side JavaScript to do Node.js scripts, and then they finally released .NET scripts that you can have available on the server side as well. So really cool technology.
Perfect. So we really got the best of both worlds. Like you said, if you're a .NET developer, you should feel right at home. But if you're also a web developer, JavaScript will work just as fine. So nice permissions we have here. We have this leaderboard. Okay, say we're integrating into our Windows Phone or Windows 8 or even iOS and Android Unity game. We may not want to open them up to anybody, because if someone had an opportunity to decompile or open our code, they could then access these leaderboards and perhaps manipulate either the names or the numbers at some point. So what we can do is we have table permissions here on the left-hand side. So we have insert, update, delete, and read. These are also functions that we'll have available to us within the plugin itself. And right now I have it set to anybody with the application key can open this up and manipulate the data. So look at these tables and these keys as really the URL or endpoint is essentially a door or an address to a location, and the key is exactly what it sounds like. It's the key to get through that door.
I noticed in the list there, everyone. That could be a potentially dangerous drop-down to have enabled.
That could.
Unless you want that, right? You can
Absolutely.
have everyone available to insert data in your application. That surely could work.
Right. But in this particular case, I decided to leave it open for everyone, to leave it as simple as possible for developers to get started with. So we have authenticated users. You can also use a number of authentication services for Azure.
Various OAuth providers will integrate on Azure. Actually, a whole plethora of OAuth providers will actually integrate with Azure, so you can do authentication to mobile services.
Right. So it's anything from Facebook. They don't currently have a Windows Phone or Windows 8 specific authentication platform, but what you can use is their HTML5 or RESTful interface to then talk to your Windows Phone or Windows 8 app.
Very cool.
Google has the same thing. Microsoft has identity, direct identity. So we have a number of ways we can kind of work with developers to authenticate users who are going in there. This way, anybody and everyone can't just jump in and add to the leaderboard. So right now I have it open for everyone, but let's take a step back. We also have the URL or the endpoint for where this actually exists too. So I can click on this URL, pops up here, and you see it just says this mobile service is up and running. Perfect, looks good to me. Let's take a step back. So now we have our mobile service up and running. Let's have a better understanding of what this is exactly and how it can help us out. So you see right here, this little middle ground, this is the actual mobile service. This is what we were just looking at a moment ago. On the right-hand side, I have the SQL database, and that's where all this table data is stored. Again, that was the unique ID, the username, and the score. On the left-hand side here, we're showcasing a tablet and a screen of some sort to illustrate how we can go back and forth in our Unity game to this back-end mobile service and then pull from this database.
So I could, in theory, have a website looking at your leaderboard. Maybe I want some services integrated on the website side.
Right.
Maybe I have Windows Phone, Windows 8. My game's across iOS, Android.
Yeah.
I do some other services, a multi-platform Xamarin application. All those things can point up to that same leaderboard using the same API.
Absolutely.
And everything. That is amazing.
Yep. So you can limit to one specific platform, or you can open up to just about everybody to hit that same back-end service.
Very cool.
Okay. So how does Unity handle DLLs? Well, first of all, let's understand exactly what a DLL is.
What is a DLL?
Okay, a DLL is a dynamically linked library. Essentially, it's a collection of code and or data which may be used by several applications. So this include libraries or modules. So really, this is just common methods or things that we're going to have to use over and over. So essentially, we write them once and try to make them available to as many platforms as possible because they're going to share a lot of the same functionality. So with Prime 31 in this case, we have several DLLs that the developer had wrote that are available to us in our project. So first thing we need to understand is how Unity handles these actual DLLs. So inside of our assets folder, which is the main root folder for all of your Unity projects.
Everything's in assets?
That's right.
Everything.
We have a plugins folder. So sometimes you can be willy-nilly and name things however you like in Unity, but in this particular case, this folder has got to be called plugins. Now by default, Prime 31 has already created a folder called plugins for us, and then we have platform-specific folders on top of that. So
That's helpful.
Yeah, absolutely. So we have Metro and WP8. So those are already designed by Unity, and what happens is when you're building or compiling your Unity project, Unity will first do a quick run-through, put everything together, and grab everything inside the assets/plugins folder. It then does another pass, and it looks for platform-specific folders, in this case, Metro and Windows Phone 8. And what happens is if there is another plugin or another DLL that has identical names, it'll then take the first one, say, okay, you're not very specific because you're just in the plugins folder, but I see you have a very specific one and I'm building for Windows Phone, so I'm going to take that one in the plugins folder, get rid of it, and I'm just going to overwrite what was originally there. This way it knows, okay, there must be a reason why you have this in a platform-specific folder. Okay, installing the plugin itself. Let's come over here and I'll show you. You see, just like any other asset, I would download the Prime 31 from that link in my email. I would open this up, and Prime 31's plugin or asset will look just like this. I have a plugins folder, Metro, Metro Azure, and Windows Phone 8. So Metro Azure actually just holds the scene and the data specific to this actual project. You see inside my plugins folder, I have 3 different folders we just went over, and the DLLs. So it's P31 Metro Azure and P31 REST-Kit. So what these are is platform-specific plugins that Prime 31 has already taken care of for us. This is what allows us to at least run the plugin inside of our Unity project. So they're essentially functions or methods that are empty. There's not much going on in there because they can't connect to our backend just yet.
Not quite yet. Almost.
Right.
Almost there.
And that's why I mentioned during the first few slides that you can open this up and take a look at our project, but we can't connect anything just yet. So inside Metro Azure, which is really just my scene folder at this moment, so you have 3 different classes in here. I have my leaderboard class, my Metro Azure demo UI, and my to-do item, which we're not even going to use at this point. Let's open up this scene, and you'll see we have main camera and UI. Let's hit play, see how it pops up. It does not want to open up for me, or expand at least. Let's go to, where's maximize on play, or scene? There we go. Here's my scene. Okay, so you see on the top left here, I have the Azure endpoint. And again, that's that same web address that we were looking at earlier. We checked it before and she said, hey, you're up and running.
All good to go.
So that's the house or address that we're actually going to.
That's the most important piece of the equation.
That's right.
That's got to be up and running. Without that, you're in trouble.
We're going to be a little lost along the way there. Moving down, we then have our application key. So like I said before, it's a long string of text that serves as our key to get through. So before, I said we made this available to just about anybody. I didn't want to overly complicate things, so I made it so anyone who has this key can then connect to our leaderboard. Hit this little button, and it would ideally connect to our Azure service. Moving over to the right here, we have our username, which again, I can add any name at this point. Right now, it's just looking for whatever is in this input field. It would then add it to my mobile service. I have a score. Ideally, as your game is going along, perhaps you're incrementing your score for every enemy you destroy or basket you get through the hoop. And I can insert that into the leaderboard. So if I can adjust this a little more, This is kind of set. Do you know why this screen will not open up larger for me?
You want to go to the which one for the game tab?
Yes.
You can do a shift spacebar.
Shift spacebar. Ah, there we go. And it went away on me.
If you want your game tab, you have to get out of that and then go over to, the windows are kind of little.
Yeah.
Go to that game tab, then you can do, or maximize on play, either one.
Oh, that's what I was looking for, maximize on play. Okay, so we have our username, our score. I can then insert these things into the leaderboard. And then same thing here. Once I connect to Azure, I could hit these buttons to list all the items in the leaderboard, or I could query all scores that are less than or equal to 200. So like I said before, this plugin requires DLLs to work. But Unity itself cannot understand these DLLs until they actually build the whole project. So if I hit these buttons here, nothing's going to happen. It's going to be unresponsive. You're going to see my little debug information right here on the bottom. See, connecting to Azure Mobile Service, endpoint, but nothing's actually happening. So let's get out of this and understand what's going on. So you have installing the plugin. So we have our plugin, or our scene, at least up and running. Now I've actually got to build this project. So I go up here to File, Build Settings.
Look at all those platforms.
That's right. It's one of the selling points behind Unity for us, right? So you see I've already gone ahead and included the current scene I have right here. This is my Metro Azure test scene. I have type set to C# project. So I'm going to be very careful here and let you know that the C++ projects will not work at this point. Right now it has to be a C# solution. Also, it's set for Windows 8.1 SDK. And then you don't need to have the C# projects here, but this allows you to edit your Unity scripts within one instance of Visual Studio at a time. So one thing of note I want to make very clear here again as well is player settings. See this button right here? Let's click on this. And I've seen the inspector window on the right-hand side popped up. So on these settings,
all your platform-specific settings across whether it's Windows Store, Windows Phone, web builds, iOS, Android, etc. All the goodies are right there.
Yep. And a lot of these, what they'll do essentially is alter the app manifest file within Visual Studio. So you can do it here, or you can often do it in the app manifest itself. But for this particular plugin, what we're going to have to do is go over here to Publishing Settings. Give myself a little more space to work with. And beforehand, if I hadn't edited this at all, it would say Unprocessed Plugins. And it would say size 0. And I have the first element in the array here that says P31 Metro Azure DLL.
Very important.
Would you like to explain this and how the processing works in Unity?
They do some DL rewriting, so they actually look at DLLs and they reprocess it. They rewrite some information on there so they can kind of hook into it.
Yes.
So as part of that, they need to be in that list to kind of just leave it alone for the most part.
Okay. So Unity will always process plugins. It's just a matter of how many times it does it. So in this case, we're saying if it's unprocessed, it's not going to do two-pass processing, which it normally does.
Unprocessed means still process once, yes.
Yes, exactly. So in this case, we need to add that to add our Prime31 Metro Azure DLL. So what is that exactly? Well, it's right here in our plugins folder. So if I click on plugins, it is this one right here, P31 Metro Azure DLL. So all we're saying is, hey, we only want you to process this one time and not twice. So it's very critical that we do this. If you miss this key step, your project will not build. Finally, for capabilities, your project will still build just fine here, but if you do not click Internet Client, and you go to build your project and then deploy it to our Metro store, it'll not pass certification. So what will happen is Microsoft will look at your app and say, hey, you're trying to connect to the internet here, but you didn't tell us about this. So what Microsoft's assuming is you're trying to do something malicious. You're not informing the user of what is going on. So in that case, I click Internet Client, and now the user and I both know, hey, to use this application, we're going to need to talk to the internet in some way. So now we have our scene included and those small changes done to our player settings.
So if you don't tell that, you will fail.
Yes.
Fail certification and your application just won't work.
That's right. Hit build. And like we've done before, I enjoy keeping a clean project. So what I'll do is I have my Prime31 project. I go to my builds folder, and I like to create a new folder for each project I'm working on. So we call Metro. Again, the naming scheme doesn't matter here. It's just for simplicity and staying organized. So click on my Metro folder. And now we're going to see it's going to build my player here. It's going to take just a moment. See, post-processing. There we go. It's working its magic. And in just a moment, we'll have this folder pop up with our new Visual Studio solution. As soon as it's done, we will be good to go. And there we go. I know it's successfully built my project.
Very nice.
Always a comforting sign.
I know. You kind of wait for builds to finish. I mean, in any technology, you're building, you're waiting. It's like you hold your breath for a couple seconds. And the long builds are the worst because you're waiting a long time.
Yeah.
Like, if it's like a 3, 4, 5, 8-minute build, sometimes in the middle of the process you have a bug. Not just, not in Unity in particular, but any projects we worked at.
Absolutely.
Some big projects in some past companies that took a long time to build. Yeah.
And I see why I became a web developer where you don't have to compile our code.
That you just wait till the client reports a JavaScript issue.
That's it. Bug, feature. So now within our builds folder, I have my Metro folder, and you can see I have my new solution called Prime 31 Azure. I'll open this up, latest version of Visual Studio. Remember, I mentioned before we have to download the Azure Mobile Services SDK first to get this to work. Without that SDK, this project will not allow you to connect to our backend. So we can close these other solutions here. Right now I'm looking at Prime 31 Azure. And as you've seen many times throughout the last 2 days, I've got to change the debug settings on this. So right now, go to Conman, as we used to call it, Configuration Manager.
Conman, nice.
And set to ARM and an ARM tablet. But of course, I'm not currently building on an ARM tablet. I'm using an x86 machine. So go down to x86, make that change. And again, this only has to be done the first time that I go to build that folder. After that, that change is saved there. Go to Close, and local machine. So you saw right there, getting NuGet packages. So this NuGet package does not come with Prime 31, but it's essentially a NuGet soft JSON that allows me to parse the JSON on my backend for my mobile service and then bring it into my Unity game itself. So I've already gone and put that together in this project. I'm in a sample, so it'll include it in your project as soon as you go to launch it. We see deploy started in the bottom left-hand side. Unity's popped up. Thank you for letting me know I can always switch between apps. As soon as it finishes building,
there we go.
Get rid of this. Okay, we'll leave it there for now. But you can see this project is identical to what we were looking at before in our Unity browser. But now the catch is I can connect to my mobile service in the background. So again, I have my endpoint right here. So that's the address I'm trying to reach with all of this information. I have my application key. I'm going to connect to the Azure service. So I hit connect. Doesn't look like anything happens. So maybe I'm sweating a little bit. But hey, let's take a moment. See what's going on over here. So my call stack, where is my output here? Or my debug? They've changed this on me. Windows. No, 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 no. Where is the console log on this machine?
Debug window output, I believe.
Debug Windows output. Maybe this is it. This might be it. So I want you to see everything that I'm looking at this whole time. Okay, so I had my call in here. All right, here we go. Connecting to Azure Mobile Service with an endpoint and the app key. So I know let's try to connect. I put that debug function in there.
And keep that app key safe.
Yes.
Don't publish that over anywhere in the world.
Well, in this particular sample, again, I made this available for all of you, but generally, I would keep that very, very safe and locked away in a nice location. So it looks like I connected to the Azure Mobile Service. But before I can hit any of these buttons, before they can do anything on the right-hand side here, I need to connect. That's why I have this little note up here, connect to Azure, hit these buttons, then wait a few moments for results to return. So what I do right away is I want to list all the items in the leaderboard. So hit list all items. And I have to wait a moment, and there we go. So I have the name with the name and the name field, along with the score for the individual. So I have Richie, looks like I got 200 points. Johnny Guy, my favorite person, 110 points. So you can see I was able to pull in everything there. The first time you pull this up, though, it might take a few moments. So if you haven't used your Azure Mobile Service in a couple of days, a couple of weeks, it's spinning up that machine in the cloud in the background and then suddenly pulling all this in. So I have a number of functions listed here available to me. I have delete latest item. So what it's going to do is grab the top item in the list and it's going to remove it from our board.
Just the last one.
Just the last one. And there we go. It's gone. So I see that happen there, but I'm not sure if it's actually happened on mobile service, right? Like, maybe it's just happened locally.
Maybe it's an application bug and it's only removing from the list, not actually using the live data.
Yeah. So let's go back up top over here. Let's go back to our mobile service. Click on it. So back in my mobile service dashboard, I'm looking at data, line leaderboard, and it looks like test today. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items there. And how many do we see in Unity? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and 10. Perfect. Lining up well so far. So I can also do things like insert a new thing. Okay, so let's go to Adam Tuliper. Looks like he's doing awesome. So I got 300 points in the latest game that we're playing today. Let's insert him into the leaderboard. It'll take a few moments, but he'll be inserted in there as well.
I love test data.
Always fun.
Always
right?
looking at people's names and databases. Test data is fun.
Yes.
Manually enter test data because people are always inventive. You know, Charlie Brown and all sorts of funny little names. I've seen some crude ones, but I've seen some really funny ones too.
Well, I figured you're sitting next to me, so it's easy enough to use your name here, right? It's safe.
Adam Fathom.
So I had insert to leaderboard, and then I had to do a refresh. So I listed all the items on the leaderboard, pulled them in, and here we go. Adam's name is added to the bottom right here. Okay?
Do I have the high score?
I think so. Yeah, everyone else?
Yes, you're awesome.
230 seems to be the closest at this point. But again, let's go back to our dashboards to make sure. So no change here. I have to hit refresh, and let's see what pops up. Curious to see if Adam's name actually appears here.
Me too.
Fingers crossed.
I want my high score persisted.
Yeah, exactly. You want to be able to rub it in the noses of everyone else who goes to play that
Johnny
game.
Guy and whoever this Test Monday person is.
Yeah, and Unity tutorial test. And here we go. Adam Tuliper, 300.
Nice.
Remember I said before, Azure provides a unique ID for me as well. So I've even gone to the trouble of adding debug functions inside of Visual Studio for you. So each time you pull in these leaderboard assets, you can see in debug right here, once it's finished pulling in the leaderboard, it says done with where. So that's the where function, and it's found 11 items. Because remember, just added Adam a moment ago. So it said queried all scores completed with leaderboard list 11. And it's going to give me insert item to the leaderboard. And it's inserting this actual item for us. So let's take a step back. We can see we can pull in information. We can insert. What if we want to update too? So Adam Tuliper, I'm going to update the latest item in the leaderboard, which should be the guy up top here. Looks like Richie's score 200. Maybe I'm going to change, I'm going to keep his name to Richie, but I'm going to give him a score of 300. So I have username, score, update latest, and let's go pull this in too. Oh, Richie don't want an update there, but tough luck for him for right now. Oh, this guy didn't like me real quick. Insert.
Non-critical issue.
Yeah. He'll get to it. Oh, he doesn't like that. And here we go. Change the score to 23. But Richie doesn't want to work with us today. That's quite all right. So now I have all this data. Why don't we see if we can query scores that are just less than or equal to 200? So in this case, you may have to go.
Or maybe just greater than or equal to 300.
Yeah. Oh, don't know what this utility is. That keeps popping up. And there we go. So I hit latest scores, and we have the scores that are all less than 200 at this point. So again, you had 300 earlier today, but you're not there anymore.
In Visual Studio, sometimes you can set the levels of where you want to see exceptions. You can say, show me all the exceptions, show me exceptions in just my code. So I think that's what's going on there. It's just showing everything that's popping up behind the scenes.
Yeah, kind of hit or miss. So let's get back from this guy, and let's step through the code really quick so we have an understanding of how this all works. So stop this project. And again, there's really only one file we're looking at here, or essentially two. We have our Metro Azure Demo UI, which is our main scene. So right here, you see we're using some Unity-specific functions. We have Prime 31. Let's close this up. We have a tutorial right up here. So you can download this from my GitHub. My name is David Voiles on GitHub. And have step-by-step tutorial with PowerPoints, along with 3 pages of actual content to walk through all of this. So right here, we have our little leaderboard object. Okay, so you have private leaderboard. It's an item, contains, again, just a username which is I'm setting my ID to null because Azure will do that on its own, and accepting a score. So let's actually look at this leaderboard and what it does. So assets, oops, wrong folder. Scripts, nope, wrong one again. Plugins, there we go, Metro Azure leaderboard. So my leaderboard item, very, very simple, okay?
Make that text a little bit bigger.
Oh, yes, I'm sorry.
My eyes are getting older here. Oh, look at that.
So our leaderboard item is essentially just an ID, a username, and a score. We're just doing a getter and a setter. So something I want to make clear here as well is I needed to use underscores or lowercase for both username and score. Previously, I had capitalizations, so I had capital U for username, capital S for score, and it wasn't returning. So make sure when you're creating this new leaderboard or leaderboard item that you use lowercase for both of them. Let's go back.
Are you saying it's case sensitive or must be lowercase?
In this particular case, it is case sensitive.
Okay.
Yes. So we have our leaderboard or our list right here. Our leaderboard items, I should say. Then we have a list, which is really just a collection of the items in our leaderboard. Can I have minimum scores to return? So in this case, I'd set it to 100 and the column width. And that's how wide those buttons and all information is actually going to appear. So we have our serialized fields. So I have private strings. In Unity. But serialized field, what that essentially means is I want to keep it private. I don't want to share it everywhere in this project. But serializing means I get to expose it to the editor itself. So I can make changes there.
So in Unity, you can go in and set that value right inside Unity Editor, but no other code classes can see that value.
Exactly.
Very cool. That's one of the neatest things I like about Unity, because I used to have public variables everywhere.
Yeah.
And then it's just not very good for encapsulation,
right.
Object-oriented programming practices. And then I found out about the serialized field attribute. I'm like, oh, I can hide all of my data from my other classes that shouldn't see it, but expose it in Unity's editor. Brilliant.
Exactly. Cool. So a very much different mindset to go. You used to be a web developer where basically everything's global and JavaScript doesn't have a good sense of encapsulating everything. But C# is just the opposite, because ideally you want to protect all of your code and content and keep most of it private. So again, we have our endpoint here and our application key. And then onGUI is a function we use for basically just drawing the buttons and the inputs that we have here. So I've kind of formatted this so you can see where we begin our layout, and then we also end it. Everything else is kind of indented. So I've organized it by columns. Right? We have several columns here. Then we have buttons for the layout itself. So I'm not going to spend too much time going into all the buttons, but we have one for draw endpoint and application keys. We have another one for connect to Azure Mobile Services. So that was that first button we saw before. Let's go back into Unity so we have an idea of what this actually looks like.
So as a first step before you do anything,
yes,
connect, then worry about everything else after that.
That's right. So we have our Azure endpoint and our application key. So I have ordered these, for the most part, in the way that they appear on the screen from left to right. So I have draw endpoint, app key buttons. That's right. We have Azure endpoint, Azure app key. And what it's doing is setting that value to whatever you enter there. And there's our endpoint, and there's our app key, right? First few functions we run across. And there's our button, connect to Azure Service. And what do you know? A button says connect to Azure Service. And again, because it's very much a sample project I want all of you to learn from, I've kind of used debug.log all over the place, just so I could verify that I'm returning information constantly. So when you're actually building your project, though, and putting it into production, you're going to want to remove all this information. It's going to slow you down quite a bit. Then I have our draw insert button. And this is the first key prime31 function that we're using here. So anything you see that begins with Azure, so type Azure right here, azure.insert, that's actually a prime31 function that we are using. So it's going to take something, our leaderboard item, and on success, it's going to use a lambda function. Are you familiar with those?
I am. One of my favorite things in C#.
Yeah. It's basically an anonymous function if you're coming from a JavaScript background, I guess the best way to explain it.
Absolutely. Yep. Doing this inline function so you don't have to create a whole other function and then refer to that function.
Yep.
If you want to do a debug.log kind of encapsulated right there, you just do it right in line. Yep.
Exactly. And
really cool.
It's very useful if you're only going to use a function one time for one particular case, right?
It's a weird syntax for people coming to the language. It's like, what is this? This looks weird. Parentheses, arrow. But once you get used to it, it's one of the best language features there is.
Absolutely. It took me a bit to wrap my head around as well, because you look at this parenthesis and you're thinking, well, what is this? And then it looks like equal or greater than, so all of a sudden you're assuming it's something to do with math, right?
That's true. That's true.
So really all I'm saying here is I have an anonymous or unnamed function. I'm not passing in anything as a parameter. And this is the function itself. It's really just debug.log. And I'm saying I've inserted a leaderboard item, and I want to just draw that name to the leaderboard. So I want to make sure that not only am I pulling in an item, but it's also the name of the person who I'm looking for, too. So that is our draw insert button. So we can list all items. So we have another button here, and fields, so that we can list all items in the leaderboard. Again, like you mentioned before, we're going to have to connect to Azure first before we can do anything. Then, scroll down here a little bit more. You can see each time I'm removing everything in our current list. That's why I'm using leaderlist.clear. So I'm grabbing the items that are in our list that are being drawn to the screen and removing them because, like you saw before, sometimes I would draw everything, and then other times I'd only want to return, say, values that are less than or equal to 200 or 100. Another example may be you want to look for a particular person within a game. Like, how do I know? I want to see all the scores just done by list_item.username Adam.
Adam.
Right.
That's right.
So I can only return your information, display that.
Wow, this guy's got 300. I better play this game more.
That's right. That's right. So you can think of all kinds of creative ways to kind of use this. So again, this is very simple to link in many ways where I'm querying this dashboard or this leaderboard. So I have my prime31 function, azure.where, and I'm passing in, again, anonymous function. So I'm looking for the username, making sure the username is not null or not empty, saying, hey, give me a leaderboard, and make sure the leaderboard names are not empty. And then for each item in their leaderboard, I want you to say, hey, I've queried all the scores in the leaderboard, and I've completed everything with a count of, here's how many items are in this list. So you saw the first time we did it, we had 10, and I added Adam, and suddenly we have 11. So that's how you know that our leaderboard is actually being updated in the background as well. Then I'm setting my leaders list, which is above the top here. So this way my other functions can expose it. I'm saying for each item in this leader list, okay, debug.log, item in the leaderboard. So I'm saying take each item, write it out in our console like you saw before down here. And this way I know or I'm guaranteed that I've actually returned everything. So nearly wraps up everything we have for our Azure-specific functions.
Looks pretty easy. Just a couple function calls, give you a lot of functionality. Can you do me one favor now?
Yes.
On that Azure object, just hit dot after it. I just want to see some of the stuff that kind of pops up on it.
Absolutely. Let's go back up to Azure right here. Azure dot.
Connect. Could you expand that a little?
I don't think I can
font
actually
size, I mean.
zoom
I'm
in.
sorry.
Oh, okay.
Azure dot. So at least we see the Azure dot. Everything else has to still
here we go.
Control.
Yeah, there we go.
Perfect.
Oh, you know what? Here we go. Dot.
It clears away.
Oh, there
Look
we
at that.
go.
There we go. Connect to equal. Oh, of course, that's built in. So connect, insert, lookup, update, where. Pretty simple API.
Yeah.
Few functions, keeps it nice and simple. Just it's hard to kind of mess it up because you've only got a couple things available to you. But for reading data, that's all you need, right?
Absolutely.
Read, write. Easy.
Very, very simple. And you see, like we mentioned before, at the very beginning, we talked about authenticating with the service provider. So that could be anything like OAuth or Google authentication, Facebook, even some of Microsoft's own services. So this way we can say, well, maybe we want the user to actually sign into one of these services first, and then we can verify if they actually are who they really are and add that to their profile.
Very cool.
So that really covers a lot of what we had here. Again, you can feel free to take a look at some of the source code we have. Let's go around the home stretch. Now we've taken a look at all the technical nitty-gritty. So we walked you through the code, gone through the leaderboards, several of the functions, insert, delete, and update. Finally, we verified through the Azure portal, which as you saw before. We added Adam with his fine score of 300.
Yes.
We pulled him into the leaderboard itself. But now we have Prime31. What other options exist? Well, I quickly browsed through the internet fast, and I saw that another option was Bitrave. It requires Newtonsoft.json. So this might be a bit of a downfall for some people because that's a premium plugin for Unity. So Bitrave is free, and it does much of the same thing that Prime31's plugin does, but you need to download this $20 or $30 asset from the Unity store. And essentially what it allows you to do is serialize and parse JSON through a RESTful interface. This runs across more platforms, But again, a lot of the functions work identical to what we have here. If you visit my site in the near future, you can also see that I have a tutorial coming in for that as well. Again, our goal is to get developers using Azure and understanding how to write leaderboards and really take advantage of everything both Microsoft and Unity has to offer.
It's pretty easy.
Yeah, absolutely. Like I said before, JSON.NET plugin, $20. You can get it from the Unity store itself and build it into your project. So, coming around the home stretch, what are Azure Mobile Services? Can you give us some fine examples of how you think you could use some mobile services?
Leaderboards, user storage, user data storage on there, multi-platform data storage.
So you're saying if I could really keep a lot of the same save information on perhaps Windows 8, and then how else could I use that?
All my player settings across all the devices that I want to deploy to. So I want to store the user's profile information, their name, whatever other information I'm collecting, not just high scores, but all sorts of other information. Maybe I want to store gameplay statistics, and I'm not using another analytics service. I could store all that data myself up there, so you can actually do all of your own little analytics, user storage, user profile, anything you can store data for.
Not a bad idea. Or maybe if you're a developer who works on multiple games, you could say something like, well, I see you've already played games A, B, and C. In that regard, why don't we give you games D, E, and F for free, or perhaps at a discounted rate? So their own backend, they could say, you've already logged in through OAuth in this way. I can verify you are who you say you are. You have several of our games, so I'll throw you a bone. Here's 1 or 2 for free for you.
Very cool.
Again, we can create an Azure mobile service both through the dashboard itself that you just saw in Internet Explorer, or Visual Studio has its own tools built into the Azure SDK. Again, no time to get into that, but feel free to look at it on your own. Compiling our project, we want to understand how the DLLs work. So again, very quickly, Unity will look at the plugins folder for any DLLs it has in there. Then as you're building for a specific platform, it's going to look for, say, Metro or WP8 for Windows Phone 8. Those are essentially preprocessor directives that Unity has built in already. If I'm going for Windows Phone, it'll look just for those plugins and build Azure for that platform, or DLLs for that platform. Again, if you're looking for other options in the future, Bitrate Vote exists as well, but again, that requires a $20 additional plugin. This source code and more is all available at github.com. So feel free to look for me on GitHub. Ask any questions you'd like there. So I have many detailed tutorials along with about 5 or 6 times as many slides as we have here.
Nice.
So step-by-step instructions. If you have any questions along the way, feel free to ask. But I'm confident that you'll have no problem getting started as well. So thank you again for joining me today, Adam.
Thank you. That was a wonderful session. And join us next for our final session of the day, adding the finishing touches. We hope to see you soon. Thank you.
Thanks.
Welcome back. Our last module of the day of developing 2D and 3D games with Unity for Windows. I think this has been awesome.
I've had a great time.
This has been amazing. I know I've said it over and over and over again. I'm so happy about this. I think this has turned out well. Hopefully you've gotten a lot of good information from this. But I do want to point out that the folks watching this live right now, hang on for a little bit at the end of the session after we say goodbye. I've got some directions for a couple little random drawing that we're going to do for a few of the folks that are joining us today. So just hang tight at the end. And let's get rolling on adding the finishing touches, Module 10, the last one of the day.
Beautiful.
All right.
Home stretch.
Let's talk about what we're going to talk about. We're going to go meta, talk about what we're going to talk about. In our module overview here, we've got live tiles, integrating a privacy policy, a pause screen for your application, and in-app purchases. And we're going to do this all in Zombie, Pumpkin, Slayer.
Yeah.
I had to make sure that was working there. Very nice. These guys in the back are awesome.
Yeah.
Woo. So, live tiles.
Okay.
Very cool way for folks to integrate additional pop into the application.
Okay.
Yeah, the idea behind this module is there's things that you want to do in your game to differentiate it from the rest of the games.
Right.
Leaderboards, your session.
Right,
in fact, I tried to do leaderboards during the break. I thought it would be really cool to get them integrated in ZPS. during the break here, and we almost got it.
We got it up and running.
Got up and running. Got it actually querying Azure. I just didn't have enough time to do the GUI elements to list all the names in there, but it was close, and we only had about a 15-minute break. Yeah. So live tiles, they give the user extra info. A great example of this. Let me show my start screen on these computers here.
Very nice. I like that.
See
I like
the little pop
keys,
going on here? Live tiles. They kind of catch the user's eye. 2, they give relevant information without always having to go into the application. So in news and weather, stocks, 3 things that I use it for all the time. So what we can do, being that we're doing gaming here, is talk about ways that a game could maybe have you come back easier to the game. You want to entice people to come back to the game.
Right.
So cut the rope, for example. That does a really neat way of doing it. They show you how many stars you've got. It's kind of an enticing way to come back. So how do you use a live tile? What is a live tile? We saw that they flipped. Are you limited to the size of them?
Right.
There are many, 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 many different tile templates that you can use.
It looks like it's displaying information of some sort, but I guess it doesn't always have to do that.
It can be just a simple message. It could be an image. It can be a gallery of images. Like on here, I show an example for Windows. Bunch of image tile format. This is tile-wide 310 by 150 image collection. So this is actually the template name that you would use if you wanted to do this.
Okay.
And you can do this in games. You can do this in C# XAML applications. You can do this, desktop or Windows Store applications, Windows Phone applications as well.
Yep.
On the C# side, outside of the gaming side, you can do this. If I go to a browser here, tile template catalog, Windows 8. Let's search for that. This shows you, this is a list. Let me increase the size here. This is a list of all the different tile templates. And you can use all of these in your application, any one of these. You just have to use these names. And we'll look at how you use those names.
A lot of diversity there.
A lot of diversity to show you. Here's on Windows. Here's if you want to do it on Windows Phone.
Okay.
So many different formats if you want to do wide or with text on it.
Yeah, and actually, I like that it looks very similar on both platforms as well.
Yes, I like where the convergence of the platform API is going. So very cool ways, right? You can see that you have a ton of potentials here, really however you want to display it. Whether you want to do text or image and text or multiple images, you have a variety of ways and sizes that you can do this. Now, with tiles, you can include them as local tiles in your application. In other words, they can be something included in your project, or they can be a remote tile. So you can actually point somewhere on the net.
Yeah.
And your application can pull that down from that location and set that as a tile.
So maybe if I want to send people updates or things, perhaps seasonal information later on, I don't have to actually rebuild and republish my entire app?
Correct. Correct. So you can use something on the net, point them to an image out on the net. Prime 31, actually, when you download, because we're going to be using Prime 31 here today, when you download it and install it, they have actually an example of pulling a remote tile down from the net. Beautiful. Very cool. So you could write a service around that, maybe a website or an Azure mobile service, and use the data and services, server-side services to bring back data. Really cool things that you could do there.
I like it.
All right, so for this, we're going to be using one of the plugins from Prime 31. This is the Microsoft Essentials plugin. Of course, you want to go to prime31.com, and you want to install the package into your project. In other words, you double-click on the package that you download from their website. Early on, when we talked about architecture, the first module went over what packages are, and they're just simply a way that you can redistribute stuff that you can use across your projects.
Okay.
So the Prime 31 plugins come down as a .unity package file. Double-click on it, it goes into your project. Now, last session, you were showing that with Azure, you had to add the P31 Metro Azure DLL.
Yes, correct.
To unprocessed DLLs.
Okay.
So in this case, it's slightly different. We need to do this one as well, P31 Metro Essentials DLL. And we'll look at that inside of Unity to what that looks like. And ensure you have Windows Store selected as what you're building to. This does not run in the editor. This is meant for when you do your actual build because this calls into a platform-specific API.
Correct.
And I add a little tech note here just for the folks that like to really understand how things are happening because Unity will generate your Visual Studio project, as Jason was showing yesterday. It doesn't overwrite that project. So if you happen to have your project already generated, your Visual Studio project, and then you decide later on to install Prime 31 in, well, that project needs references to those libraries.
Right.
So either you can do a comparison between a new generated project and an old one, and you can see where your C# project differs.
Yeah.
Update the post-build step, add the reference manually. You can. I've done it before manually.
All right.
Or you can just, if you don't have anything custom in your project, you can just delete the build that Unity creates for you and just have it regenerated again. So that's
So
why I have
many
the little
ways to
note.
skin a cat, though.
Many ways to do it. Some folks like it, the technical information, so I just wanted to add a little note on there for it. All right. What do you say we do a demo of this?
I'd love to see this.
Okay. So first, let us do this. I'm going to turn this off so we don't really get a full preview of what's going to happen here,
Okay.
even though I know you just saw it.
Very vibrant dashboard. I like it.
And we can see what I was doing during the break here. We're trying to get the leaderboard integrated here. So actually this window is going to look a little funny when we do our build because we were concentrating on getting this as opposed to the size of this.
Yeah.
So we'll notice when we finally export, we're going to get a little extra blue probably on the background. The title screen will need a little fixing, but that's okay. We'll talk about it now and you'll know what's going on. So in here, I've downloaded and installed that Prime 31 project in here. And as you were mentioning in your session, we get things that show up in plugins, Metro,
Okay, looks like platform-specific folders.
Metro Essentials, Metro Store. So we're going to talk about the Metro Store shortly. For Metro Essentials, we can just simply double-click on Test Out a Scene here. But I've got this code brought into my application.
Okay.
So let us load this up over here. And let me find... We're going to check out a couple things here. All right. We've got this that we're going to look at in one moment.
Right. Again, platform-specific code. Hence
Platform-specific code.
preprocessor directives.
That's right.
there.
And I'm going to load up my build settings here. Control-Shift-B for the hotkey fanatics.
Yeah.
Windows Store is my player. Now, one thing that got me when I first started Unity is everything defaults in a project to being a PC standalone build.
Okay.
If you need to make it any other platform, you actually need to highlight that platform and click Switch Platform. Otherwise,
You
you're not
just click,
actually...
but don't switch.
Just click, it doesn't do it. You've got to actually switch platform, and it re-encodes and processes and does a bunch of stuff on the back end. Now, if we look under the player settings, you were talking about that last session here,
Yes.
and Jason was talking about that too. This gives you your platform-specific settings.
Right.
And so what I did here, a couple things. So a wide tile is 310 by 150.
Okay.
So when you deploy your application by default, it doesn't have a wide tile with it. Not everybody uses wide tile.
Right.
So for example, if I look at Unity here, I don't have a wide tile for it.
Yeah.
But Zombie Pumpkin Slayer, pause for effect. I love it. Zombie Pumpkin Slayer does have this. That game, ZPS, does have this here. This is the wide tile. So Matt created this.
Yes.
This is simply a 310 by 150 image.
Yeah.
So I set that here because that will get pushed out to my Visual Studio solution.
Right.
So that will be there by default. Now that's not a live tile. That's
Right.
just my wide tile.
So it's just an image, essentially, at that point.
It is nothing more than an image. In fact, if I come over here and I look, that's my image right there. That is my wide tile right there.
Well, something I want to point out real quick, I found it saved quite a bit of time, is if you look for the Microsoft Web App Template, at their GitHub, they actually have a tool you can use that'll automate this. So you can pass in one image, it'll then center and process everything as a web worker in the background. You just drop in an image, and it'll spit out resulting image sizes very quickly in a zip file for all of those.
That's pretty cool.
Yeah, this way, all that done in about one fell swoop, 10 seconds.
That's better than, I did one actually about a year ago, which will only do the main ones for a project where you drag and drop an image onto it, it generates it, and but doesn't do all of them. So.
Saved me quite a bit of time. I love
very
it.
Cool. All right, so this is just an image here. If we look on our player settings and we scroll down to our publishing settings, now, David, that's the one that you were talking about in your session here,
Yes.
P31 Metro Azure. We need to tell Unity not to process these libraries, which means only process it once, not
Right,
twice.
it's still doing the processing, but only one pass.
And so this one here is P31 Metro Essentials.dll unprocessed plugins. You must do this. This is in the Prime 31 documentation. If you don't do this, things won't work. That is a must. So once we've got that set, now the only other thing you need to do after bringing in that project is to do something in code. Well, I shouldn't say the only thing. One of the few remaining things we need to do.
Okay.
In your Unity code, you simply need to say, hey, in my resulting project, this is where my live tile is going to be.
Okay.
And then secondly, it is one line of code to tell the Windows system that you want to use this new image.
As your wide tile image.
As my wide tile. Now, check this out. So we looked at all of those different tile templates on the website. If I click on dot here, look at it's already all set for you. You don't need to use like a string for a name or
Beautiful.
anything. This is all right here.
So you're basically just passing in the image that is the correct size to begin with, and it just draws it for you.
Yes. Now there is something to be aware of, and this has bit me many times because I don't know, I might be copying and pasting other code, and I might have tile, square, block. If you pass in a wide tile to tile, square, block, nothing will happen. It just won't work. Won't do anything.
It's expecting something.
Yep. So you got to make sure that whatever template you select, that you indeed have specified the right stuff for it.
Perfect.
So we're doing tile wide image, which is that same image 310 that I was showing you before. Mm-hmm. All right. So we'll save that. This is all that we need here. Now we need to create our build.
Okay.
And Jason was demoing this yesterday, so we'll just do this real quick here. Build. Windows Store.
Okay. Compiling everything in the background.
Compiles actually a lot faster than my machine is currently going.
Yeah.
So this is nice. I'm taking the system home, guys.
I like it too.
Very cool.
Post-processing player, doing all the processing in the background. It's going to spit us out a nice, beautiful Unity project at the end.
Here we go. Wait for it. No whammies, big money. Anybody remember
Big money,
that show?
big money. Yeah, of course we do. Come on.
Not everybody remembers that.
I know. We're just waiting a moment for a zombie pumpkin slayer to be brought.
Zombie. So here is our resulting project. This generated a Visual Studio solution. Again, Jason was demoing this in Module 5 yesterday. Yeah. So I'm going to open up the Zombie Pumpkin Slayer project. Pause for effect.
Yeah.
And what happens here, if we open this guy right here, we don't need to make any changes. I just want to show you what happens. app.xaml.c#. I'm going to open that file up. And if I scroll down,
okay, as our list our functions available.
we can see inside is a method called initialize Unity.
Yes.
And what Prime31 has done is basically injected their code into there that talks back and forth between here and your Unity code. Your Unity-specific libraries are all packaged up underside this data folder here.
Okay. There's a Lambda function again we spoke about earlier.
Yep, that's right here. So it's all set up for you. We don't need to make any changes to this file. We don't actually need to make any changes to any of the code here.
Okay.
What we do need to do is bring in our image, whatever we want to use. And in this case, I'm going to show and explore. I like to keep everything in my project here. So even though I'm not going to use this image in my project, this come back right here. Come back, pumpkins are attacking. This is going to be our enticing image to get the users to come back.
I like where we're going with this. I've had that issue in several other games before, and it's worked very, very well.
This is what we're going to do. Come back, pumpkins are attacking. So I keep this in my Unity project, although we do have to bring it into our Visual Studio solution.
Okay.
And that by itself is pretty easy. All I did was I literally dragged and dropped it in here.
Doesn't
and
get easier than that.
And I just renamed it because my code is actually referencing livetile.png. That's the only reason I renamed it.
Ah, all right.
Now, we go ahead and we can run this.
Let's build this bad boy.
We run Zombie Pumpkin Slayer.
I'm looking to get my sleigh on.
Now we know our title screen is going to look a little funny here, so forgive me for that. We're trying to get too much stuff done during the break. The leaderboards, when we open source this shortly, have the demo project available out on GitHub. I'll make sure that this is actually integrated and working, or at least template that you can finish off. Maybe we can do a tutorial on that.
Perfect.
But then you can see it's used inside of a real game. So, play game. All right, there we go. Now, let's go ahead and switch away from this because the call should already have been done to the system to update this tile.
Okay.
Now, I actually turned my live tile off before.
Whoa.
There we go. There we've got the flip. Let's see if we go away and go back. Now, one other thing I do need to update in my project is I have a default Unity icon here, my little small icon.
Okay.
So I haven't finished off and specified the rest of the icons for the project. And I believe Jason talked about that yesterday as well, where under your player settings, you have all the different images that you can specify.
Yeah.
I'm sorry, that's under...
It's almost like your app manifest file.
Under icon, yes. Everything that's generated here, everything that's listed here, gets pushed out into this project in your package.appx manifest, visual assets, all that good stuff there. So that happens. That works for us. We get our little live tile here on our screen.
Okay.
Come back. Pumpkins are attacking.
It's a great way to send push notifications, right? Someone's coming after you, or maybe it's Halloween. You have some kind of special reward scenario going on.
Come back for a free weapon.
Ah.
Right? You could do something like that. Different ways to entice the user to come back.
Yeah.
You can really, especially You can pull users in. You just got to be a little smart about the marketing that you want to do.
I remember
the message on it.
My EverQuest days on Halloween, I'd have special events where all of a sudden Skeleton Kings would come down. And looking back, I wish,
Kings, yes.
I wish that I had some sort of push notifications back then instead of me having to log in and hope for the best.
So integrating a live tile.
Yeah,
pretty easy.
I like it. We
do
did just a few steps, and what was that, 5-10 minutes at most?
That's it.
Had it done.
Bring in your library. Add your unprocessed plugins.
Yep.
So bring in the Prime 31 package. Add your unprocessed plugin for the P31 Metro Essentials. That is case sensitive. And then you simply add on the image into your resulting project. Make your API call. 2 lines of code.
Right.
Done.
Looks like a very small, simple way to make a very large change to your game and add that sense of professionalism.
That's right. That's right. Now, next, let's talk about a privacy policy in a game. What's a privacy policy? Why do you need a privacy policy? Well, I'll tell you. Privacy policy is required, is absolutely 110% required. I've seen apps get rejected for this. There's no ifs, ands, or buts about this. Yep. As it stands today, privacy policy is required if your app sends any data to a third party.
Okay.
So if you're integrating with, I don't know.
Say an ad service.
Ad service. You are transmitting potentially some sort of information.
Correct.
Right? Because you're using the internet to transmit that data,
right.
Something's required. So you need a privacy policy. 2 places. And I actually have a little sample of a privacy policy here. I don't even want to call it a sample. This is an extract, the way that it stands currently on the documentation for Windows Store certification. A very similar thing for Windows Phone as well. Your app must have a privacy policy statement if it is network capable. So you need to basically tell users how you are going to use their data, if you use it at all. A privacy policy URL is required in this case during submission. So when you go to the portal and you go to submit your application that you made the build for, it says privacy policy URL. If you don't specify it, you will fail certification. Now, the certification process is pretty fast. I've seen apps certified in under 2 hours before.
Yes.
So, if they reject it, you can turn around and just add that privacy policy URL and resubmit it. But you also need it there, and you need it in your application as well. So let's do a little demo for showing it inside of an application.
I would love to see this.
All right. Let me show you the demo. I should have had a demo slide there. Let's go back to our code over here. Now, this also uses the Metro Essentials. And this one is even easier because all that we need is settings pane, which is something from Prime 31, .register settings command. We're going to give it a name called privacy policy. This is what's going to show up on the side of our screen, and I'll demo that in 1 second here.
Okay.
This is my privacy policy. Consider a URL as well to bring you to site. So you can actually have text in here of your privacy policy, or you can actually have you could do a Lambda method here.
Yep.
Unity has a call built in to open a URL, so you can actually just, if you have your privacy policy hosted on a website, you can just actually just call off the URL here rather than displaying text.
That's actually what I do quite a bit too to save some time. I'll just have it stored in a publicly accessible SkyDrive link and then share it that way.
Share it that way. So let's run this zombie pumpkin slayers. This is going to get so old by the end of the day. I'm sorry, audience.
No, I like it. I like the energy we're bringing to the party right now.
All right, so let's run this game. And we'll get through this first screen here. I feel like this is a...
Look at that beautiful game. That performance.
So I click on settings.
particles.
I go to privacy policy. This is my privacy policy. Consider a URL as well to bring you to the site.
Okay.
That's it. That's all that we need. And that was integrated in the side. So this bar here is a charms bar.
Okay.
Gives you an easy way to integrate with all sorts of different... let's do this.
Well, let's see what the privacy policy happens to be for this.
Right. So this does not transmit your information outside. So in this case here, we have permissions and rate and review.
Yes.
So it's an easy way to kind of integrate with that. 2 lines, actually, in this case, 1 line of code.
Yeah, that seemed like it was done even fewer minutes than the one we worked on before.
Super, super easy.
Yeah.
Super easy. So that means we can move on to the next one even faster.
Yep.
Pause screen. Ooh.
This sounds like it can get tricky because how do you handle these different states and what's going on in the background? I'm curious to see your viewpoint on this.
A couple different ways of doing this. Why would you need a pause screen? What happens when a user does any of the following? Your phone rings.
Yeah.
Right? You switch away. You need a break. All of the above. You need to somehow show a pause dialog if you want a friendly game.
Right.
Now, the good news is you can do this 100% in the code inside of Unity.
Wow, okay.
You can also do this inside of your exported Visual Studio project as well. You have multiple solutions. I will show you the one that I use in Unity right now.
Okay.
Platform uses. Well, on my Windows Store device, I probably won't be getting a phone call.
Right.
So in that case, I can do maybe somebody takes my application and they bring it on over to the side and they scale it down really small. I determine, you know what, my game doesn't look good underneath a width of 500 pixels.
Right.
And so I might want to show them, just immediately pause my game state.
Okay.
I've seen several games do that before, that as soon as you scale it over, they just show you paused. It's too small to run, the graphics don't look good.
That's simple.
Yep, so they're just trying to help you out a little bit
And
there.
plus, you may not want to strain all the device's resources as well.
Yes. Another case is you switch away from the application, or when your application's suspended, you want to do it then.
Yep.
Now, Windows Phone, app gets suspended, or maybe the user presses the back button once. You want to show it. You'll see a lot of games that do that. You press the back button on your phone, a pause dialog comes up.
Okay.
And then you can just resume your game from there, or switch back to your home screen or whatever. So it's
Got to resume your state or where you left.
Yep. It just gives a nice, consistent way. Back button, same thing as hitting escape on here, which will show, and that just triggers it off.
Yep.
So let's go and look at a little demo of this, implementing a pause screen. And we will do this in Angry Birds. Just kidding. Zombie pumpkin. Zombie alert. This is getting better and better.
Yeah, I know. I don't know what to expect.
He's mixing it up all sorts of ways. This is cool.
Well, that one killed your audio.
Yeah.
Speaking of audio, let's do a little bit of this. All right. Now, let's go to my pause screen is actually on my main game because I don't care about it on my title screen because my title screen's not doing anything right now. So I'm going to go to my level 1.
Okay.
Okay, and we've got a bunch of other things we're going to show here, but let's hide a couple things here so you can see it. Let's take... Okay. What I have is I have a pause screen here. A pause screen is nothing more than what I did in this implementation, different ways of doing this. I have a UI element here called a panel. And underneath that UI element, I have my pause and continue. So all I did was I went to Game Object, UI, I created the panel, and inside of this panel, I dragged my images into it. That's all that panel is.
Okay.
Why do I do that? I do that because that gives me an easy way to just hide this panel here.
Okay.
I can show it and hide it very, very easily. So I have all my pause logo here and the continue button inside of this panel. That's all. That's the only reason I do it like that.
Wherever that panel goes, those icons will go.
Those guys go. So if I go to pause, right, that's my entire pause screen right there.
Just kind of slides into view at that point.
And what I also did was because I want to search for this in code, I actually just gave it a tag of pause.
Easy enough?
Easy enough. I just went in and added it through add tag. I called it pause because my code will say, hey, I need my pause screen. And so that's how it looks for it.
Okay.
Speaking of code, the class in here that I want to demo is called Screen Manager. And Screen Manager, we do a couple things. So we hook into the window size changed. So we can do a little detection that if the window size is less than 500 pixels, we can go ahead and call our method pause. Otherwise, it's not. Make sure that we're resumed. This only gets triggered when you change the window size.
Okay.
And here, when we start our code, we've talked about these methods before. Start is right before that whatever object this code is assigned to, whatever game object that this class is assigned to, right before its first frame is processed, this code gets called. And so right there, we're saying, you know what? This is a Screen Manager game object. So if I look in Unity, I have a Screen Manager game object. It is nothing more than an empty game object with this script attached to it. That's all it is. And so when this object starts up, it looks for this guy right here. So this guy starts up and says, Unity, where is my pause screen?
Right.
Because it looks for it by tag. And so now it has a reference to it. And so that's what we're doing right here. We have a reference to our pause panel. Now, if we can't find it, I just do a little quick error so we know that, hey, I don't have anything in my game with pause. I do this a lot. If I can't find an object I look for in startup, I will debug that log error and with some details so I know, hey, maybe I'm integrating this into a new game and I missed the requirements here.
Okay.
I just kind of be specific here. Missing a game object, tag pause. This is the item shown, yada, yada, yada.
Do you know if there's anything different between debug.log and log error?
Yeah, so with log error, let me do this. Watch this. Are you ready?
I would like to see this.
Test error. let's start this guy up, and we are in our level 1, and let me just enable that.
Ooh, very nice.
So, notice on our console here, we have an error that's been logged. This is not just an information log.
Yes. It's actually in the warning screen.
So this is saying, hey, you've got something you need to pay attention to. This is pretty critical here.
Ah, so it kind of stands out a bit more than the
Stands
rest.
out a whole lot more. So let's make sure we get rid of this guy. Next, if we can find it, we just go ahead and we hide it, because we don't need it right now. It's our pause screen. So we're just setting set active to false. And all set active does in Unity, you give it true or false. That's the same thing as checking off over here, this guy right here.
Okay.
So set active is essentially the same thing as checking or unchecking that. You pass in true or false.
Okay.
Make sense so far?
Yeah, it's on or
All
off.
right, cool. Then, if we hit escape, what do we want to do?
Well, tell you want to do something.
So if we are already paused, we're going to resume our game. If we are not already paused and somebody hits escape, we want to
Okay.
pause.
Just kind of switching states, going back and
That's
forth.
it. You got it. All right, so let's go ahead over here, and let's run this. And let's see what this looks like.
Okay, pause screen. Looks like all the state in the background is not resuming.
Now, there's one thing I want to point out here.
Yeah.
Let's look at what pause does.
I was actually just going to ask that.
Good timing. So what I do with pause here is I save the original timescale. Timescale is like changing time. Imagine if you were a superhero and you could scale time and change time.
Okay.
This would be the property assigned to you. It would be David.timechanger.timescale.
All right.
So what this does, this is our current time scale. In other words, it's value between 0 to 1, I believe.
My next question.
And that tells you how fast is time processing. One is real time. One is how we are experiencing right now. So I'm just saving that value, and then I set it to 0, which stops all physics and stuff going on in the game.
And you're saving the value because?
I want to restore it afterwards. So I'm setting timescale equal to 0, and just a little flag so I know I'm paused.
Yep.
And I'm just making sure that this paused dialog is now active.
Okay.
So I could have just passed in true there because I know it's true at this point in time.
Yep.
And so that shows the dialog. Then, when you hit escape and we resume it, what do we do?
Say, if you're not paused.
Now, I could, if you caught what I did real quick in the beginning was here, you can stop all audio from playing if you want. I know some games, when you pause them, they continue to play audio.
Right.
So I kept it in this case. That's why I just kind of
You see how easy it is to really turn it off.
Yeah.
And
So
audio
down
listener,
here,
is that referring to every audio listener or?
that is everything in your game.
Okay.
Yep. Now, ideally, in a scene, you're only supposed to have one audio listener.
Right.
If you have more than one, Unity will tell you excessively, hey, you have 2 audio listeners.
Okay.
Now, this right here is we are restoring timescale, putting it back to its original value, in this case 1, and then we're going ahead and hiding our dialogue. So let's see that in its implementation again in Zombie Pumpkin Slayer. Very cool. Everything, physics has stopped, animations have stopped, everything has stopped.
Wow, I'm amazed it was that simple.
Except now I can come in here and click on continue or hit escape.
That is extremely easy.
Super easy.
Yeah.
Super, super, super easy. Now, what I did before was we had our Windows build here. Let's go ahead and run that build.
Yep.
Get our title screen here. Play. Right. This is easy. Let's see if I did my...
Okay, still playing. And
hooked into my event. Oops, I just closed. There we go. I died.
Way too good.
I can't show you this next scene yet. The resurrection scene we'll see
One
shortly.
step at a time.
One step,
okay.
Yes, I have that code there. That's why you're seeing it now. But we'll unveil that shortly here.
Yeah.
So back to this. Super, 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 super easy. Integrating a pause screen adds a little bit to your application to make it just a little bit. It's one of those finishing touches on here.
Okay.
In-app purchases.
Not necessarily as evil as many people may be led to believe.
In-app purchases, in my opinion, currently in the state of the game dev economy today, in-app purchases, for the most part, is how you're going to make your money.
I agree.
if you have a good ad strategy, it's tough, but you could potentially do it that way as well.
Right.
But in-app purchases, that's where to me, you get kind of the best experience in a game.
Right.
So let's say I want to purchase a weapons pack, or I want to purchase some sort of power-up or something like that in the game.
Okay.
In-app purchases are great. And one of the models that you see today, somebody has a free game they release, and then they have an in-app purchase. Tobias covered a lot of these topics in the last talk, or 2 talks ago, I should say.
Very well done.
Very well done. Great talk. He's got great expertise there, so I always love hearing that. I pick up things from it every time.
Absolutely.
And I've heard it probably many times already.
Uh-huh.
Pick up something new every time. So different ways of doing that strategy. We can have a user purchase something up front, or we can kind of place it correctly in the game, right?
like
So there's a
case
strategy. Yes.
Yes.
So you can show them all these power-ups in the beginning or whatever they want to purchase.
Right.
You know what? That's not enticing to them.
Yeah, you don't really want to taunt them.
Yeah. So let's talk about how we can use the Prime 31 plugin here.
Wow, Prime 31 all over the place.
All over the place. Now, all the stuff that we're talking about, if you happen to have this code or you are very comfortable writing Windows Store applications already, we have some great porting guidance, integration guidance, so you can write your own code on the C# XAML side and hook into an event on the Unity side. So you don't have to use a plugin here. You can write all of your own code there if you're comfortable doing that. You can hook into an event on the Unity side, raise that event, and then trigger it off in your C# project. I believe in the session coming up tomorrow, I think Jaime and team are going to be covering some of those tactics as well. I just want to point out, you don't have to use a plugin, but to me, I can drop it in my project. It makes it quite a bit easier for me to use, and it's free. So let's talk about it. In this case, we're going to bring in Metro Essentials Unity package. And again, we also need P31 Metro Essentials added to that unprocessed DLLs. So we've looked at that now twice, one for the Azure one and one for the Metro Essentials.
So it seems like the same song and dance each time.
That's right. Sure, you have Windows Store selected as the build. Now, we do need one other thing here, because the way that in-app purchases operate is you have your real live application, but then you have your application you're using during testing. And so that brings up a bit of, as a friend of mine called it, 2/3 of a dilemma. 2/3 of a trilemma. He called it dilemma.
Trilemma.
2/3 of a trilemma. Don't want to mess up that quote. Cause
I want to understand this.
So on one hand, your application's running live. You're charging against something. A user's purchasing something, and it's charging your account. In test, the current strategy is there's a simulator that you can use. When you're coding a Windows Store application, there's this purchase simulator you can use. And so
like playing with Monopoly money, we'll say.
Yes, exactly. And so, in fact, I won't even say yes. You know what? That is a good analogy. I like that.
So I put on my top hat and my monocle.
Now I've got that scene from Ace Ventura stuck in my head now when he dances the guy around. Anyway. So we're going to add this license.xml to our exported project. And so we'll look at how we have to create that. And let's get to this and look at an actual demo of doing this.
Let's go.
All right. So what we're going to do for our in-app purchases, we want this to entice the user when they die. Now, you're just really doing well in this game. Right? In what game are we playing here? This is... I don't want to get lost today. Let me see if I can see the name here. Zombie, pumpkins.
Yeah, I think that's
I didn't even finish it. Again, reminds me of the scene from Ace Ventura. Chicago. I'll have to test these guys out a little bit. It's too bad it's the last session of the day.
I know. Keep the energy high for a while, right?
That's right. So here, I did the exact same thing for this pause screen. Let me hide the pause screen so you can see our resurrection screen. Simply a little dialogue here. Let's go back to our UI. It is the exact same thing. So a panel in the UI system. A panel is nothing more than an image. Unity, there was a lot of call for people to use usability. People wanted the panel, something that represents a panel. Even though it's just an image, it's still easy to just go ahead and create a panel, but it really is an image behind the scenes. So I create this panel, and inside of that panel, I have this little image right here. And inside of that little image, I have this little image.
All right, so images within images.
Images within images.
How far down the rabbit hole does it go?
And then what I've used, so these are all child game objects. So, of course, if we disable this top one, disable this top one right here, everything will get disabled with it as well.
Makes sense.
Now, what I did here was, on my bottom resurrect image, because this is a child of this one, I could position this really anywhere I want. But I try to take advantage of the new anchoring system that's provided in Unity 4.6.
Wow.
And I basically...
So much easier.
So I anchored this down here at the bottom center of its parent. And then just adjusted its offset a little bit. So when I anchor it down here, let me show you. I can change these positions here. I can go like this, 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 this. I can anchor that all over.
Okay.
So I just anchored it kind of down there and just bumped it up a little bit here. It's good? He's good. All right. Now, I did a similar strategy here. I have some code. Let's go back to my code.
Okay, here we go. Back in our screen manager.
So let me get rid of my screen manager, because actually this is going to be in my game controller class. I probably could have, being that it is a screen element, I probably could have put this in there as well. But to me, this is an aspect that goes through my game orchestrator. So my screen manager is just doing my pausing.
Right.
Really, maybe I could have renamed it like pause manager.
Okay, makes sense.
But in this case, I consider this really an in-game experience application experience that I want to be controlled by my orchestrator of my game, which is my game controller class. And so when this starts up, I'm doing the exact same thing. Now, I just wanted to show you a difference in when I was talking about in kind of my in the optimization thing that we did earlier today. In Module 6, we did optimizations.
Yes.
I talked about different ways of finding objects.
Yeah, looks like you're doing quite a bit of searching in that.
Yeah, so this right here is actually going to search through everything in my scene until it finds this dialogue. A better thing I could have done here is find game object with tag and just tagged it as something like resurrect over in Unity. I just want to show you. This is kind
there
of
are fewer tags to sort through.
Fewer tags to sort through. Actually, in this case, it looks through every single game object for its name, and remember, names can change.
Yeah.
In this case here, we're just looking at only objects that have a tag. So I want to show you both ways that I'm doing it.
Okay.
In this case, I typically would stick with this all the time, but sometimes it's good to show you the not as good way as well.
Okay.
So resurrect dialog, it's going to find it. Actually, I'll tell you what, why don't we fix that right now so you can see how you can take code that you download from the net, although this was not code from the net, but just to show you.
Well, if other people are downloading it following the videos, it will be code from the net.
And notice what I did here. So by default, the API selected was find game objects with tag. I don't want to return multiple objects. I want the first one found with the tag resurrect. And creating a tag in Unity is extremely simple. It's going to do a background compile here. That's why we have that pause. I will go into my resurrect dialog.
Untagged.
I'm going to add a tag. Paste that text into there, resurrect.
Automatically increases the size of our array.
There we go. I just pasted a name into there.
Easy enough.
Easy enough. Then I'm going to go back to my resurrect dialog. It's still untagged. I actually have to come in here to my tag, do something with that, and that's easy enough. It's just, there we go. Save that. Now, when this starts up, you should be able to find it. And ideally, I want to do the same thing with this one too and fix that, but we won't do that right now. First thing it does when it finds it, it hides it. I don't want that dialog showing up all the time. So now let's see where else this is used. Show resurrect purchase and hide resurrect purchase. All these two methods do, show the dialog by setting active. Remember, that equates to?
Right, turning it on or off.
Turning on or off. All it does is check this little checkbox.
Okay.
So I have two methods there, show and hide.
Easy enough.
Makes sense so far. If I want to find out where this is referenced, I can just right-click and say show all references in Visual Studio.
Very nice.
And here we find that it's calling decrement cross health. So my game controller is managing the center cross. So pumpkins come up and they attack that cross. The idea is when the health on that cross gets down, you die.
Okay.
So I have this really easy for this simple demo purpose. The first time that cross gets hit by pumpkin, it's going to show us our resurrect dialog. As opposed to having to wait a few minutes as I battle these pumpkins. First time that cross gets hit, we're going to show this purchase dialog.
Yeah.
All right. Let's see what happens here.
Kind of hinting that something greater could happen.
Yes. So let's show what happens, and then we'll look at the actual code on what happens for our purchase. Or we go to actually have an in-app purchase class right here. So let's see what happens, and then we'll walk through the code on that.
Yeah.
Now, what I want to do on this case, because this is Windows Store specific code.
Yes.
This is meant when you do your Windows Store build.
Okay.
So let me make sure I have that selected as my build
so we had all those DLLs in there before.
Yep. So we need to actually go back to our Visual Studio project. Now, I don't want anybody to confuse this with the Unity VS project, which is also Visual Studio. This is all my game development code. This is not my exported Windows Store project. Just to recap on that, all I did was I come to here, I build my project. That's what we're opening up, this resulting project here.
Okay.
All right, so this is my resulting project. And in this project, we're going to run it. This is the same one that we looked at for our live tiles, same one that we looked at for our privacy policy. Now let's see for our in-app purchase.
Okay, let's see what happens here now.
Now what I did was I configured this in-app purchase to be free. I should probably have that audio change. Okay, now I don't pause my game.
Right.
Because sometimes you see things still run in the background on games.
Yes.
So I wanted that kind of intentionally, you see things still going on there. You died, you could resurrect, or in this case, I have no way for the user to get out of this.
Oh.
So they must purchase my in-app purchase. Ideally, you want a little...
Probably not the best way of handling it.
No, a little icon here just to hide that too, but this was kind of a quick implementation.
Yes.
Now, in this case, I have no kills yet, but imagine I've got like 1,000 pumpkins that I just offed here.
Yeah.
So you know what? I've got great progress. I want to be
wanna keep
high.
going.
I want to be higher on your leaderboard.
That's right.
300 isn't enough. I want to be higher. So now that we've all heard this audio 1,000 times, let's just disable that audio real quick and switch back to this. All right. Resurrect. I click on resurrect. And now this tells you right now, simulate this purchase because we are using the simulator.
That's right.
This is not a live published application.
It's our Monopoly money coming into play again.
That's right. Now I can simulate what I want to return here. OK means the user accepted it.
Perfect.
Invalid arg, out of memory, right? Catastrophic failures, or fail. Like so, if I cancel this, this is going to fail.
Yes.
I want to OK this. As soon as that happens, there we go. We're back in the game. Now these pumpkins are only registering on the first hit. That's why we're not. Why isn't it ending? Right. This cross is still getting bit right now.
Yeah.
Let's kill one, and then it'll happen again when the next one falls up. There we go.
Okay.
Resurrect, okay. Died again. So again, I'm doing this intentionally just on one.
Right,
hit,
otherwise
just
you
to make
offer
it
some
easy.
sort of delay for you to kind of get your scene back in order.
Yeah. So let's close that out and look at what I do in code.
Yeah.
So code is real easy here. I'm loading a license file. And the way that the Prime 31 plugin works is if you happen to load a test license file,
Okay.
it will use it. If you don't, it's live. So it's an easy way to switch back and forth.
Yes.
So because I'm doing my testing here, I'm just calling this. If I'm going live in my app, I'll just comment that out. Now, the only other thing that I need here, there's two things. So one, we're going to add this license file here, this code in the license file. And this license file you actually have to bring into your resulting project.
Okay.
When you install the Prime 31 plugin,
Yes.
it brings in a license.xml file.
All right.
Contains all the stuff in it right here. So you take your license file and you bring it into your Visual Studio solution here, right there. I literally just dragged it and dropped it right into this project.
Okay.
And jumping out from Unity to do that is real easy. You can right-click on any item
Open
and show
Explorer.
in Explorer, and then you can just come back over to your Visual Studio solution, drag it on over, bring it into your project, and its root, and
Perfect.
away you go. So we've got that there. Referencing a licensing file means go ahead and do this in trial mode,
Yep.
trial licensing mode. And secondly is I've got a purchase resurrection method. And it is essentially a one-line code
Right.
to do your purchase. Now, so in this case, I'm requesting an app purchase on this. And here I'm showing my in-app purchase result.
Yep.
That's easy enough to do, right? So in actually the in-app, let me go into what...
I mean, most of that is really just the debug stuff you have in there.
Let's go to our Prime 31 under our plugins. Metro Store. Let me save this and open this one up here real quick. If you look at the source code that's provided with this, you'll see there's a bunch of options in here. So you can find out if your app is currently in a trial.
Okay.
Because you can offer a trial. Like, let's say you want to do a 3-day trial of your application.
Yeah.
You can request an application purchase here. So you can say, hey, request an app purchase. Now you can do things like, actually I think he has an example down here.
Consumables.
Consumables, right?
Yes.
So there's a workflow with consumables. You have to have them purchase a consumable, report the consumable. In other words, fulfill the consumable.
Yes.
So there's demos in here on how to do that as well. The API itself is actually real easy. Request product purchase. And what you do with these in-app purchases, let's say we want to do this as,
Resurrection.
we'll call this resurrection.
Okay.
And actually, I think I just realized a minor error in my code here. Let's talk through that.
Okay.
Yes, I actually did a minor error in my code here.
And this is why I enjoy doing these kinds of talks.
See,
This is a real-world example of how you ran into an issue and how we can get out of it.
with demos, you always find that you kind of are adding on at the last minute. You're like, you know what? It'd be really cool to add this in. I was going to try to add that leaderboards in last minute. So you're always trying to kind of fit really cool content.
You know, it
in,
shows that
change
you know
things
your
around.
code base very well, that you can kind of bounce in and out at will.
Cool. So, Resurrection.
Yep.
That is the name of our in-app purchase. Let's go ahead and rebuild this again here.
Okay.
We can regenerate this just like this. Now, Unity will not overwrite the project. It just overwrites the data folder in that project,
Yes.
which happens to have all of your Unity code in it.
That's right.
So that's perfect. So all of my existing stuff does not get overwritten. Just my Unity code and assets get overwritten in there. So this should work just fine. We're going to come back over here.
Okay. As we're slowly building up our player. Looking forward to playing this game again.
Now, while that's building, let me talk about what this is.
Yes.
When you go into the store and you submit your application, one of the things you have to fill out is if you want to use in-app purchases and if you want to use Microsoft's in-app purchase system.
Okay.
And, you know, there's just a few things, a couple pages you go through submitting your application. And when you choose it, it says, all right, what in-app purchases do you want to use? In this case, you name it. You name it whatever you want to use. If this happens to be extra gun pack, this name must match the name when you're submitting your application. And you tell the store, you say, you know what, this is a whatever the price you want it. It could be free, or you can charge up to like $999 for an in-app purchase.
Okay.
I recall Tobias saying, I don't know if he mentioned it in his talk today or not, but in their game they had a larger valued in-app purchase.
Yeah.
And it was interesting that even though it seems like people might not click that a lot, they just want to get it. Actually, he may have talked about that today.
There's a whole psychology.
There is definitely a psychology behind that. So this is the name of whatever we're going to have in the store. Let's go ahead and run this project now. We should have a very similar result here. Compile, deploy, run it. Click on play to get past that title screen, and
Here we go.
there we go. Now we're just going to get out of the way and let this happen fast.
Let the pumpkins do their thing.
Let the pumpkins do their thing. You died, resurrect, and something didn't work right on there.
Who didn't get called?
Who didn't get called?
So, we didn't see an error pop up there, did we?
I didn't see an error pop up there. Let's try this again. No. Well, anyway, so because I kind of did the live debugging on this, I'd have to go back and look at what exactly didn't get called in there. And I will definitely make sure that this is updated for the demo.
Okay.
We're going to open source this project so you can see it. I will make sure that this actually shows you the dialogue that you'll expect to see here.
Perfect.
And then this is the initial one that I had. So my app purchase was working great.
Yes.
It just wasn't the other in-app purchase here, the product purchase with a
Okay.
key. All right, so let's move on. In-app purchases, pretty
Yes.
easy to implement, even though I had the wrong API call there. Saw that and go back and fix
Looks
that and add the
simple
right
enough.
one. Simple enough. Privacy policy, this actually, this is a quick slider that should have been a little bit prior.
Okay.
That actually brings us to the end of this session. But you know what? I see that we have about 45 seconds left.
Okay.
So, so we could do something here. We could talk about zombie pumpkin slayers. Have you had fun during this whole session?
I've had an absolute great time.
I have had a phenomenal time.
I don't know about you, but there's a lot of work to kind of put this together, so I want to thank you for coordinating and organizing all of this.
My pleasure. This has been a great time. Folks that are watching this, please fill out the survey. Your information helps us make these events better. We absolutely love doing them. It's very rewarding. This is very fun being here.
Yeah. Your feedback is much appreciated. So the more detailed your feedback is, the more incentive we have to then come back and do this kind of thing again for you.
Yes, and just as a quick reminder, folks that are watching this live, tune in. We're going to do a quick little thing after this. Thank you again very much, and please let us know any feedback and follow us on Twitter. We're always publishing out new things on gaming, and check out our blogs. We have a lot of good content. But thank you most of all for attending and watching this.